What do companies in e-commerce, entertainment, healthcare, manufacturing, marketing, finance, tech, and hundreds of other industries all have in common? You guessed it, they all use data. Organizations of all kinds need data analysts to help them improve their processes, identify opportunities and trends, launch new products, provide great customer service, and make thoughtful decisions. Hi, I'm Tony, a program manager at Google and a data analyst myself. I'd like to welcome you to the Google Data Analytics Certificate. Now, there are lots of great reasons to earn this certificate. Maybe you're thinking about starting a career in the exciting world of data analytics. Or maybe you're just fascinated by the power of data as I am. No matter what brought you here, you're in the right place to kickstart a career and learn industry-relevant skills in data analytics. But first, what exactly is data? Well, I like to say that data is a collection of facts. This collection can include numbers, pictures, videos, words, measurements, observations, and more. Once you have data, analytics puts it to work through analysis. Data analysis is the collection, transformation, and organization of data in order to draw conclusions, make predictions, and drive informed decision-making. And it doesn't stop there. Data evolves over time, which means this analysis, or analytics as we call it, can give us new information throughout data's entire life cycle. Data is everywhere. You use and create data every day. Have you ever read reviews of a product before deciding whether or not to buy it? That's data analysis. Or maybe you wear a fitness tracker to count your steps so you can stay active throughout the day. That's data analysis. But you don't just use data, you also create huge amounts of it every single day. Anytime you use your phone, look up something online, stream music, shop with a credit card, post on social media, or use GPS to map a route, you're creating data. Our digital world and the millions of smart devices inside of it have made the amount of data available truly mind-blowing. Here at Google, we process more than 40,000 searches every second. That's 3.5 billion searches a day and 1.2 trillion searches every year. Here's another way to think about it. YouTube has almost 2 billion users. If YouTube users made up a country, it would be the largest in the world. All of that data is transforming the world around us. The publication, The Economist, recently called data the world's most valuable resource. So it's easy to see why data analysts are so valued by their organizations. And what exactly does a data analyst do? Put simply, a data analyst is someone who collects, transforms, and organizes data in order to help make informed decisions. Besides the role itself, one of the most exciting parts of being a data analyst is the number of opportunities available. The demand for data analysts is greater than the number of qualified people to fill these job openings. And this certificate program is a great first step in your journey to finding a job you love. Data analysts come from many different backgrounds and have all kinds of life experiences. You don't need decades of work experience or an expensive education to get started. Many data analysts taught themselves the skills they needed to land their first job, just like you're doing right now. Okay, now let's talk more about what you're going to learn. The Google Data Analytics Certificate is split into courses based on different processes for data analysis. Those are Ask, Prepare, Process, Analyze, Share, and Act. Plan to watch these videos in order. Each one covers a new topic, and every topic builds on what you've learned before, making it easy to track your progress. And you're in the driver's seat. Even though you might see things organized by weeks, everything can be completed at your own pace. So you decide how much you want to do each day. By the end of the program, you'll take everything you've learned and turn it into a project that you can use to show off your skills and wow hiring managers at your job interviews. Now, along the way, you'll also hear from Googlers. That's what we call people who work here at Google. They'll give you an inside look at what it's like to work in our industry and share personal stories of how they got into the field. They'll also give you some excellent tips on how to land your dream job. Stay tuned. Some of them are going to introduce themselves in just a sec.
So I'm Angie. I'm a program manager of engineering at Google. I truly believe that cleaning data is the heart and soul of data. It's how you get to know your data, its quirks, its flaws, its mysteries. I love a good mystery, and it felt like a superpower almost. Like I was a detective and I'd gone in there and I'd really solved something.
Hi, I'm Alex. I'm a research scientist at Google. I research the different impacts of artificial intelligence on society and our users.
So my name is Lila Jones, and I am a part of our cloud team. I get a chance to lead a team of amazing individuals that are focused on helping customers get to the cloud.
Hi, I'm Evan. I'm a learning portfolio manager here at Google. And I have one of the coolest jobs in the world, where I get to look at all the different technologies that affect big data and then work them into training courses like this one for students to take.
I'll be your instructor for the first course. I'll take you through each module that will cover a specific topic in a few different ways. You'll have videos, reading materials, quizzes, hands-on activities, and discussion prompts for you to chat about with other students in an online forum. I'm really excited to be guiding you through this course, but I'm especially excited that you've chosen this adventure. Lifelong learning is something that I'm very passionate about. Growing up, when I looked around, I often didn't see many options available to me. It wasn't until I started getting serious about my education that I realized I had the control to make my own opportunities, with education being the key that would open those doors. The more I learned and the harder I worked, the more possibilities opened up. Had I not gone after that knowledge and continued challenging myself, I may not be where I am today. Learning allowed me to grow personally, be successful, visit places I would never have seen, and meet people I would never have known. And now I'm going to introduce some of those great people.
Hello, I'm Jimena, financial analyst. I'll be helping you learn how to ask the right questions about data, the project you work on, and the problems you're trying to solve.
Hey, my name is Hallie, analytical lead. I am so excited to show you how to prepare your data so it's ready for analysis.
Hello, I'm Sally, measurement and analytical lead. Together, we'll cover how to process and clean your data. Cleaning data doesn't require soap and water. I'm talking about making sure your data is complete, correct, and relevant to the problem you're trying to solve.
Hey, I'm Ayana, Global Insights Manager. We'll be digging into analysis. You'll learn how to collect, transform, and organize data so that you can use it to discover useful information, draw conclusions, and make great decisions.
My name's Kevin, and with my experience as Director of Analytics at Google, I'll guide you through what I think is the most exciting part of the data analysis process. Plan, create, and present effective and compelling data visualizations.
Hello, my name is Carrie. I can't wait to tell you about all the exciting things you can do with the programming language R. Are you ready?
Hi, I'm Rishi, Global Analytics Skills Curriculum Manager. I'm going to help you bring together everything you learned during this program by creating a case study that will dazzle any hiring manager. Just like the capstone of a great building shows everyone that it's complete, your case study will signify your own great achievement of earning a Google certificate in data analytics.
Okay, are you getting excited about the potential of becoming a data analyst? So much is possible with data. You're about to enter a whole new world. Ready? Let's go. Data, data, data. I can't make bricks without clay. Any guesses who said this? I'll give you a hint. It wasn't a famous tech CEO or a data analyst. The person who said this lived long before tech companies even existed. But I bet you've still heard of him. This line was said by Sherlock Holmes, the famous detective created by Sir Arthur Conan Doyle. What Doyle meant was that Holmes couldn't draw any conclusions, which would be the bricks he mentioned, without data, or the clay. You're probably not here to become a world-famous detective, but data is still the building block that you'll use for everything you do in your new data analyst career. Sherlock Holmes would agree. By starting this program, you've shown that you and Sherlock Holmes have something in common. You both have an interest in learning more. That's one of the most important qualities that data analysts can have. Now, there are a bunch of different ways to explore data, but one of the great things about data analytics is that you can often learn how you want, when you want. That might mean doing your own research, talking with people in the industry, or taking online courses. With that said, welcome to your first course. This is your introduction to the wonderful world of data analytics. Since data analytics is the science of data, you'll use this course to begin to learn all about data. Data is basically a collection of facts or information, and through analysis, you'll learn how to use the data to draw conclusions and make predictions and decisions. Personally, I didn't jump right into the data analytics field. I thought data analysis was for computer engineers. Instead, I started off with dreams of working in finance. Once I got through an internship, though, I realized it wasn't the career path I wanted to take. I started to learn about financial planning and analysis and all of the work finance analysts were doing with data. I realized that finance analysts are really just data analysts working in a finance department. These analysts were helping to guide business decisions by knowing how to use data. It was then I realized how powerful data is, and I started to embrace it. Soon enough, I realized I could do this data analysis myself. Data analytics is a big open world of opportunity. There are so many areas your analysis skills can be applied and in all kinds of different ways. If you're new to this world, you'll learn how to identify which path and industry might suit your skills and your interests the best. And for those of you who already have some experience, we'll help you open doors to new and exciting opportunities. One of the skills you'll gain from the program is how to follow the best practices that analysts use to help make data-driven decisions. Computers are one part of the process, but analysts rely on so much more to make decisions. That's why learning how to think analytically and using your other skills and traits on the job will make your work easier. I know you already know how to make good decisions. You chose to be here after all. In this first course, you'll learn more about each phase of the data analysis process. Ask, prepare, process, analyze, share, and act. As a data analyst, you'll go through these steps as you use data to inform your decisions. Eventually, you'll see how this program itself is, in a way, its own version of this process. While I know you'll enjoy watching these videos, your trip through the first course will include a whole lot more. Other videos will take the form of vignettes where you'll learn from data analytics professionals who are already established in their careers. They'll offer words of wisdom as well as tales of their own experiences, starting off on their career path. You'll start your own data journal that will help you keep track of what you've learned throughout the course. You'll also add your own thoughts about what you're learning as well throughout the program. You'll read up on how to navigate this program in the world of data analytics. You'll complete activities, including some that will help you get in the mindset of a data analyst. Along the way, you'll also have the chance to connect with your fellow learners. Discussion prompts will give you a chance to share your thoughts and at the same time, see what your peers think about all that you're learning. These prompts will help you build a community support system to use throughout the program. All right, enough talking. Let's get started on this exciting path. Your next step awaits. Welcome back. At this point, you've been introduced to the world of data analytics and what data analysts do. You've also learned how this course will prepare you for a successful career as an analyst. Coming up, you'll learn all the ways data can be used, and you'll discover why data analysts are in such high demand. I'm not exaggerating when I say every goal and success that my team and I have achieved couldn't have been done without data. Here at Google, all of our products are built on data and data-driven decision-making. From concept to development to launch, we're using data to figure out the best way forward. And we're not alone. Countless other organizations also see the incredible value in data, and of course, the data analysts who help them make use of it. So, we know data opens up a lot of opportunities, but to help you wrap your head around all the ways you can actually use data, let's go over a few examples from everyday life. You might not realize it, but people analyze data all the time. For instance, I'm a morning person. A long time ago, I realized that I'm happier and more productive if I get to bed early and wake up early. I came to this conclusion after noticing a pattern in my day-to-day experiences. When I got 7 hours of sleep and woke up at 6:30, I was the most successful. So I thought about the relationship between this pattern and my daily life, and I predicted that early to bed, early to rise would be the right choice for me. And I'm definitely my best self when I wake up bright and early. I bet you've identified patterns and relationships in your life too. Maybe about your own sleep cycle, or how you feel after eating certain foods, or what time of day you like to work out. All of these are great examples of real-life patterns and relationships that you can use to make predictions about the right actions to take. And that is a huge part of data analysis right there. Now, let's put this process into a business setting. You may remember from an earlier video that there's a ton of data out there. And every minute of every hour of every day, more data is being created. Businesses need a way to control all that data so they can use it to improve processes, identify opportunities and trends, launch new products, serve customers, and make thoughtful decisions. For businesses to be on top of the competition, they need to be on top of their data. That's why these companies hire data analysts to control the waves of data they collect every day, make sense of it, and then draw conclusions or make predictions. This is the process of turning data into insights, and it's how analysts help businesses put all their data to good use. This is actually a good way to think about analysis, turning data into insights. As a reminder, the more detailed definition you learned earlier is that data analysis is the collection, transformation, and organization of data in order to draw conclusions, make predictions, and drive informed decision making. So after analysts have created insights from data, what happens? Well, a lot. Those insights are shared with others, decisions are made, and businesses take action. And here's where it can get really exciting. Data analytics can help organizations completely rethink something they do or point them in a totally new direction. For example, maybe data leads them to a new product or unique service, or maybe it helps them find a new way to deliver an incredible customer experience. It's these kinds of aha moments that can help businesses reach another level. And that makes data analysts vital to any business. Now that you know more of the amazing ways data is being used every day, you can see why data analysts are in such high demand. We'll continue exploring how analysts can transform data into insights that lead to action. And before you know it, you'll be ready to help any organization find new and exciting ways to transform their data.
Hi, I'm Cassie, and I lead Decision Intelligence for Google Cloud. Decision Intelligence is a combination of applied data science and the social and managerial sciences, and it is all about harnessing the power and beauty of data. I help Google Cloud and its customers turn their data into impact and make their businesses and the world better. A data analyst is an explorer, a detective, and an artist all rolled into one. Analytics is the quest for inspiration. You don't know what's going to inspire you before you explore, before you take a look around. And so when you begin, you have no idea what you're going to find and whether you're even going to find anything. You have to bravely dive into the unknown and discover what lies in your data. There is a pervasive myth that someone who works in data should know the everything of data. And I think that that's unhelpful because the universe of data has expanded, and it's expanded so much that specialization becomes important. It's very, very difficult for one person to know and be the everything of data. And so that's why we need these different roles. And the advice that I give folks who are entering the space is to pick their specialization based on which flavor, which type of impact best suits their personality. Now, data science, the discipline of making data useful, is an umbrella term that encompasses 3 disciplines: machine learning, statistics, and analytics. These are separated by how many decisions you know you want to make before you begin with them. So if you want to make a few important decisions under uncertainty, that is statistics. If you want to automate, in other words, make many decisions under uncertainty, that is machine learning and AI. But what if you don't know how many decisions you want to make before you begin? What if what you're looking for is inspiration? You want to encounter your unknown unknowns. You want to understand your world. That is analytics. When you're considering data science and you're choosing which area to specialize in, I recommend going with your personality. Which of the 3 excellences in data science feels like a better fit for you? The excellence of statistics is rigor. Statisticians are essentially philosophers, epistemologists. So they are very careful about protecting decision makers from coming to the wrong conclusion. So if that care and rigor is what you are passionate about, I would recommend statistics. Performance is the excellence of the machine learning and AI engineer. You know that's the one for you. If someone says to you, I bet that you couldn't build an automation system that performs this task with 99.99999% accuracy, and your response to that is, watch me. How about analytics? The excellence of an analyst is speed. How quickly can you surf through vast amounts of data to explore it and discover the gems, the beautiful potential insights that are worth knowing about and bringing to your decision makers? Are you excited by the ambiguity of exploration? Are you excited by the idea of working on a lot of different things, looking at a lot of different data sources, and thinking through vast amounts of information while promising not to snooze past the important potential insights? Are you okay being told, here is a whole lot of data, no one has looked at it before? Go find something interesting. And do you thrive on creative, open-ended projects? If that's you, then analytics is probably the best fit for you. A piece of advice that I have for analysts getting started on this journey is it can be pretty scary to explore the unknown, but I suggest letting go a little bit of any temptations towards perfectionism and instead enjoying the fun, the thrill of exploration. Don't worry about right answers. See how quickly you can unwrap this gift and find out if there is anything fun in there. It's like your birthday, unwrapping a bunch of things. Some of them you like, some of them you won't. But isn't it fun to know what's actually in there?
Hello again. You've already learned about being a data analyst and how this program will help prepare you for your future career. Now, it's time to explore the data ecosystem, find out where data analytics fits into that system, and go over some common misconceptions you might run into in the field of data analytics. To put it simply, an ecosystem is a group of elements that interact with one another. Ecosystems can be large, like the jungle in a tropical rainforest, or the Australian outback, or tiny, like tadpoles in a puddle or bacteria on your skin. And just like the kangaroos and koala bears in the Australian outback, data lives inside its own ecosystem too. Data ecosystems are made up of various elements that interact with one another in order to produce, manage, store, organize, analyze, and share data. These elements include hardware and software tools and the people who use them, people like you. Data can also be found in something called the cloud. The cloud is a place to keep data online rather than on a computer hard drive. So instead of storing data somewhere inside your organization's network, that data is accessed over the internet. So the cloud is just a term we use to describe the virtual location. The cloud plays a big part in the data ecosystem. And as a data analyst, it's your job to harness the power of that data ecosystem. Find the right information and provide the team with analysis that helps them make smart decisions. For example, You could tap into your retail store's database, which is an ecosystem filled with customer names, addresses, previous purchase, and customer reviews. As a data analyst, you could use this information to predict what these customers will buy in the future and make sure the store has the products in stock when they're needed. As another example, let's think about a data ecosystem used by a human resources department. This ecosystem would include information like postings from job websites, stats on the current labor market, employment rates, and social media data on prospective employees. A data analyst could use this information to help their team recruit new workers and improve employee engagement and retention rates. But data ecosystems aren't just for stores and offices, they work on farms too. Agricultural companies regularly use data ecosystems that include information, including geological patterns and weather movements. Data analysts can use this data to help farmers predict crop yields. Some data analysts are even using data ecosystems to save real environmental ecosystems. At the Scripps Institution of Oceanography, coral reefs all over the world are monitored digitally so they can see how organisms change over time, track their growth, and measure any increases or declines in individual colonies. The possibilities are endless. Okay, now let's talk about some common misconceptions you might come across. First is the difference between data scientists and data analysts. It's easy to confuse the two, but what they do is actually very different. Data science is defined as creating new ways of modeling and understanding the unknown by using raw data. Here's a good way to think about it. Data scientists create new questions using data, while analysts find answers to existing questions by creating insights from data sources. There are also many words and phrases you'll hear throughout this course that are easy to get mixed up. For example, data analysis and data analytics sound the same, but they're actually very different things. Let's start with analysis. You've already learned that data analysis is the collection, transformation, and organization of data in order to draw conclusions, make predictions, and drive informed decision-making. Data analytics, in the simplest terms, is the science of data. It's a very broad concept that encompasses everything from the job of managing and using data to the tools and methods that data workers use each and every day. So when you think about data, data analysis, and the data ecosystem, it's important to understand that all of these things fit under the data analytics umbrella. All right, now that you know a little more about the data ecosystem and the differences between data analysis and data analytics, you're ready to explore how data is used to make effective decisions. You'll get to see data-driven decision-making in action. So far, you've discovered that there are many different ways data can be used. In our everyday lives, we use data when we wear a fitness tracker or read product reviews to make a purchase decision. And in business, we use data to learn more about our customers, improve processes, and help employees do their jobs more effectively. But this is just the tip of the iceberg. One of the most powerful ways you can put data to work is with data-driven decision-making. Data-driven decision-making is defined as using facts to guide business strategy. Organizations in many different industries are empowered to make better data-driven decisions by data analysts all the time. The first step in data-driven decision-making is figuring out the business need. Usually, this is a problem that needs to be solved. For example, a problem could be a new company needing to establish better brand recognition so it can compete with bigger, more well-known competitors. Or maybe an organization wants to improve a product and needs to figure out how to source parts from a more sustainable or ethically responsible supplier. Or it could be a business trying to solve the problem of unhappy employees, low levels of engagement, satisfaction, and retention. Whatever the problem is, once it's defined, a data analyst finds data, analyzes it, and uses it to uncover trends, patterns, and relationships. Sometimes the data-driven strategy will build on what's worked in the past. Other times, it can guide a business to branch out in a whole new direction. Let's look at a real-world example. Think about a music or movie streaming service. How do these companies know what people want to watch or listen to? And how do they provide it? Well, using data-driven decision making, they gather information about what their customers are currently listening to, analyze it, then use the insights they've gained to make suggestions for things people will most likely enjoy in the future. This keeps customers happy and coming back for more, which in turn means more revenue for the company. Another example of data-driven decision-making can be seen in the rise of e-commerce. It wasn't long ago that most purchases were made in a physical store, but the data showed people's preferences were changing. So a lot of companies created entirely new business models that removed the physical store and let people shop right from their computers or mobile phones, with products delivered right to their doorstep. In fact, data-driven decision-making can be so powerful, it can make entire business methods obsolete. For example, data help companies completely move away from corded phones and replace them with mobile phones. By ensuring that data is built into every business strategy, data analysts play a critical role in their company's success. But it's important to note that no matter how valuable data-driven decision-making is, data alone will never be as powerful as data combined with human experience, observation, and sometimes even intuition. To get the most out of data-driven decision-making, it's important to include insights from people who are familiar with the business problem. These people are called subject matter experts, and they have the ability to look at the results of data analysis and identify any inconsistencies, make sense of gray areas, and eventually validate choices being made. Organizations that work this way put data at the heart of every business strategy, but also benefit from the insights of their people. It's a win-win. As a data analyst, you play a key role in empowering these organizations to make data-driven decisions, which is why it's so important for you to understand how data plays a part in the decision-making process. We've covered a lot, and I'm sure you have so much to think about already. That's a good thing. It means you've started collecting data and you're doing your own personal analysis. That's what it's all about. You've built a great base already. As this course continues, your knowledge and data analysis skills will continue to grow. Once you've established a solid foundation, you'll apply what you've learned to the rest of the program. The data analysis process will help provide a framework for everything you do. Soon, you'll take your first graded assessment. It's a great way to check your understanding of the concepts and build confidence in your knowledge. Everyone learns at different speeds, so take your time, get familiar with the concepts. As soon as you feel ready, you can go ahead and get started. Keep in mind, if at any point you're not sure about a question, you can always review the videos and readings to remind yourself of the answer. We're all about open book tests here. Once you've passed, you'll be all set to move on. You've got this. Before you know it, you'll be done with all of the courses and you'll be ready to create your own case study. Then, if it's what you want to do, you'll start your job search equipped with the tools and skills that will wow any company you talk to. I can't wait to see where you go with data analytics. For now though, give yourself a pat on the back for a job well done. See you soon. Welcome. Now that you have a solid foundation on the basics of data, it's time to focus on some particular skills and characteristics that will be key to your future career as a data analyst. We'll begin with 5 key skills, move on to the characteristics of analytical thinking, and then learn how data analysts balance their roles and responsibilities. Along the way, you'll also discover how to tap into your own natural abilities for strategy, technical expertise, and data design. These are incredibly helpful skills to have, and you'll learn how to make them even stronger. Finally, you'll be introduced to some fascinating real-world examples of how data is influencing the lives of people all around the world. All right, let's get started. Earlier, I told you that you already have analytical skills. You just might not know it yet. When learning new things, sometimes people overlook their own skills, but it's important you take the time to acknowledge them, especially since these skills are going to help you as a data analyst. In fact, you're probably more prepared than you think. Don't believe me? Well, let me prove it. Let's start by defining What I'm talking about here. Analytical skills are qualities and characteristics associated with solving problems using facts. There are a lot of aspects to analytical skills, but we'll focus on 5 essential points. There are curiosity, understanding context, having technical mindset, data design, and data strategy. Now, you may be thinking, I don't have these kinds of skills, or I only have a couple of them. But stay with me, and I bet you'll change your mind. Let's start with curiosity. Curiosity is all about wanting to learn something. Curious people usually seek out new challenges and experiences. This leads to knowledge. The very fact that you're here with me right now demonstrates that you have curiosity. All right, that was an easy one. Now, think about understanding context. Context is the condition in which something exists or happens. This can be a structure or an environment. A simple way of understanding context is by counting to 5. 1, 2, 3, 4, 5. All of those numbers exist in the context of 1 through 5. But what if a friend of yours said to you, 1, 2, 4, 5, 3? Well, the 3 would be out of context. Simple, right? But it can be a little tricky. There's a good chance that you might not even notice the 3 being out of context if you aren't paying close attention. That's why listening and trying to understand the full picture is critical. In your own life, you put things into context all the time. For example, let's think about your grocery list. If you group together items like flour, sugar, and yeast, that's you adding context to your groceries. This saves you time when you're at the baking aisle at the grocery store. Let's look at another example. Have you ever shuffled a deck of cards and noticed a joker? If you're playing a game that doesn't include jokers, identifying that card means you understand it's out of context. Remove it, and you're much more likely to play a successful game. All right, so now we know you have both curiosity and the ability to understand context. Let's move on to the third skill, a technical mindset. A technical mindset involves the ability to break things down into smaller steps or pieces and work with them in an orderly and logical way. For instance, when paying your bills, you probably already break down the process into smaller steps. Maybe you start by sorting them by the date they're due. Next, you might add them up and compare that amount to the balance in your bank account. This would help you see if you can pay your bills now or if you should wait until the next paycheck. Finally, you'd pay them. When you take something that seems like a single task, like paying your bills, and break it into smaller steps with an orderly process, that's using a technical mindset. Now let's explore the fourth part of an analytical skill set, data design. Data design is how you organize information. As a data analyst, design typically has to do with an actual database. But again, the same skills can easily be applied to everyday life. For example, think about the way you organize the contacts in your phone. That's actually a type of data design. Maybe you list them by first name instead of last, or maybe you use email addresses instead of their names. What you're really doing is designing a clear, logical list that lets you call or text a contact in a quick and simple way. The last, but definitely not least, the fifth and final element of analytical skills is data strategy. Data strategy is the management of the people, processes, and tools used in data analysis. Let's break that down. You manage people by making sure they know how to use the right data to find solutions to the problem you're working on. For processes, it's about making sure the path to that solution is clear and accessible. And for tools, you make sure the right technology is being used for the job. Now, you may be doubting my ability to give you an example from real life that demonstrates data strategy. But check this out. Imagine mowing a lawn. Step 1 would be reading the owner's manual for the mower. That's making sure the people involved, well, you in this example, know how to use the data available. The manual would instruct you to put on protective eyewear and closed-toe shoes. Then it's on to step 2, making the process, the path, clear and accessible. This would involve you walking around the lawn, picking up large sticks or rocks that might get in your way. Finally, for step 3, you check the lawnmower, your tool, to make sure it has enough gas and oil and is in working condition so the lawn can be mown safely. So there you have it. Now you know the 5 essential skills of a data analyst: curiosity, understanding context, having a technical mindset, data design, and data strategy. I told you that you are already an analytical thinker. Now you can start actively practicing these skills as you move through the rest of this course. Curious about what's next? Move on to the next video. Now that you know the 5 essential skills of a data analyst, you're ready to learn more about what it means to think analytically. People don't often think about thinking. Thinking is second nature to us. It just happens automatically. But there are actually many different ways to think. Some people think creatively, some think critically, and some people think in abstract ways. Let's talk about analytical thinking. Analytical thinking involves identifying and defining a problem and then solving it by using data in an organized, step-by-step manner. So as data analysts, how do we think analytically? Well, to answer that question, we will now talk about a second set of 5, the 5 key aspects to analytical thinking. They are visualization, strategy, problem orientation, correlation, and finally, big picture and detail-oriented thinking. Let's start with visualization. In data analytics, visualization is the graphical representation of information. Some examples include graphs, maps, or other design elements. Visualization is important because visuals can help data analysts understand and explain information more effectively. Think about it like this. If you are trying to explain the Grand Canyon to someone, using words would be much more challenging than showing them a picture. A visualization of the Grand Canyon would help you make your point much quicker. Now let's talk about the second part of analytical thinking, being strategic. With so much data available, having a strategic mindset is key to staying focused and on track. Strategizing helps data analysts see what they want to achieve with the data and how they can get there. Strategy also helps improve the quality and usefulness of the data we collect. By strategizing, we know all our data is valuable and can help us accomplish our goals. Next up on the analytical thinking checklist, being problem-oriented. Data analysts use a problem-oriented approach in order to identify, describe, and solve problems. It's all about keeping the problem top of mind throughout the entire project. For example, say a data analyst is told about the problem of a warehouse constantly running out of supplies. They would move forward with different strategies and processes, but the number one goal would always be solving the problem of keeping inventory on the shelves. Data analysts also ask a lot of questions. This helps improve communication and saves time while working on a solution. An example of that would be surveying customers about their experiences, using a product and building insights from those questions to improve that product. This leads us to the 4th quality of analytical thinking, being able to identify a correlation between 2 or more pieces of data. A correlation is like a relationship. You can find all kinds of correlations in data. Maybe it's the relationship between the length of your hair and the amount of shampoo you need. Or maybe you notice a correlation between a rainier season leading to a high number of umbrellas being sold. But as you start identifying correlations in data, there's one thing you always want to keep in mind. Correlation does not equal causation. In other words, just because 2 pieces of data are both trending in the same direction, that doesn't necessarily mean they are all related. We'll learn more about that later. And now, the final piece of the analytical thinking puzzle, big picture thinking. This means being able to see the big picture as well as the details. A jigsaw puzzle is a great way to think about this. Big picture thinking is like looking at a complete puzzle. You can enjoy the whole picture without getting stuck on every tiny piece that went into making it. If you only focus on individual pieces, you wouldn't be able to see past that, which is why big picture thinking is so important. It helps you zoom out and see possibilities and opportunities. This leads to exciting new ideas or innovations. On the flip side, detail-oriented thinking is all about figuring out all of the aspects that will help you execute a plan. In other words, the pieces that make up your puzzle. There are all kinds of problems in the business world that can benefit from employees who have both a big picture and a detail-oriented way of thinking. Most of us are naturally better at one or the other, but you can always develop the skills to fit both pieces together. And now that you know the 5 aspects of analytical thinking, visualization, strategy, problem orientation, correlation, and big picture and detail-oriented thinking, you can put them to work for you when you're working with data. And as you continue through this course, you'll learn how. Let's recap what we've learned about analytical thinking so far. The 5 key aspects are visualization, strategy, problem orientation, correlation, and using big picture and detail-oriented thinking. And we've seen how you already use them in your everyday life. We also talked about how different people naturally use certain types of thinking, but that you can absolutely grow and develop the skills that might not come as easily to you. This means you can become a versatile thinker, which is a very important part of data analysis. You might naturally be an analytical thinker, but you can learn to think creatively and critically, and be great at all 3. The more ways you can think, the easier it is to think outside the box and come up with fresh ideas. But why is it important to think in different ways? Well, because in data analysis, solutions are almost never right in front of you. You need to think critically to find out the right questions to ask, but you also need to think creatively to get new and unexpected answers. Let's talk about some of the questions data analysts ask when they're on the hunt for a solution. Here's one that will come up a lot. What is the root cause of a problem? A root cause is the reason why a problem occurs. If we can identify and get rid of a root cause, we can prevent that problem from happening again. A simple way to wrap your head around root causes is with a process called the 5 whys. In the 5 whys, you ask why 5 times to reveal the root cause. The 5th and final answer should give you some useful and sometimes surprising insights. Here's an example of the 5 whys in action. Let's say you wanted to make a blueberry pie but couldn't find any blueberries. You'd be trying to solve a problem by asking, why can't I make a blueberry pie? The answer would be, there were no blueberries at the store. There's why number 1. So you then ask, why were there no blueberries at the store? And discover that the blueberry bushes don't have enough fruit this season. That's why number 2. Next you'd ask, why was there not enough fruit? This would lead you to the fact that birds were eating all the berries. Why number 3, asked and answered. Now we get to why number 4. Ask why a 4th time, and the answer would be that although the birds normally prefer mulberries and don't eat blueberries, the mulberry bushes didn't produce fruit this season. So the birds are eating blueberries instead. And finally, we get to why number 5, which should reveal the root cause. A late frost damaged the mulberry bushes, so they didn't produce any fruit. So you can't make a blueberry pie because of a late frost months ago. See how the 5 whys can reveal some very surprising root causes? This is a great trick to know, and it can be a very helpful process in data analysis. Another question commonly asked by data analysts is, where are the gaps in our process? For this, many people will use something called gap analysis. Gap analysis lets you examine and evaluate how a process works currently in order to get where you want to be in the future. Businesses conduct gap analysis to do all kinds of things, such as improve a product or become more efficient. The general approach to gap analysis is understanding where you are now compared to where you want to be. Then, you can identify the gaps that exist between a current and future state and determine how to bridge them. A third question that data analysts ask a lot is, what did we not consider before? This is a great way to think about what information or procedure might be missing from a process, so you can identify ways to make better decisions and strategies moving forward. These are just a few examples of the kinds of questions data analysts use at their jobs every day. As you begin your career, I'm sure you'll think of a whole lot more. The way data analysts think and ask questions plays a big part in how businesses make decisions. That's why analytical thinking and understanding how to ask the right questions can have such a huge impact on the overall success of a business. Later, we'll talk more about how data-driven decisions can lead to successful outcomes. In an earlier video, you learned about 5 essential analytical skills. As a reminder, they are curiosity, understanding context, having a technical mindset, data design, and data strategy. In the next couple of videos, we'll explore how these abilities all become part of data-driven decision-making. But first, let's look at the concept of data-driven decision-making and why it's more likely to lead to successful outcomes. You might remember that data-driven decision-making involves using facts to guide business strategy. Data analysts can tap into the power of data to do all kinds of amazing things. With data, they can gain valuable insights, verify their theories or assumptions, better understand opportunities and challenges, support an objective, help make a plan, and much more. In business, data-driven decision-making can improve the results in a lot of different ways. For example, say a dairy farmer wants to start making and selling ice cream. They could guess what flavors customers would like, but there's a better way to get the information. The farmer could survey people and ask them what flavors they prefer. This gives the farmer the data they need to pick ice cream flavors people will enjoy. Here's another example. Let's say the president of an organization is curious about what perks employees value most. She asked the human resources director, who says people value casual dress code. It's a gut feeling, but the HR director backs it up with the fact that he sees a lot of people wearing jeans and t-shirts. But what if this company were to use a more structured employee feedback process, such as a survey? It might reveal that employees actually enjoy free public transportation cards the most. The human resources director just didn't realize that because he drives to work. These are just some of the benefits of data-driven decision-making. It gives you greater confidence about your choice and your abilities to address business challenges. It helps you become more proactive when an opportunity presents itself, and it saves you time and effort when working towards a goal. Now let's learn more about how these 5 skills help you tap into all the potential of data-driven decision-making. First, think about curiosity and context. The more you learn about the power of data, the more curious you're likely to become. You'll start to see patterns in relationships in everyday life, whether you're reading the news, watching a movie, or going to an appointment across town. The analysts take their thinking a step further by using context to make predictions, research answers, and eventually draw conclusions about what they've discovered. This natural process is a great first step in becoming more data-driven. Having a technical mindset comes next. Everyone has instincts, or, as in the case of our human resources director example, gut feelings. Data analysts are no different. They have gut feelings too, but they've trained themselves to build on those feelings and use a more technical approach to explore them. They do this by always seeking out the facts, putting them to work through analysis, and using the insights they gain to make informed decisions. Next, we come to data design, which has a strong connection to data-driven decision-making. To put it simply, designing your data so that it's organized in a logical way makes it easy for data analysts to access, understand, and make the most of available information. And it's important to keep in mind that data design doesn't just apply to databases. This kind of thinking can work with all sorts of real-life situations too. The basic idea is this. If you make decisions that are informed by data, you are more likely to make more informed and effective decisions. The final ability is data strategy, which incorporates the people, processes, and tools used to solve a problem. This is a big one to remember because data strategy gives you a high-level view of the path you'll need to take to achieve your goals. Also, data-driven decision-making isn't a one-person job. It's much more likely to be successful if everyone is on board and on the same page. So it's important to make sure specific procedures are in place and that your technology being used is aligned with your data-driven strategy. Now you know how these 5 essential analytical skills work towards making better data-driven decisions. So far, many of the examples you've heard are hypothetical. That means they could be true in theory, but aren't specific real-world cases. Next, we'll look at some real examples. I can't wait to share how data analysts put data to work for amazing results. In this video, I'm going to share some case studies that highlight the incredible work data analysts do. Each of these scenarios shows off the power of data-driven decision-making in unexpected ways. The first story is about Google. As I mentioned a little while back, here at Google, our mission is to organize the world's information and make it universally accessible and useful. All of our products, from idea to development to launch, are built on data and data-driven decision-making. There are tons of examples here at Google of people using facts to create business strategy. But one of the most famous ones has to do with Google's human resources. So here's how it went. The HR department wanted to know if there was value in having managers. Were their contributions worthwhile, or should everyone just be an individual contributor? To answer that question, Google's People Analytics team looked at past performance reviews and employee surveys. The data they found was plotted on a graph because, as you've learned, visuals are extremely helpful when trying to understand a problem or concept. The graph revealed that Googlers had positive feelings about their managers, but the data was pretty general, and the team wanted to learn more. So they dug deeper and split the data into quartiles. A quartile divides data points into 4 equal parts, or quarters. Here's where the really cool stuff started happening. The data analysts discovered that there was a big difference between the very top and the very bottom quartiles. As it turned out, the teams with the best managers were significantly happier, more productive, and more likely to want to keep working at Google. This confirmed that managers were valued and make a big difference. Therefore, the idea of having only individual contributors was not implemented. But there was still more work to do. Just knowing that great managers create great results doesn't lead to actionable insights. You have to identify what exactly makes a great manager. So the team took 2 additional steps to collect more data. First, they launched an awards program where employees could nominate their favorite managers. For every submission, you had to provide examples or data about what makes that manager great. The second step involved interviewing managers who are graphed on the top and bottom quartiles. This helped the analytics team see the differences between successful and less successful management behaviors. The best behaviors were identified, as were the most common reasons for a manager needing improvement. The final step was sharing these insights and putting a procedure in place for evaluating managers with these qualities in mind. This data-driven decision continues to create an exceptional company culture for my colleagues and me. Thanks, data. Another interesting example comes from the nonprofit sector. Nonprofits are organizations dedicated to advancing a social cause or advocating for a particular effort, such as food security, education, or the arts. In this case, data analysts research how journalists can make a more meaningful impact for the nonprofits they would write about. Because journalists write for newspapers, magazines, and other news outlets, they can help nonprofits reach readers like you and me, who then take action to help nonprofits reach their goals. For instance, say you read about the problem of climate change in an online magazine. If the article is effective, you learn more about the cause and might even be compelled to make greener choices in your day-to-day life, volunteer for a nonprofit, or make a donation. That's an example of the journalist's work bringing about awareness, understanding, and engagement. So, back to the story. The data analysts used a tracker to monitor story topics, clicks, web traffic, comments, shares, and more. Then, they evaluated the information to make recommendations for how the journalists could do their jobs even better. In the end, they came up with some great ideas for how nonprofits and journalists can motivate people everywhere to work together and make the world a better place. There's really no end to what you can do as a data analyst. As you progress through this program, you'll discover even more possibilities. Great job following along with the topics in these past few videos. You learned all about analytical skills and the 5 key characteristics of data analysts. You probably even learned that you're a pro at most of these already. Next, you discovered what it means to think analytically and the specific skills data analysts develop to help them do it. You explore tools and processes that enable data analysts to pinpoint a problem and ask the right questions in order to solve it. Finally, some real-world stories helped illustrate why data-driven decision-making is usually more successful than other methods. You're building a wonderful foundation for your career as a data analyst. With every video, your skills will continue to expand and your understanding of key data analytics concepts will only get stronger. Soon, you'll have a chance to test out everything you've learned. This is a really useful opportunity to check your understanding of all the concepts we've discussed. And if you're ever unsure about a question, you can review the videos and readings to find the answer. This is another awesome way to practice collecting data. Keep up the great work. Hey, it's great to have you back. So we've talked a little bit about the data analysis process. As a quick refresher, the data analysis process phases are ask, prepare, process, analyze, share, and act. You might remember me saying earlier that this entire program is modeled after these steps. So now, we're going to really dig in and explore how each of these phases work together. But I'm getting a little ahead of myself. First, let's spend a little time understanding the data lifecycle. No, data isn't actually alive, but it does have a life cycle. So how do data analysts bring data to life? Well, it starts with the right data analysis tool. These include spreadsheets, databases, query languages, and visualization software. Don't worry if you don't know how these work, or even what they are. At one point, every data analyst has been right where you are right now, and they probably had a lot of the same questions. I remember when I first started learning about spreadsheets. I was a young intern, and the company I was working for was in the middle of a big systems change. That meant we had to move tons of reports from the old system to the new one. After a few weeks, I noticed that even the people who are further in their careers were not as technically minded as I was. So that became a great opportunity for me to add value. My aha spreadsheet moment came when I started researching shortcuts that I could use to work with the spreadsheets more efficiently. This would really streamline the process of getting those reports moved over to the new system. Once everything started flowing, I remember getting emails from other finance analysts at the company. They were so grateful that someone had come in and fixed a problem that no one else could. That inspired me to go even further and learn how to use spreadsheets in all sorts of incredible ways. As you continue through this course, I bet you'll be just as impressed as I was. And before you know it, you'll bring data to life too. Let's get started. Here's a question for you. When you think about a life cycle, what's the first thing that comes to mind? Now, I'm not a mind reader, but I know whatever you're thinking is right. There's actually no wrong answer because everything has a life cycle. One of the most well-known examples of a life cycle is a butterfly. Butterflies begin as eggs, hatch into caterpillars, and then become a chrysalis. That's where the real magic happens. Data has a life cycle of its own too. In this video, we're going to talk about each of the stages in that life cycle to help you understand the individual phases data goes through. The life cycle of data is plan, capture, manage, analyze, archive, and destroy. Let's start with the first phase, planning. This actually happens well before starting an analysis project. During planning, a business decides what kind of data it needs, how it will be managed throughout its life cycle, who will be responsible for it, and the optimal outcomes. For example, let's say an electricity provider wanted to gain insights into how to save people energy. In the planning phase, they might decide to capture information on how much electricity its customers use each year, what types of buildings are being powered, and what types of devices are being powered inside of them. The electricity company would also decide which team members would be responsible for collecting, storing, and sharing that data. All of this happens during planning, and it helps set up the rest of the project. The next phase is when you capture data. This is where data is collected from a variety of different sources and brought into the organization. With so much data being created every day, the ways to collect it are truly endless. One common method is getting data from outside resources. For example, if you're doing data analysis on weather patterns, you'd probably get data from a publicly available data set like the National Climatic Data Center. Another way to get data is from a company's own documents and files, which are usually stored inside a database. While we've mentioned databases before, we haven't gone into too much detail about what they are. A database is a collection of data stored in a computer system. In the case of our electricity provider, the business would probably measure data usage among its customers within a database that it owns. As a quick note, when you maintain a database of customer information, ensuring data integrity, credibility, and privacy are all important concerns. You'll learn a lot more about that later on. Now that we've captured our data, we move on to the next phase of the data lifecycle, manage. Here we're talking about how we care for our data, how and where it's stored, the tools used to keep it safe and secure, and the actions taken to make sure that it's maintained properly. This phase is very important to data cleansing, which we'll cover later on. Next, it's time to analyze your data. This is where data analysts really shine. In this phase, the data is used to solve problems, make great decisions, and support business goals. For example, one of our electricity company's goals might be to find ways to help customers save energy. Moving on, the data lifecycle now evolves to the archive phase. Archiving means storing data in a place where it's still available but may not be used again. During analysis, analysts handle huge amounts of data. Can you imagine if we had to sort through all of the available data that's out there, even if it was no longer useful and relevant to our work? It makes way more sense to archive it than to keep it around. And finally, the last step of the data lifecycle, the destroy phase. Yes, it sounds sad, but when you destroy data, it won't hurt a bit. So let's get back to our electricity provider example. They would have data stored on multiple hard drives. To destroy it, the company would use a secure data erasure software. If there were any paper files, they would be shredded too. This is important for protecting a company's private information, as well as private data about its customers. And there you have it, the data life cycle. And now that you understand the different phases data goes through during its life cycle, you can better understand how to approach the data analysis process, which we'll talk about soon. Now that you understand all the phases of the data lifecycle, it's time to move on to the phases of data analysis. They sound similar, but are two different things. Data analysis isn't a life cycle. It's the process of analyzing data. Coming up, we'll look at each step of the data analysis process and how it will relate to your work as a data analyst. Even this program is designed to follow these steps. Understanding these connections will help guide your own analysis and your work in this program. You've already learned that this program is modeled after the stages of the data analysis process. This program is split into courses, 6 of which are based upon the steps of data analysis: ask, prepare, process, analyze, share, and act. Okay, let's start with the first step in data analysis, the ask phase. In this phase, we do 2 things. We define the problem to be solved, and we make sure that we fully understand stakeholder expectations. Stakeholders hold a stake in the project. They are people who have invested time and resources into a project and are interested in the outcome. Let's break that down. First, defining a problem means you look at the current state and identify how it's different from the ideal state. Usually, there's an obstacle we need to get rid of or something wrong that needs to be fixed. For instance, a sports arena might want to reduce the time fans spend waiting in the ticket line. The obstacle is figuring out how to get the customers to their seats more quickly. Another important part of the ask phase is understanding stakeholder expectations. The first step here is to determine who the stakeholders are. That may include your manager, an executive sponsor, or your sales partners. There can be lots of stakeholders, But what they all have in common is that they help make decisions, influence actions and strategies, and have specific goals they want to meet. They also care about the project, and that's why it's so important to understand their expectations. For instance, if your manager assigns you a data analysis project related to business risk, it would be smart to confirm whether they want to include all types of risks that could affect the company, or just risks related to weather, such as hurricanes and tornadoes. Communicating with your stakeholders is key in making sure you stay engaged and on track throughout the project. So as a data analyst, developing strong communication strategies is very important. This part of the ask phase helps you keep focused on the problem itself, not just its symptoms. As you learned earlier, the 5 whys are extremely helpful here. In an upcoming course, you'll learn how to ask effective questions and define the problem by working with stakeholders. You'll also cover strategies that can help you share what you discover in a way that keeps people interested. After that, we'll move on to the prepare step of the data analysis process. This is where data analysts collect and store data they'll use for the upcoming analysis process. You'll learn more about the different types of data and how to identify which kinds of data are most useful for solving a particular problem. You'll also discover why it's so important that your data and results are objective and unbiased. In other words, any decisions made from your analysis should always be based on facts and be fair and impartial. Next is the process step. Here, data analysts find and eliminate any errors and inaccuracies that can get in the way of results. This usually means cleaning data, transforming it into more useful format, combining 2 or more data sets to make information more complete, and removing outliers, which are any data points that could skew the information. After that, you'll learn how to check the data you prepared to make sure it's complete and correct. This phase is all about getting the details right, so you'll also fix typos, inconsistencies, or missing and inaccurate data. And to top it off, you'll gain strategies for verifying and sharing your data cleansing with stakeholders. Then it's time to analyze. Analyzing the data you've collected involves using tools to transform and organize that information so that you can draw useful conclusions, make predictions, and drive informed decision making. There are lots of powerful tools data analysts use in their work, and in this course you'll learn about 2 of them: spreadsheets and structured query language, or SQL, which is often pronounced SQL. The next course is based on the share phase. Here, you'll learn how data analysts interpret results and share them with others to help stakeholders make effective, data-driven decisions. In the share phase, visualization is a data analyst's best friend. So this course will highlight why visualization is essential to getting others to understand what your data is telling you. With the right visuals, facts and figures become so much easier to see, and complex concepts become easier to understand. We'll explore different kinds of visuals and some great data visualization tools. You'll also practice your own presentation skills by creating compelling slideshows and learning how to be fully prepared to answer questions. Then we'll take a break from the data analysis process to show you all of the really cool things you can do with the programming language R. You don't need to be familiar with R or programming languages in general. Just know that R is a popular tool for data manipulation, calculation, and visualization. And for our final data analysis phase, we have ACT. This is the exciting moment when the business takes all of the insights you, the data analyst, have provided and puts them to work in order to solve the original business problem, and will be acting on what you've learned throughout this program. This is when you'll prepare for your job search and have the chance to complete a case study project. It's a great opportunity for you to bring together everything you've worked on throughout this course. Plus, adding a case study to your portfolio helps you stand out from the other candidates when you interview for your first data analyst job. Now you know the different steps of the data analysis process and how our course reflects it. You have everything you need to understand how this course works. And my fellow Googlers and I will be here to guide you every step of the way.
Regardless of what type of data analysis you're conducting, the process is generally the same. The example that I'll walk through is that of our employee engagement survey, but you can imagine that this process applies to just about any data analysis that you're going to conduct as an analyst. The first thing you want to do is ask. You want to ask all of the right questions at the beginning of the engagement so that you better understand what your leaders and stakeholders need from this analysis. So the types of questions that I generally ask are around, what is the problem that we're trying to solve? What is the purpose of this analysis? What are we hoping to learn from it? So after you've asked all the right questions and you've wrapped your arms around the scope of the analysis you need to conduct, the next step is to prepare. We need to be thinking about what type of data we need to answer those key questions. This could be anything from quantitative data or qualitative data. It could be cross-sectional or point in time versus longitudinal over a long period of time. We need to be thinking about the type of data we need in order to answer the questions that we've set out to answer based on what we learned when we asked the right questions. We also need to be thinking about how we're going to collect that data, or if we need to collect that data. It may be the case that we need to collect this data brand new, and so we need to think about what type of data we're going to be collecting and how. For our employee engagement survey, we do that via a survey of both quantitative and qualitative questions. But it may actually be the case that for many analyses, the data that you're looking for already exists. Then it's a question of working with those data owners to make sure that you're able to leverage that data and use it responsibly. After you've done all the hard work to collect your data, now you need to process that data. It begins with cleaning. This, to me, is the most fun part of the data analytics process. We can think of it as the initial introduction or the handshake, hello to your data. This is where you get a chance to understand its structure, its quirks, its nuances, and you really get a chance to understand deeply what type of data you're going to be working with and understanding what potential that data has to answer all of your questions. This is such an important part, too, where we're running through all of our quality assurance checks. For example, do we have all of the data that we anticipated we would have? Are we missing data at random, or is it missing in a systematic way such that maybe something went wrong with our data collection effort? If needed, did we code all of our data the right way? Are there any outliers that we need to treat differently? This is the part where you spend a lot of time really digging deeply into the structure and nuance of the data to make sure that you're able to analyze it appropriately and responsibly. After cleaning our data and running all of our quality assurance checks, now is the point where we analyze our data, making sure to do so in as objective and unbiased a way as possible. To do this, the first thing we do is run through a series of analyses that we've already planned ahead of time based on the questions that we know we want to answer from the very, very beginning of the process. One thing that's probably the hardest about this particular process, the hardest thing about analyzing data, is that we as analysts are trained to look for patterns. And over time, as we become better and better at our jobs, what we'll often find is that we can start to intuit what we might see in the data. We might have a sneaking suspicion as to what the data are going to tell us. And this is the point where we have to take a step back and let the data speak for itself. As data analysts, we are storytellers, but we also have to keep in mind that it is not our story to tell. That story belongs to the data, and it is our job as analysts to amplify and tell that story in as unbiased and objective a way as possible. The next step is to share all of the data and insights that you've generated from your analyses. Now, typically for our employee engagement survey, we start by sharing the high-level findings with our executive team. We want them to have a landscape view of how the organization is feeling, and we want to make sure that there aren't any surprises as they dig deeper and deeper into the data to understand how teams are feeling and how individual employees are feeling. All of this work, from asking the right questions to collecting your data to analyzing and sharing, doesn't mean much of anything if we aren't taking action on what we've just learned. This, to me, is the most critical part, especially of our employee engagement survey. I like to say that the survey is actually the easy part, and acting on the results is really where the real work begins. This is where we use all of those data-driven insights to decide what types of interventions we want to introduce, not only at the organizational level, but also at the team level as well. So we might find, for example, that the organization is working on a series of interventions to help improve part of the employee experience, whereas individual teams have additional roles and responsibilities to play to either bolster some of those efforts or to introduce new ones to sort of better meet their team where their strengths and opportunity areas are. The data analysis process is rigorous, but it is lengthy. And I can completely appreciate that we as data analysts get so excited about just diving right into the data and doing what we do best. The challenge is that if we don't work through the process in its entirety, if we try to skip steps, we're not going to be able to elicit the insights that we're looking for. I absolutely love my job. I have such a deep appreciation for data and what it can do and what type of insight we can derive from it.
I'm looking forward to introducing you to some of the tools data analysts use each and every day. There are tons of options out there, but the most common ones you'll see analysts use are spreadsheets, query languages, and visualization tools. And this video is going to give you a quick look at how these tools are being used by data analysts every day. Believe it or not, I was several years into my accounting and finance career before I saw all of these tools working together. At that point, I was very experienced with spreadsheets and had worked in large data sets with some of the traditional database programs. I had the foundational skill set to use query languages, and I had dabbled in visualizations, but I had never brought them all together. Then I got hired here at Google, and it was so eye-opening to come into a place like this with an abundance of information everywhere you look. As an analyst at Google, the true power of these tools became so much clearer to me. I became more focused on really maximizing everything these tools could do, streamlining my reporting, and just making my work simpler. All of a sudden, I had a lot more time and space to dedicate to identifying new problems to solve and driving decision-making. Without a doubt, once you've learned the power of these tools, you will be well on your way to becoming the best data analyst you can possibly be. All right, I hope that story has you even more motivated for this course. Let's get started with spreadsheets. Again, there are lots of different spreadsheet solutions, but two popular options are Microsoft Excel and Google Sheets. To put it simply, a spreadsheet is a digital worksheet. It stores, organizes, and sorts data. This is important because the usefulness of your data depends on how well it's structured. When you put your data into a spreadsheet, you can see patterns, group informations, and easily find the information you need. Spreadsheets also have some really useful features called formulas and functions. A formula is a set of instructions that performs a specific calculation using the data in a spreadsheet. Formulas can do basic things like add, subtract, multiply, and divide. But they don't stop there. You can also use formulas to find the average of a number set, look up a particular value, return the sum of a set of values that meets a particular rule, and so much more. A function is a preset command that automatically performs a specific process or task using the data in the spreadsheet. That sounds pretty technical, I know. So let's break it down. Just think of a function as a simpler, more efficient way of doing something that would normally take a lot of time. In other words, functions can help make you more efficient. Those are the spreadsheet basics for now. Later on, you'll see them in action and start working with spreadsheets yourself. The next data analysis tool is called query language. A query language is a computer programming language that allows you to retrieve and manipulate data from a database. You'll learn something called structured query language, more commonly known as SQL. SQL is a language that lets data analysts communicate with a database. A database is a collection of data stored in a computer system. SQL is the most widely used structured query language for a couple of reasons. It's easy to understand and works very well with all kinds of databases. With SQL, data analysts can access the data they need by making a query. Although query means question, I like to think of it as more of a request. So, you're requesting that the database do something for you. You can ask it to do a lot of different things, such as insert, delete, select, or update data. Okay, that's a top-level look at SQL. In a later video, we'll explore it further and use SQL to do some really cool things with data. Lastly, let's talk about data visualization. You've learned that data visualization is the graphical representation of information. Some examples include graphs, maps, and tables. Most people process visuals more easily than words alone. That's why visualizations are so important. They help data analysts communicate their insights to others in an effective and compelling way. When you think about the data analysis process, after data is prepared, processed, and analyzed, the insights are visualized so it can be understood and shared. This makes it easier for stakeholders to draw conclusions, make decisions, and come up with strategies. Some popular visualization tools are Tableau and Looker. Data analysts like using Tableau because it helps them create visuals that are very easy to understand. This means that even non-technical users can get the information they need. Looker is also popular with data analysts because it gives them an easy way to create visuals based on the results of a query. With Looker, you can give stakeholders a complete picture of your work by showing them visualization data and the actual data related to it. All visualization tools have great features that are useful in different situations. Soon, you'll learn how to decide which tool to use for a particular job. And that's everything you need to know about the data lifecycle and the data analysis process. You'll get a chance to test out what you know so you can feel confident moving forward in this course. Feel free to take some time to refamiliarize yourself with the concepts. And when you're ready, give it your best shot. If you're ever unsure of an answer, you can always go back and review the videos and readings. Then you'll be ready to move on to the next set of videos where we'll continue exploring the data analytics tools you've already covered, and you'll get some really fascinating insights into exactly how they work. Before long, you'll have the knowledge and confidence to start using them yourself. Stay tuned. Welcome back. In the next few videos, you'll continue to explore the data analytics tools we discussed earlier, and you'll get the chance to see them in action a little bit. This will give you a clearer picture of how to use these tools. The rest of the program will build on from what you learned here. We'll start with a closer look at spreadsheets. We'll break spreadsheets down to their basics to better understand a few of their features and functions. You'll also learn how you might want to use them in your work as a data analyst. For example, how do you sort your data to make it easier to use? We'll find out. Next, we'll see SQL in action. Data analysts use SQL in their work all the time, like when they need a large amount of data in seconds to help answer a quick business question. Chances are you're not familiar with SQL. That's okay. You'll learn how using SQL is just like ordering food at a super speedy restaurant. Your SQL query might not be as delicious, but you won't have to wait long to get your order. Speaking of food, what better topic than dessert? You can think of data visualization as the dessert to the meal of data analytics. It's served at the end of your analysis after you've done what you need to get the right data for a question or task. We've already seen that visualizations come in a lot of forms, like graphs or charts. And just like dessert, they're a treat to look at. You'll learn more about these visual representations and see other examples of how they might look. Then, you'll get to talk about visualizations with other future data analysts just like yourself. We'll wrap things up with an assessment, but you'll have time to review what you've learned before then. Okay, let's keep going. By the way, is anyone else hungry now? On October 17th, 2019, we celebrated the 40th anniversary of a very special event. Well, special for people like me anyway. In 1979, VisiCalc was introduced to the world as the first computer spreadsheet program. While spreadsheets have changed a lot since then, it was still an important achievement. And so now we celebrate October 17th every year as Spreadsheet Day. While there's a good chance you've never been to a Spreadsheet Day party, spreadsheets are a big part of data analytics. The sooner you make friends with spreadsheets, the better. Trust me, they'll save you a lot of time as a data analyst and make your job easier. This spreadsheet is one example of how an organized spreadsheet might look. In this video, we'll demonstrate some basic spreadsheet concepts for all of you who are new to this world. This might be a review for some of you more experienced folks out there, but it never hurts to practice what you know. Plus, you might still learn a new trick or two. I showed you this image earlier. Let's explore it further because it's a great example of the three main features of a spreadsheet: cells, rows, and columns. They'll be a part of almost everything you do in a spreadsheet, from making a simple grocery list to analyzing a complex data set. I use spreadsheets to manage everything from my own personal finances to the annual homecoming party my friends and I have every year. I'm the planner, so I use a spreadsheet to keep things in order, making sure we have everything we need. Speaking of keeping things in order, the columns in a spreadsheet are ordered by letter, and the rows are ordered by number. So when you talk about a specific cell, you name it by combining the column, letter, and row number where the cell is located. For example, in this spreadsheet, the word row is in cell D3. Pretty simple, right? Let's get started in an actual spreadsheet. You can complete all of these steps in just about any spreadsheet program. Let's get to know your spreadsheet a little better now. All right, we'll start with some basic operations. Keep in mind, as an analyst, you won't always create your own data sets, but for now, let's do just that. I'll click in cell A2 and type my first name in the cell like this. Next, I'll click in cell B2 and type my last name. Don't worry if your name doesn't fit in the cell. You can always make the columns wider if you need to. All you have to do is click and drag the right edge of the column until the name fits. Or you can also use the text wrapping feature, which will set cells to automatically change their height and allow the text in the cell to fit. To use this feature, select the cells, columns, or rows with text. Then use the Format menu to look at the text wrapping options. It is automatically set to allow the text to overflow out of the cell. But you can wrap the text instead, so all of the text is visible. The clip option will cut off the text in the cell, so only the text that fits is visible. There it is. We've added data. Now let's label the data. This is important for organization. Adding labels to the top of the columns will make it easier to reference and find data later on when you're doing analysis. The column labels are usually called attributes. An attribute is a characteristic or quality of data used to label a column in a table. You might hear them called variables, or a few other names too. All right, let's add some attributes to our data. I'll click in cell A1 and type the words first name. In cell B1, I'll type last name. We'll make these attributes bold so they stand out more. Spreadsheets can be really big, so you want to make sure your data is clearly labeled and easy to find. So let's make these attributes stand out. I can use my cursor to select the cells with the attributes. Then I'll click the bold icon to make the attributes bold. Looking good so far. Ready to add some more data? Let's start with some new attributes. First, I'll add a column for age by typing age in cell C1. Then I'll add two more attributes in the next two columns. Let's go with favorite color and favorite dessert. I'll make them bold too. And to fit the labels in the cells, I'll adjust the size of the columns just like before. Now keep in mind, there are more ways to adjust the size of columns and rows. If you have questions about using spreadsheets, a quick search online will usually help you find what you need. We've also included a reading with more tips and information about spreadsheets. Okay, let's get back to it. Now, I can add my own data to the data set. I'll type in my age and favorite color and dessert in the appropriate cells. Next, I'll add data for two more people. We now have 3 rows of data. In a data set, a row is called an observation. An observation includes all of the attributes for something contained in a row of a data table. In this case, row 3 is an observation of Willa Stein because we see all of her attributes in this row. So now we know spreadsheets let you do lots of things with data. You can store and organize data like we've done in this spreadsheet, but you can go even further and reorganize existing data too. Here, I'll show you how. Let's say we want to organize our data by age. There's a simple way to do that. First, we'll need to select all of our columns with data so that all of it gets reorganized together. Then we can go to our data menu. Here, we have some options. Let's select Sort Range. This will let us choose how to organize the column. Next, we'll choose A to Z, which will organize our numbers in order from the smallest to the largest. Now, we want to watch out for our header row, which is the word age, the attribute for this column. We'll check that box. This makes sure that the word age stays in place. All right, now we're ready to sort. Voila! We just reorganized our data by sorting it from the smallest number to largest. And as we go further, you'll discover lots of other ways to work with data in a spreadsheet, including functions and formulas. Let's finish with a quick example of a formula. You can think of formulas as one way of manipulating data in a spreadsheet. Formulas are like a calculator, but more powerful. A formula is a set of instructions that performs a specific calculation using the data in a spreadsheet. To do this, the formula uses cell references for the values it's calculating. Let me show you. Here we go. We'll click in the next cell in the age column. Then we'll type an equal sign. All formulas begin with this symbol. Next, we type average. This is the function we are using in the formula. We've briefly discussed how functions work before, but it's okay if you don't completely understand them yet. We'll take a closer look later on. In this case, we follow the function average with the left parentheses. Now, we can add the names of the cells where we find the data we're using. These are the cell references the formula will use to make its calculation. We'll start at the top with cell C2. C2 represents the value in the cell, in this case, 36. Then we'll add a colon next to it, which shows that we have a range of numbers in consecutive cells. Finally, we complete our formula by adding the last cell reference in the range, C4, and a right parentheses to end it. Then we press enter to perform the calculation. And there it is. The formula has given us the average age of the ages in this data set. We've just analyzed some data. We'll want to store the data for later use. In Google Sheets, a spreadsheet is automatically saved in your Google Drive. For Excel and other spreadsheets, you'll save them as a file. And now you know some basics for using spreadsheets. Once you're used to these concepts, you'll be able to learn even more about spreadsheet tools. It's a lot to digest, so feel free to rewatch and practice on your own. You can even make your own version of this spreadsheet with your own data. We'll work together in the spreadsheet soon as well. For now, good job for sticking with me through this. It'll be worth it. As you might remember, earlier we touched on the query language SQL. In this video, you'll see SQL in action and finally learn what you can do with it by taking a look at some examples of specific queries. I guess you can call this the SQL sequel. We'll try to make this one at least as good as the first. Remember, SQL can do lots of the same things with data that spreadsheets can. You can use it to store, organize, and analyze your data, among other things. But like any good SQL, it is on a larger scale. Bigger, more action-packed. Think of it as supersized spreadsheets. For example, you might want to consider a spreadsheet when you have a smaller data set, like 100 rows. But if your data seems to go on forever and your spreadsheet is struggling to keep up, SQL would be the way to go. When you use SQL, you'll need a place where the SQL language is understood. If you've ever gone somewhere and not known the language, it can be challenging to communicate. You might think you're asking for one thing and get something completely different. Well, SQL knows that feeling. SQL needs a database that will understand its language. So let's talk. There are a number of databases out there that use SQL. You may use several of them during your time as a data analyst. But here's the thing. No matter which database you use, SQL basically works the same in each. For example, in SQL, queries are universal. We've talked about queries before, but it never hurts to have a refresher. A query is the way we use SQL to communicate with the database. Here's the structure of a basic query. You can see that with this query, we can select specific data from a table. By adding where, we can filter the data based on certain conditions. All right, let's get started. We'll open our database and see how SQL can communicate with it to do some simple data tasks. First, let's select our data. We'll use an asterisk to select all of the data from the table. And with that simple query, the database calls up the table we need. Magic. Let's add where to the query to show how that changes what data we get. You can see that the data now only shows movies that are in the action genre. And that's it. A basic query in SQL. Pretty cool, huh? There are plenty of other commands that you'll use in queries as you continue. For now, though, we can celebrate learning about three big ones: select, from, and where. As you continue the program, you'll have the opportunity to use SQL yourself. So I hope that this video was a useful sneak peek at what's coming later. Like with any new language, learning it takes time. And now, it's time to move on.
I'm Angie. I'm a program manager of engineering at Google. I'm currently working on the data analytics certificate, and previously I was a researcher in people analytics. I was also what I call an analytical mercenary, working for a lot of different companies to help them make sense of their data. Every time I learn a new skill, I feel like I'm learning how to speak all over again. I remember the first time I learned SQL, I was so frustrated because everyone around me it felt like they were fluent. They knew exactly what they were doing. And I remember struggling with the most basic things, just like getting the data out of the table, right? Or I remember somebody asked me just to find like an average of something, and I kept on getting an error. And it really does feel like you're learning a new language and you're at toddler level and everyone around you is like maybe fluent. So my parents immigrated to this country when they were in their 30s. So after, they had learned another language and they had to start over and learn, English. And I remember as a child watching them struggle every day to pick up a new language, to do really basic things, like ask for help at the grocery store. I remember calling the cable company when I was 6, asking them questions about the bill because my parents couldn't. And I remember how hard they worked to learn this new language and to become fluent, and every time I'm learning a new data language like SQL or R, I think about how hard that must have been. And I think if they can do that, I can learn SQL. If they can ask for help for the most basic of things, I can ask the data analyst next to me, how to write a SQL statement, how to get data out of a table. And that's really helped me, is just having that mindset and knowing that I can ask for help.
Wow, your data analysis toolbox is getting full. Learning about both spreadsheets and SQL will get you far in the world of data analysis. There's more to learn, of course, and lots more tools you'll be able to use. But your future is looking bright. And it's about to look even brighter, because we're here to talk more about data visualization. I'll tell you a little more about the role of data visualization tools in data analytics and give you a chance to see those tools in action later in this video. You might remember that data visualization is the graphical representation of information. For tons of data analysts, it's the most exciting part of their job because they get to see their hard work pay off with something interesting. Not to mention that data visualization is beautiful and useful. I was floored when I got to Google and started to get a quarterly data report in my email. It had a big slide deck where people contributed their visualizations. It was definitely a source of light as I started to build my own visualizations. If you're not impressed by my story, let me tell you about Florence Nightingale. Does that name ring a bell? She's responsible for much of the philosophy of modern nursing. And believe it or not, she was also a data analyst. During the Crimean War in the 1850s, thousands of soldiers were dying every day. Nightingale wanted to find a way to reduce the number of deaths. After examining the data, she found that the majority of soldiers were dying from preventable conditions. To convince hospital administrators that they needed to focus on these conditions, she created a chart showing the number of deaths over several months. The much larger blue sections in the visualization represent the preventable deaths. Her work directly led to major changes in patient care. And she did all of this over 150 years ago without a computer. One of the main reasons Nightingale created this visualization was to make the data easier to digest for her audience. She felt she'd be more successful convincing the stakeholders using visuals instead of just words and numbers. She was right. Tables filled with data, while necessary for analysis, just aren't able to show trends and patterns as quickly and clearly as visualizations can. Imagine you receive an assignment that needs to be completed the same day. You gather the data you need in a table. Could you explain your findings using the table? Yes, you probably could. But a better idea would be to use a visualization like this bar graph. Something like this makes it much easier for you to explain quickly. And you've got the benefit of a cool graphic to back up your analysis. As a data analyst, you'll want to create visualizations that make the data easy to understand and interesting to look at. So show it off. Stakeholders may not have much time to devote to the data. Your job will be to make their time worthwhile. Let's go back to that data table we created earlier in the course. If you created your own for practice, you can open it up now or try this out later. Here's the data we added before. Let's create a visualization of the data by inserting a chart, a bar graph. Boom. You can see that the spreadsheet visualized the data from our table in a way that made the most sense. It created a bar graph or column chart to compare the ages of each person by name. But you might have figured that out already. That's the beauty of visualization. It shows data analysis quickly and clearly. We can use Chart Editor to adjust the chart. Different spreadsheet programs might have different ways to do this, but they all have visualization functions and ways to edit those visualizations. All right, for now, let's just look at the suggested charts. We can make the bars go horizontally using a bar chart. That looks great. So let's close the chart editor. There are lots of options to look at, but we'll keep it basic for now. Feel free to try other visualizations if you practice later. Now we can adjust our chart to make our whole spreadsheet look clean and professional. Excellent. I hope you learned to love data visualization as much as I do. Maybe you'll become a data visualization pioneer just like Florence Nightingale. As a budding data analyst, you've started to fill your utility belt with valuable tools that you'll use throughout the rest of the program. Having spreadsheets, SQL, and data visualization know-how will help make you an ace data detective. You'll be able to use these tools throughout the data analytics process as you move forward. Coming up next, you'll complete a few activities to wrap up this part of the program. You'll also complete an assessment to check your understanding of all that you learn. This is a great opportunity to think about some of the areas that you'll continue to explore in this course and in your career. As always, feel free to review the videos and readings to help remind you of certain topics and ideas, even if you already feel prepared. You're just a few steps away from the next course. That's great progress. Keep it up.
My name is Lila Jones, and I am a part of our cloud team. I get a chance to lead a team of amazing individuals that are focused on helping customers get to the cloud. Data visualizations. That's a long word, and that can also make your eyes glaze over. But I wonder if when you were little and you were with your parents, maybe they had a bedtime routine, or maybe you have children, you're doing a bedtime routine with them, you very rarely are going to come to those children with a bunch of facts and figures before they go to bed. But I bet you probably are telling them a story. You're showing them pictures. I know I always loved comic books. Pictures tell a story. Data visualizations are pictures. They are a wonderful way to take very basic ideas around data and data points and make them come alive. You can do all different types of combinations of visualizations, but the ones that are interactive, wow, those are huge. Can you imagine being an executive in an organization and trying to figure out, wow, should we open up another site in Bangkok? Does that make sense? And us being able to walk in and saying, here's why it makes sense, and having great data visualizations to support all of our points of view makes it a no-brainer. Interestingly enough, I do recall the first time I came across a super amazing visualization. It was in my personal life. I switched my budgeting software from one provider to another. And the provider that I switched to was really focused on every dollar has a job and making sure you're budgeting every single dollar. They gave visualizations that changed depending on what input you would add to it. And it really just changed my entire perspective, the entire thing. So having the data is like having the answer sheet for a test. It really just lets you know that you're going to make good decisions because it's backed up by data.
Hi, in this video, we're going to be taking a look at how you can access Quick Labs from within your Coursera user interface. Let's take a look. Here we are, and you're working your way through a course, and you see inside of your left side bar a graded external tool. Now, first of all, you should get excited. That's where you're actually going to apply a lot of these concepts that you learned hands-on inside of our Quick Labs. But how do you get from Coursera to Quick Labs? It's pretty easy. It'll take us just about a minute. So what you're going to do, you land on this page. We have some tips and tricks here for you, and I'll walk you through one key important one. The number one thing that I normally get wrong when I'm recording these videos or taking Coursera courses with Quick Labs myself is that you want to make sure that you're in a private browsing or an incognito mode window inside of your browser. Why would you want to do that? Well, if you're logged into Coursera with incognito, and keep in mind you might have to go through a CAPTCHA by selecting some images to make sure that you're not a robot before you go through, it allows you not to accidentally make the mistake of logging into Quick Labs or Coursera with any email that you don't intend to. So once you're here and making sure that you're in an incognito window, and if you're using Chrome in the upper right hand corner, you can just verify there's this little incognito icon here, then you're good to go. All you got to do is scroll down to the bottom, click the I understand box, add your initials, and the most important thing that you're going to see is Open Tool. In the lower right hand corner, this button will become nice dark blue once you've checked that button. You open the tool and you'll see a new browser window come up. Now, unless you want to hear my voice again, you can just click skip this video because that's just an introduction. There's also an X in the upper right hand corner for you, which will then take you into the Quick Lab itself. So to do your work, you should now have two different tabs in your browser. One has all the video lectures inside of Coursera, and the other has the actual hands-on Quick Lab. And that's going to be the subject of our next video, where you can learn all about how you can get credit for your work done inside of the Quick Labs. We'll see you there. Welcome to Quick Labs. Now it's time to get hands-on practice on a lot of the amazing data analyst concepts that you've learned so far. Here's where you get to prove that you've learned some great technologies, and then you'll get credit for it back inside of Coursera. But before you jump right in, let me just give you a quick walkthrough of what a Quick Lab is, and then we'll get started. First and foremost, in the upper left-hand corner, you notice a gigantic tempting button called Start Lab in green. I want to go ahead and start that. Click this box that says I'm not a robot. select a few of the different items for your captures. You can see this is the hardest part of the lab, is trying to actually get through the anti-robot technology that they have here. Now, a couple things happen in the background. As author of these labs, this is some of our best work that we're getting you hands-on practice for. And what we're going to do next is just make sure that that timer starts counting down, because then that's going to give you the account logins that you need to practice the work inside of the lab. Now, here's what you're going to do. There's going to be a gigantic big button that says Open Google Cloud Console. I want you to go ahead and click on that. And now you have 3 browser tab windows open, or 100 if you're like me. And in the second browser, this is your Quick Labs login. All the way under username, what I want you to do is copy that username. And here's the #1 mistake that I've seen students make. When you're back into Google, everyone sees this Google sign-in screen here, and they immediately start typing in their personal Gmail address. You don't want to be charged for any of the resources that you're going to be using. That's why we're providing you with this Quick Labs account yourself. And all I'm going to do is paste in the email that's been given to me by the Quick Lab for use for an hour, and then click Next. And then I'm going to go ahead and grab the password, paste that in here. And then you're going to see a bunch of terms and conditions because this is a brand new account. Scroll through the terms and conditions, read them at your leisure, click Accept. And as you work through the terms of service here, eventually you'll land on the homepage for Google Cloud. Scroll down, read the terms of service, accept terms of service. All the steps that I'm walking you through right now are also available inside of the lab written instructions as well. So once you've gotten that out of the way, let's take a look at what this particular Quick Lab is going to teach you. At a high level, I'm not going to do the lab for you, but don't worry, it's step by step. You'll have a blast doing it. And you have way more than enough time you need in this timer before your lab timer runs out. Generally, as lab authors, we try to double the budget of allowed time, so don't worry about lab timeouts. So inside the lab, every lab will start with an overview, and then what specifically it is that you're going to do. Inside of this lab, since you're a data analyst, you're going to be creating spreadsheets and adding files and sharing files with some of your other data analysts. If you forget what section you're in, another pro tip that I like to do is on the right-hand side, you can actually click between each of the different header sections right here as I'm doing now, and you can jump to a particular section inside of the workbook. So say you and your friends are working on this together, you can say, hey, I'm having trouble on the share and collaborate section. You can just click on that and it'll jump right to that section. Well, that's pretty much it. A few more housekeeping items and then you're off to the races. As you work your way through the lab, you want to make sure that you're completing the objectives and making sure that you're staying on track. There is intelligence built into the Quick Labs to prevent any kind of behavior that's not part of the lab. So make sure you're following the lab as is. And when you're done with the lab, say I was completed here, all you have to do is click on End Lab, click on OK, and that's going to bring you to a pop-up screen that asks you to rate the lab, add in any comments for the lab authors like me, submit it, and then automatically your score for the work that you've done in the lab is fed back to Coursera, which is pretty cool. And that's it. That was a quick tour of Quick Labs, about 5 minutes, but honestly, you'll have a blast going through these. Good luck. Next, we're going to cover a really important topic, which is how to get help with Quick Labs should you need it. And to do that, we're going to jump back into our Quick Labs user interface. Here I am back inside of the Quick Lab. Inside of the Quick Labs user interface, if you're working through a lab and just something's not acting right or the lab instructions don't seem to be telling you exactly what you need to do, we try our hardest to make sure that the labs are step by step, but at any point in the lower right-hand corner, you can click on the chat bubble. Once we've done that, add in your name, add in your email, and you can optionally define the department for Quick Labs. I'm going to say Quick Labs General Support, and you can start a chat. So let me go ahead and add my name, add my email, and start chat. And then this window will pop up. Now this gets you connected with the Quick Labs live support representative. They're amazing, they're friendly, they've been doing this for years, and likely your problem has already been encountered by somebody before. So don't hesitate, drop them a line, and if they're out of office, it'll automatically create a support ticket where they'll follow up with you from that email address that you provided. That's it. Have fun working through your labs and earning that credit.
Hey, great to have you back. Now it's time to get down to business. We're going to start talking about practical ways businesses are using data and the opportunities that it can create for you. So far, you've learned a lot of practical data analysis skills. With these next couple of videos, we're going to switch gears a little and talk about why you're learning these skills. Hopefully this will give you more perspective into what kinds of opportunities are out there for you. Coming up, we're going to talk more about the kinds of roles data analysts play in different industries, the tasks that these roles require, and the importance of fairness and avoiding bias in analyzing data for business tasks. We'll also talk about opportunities you can tap into and how this program factors into your future success in the data analyst role. So with all that in mind, let's get started. Previously, we learned about what a data analyst does and why that work is so valuable. Now, let's look at where data analysts actually do their work. You'll learn much more about the industries you could work in as a data analyst and how companies in these fields are already using data analytics to do some really cool things. There are so many businesses out there that have a big need for the skills you're learning right now. Across industries like technology, marketing, finance, healthcare, and so many more, real companies are already using data analytics to stay ahead of the curve. And the more they use data in their business, the more they understand just how important data analysts like you are to their success. Let's look at a real-life example of a brand you'll probably recognize, Coca-Cola. Data is changing the way Coca-Cola approaches its marketing strategies. Coca-Cola uses data gathered from consumer feedback to create advertising that speaks directly to different audiences with different interests. How does this work? You know those high-tech Coca-Cola vending machines you see at movie theaters sometimes? It's always fun getting to make your own flavors. Well, those machines have built-in artificial intelligence and data analysis tools. This helps Coca-Cola see all the different kinds of flavor combinations people are coming up with, which they can then use as inspiration for new products. How cool is that? Ever wonder how Google gives you the right answer to any question in just seconds? That's powered by data too. We use all kinds of data to determine a website's reliability and accuracy to make sure you get the most useful results for any search you make. But it isn't just big companies like Coca-Cola and Google that use data. Small businesses everywhere are also starting to take advantage of data-driven insights to improve their operations and make better decisions. Small businesses can use data to do all kinds of things. They might use data analytics to better understand their customers' buying habits, create more effective social media messaging, or, in the case of one city zoo and aquarium, predict the number of daily visitors based on local climate data. City Zoo and Aquarium realized that on rainy days, they were seeing huge drop-offs in attendance, but they had no way to accurately predict when those rainy days would hit. This made staffing a real challenge. Some days they found themselves overstaffed. Other days, they were unprepared for the rush of visitors. To deal with this, data analysts took years of weather records from the zoo and used that data to accurately predict future weather patterns. This made it easy for the zoo to know how much staff they needed when. Because the zoo could predict and manage their staffing needs more accurately, they were able to provide a better experience for visitors and dedicate more resources to creating a better experience for the animals too. We see a similar thing in the healthcare industry. There, data analysts look at clinic attendance data to help hospitals and doctors' offices predict when rush hours will hit so they can be ready for it. Your local city hospital is a great example. Let's say they've been getting complaints about long wait times, sometimes an hour or more, which made it hard for some patients to get the care they needed. So data analysts use data about the hospital's daily foot traffic to help them make more informed decisions about how many doctors they need on staff at any given time. This helped reduce wait times, improve their patients' experience, and make better use of the healthcare workers' time too. Like I said, there are many ways that companies in different industries put data to use, but they can only do that if they have data analysts they can rely on. So you might be wondering how you fit into the equation. Well, you've got plenty of options, but you don't have to decide what industry you want to work in right away. There will be plenty of time to think about that as you make your way through this program. By the time you finish this program, You'll have the core skills that will make you valuable in any industry that makes data-driven decisions, which, as it turns out, is most industries, even zoos. Coming up, we'll check out the business task where data can be helpful, and we'll explore even more how data analysts are empowering businesses through data. I'll see you then.
Hi, I'm Joey, and I work as an analytics program manager within RUSE. Now, RUSE stands for Real Estate and Workplace Services, and my job is to bring data and analytics into the decision-making here, especially with regards to creating a safe and fun work environment. My journey into analytics was a bit different in that I had no plan or really didn't see myself being where I am now. Now, luckily, I started in a rotational program called the HRA program within people operations, which afforded me the ability to play 3 different roles, essentially. I was in a generalist capacity, in a specialist role, and as an analyst. And I really found a love and a passion in the analytical work. I started on the business intelligence team, whose job was to provide SQL-based reporting back to the business. I realized that analytics is the right career path for me when I found myself enjoying coming to work and getting my work done. And I think I can connect that to 2 passions of mine. The first is problem solving. I love taking a complex problem, a mystery, a riddle, and being able to find the answers and come up with the solution. And then the second thing is being able to work with people and help people. In analytics, I feel like the key to success is being able to blend the personal side with the technical side. At the beginning of my career, I focused a little more on the technical pieces, and I wanted to make sure I had the right technical knowledge to be able to answer questions. But what I found is over time, I needed to grow that other side just as much. And I think that my career has allowed me those opportunities to kind of work each of those muscles, the human interaction part and the technical part, to make sure that they're both growing at the end of the day.
For any analyst, for any person that's honestly at the early stages of their career, understanding data, respecting data, knowing how to work with data is incredibly important because my vision is that every role in some form or fashion will involve data, and its use in learning how to extract insights from it will be at the core of any critical role across any company or organization. Generally, in those first 2 years, you're developing the core skill sets that make you a fantastic generalist. And then in the next 2 to 5 years, you're learning about something very specific as it relates to your job. So whether it's the area that you're supporting or maybe a very technical component, like let's say you want to become a SQL expert so that you can manipulate large data sets for financial analysis purposes. Similarly, even if you come into finance as a data analyst, you can pop out of finance and go into what a lot of people like to call the business, which is typically your operations functions, and become a business analyst or a data analyst. There's so many different paths that you can take from the starting point that you really can't predict you're in. I'm just deeply passionate about working with and supporting young people and really giving them a jump start to their career. This stems from, honestly, my own personal experience, where in the first 2 years of my career, I had essentially 0 support from my manager and my direct management chain. Having gone through that experience in my first 2 years, I realized and I experienced how that can slow you down. And especially when you're somebody that has a lot of potential and a lot of ability, you want to be in an environment that fosters that ability and really wants to see you grow. I think it's incredibly important to have programs like these that take away all the barriers, that remove any of the constructs that prevent people from being able to find out what they need to be in an industry like this, to be successful in a role like a data analyst, so that they themselves can dream about where they can go in their career. My name is Tony. I'm a finance program manager at Google. As a data analyst, you'll be tackling business tasks that help companies use data. Coming up, we'll talk more about what a business task actually is and some examples of what they might look like in real data analyst jobs. Let's take a second to think back on the real examples of businesses using data analytics in their operation we've seen before. You might have noticed a common theme across every example. They all have issues to explore, questions to answer, or problems to solve. It's easy for these things to get mixed up, so here's a way to keep them straight when we talk about them in data analytics. An issue is a topic or subject to investigate. A question is designed to discover information, and a problem is an obstacle or complication that needs to be worked out. Coca-Cola had a question about new products. Data analysis gave them insights into new flavors customers already like. The city zoo and aquarium had a problem with staffing. Data helped them figure out the best staffing strategy. These questions and problems become the foundation for all kinds of business tasks that you'll help solve as a data analyst. A business task is the question or problem data analysis answers for a business. This is where you'll focus a lot of your efforts in the work you'll do for future employers. Let's stick with our zoo example and see if we can imagine what a business task for a zoo might look like. We know the problem. Unpredictable weather was making it hard for the zoo to anticipate staffing needs. So maybe the business task could be something like analyze weather data from the last decade to identify predictable patterns. The data analyst could then plan out the best way to gather, analyze, and present the data needed to solve this task and meet the zoo's goals. Then, using data, the zoo would be able to make informed decisions about their daily staffing. So we talked a little about data-driven decision-making in previous videos. But just in case you need a refresher, here it is. Data-driven decision-making is when facts that have been discovered through data analysis are used to guide business strategy. The simplest way to think about decision-making is that it's a choice between consequences, good, bad, or a combination of both. In our zoo example, the zoo had the data they needed to make an informed decision that solved their problem. But what if they had made this decision without data? Let's say they just relied on observation and memory to track the weather and make staffing schedules. Well, we already know that wouldn't have solved their problem long term. Data analytics gave them the information they needed to find the best possible solution to their problem. That's the power of data. Observation and intuition are powerful tools in decision making, but they can only take us so far. When we make decisions based on just observation and gut feelings, we're only seeing part of the picture. Data helps us see the whole thing. With data, we have a complete picture of the problem and its causes, which lets us find new and surprising solutions we never would have been able to see before. Data analytics helps businesses make better decisions, and it all starts with a business task and the question it's trying to answer. With the skills you'll learn throughout this program, you'll be able to ask the right questions, plan out the best way to gather and analyze data, and then present it visually to arm your team so they can make an informed, data-driven decision. And that makes you critical to the success of any business you work for. Data is a powerful tool, and with great power comes, well, you know the rest. And you're doing a super job taking in all of this information. Up next, we'll talk about your responsibility as a data analyst to make sure you're gathering, analyzing, and presenting data in a way that's fair to the people being represented by that data.
Hi, my name is Rachel, and I'm the Business Systems and Analytics Lead at Verily. There are a lot of different types of problems that a data analyst can solve. I've been lucky enough over my career to have seen a lot of them and to take in a lot of very different types of data and help turn that into meaningful answers. I think one of the most important things to remember about data analytics is that data is data. I'm a finance data analyst. And so my role at Verily is to take all of our financial information, all of the information of the money we're spending and the money we're making, and turn that into reports and insights so that our business leads can understand what we're doing. One of the most important things I've done at Verily recently was help create what's called a profit and loss statement for each of our business units. And that means that in real time, our teams can see what their budget is and how they're spending against that budget. And what that does is that helps our teams keep to that budget by either increasing their revenue streams so that they have more money to play with, or pulling back their spending so that they can keep themselves within that budget. And all of that really helps keep us on track as a company and making sure that we're hitting our goals. I've found that data acts like a living and breathing thing. When you have a ton of data points, it can be overwhelming when you first sit down to make sense of it. You have tons of columns, tons of records, tons of different types of data, and finding a way to make sense of that is really hard. And that's where the expertise of a data analyst comes in. It has been some of the most frustrating moments of my career, but also some of the most rewarding work I've ever done when it finally comes together. The best advice I have for any data analyst starting out is keep at it. If the angle you're taking doesn't work, try to find another one. Try to come at it in a different way. Try to ask a different question. Eventually, the data will yield, and you'll get the insights you're looking for.
So far, we've covered the different roles data analysts play in business environments and the kinds of tasks that come with those roles. But data analysts have another important responsibility: making sure their analyses are fair. Now, I know what you're probably thinking. Data is based on collected facts. How can it be unfair? Well, that's a good question. So let's learn what fairness means when we talk about data analysis and why it's important for you as an analyst to keep in mind. Fairness means ensuring that your analysis doesn't create or reinforce bias. In other words, as a data analyst, you want to help create systems that are fair and inclusive to everyone. Sounds simple enough? Well, here's the tough part about fairness in data analytics. There isn't one standard definition of it, but hopefully the way we've just described it can give you one way to think about fairness for right now. But it's about to get a bit trickier. Sometimes conclusions based on data can be true and unfair. What can you do then? Well, let's find out with an example. Let's say we have a company that's notorious for being kind of a boys' club. It's very male-dominated, and there aren't many women employees. This company wants to see which employees are doing well, so they start gathering data on employee performance and their own company culture. The data shows that women just aren't succeeding as often as men in their company. Their conclusion? That they should hire fewer women. After all, women are doing poorly here, right? But that's not a fair conclusion, for a couple of reasons. First, it doesn't even consider all of the available data on company culture, so it paints an incomplete picture. Second, it doesn't think about the other surrounding factors that impact the data, or in other words, the conclusion doesn't consider the difficulties women have trying to navigate a toxic work environment. If the company only looks at this conclusion, they won't acknowledge and address how harmful their culture is, and they won't understand why women are set up to fail within it. That's why it's important to keep fairness in mind when analyzing data. The conclusion that women aren't succeeding in this company is true, but it ignores the other systemic factors that are contributing to this problem. But don't worry, there's a way to make a fair conclusion here. An ethical data analyst could look at the data gathered and conclude that the company culture is preventing women from succeeding, and the company needs to address these problems to boost performance. See how this conclusion paints a much more complete and fair picture? It recognizes the fact that women aren't doing as well in this company and factors in why that could be, instead of discriminating against women applicants in the future. As a data analyst, it's your responsibility to make sure your analysis is fair and factors in the complicated social context that could create bias in your conclusions. It's important to think about fairness from the moment you start collecting data for a business task to the time you present your conclusions to your stakeholders. We'll learn more about bias in the data analysis process later on in another course. For now, let's check out an example of a data analysis that does a good job of considering fairness in its conclusion. A team of Harvard data scientists were developing a mobile platform to track patients at risk of cardiovascular disease in an area of the United States called the Stroke Belt. It's important to call out that there were a variety of reasons people living in this area might be more at risk. With that in mind, these data scientists recognized that fairness needed to be a priority for this project, so they built fairness into their models. The team took several fairness measures to make sure they were being as fair as possible when examining sensitive and potentially biased data. First, they teamed analysts with social scientists who could provide insights on human bias and the social context that created them. They also collected self-reported data in a separate system to avoid the potential for racial bias, which might skew the results of their study and unfairly represent patients. And to make sure their sample population was representative, they oversampled non-dominant groups to ensure their model was including them. It's clear that the team made fairness a top priority every step of the way. This helped them collect data and create conclusions that didn't negatively impact the communities they were studying. Hopefully these examples have given you a better idea of what fairness means in data analysis. But we're going to keep building on your understanding of fairness throughout this program, and you'll get to practice with some activities.
Hi, I'm Alex. I'm a research scientist at Google. My team is called the Ethical AI team, and we're a group of folks that really are concerned not only about how AI and the technology operates, but how it interacts with society and how it might help or harm marginalized communities. So when we talk about data ethics, we think about, what is the good and right way of using data? What are going to be ways that are going to be uses of data that are going to be beneficial to people? When it comes to data ethics, it's not just about minimizing harm, but it's actually this concept of beneficence. How do we actually improve the lives of people by using data? When we think about data ethics, we're thinking about who's collecting the data, why are they collecting it, how are they collecting it, and for what purpose? Because of the way that organizations have imperatives to make money or to report to somebody or provide some kind of analysis, we also have to keep strongly in mind how this is actually going to benefit people at the end of the day. Are the people represented in this data going to be benefited by this? And I think that's the thing you never want to lose sight of as a data scientist or a data analyst. I think aspiring data analysts need to keep in mind that a lot of the data that you're going to encounter is data that comes from people. So at the end of the day, data are people. And you want to have a responsibility to those people that are represented in those data. Second is thinking about how to keep aspects of their data protected and private. We don't want to go through our practice thinking about data instances as something we could just throw on the web. No, there needs to be considerations about how to keep that information and likenesses like their images or their voices or their text. How do we keep that private? We also need to think about how we can have mechanisms of giving users and giving consumers more control over their data. It's not going to be sufficient just to say we collect all this data and trust us with all these data, but we need to ensure that there's actionable ways in which people can consent to giving those data and ways that they can ask for it to be revoked or removed. So data is growing, and at the same time, we need to empower people to have control over their own data. The future is that data is always growing. We haven't seen any kind of evidence that data is actually shrinking. And with the knowledge that data is growing, these issues become more and more peaked and more important to think about.
By now, we know that there are all kinds of jobs in different industries available for data analysts. But now, it's time to think about something just as important. How can you tell if a job is a good fit for you and your career goals? Tough one, right? Don't worry, that's exactly what we'll cover in this video. There's a lot of important factors to think about when searching for your dream job. Let's talk about some of the most common factors first. Industry, tools, location, travel, and culture. Data is already being used by countless industries in all kinds of different ways. Tech, marketing, finance, healthcare. The list goes on. But one thing that's important to keep in mind, every industry has specific data needs that have to be addressed differently by their data analysts. The same revenue data can be used in 3 different ways by data analysts in 3 different industries: financial services, telecom, and tech. For example, a finance analyst at a bank pulls public revenue data of telecom company X to create a forecast that predicts where revenues will be in the future to recommend a stock price. The business analyst at telecom company X uses that same data to advise the sales team. Then a data analyst at the company who created a customer management tool for telecom company X will use that revenue data to determine how efficiently their software is performing. Finance, telecom, and tech all use data differently, so they need analysts who have different skills. It all comes down to what the needs of the industry are. Those needs will determine what kind of task you'll be given, the questions you'll be answering, and even how you'll approach job searching. If you're just starting out, a great way to guide your search is to think first about what you're interested in. Does helping people get healthier sound meaningful to you? Maybe you want to focus on using data to improve hospital admissions. What about helping people save for a happy retirement? You might want a job that uses data to determine risk factors in financial investments. Or maybe you're interested in helping journalism grow in your city. A job using data to help find your local news website find more subscribers could be the perfect role for you. The key is to think about your interest early in your job search. That'll lead you in the right direction, and it'll help you in interviews too. Potential employers will want to know why you're interested in their company and how you can address their needs. So if you can speak about your motivation to work in data analytics during interviews, you'll make yourself stand out in a great way. You'll have options when it comes to where you work and who you work for. But remember, you want to enjoy what you do. So it's a good idea to think about how you want to use your skills, then search for jobs that allow you to do that. Next on the list of things to think about, location and travel. When you start your job search, you need to make some decisions about where you want to live. So it helps to ask yourself some questions. Does your preferred industry have opportunities in your area? Are you trying to stay local, or would you be happy relocating? How long are you willing to commute to work every day? Will you drive to work, walk, take public transport? Is that possible year-round? How do you feel about working remotely? Does working from home excite you or bore you? And of course, you'll want to consider cost of living and whether or not you want the convenience of city living or a quiet suburban home. And it's not just about where you'll be based. Some jobs may ask you to travel, which could be an exciting chance to see the world or a deal breaker. It's all about what you want out of this job. So start asking yourself some of these questions. Figuring out the answers can help you narrow down your search even further, so you're only looking at jobs you'd actually accept. Once you've answered enough questions, you'll be able to identify some specific companies that fit your needs. At this point, it's a good time to think about your values and what kind of company culture is a good fit for you. Ready? Here come some more questions. Do you work best in a team or by yourself? Do you like to have a set routine, or do you enjoy taking a new project and trying new things? Do your values match the company's values? You'll want to pay attention to these things during your job search and interview process so you can be sure you fully invested in the company you work for. That's the best way to start building an exciting and fulfilling career. This program will help you learn the core skills for data analytics in any setting. It's up to you where you want to take them. Whether that means starting in a completely new industry or moving into an analyst position in an industry you already have experience in. And hopefully what we've covered here has helped you get on track for your future job search. After this, you'll have a few activities to do, and then you'll be able to move on to the next part of this course. We learned a lot so far, like what kinds of opportunities are out there for data analysts in different industries, how data analysts help businesses make better decisions, the importance of fairness in data analytics, and the potential questions you can start asking yourself before your future job search. And you can always look back at these lessons if you want to review. In an upcoming course, we'll look at the skills all successful data analysts have and you'll learn how you can start practicing them too. But before that, you'll have an assessment. Good luck, and I'll see you later.
My name is Sama Moid, and I'm a recruiter here at Google for the large customer sales team. Basically, I hire talent for the sales team here. Even within the sales recruiting space, I recruit specifically for the analytical lead roles here at Google. I want the candidate to be as comfortable as possible. As a recruiter, I'm also their advocate. If they're a good fit for the team, I'd like to present them in the best light. As a recruiter, some advice I would give for a data analyst that's just starting to look for a job: think about a time where you've used data to solve a problem, whether it's in your professional or personal projects. Another tip I would say for a data analyst that's just looking for a new job is to increase your professional network. There are many ways to increase your professional network. One of them is to increase your online footprint, reach out to other analysts on LinkedIn, join local meetups with other data scientists. Sometimes when we're looking for a unique skill set, recruiters are going on websites like LinkedIn and GitHub and trying to find that talent themselves. It's really important to have your LinkedIn updated along with websites like GitHub, where you can showcase a lot of the data analyst projects you've done. Another tip I would say for an in-person interview is to prepare questions for the interviewer. Make sure they're not broad questions. They should be questions that will help you understand the team and the job better. If you're given a case study in an interview, you should expect to be given a business problem along with a sample data set. Then you'd be asked to take that sample data set, analyze it, and come up with a solution. One of the things you can do to help prepare yourself for this is to ensure you are analyzing the data and coming up with a solution that relates back to that data. Sometimes there is no right answer, and a lot of times interviewers are looking to see your thought process and the way you get to your solution. I highly encourage that if you find a role that you're interested in, not only apply to it, but go the next step. Look for the recruiter, look for the hiring manager online, see if you can reach out to them and set up a coffee chat, or send them your resume directly. Online applications could be a really big black hole where you never hear back from the recruiter or the team. When you reach out directly to a hiring manager or recruiter, it really shows your eagerness for the role and your interest for the role. Even if sometimes you don't get a response from reaching out, you never know. You try multiple different times, and that one time you get a response back from a recruiter or hiring manager could be the time you get the job that you really wanted.
We're at the end of this course, which means it's time to show off what you've learned. We've covered the different kinds of industries using data to drive decisions and how you can help them, how to promote fairness in your data work, and opportunities that are out there in the world of data analytics. I know you've got this, and once you finish the course challenge, I'll be right here to introduce you to the next course. Congratulations on finishing this first course. You've already learned a lot, and you're ready to take what you've learned and move forward. And if you ever need a refresher, just remember that these videos will still be here whenever you need them. You might remember your next instructor from our introduction at the beginning of the intro course. Get ready to meet my fellow Googler and your instructor for the next course, Jimena. She's ready to help you get started on your next step towards finishing this program and becoming a data analyst. This next course will build directly on some of the topics that you've learned so far and give you insight into the things we've already talked about. Like any good detective, you'll learn how to ask the right questions and use data to find answers. Employees in every industry need to become comfortable asking questions, but this can especially be true for data analysts. A lot of data analysts try to make their work perfect the first time, even though they might not have all the information. Instead of asking questions, they make assumptions. That can lead to mistakes. It's so much better to be humble and inquisitive, and to ask questions. I'll show you what I mean. One of the analysts I supervised came into Google with no coding experience. He was nervous about leaving a great first impression, so he tried to study up on multiple languages by himself before he started. When the work actually began, he didn't ask us, his team, questions, or ask us for help when he ran into roadblocks. There are a lot of great places to find answers, especially online, and his initiative helped him find some of those places. But at the end of the day, he forgot to tap into his best resource, us, his team. Because he was nervous about how he would be perceived if he asked us for help, he almost missed out on some great insights from his team members. As roadblocks persisted, he realized he needed to make a change. He stopped trying to guess expectations, processes, and more all on his own and started asking us more questions. As soon as he embraced this new approach, he skyrocketed on our team. His learning went straight up the curve like a hockey stick. His impact on the organization, the number of people who reach out to him, and his career path going forward all did the same. The bottom line is, you don't need to know it all. The saying is true. There are no bad questions. Being open to learning is one of the most important qualities for a data analyst. Speaking of learning, in the next course, we'll go into more depth learning about basic spreadsheet skills and when you'll need to use them. You'll discover how to apply structured thinking to data work, and you'll focus on how to best meet stakeholder needs and expectations by gathering all the clues. Great work, and good luck on the next course.
Welcome to the second course in the Google Data Analytics Certificate. If you completed Course 1, we met briefly at the beginning. But for those of you who are just joining us, my name is Jimena, and I'm a Google Finance Data Analyst. I think it's really wonderful that you're here with me learning about the fascinating field of data analytics. Learning and education have always been very important to me. When I was young, my mom always said, "I can't leave you an inheritance, but I can give you an education that opens doors." That always pushed me to keep learning, and that education gave me the confidence to apply for my job at Google. Now, I get to do really meaningful work every day. Just recently, I worked as an analyst on a team called Verily Life Sciences. We were helping to get life-saving medical supplies to those who need it most. To do this, we forecasted what healthcare professionals would need on hand and then shared that information with networks. The information that my team provided helped make data-driven decisions that actually saved lives. I'm thrilled to be your instructor for this course. We're going to talk about the difference between effective and ineffective questions and learn how to ask great questions that lead to insights that can help you solve business problems. You will discover that effective questions help you to make the most of all the data analysis phases. You may remember that these phases include ask, prepare, process, analyze, share, and act. In the ask step, we define the problem we're solving and make sure that we fully understand stakeholder expectations. This will help keep you focused on the actual problem, which leads to more successful outcomes. So we'll begin this course by talking about problem solving and some of the common types of business problems that data analysts help solve. And because this course focuses on the ask phase, you'll learn how to craft effective questions that help you collect the right data to solve those problems. Next, we'll talk about the many different types of data. You'll learn how and when each is the most useful. You'll also get a chance to explore spreadsheets further and discover how they can help make your data analysis even more effective. And then we'll start learning about structured thinking. Structured thinking is the process of recognizing the current problem or situation, organizing available information, revealing gaps and opportunities, and identifying the options. In this process, you address a vague, complex problem by breaking it down into smaller steps. And then those steps lead you to a logical solution. We'll work together to be sure you fully understand how to use structured thinking in data analysis. Finally, we'll learn some proven strategies for communicating with others effectively. I can't wait to share more about my passion for data analytics with you, so let's get started. In this video, I'm going to share an interesting data analytics case study. It will illustrate how problem solving relates to each phase of the data analysis process and shed some light on how these phases work in the real world. It's about a small business that used data to solve a unique problem it was facing. The business is called Anywhere Gaming Repair. It's a service provider that comes to you to fix your broken video game systems or accessories. The owner wanted to expand his business. He knew advertising is a proven way to get more customers, but he wasn't sure where to start. There are all kinds of different advertising strategies, including print, billboard, TV commercials, public transportation, podcasts, and radio. One of the key things to think about when choosing an advertising method is your target audience. In other words, the specific people you're trying to reach. For example, if a medical equipment manufacturer wanted to reach doctors, placing an ad in a health magazine would be a smart choice. Or, if a catering company wanted to find new cooks, it might advertise using a poster at a bus stop near a cooking school. Both of these are great ways to get your ad seen by your target audience. The second thing to think about is your budget and how much the different advertising methods will cost. For instance, a TV ad is likely to be more expensive than a radio ad. A large billboard will probably cost more than a small poster on the back of a city bus. The business owner asked the data analyst, Maria, to make a recommendation. She started with the first step in the data analysis process, ask. Maria began by defining the problem that needed to be solved. To do this, she first had to zoom out and look at the whole situation in context. That way, she could be sure that she was focusing on the real problem and not just its symptoms. This leads us to another important part of the problem-solving process, collaborating with stakeholders and understanding their needs. For Anywhere Gaming Repair, stakeholders included the owner, the vice president of communications, and the director of marketing and finance. Working together, Maria and the stakeholders agreed on the problem, not knowing their target audience's preferred type of advertising. Next up was the prepare phase, where Maria collected data for the upcoming analysis process. But first, she needed to better understand the company's target audience, people with video game systems. After that, Maria collected data on the different advertising methods. This way, she would be able to determine which was the most popular one with the company's target audience. Then, she moved on to the process step. Here, Maria cleaned the data to eliminate any errors or inaccuracies that could get in the way of the result. As we've learned, when you clean data, you transform it into a more useful format, create more complete information, and remove outliers. Then it was time to analyze. In this step, Maria wanted to find out two things. First, who's most likely to own a video gaming system? And second, where are these people most likely to see an advertisement? Maria first discovered that people between the ages of 18 and 34 are most likely to make video game related purchases. So, she could confirm that Anywhere Gaming Repair's target audience was people 18 to 34 years old. This was who they should be trying to reach. With this in mind, Maria then learned that both TV commercials and podcasts are very popular with people in the target audience. Because Maria knew Anywhere Gaming Repair had a limited budget and understanding the high cost of TV commercials, her recommendation was to advertise in podcasts because they are more cost effective. Now that she had her analysis, it was time for Maria to share her recommendation so the company could make a data-driven decision. She summarized her results using clear and compelling visuals of the analysis. This helped her stakeholders understand the solution to the original problem. Finally, Anywhere Gaming Repair took action. They worked with a local podcast production agency to create a 30-second ad about their services. The ad ran on podcast for a month, and it worked. They saw an increase in customers after just the first week. By the end of week 4, they had 85 new customers. There you go, effective problem solving using data analysis phases in action. Now you've seen how the 6 phases of data analysis can be applied to problem solving and how you can use that to solve real-world problems.
I'm Nikki, and I manage the Education, Evaluation, Assessment, and Research team. My favorite part of the data analysis process is finding the hardest problem and asking a million questions about it and seeing if it's even possible to get an answer. So one of the problems that we've tackled here at Google is our nuclear onboarding program, which is how we onboard new hires. One of the things that we've done is ask the question, how do we know whether or not Nooglers are onboarding faster through our new onboarding program than our old onboarding program, where we used to lecture them? And we worked really closely with the content providers to understand just exactly what does it mean to onboard someone faster. Once we asked all the questions, what we did is we prepared the data by understanding who was the population of the new hires that we were examining. So we prepared our data by going through and understanding who our populations were, by understanding who our sample set was, who our control group was, who our experiment group was, where were our data sources, and make sure that it was in a format that was clean and digestible for us to write the proper scripts for. So the next step for us was to process the data to make sure that it was in a format that we could actually analyze in SQL, making sure that it was in the right format and in the right columns and in the right tables for us. To analyze the data, we wrote scripts in SQL and in R to correlate the data to the control group or the experiment group and interpret the data to understand, were there any changes in the behavioral indicators that we saw? Once we analyze all the data, we want to report on it in a way that our stakeholders could understand. So depending on who our stakeholders were, we prepared reports, dashboards, and presentations, and share that information out. Once all of our reports were complete, we saw really positive results and decided to act on it by continuing our project-based learning onboarding program. It was really satisfying to know that we had the data to support it and that it really, really worked. And not just that the data was there, but that we knew that our students were learning and that they were more productive faster back on their jobs.
Before, I shared how data analysis helped a company figure out where to advertise its services. An important part of this process was strong problem-solving skills. As a data analyst, you'll find that problems are at the center of what you do every single day. But that's a good thing. Think of problems as opportunities to put your skills to work and find creative and insightful solutions. Problems can be large or small, simple or complex. No problem is like another, and they all require a slightly different approach. But the first step is always the same: understanding what kind of problem you're trying to solve. And that's what we're going to talk about now. Data analysts work with 6 basic problem types: making predictions, categorizing things, spotting something unusual, identifying themes, discovering connections, and finding patterns. Think back to our real-world example from the previous video. In that example, Anywhere Gaming Repair wanted to figure out how to bring in new customers. So, the problem was how to determine the best advertising method for Anywhere Gaming Repair's target audience. To help solve this problem, the company used data to envision what would happen if it advertised in different places. Now, nobody can see the future, but the data helped them make an informed decision about how things would likely work out. So, their problem type was making predictions. Now, let's think about the second problem type, categorizing things. Here's an example of a problem that involves categorization. Let's say a business wants to improve its customer satisfaction levels. Data analysts could review recorded calls to the company's customer service department and evaluate the satisfaction level of each caller. They could identify certain keywords or phrases that come up during the phone calls and then assign them to categories such as politeness, satisfaction, dissatisfaction, empathy, and more. Categorizing these keywords gives us data that lets the company identify top-performing customer service representatives and those who might need more training. This leads to happier customers and higher customer service scores. Okay, now let's talk about a problem that involves spotting something unusual. Some of you may have a smartwatch. My favorite app is for health tracking. These apps can help people stay healthy by collecting data such as their heart rate, sleep patterns, exercise routine, and much more. There are many stories out there about health apps actually saving people's lives. One is about a woman who was young, athletic, and had no previous medical problems. One night, she heard a beep on her smartwatch. A notification said her heart rate had spiked. Now, in this example, think of the watch as a data analyst. The watch was collecting and analyzing health data. So, when her resting heartbeat rate was suddenly 120 beats per minute, the watch spotted something unusual because according to its data, the rate was normally around 70. Thanks to the data her smartwatch gave her, the woman went to the hospital and discovered she had a condition which could have led to life-threatening complications if she hadn't gotten medical help. Now let's move on to the next type of problem, identifying themes. We see a lot of examples of this in the user experience field. User experience designers study and work to improve the interactions people have with products they use every day, like apps, websites, and even coffee makers. Let's say a user experience designer wants to see what customers think about the coffee maker his company manufactures. This business collects anonymous survey data from users, which can be used to answer this question. But first, to make sense of it all, he will need to find themes that represent the most valuable data, especially information he can use to make the user experience even better. So, the problem the user experience designer's company faces is how to improve the user experience for its coffee makers. The process here is kind of like finding categories for the keywords and phrases in customer service conversations. But identifying themes goes even further by grouping each insight into a broader theme. Then, the designer can pinpoint the themes that are most common. In this case, he learned users often couldn't tell if the coffee maker was on or off. He ended up optimizing the design with improved placement and lighting for the on-off button, leading to product improvement and happy users. Now we come to the problem of discovering connections. This example is from the transportation industry and uses something called third-party logistics. Third-party logistics partners help businesses ship products when they don't have their own trucks, planes, or ships. A common problem these partners face is figuring out how to reduce wait time. Wait time happens when a truck driver from a third-party logistics provider arrives to pick up shipment, but it's not ready, so she has to wait. That costs both company time and money, and it stops the trucks from getting back on the road to make more deliveries. So how can they solve this? Well, by sharing data, the partner companies can view each other's timelines and see what's causing shipments to run late. Then, they can figure out how to avoid those problems in the future, so a problem for one business doesn't cause a negative impact for the other. For example, if shipments are running late because one company only delivers Monday, Wednesdays, and Fridays, and the other company only delivers Tuesdays and Thursdays, then the companies can adjust to do deliveries on the same day to reduce waiting time for customers. Alright, we've come to our final problem type, finding patterns. Oil and gas companies are constantly working to keep their machines running properly. So the problem is how to stop machines from breaking down. One way data analysts can do this is by looking at patterns in the company's historical data. For example, they could investigate how and when a particular machine broke down in the past, and then generate insights into what led to the breakage. In this case, the company saw a pattern indicating that machines began breaking down at faster rates when maintenance wasn't kept up in 15-day cycles. They can then keep track of current conditions and intervene if any of these issues happen again. You've now learned the 6 basic problem type data analysts typically face. As a future data analyst, this is going to be valuable knowledge for your career.
Hi, I'm Anmol. I'm the head of large advertiser marketing analytics within the marketing team at Google. At its core, my job is about connecting the right user with the right message at the right time. The first step is really to get a broad sense of a certain pattern that's occurring. So, for example, we know that this particular segment of users is more responsive to this type of content. Once we're able to actually see this hypothesis through the data, we do testing to ensure that the hypothesis is actually correct. So, for example, we would test sending these pieces of content to this segment of users and actually verify within a controlled environment whether that response rate is actually higher for that type of content or whether it isn't. And so once we're able to actually verify that hypothesis, we go back to the stakeholders, in this case our marketers, and say, we've actually proven within a relatively high degree of certainty that this particular segment is more responsive to this type of content. And because of that, we're recommending that you produce more of this type of content. And so our stakeholders really get to see the whole sort of evolution from hypothesis to proven concept. And they're able to come with us on the journey on how we're proving out these hypotheses and then eventually turning them into strategies and recommendations for the business. So the outcome in this case was that we were able to actually change the way our whole marketing team worked to actually make it much more user-centric. So instead of, from our perspective, coming up with content that we think the users need, we're actually going in the other direction of figuring out what users need first, proving that they need certain things or they don't need certain things, and then using that information going back to marketers and coming up with content that fulfills their need. So it really changed the direction of how we produce things.
Now that we've talked about 6 basic problem types, it's time to start solving them. To do that, data analysts start by asking the right questions. In this video, we're going to learn how to ask effective questions that lead to key insights you can use to solve all kinds of problems. As a data analyst, I ask questions constantly. It's a huge part of the job. If someone requests that I work on a project, I ask questions to make sure we're on the same page about the plan and the goals. And when I do get a result, I question it. Is the data showing me something superficially? Is there a conflict somewhere that needs to be resolved? The more questions you ask, the more you'll learn about your data and the more powerful your insights will be at the end of the day. Some questions are more effective than others. Let's say you're having lunch with a friend and they say, "These are the best sandwiches ever, aren't they?" Well, that question doesn't really give you the opportunity to share your own opinion, especially if you happen to disagree and didn't enjoy the sandwich very much. This is called a leading question because it's leading you to answer in a certain way. Or maybe you're working on a project and you decide to interview a family member. Say you ask your uncle, "Did you enjoy growing up in Malaysia?" He may reply, "Yes." But you haven't learned much about his experiences there. Your question was closed-ended. That means it can be answered with a yes or no. These kinds of questions rarely lead to valuable insights. Now, what if someone asks you, "Do you prefer chocolate or vanilla?" Well, what are they specifically talking about? Ice cream, pudding, coffee flavoring, or something else? What if you like chocolate ice cream but vanilla in your coffee? What if you don't like either flavor? That's the problem with this question. It's too vague and lacks context. Knowing the difference between effective and ineffective questions is essential for your future career as a data analyst. After all, the data analyst process starts with the ask phase. So it's important that we ask the right questions. Effective questions follow the SMART methodology. That means they're specific, measurable, action-oriented, relevant, and time-bound. Let's break that down. Specific questions are simple, significant, and focused on a single topic or a few closely related ideas. This helps us collect information that's relevant to what we're investigating. If a question is too general, try to narrow it down by focusing on just one element. For example, instead of asking a closed-ended question like, "Are kids getting enough physical activities these days?" ask, "What percentage of kids achieve the recommended 60 minutes of physical activity at least 5 days a week?" That question is much more specific and can give you more useful information. Now, let's talk about measurable questions. Measurable questions can be quantified and assessed. An example of an unmeasurable question would be, "Why did our recent video go viral?" Instead, you could ask, "How many times was our video shared on social channels the first week it was posted?" That question is measurable because it lets us count the shares and arrive at a concrete number. Okay, now we've come to action-oriented questions. Action-oriented questions encourage change. You might remember that problem solving is about seeing the current state and figuring out how to transform it into the ideal future state. Well, action-oriented questions help you get there. So, rather than asking, how can we get customers to recycle our product packaging? You could ask, what design features will make our packaging easier to recycle? This brings you answers you can act on. All right, let's move on to relevant questions. Relevant questions matter, are important, and have significance to the problem you're trying to solve. Let's say you're working on a problem related to a threatened species of frog, and you asked, why does it matter that Pine Barrens tree frogs started disappearing? This is an irrelevant question because the answer won't help us find a way to prevent these frogs from going extinct. A more relevant question would be, what environmental factors changed in Durham, North Carolina between 1983 and 2004 that could cause Pine Barrens tree frogs to disappear from the Sandhills region? This question would give us answers we can use to help solve our problem. That's also a great example for our final point, time-bound questions. Time-bound questions specify the time to be studied. The time period we want to study is 1983 to 2004. This limits the range of possibilities and enables the data analyst to focus on relevant data. Okay, now that you have a general understanding of SMART questions, there's something else that's very important to keep in mind when crafting questions. Fairness. We've touched on fairness before, but as a quick reminder, fairness means ensuring that your questions don't create or reinforce bias. To talk about this, let's go back to our sandwich example. There, we had an unfair question because it was phrased to lead you toward a certain answer. This made it difficult to answer honestly if you disagreed about the sandwich quality. Another common example of an unfair question is one that makes assumptions. For instance, let's say a satisfaction survey is given to people who visit a science museum. If the survey asks, what do you love most about our exhibits? This assumes that the customer loves the exhibits, which may or may not be true. Fairness also means crafting questions that make sense to everyone. It's important for questions to be clear and have a straightforward wording that anyone can easily understand. Unfair questions also can make your job as a data analyst more difficult. They lead to unreliable feedback and missed opportunities to gain some truly valuable insights. You've learned a lot about how to craft effective questions, like how to use the SMART framework while creating your questions, and how to ensure that your questions are fair and objective. Moving forward, you'll explore different types of data and learn how each is used to guide business decisions. You'll also learn more about visualizations and how metrics or measures can help create success. It's going to be great.
Hi, I'm Evan. I'm a learning portfolio manager here at Google. And I have one of the coolest jobs in the world, where I get to look at all the different technologies that affect big data and then work them into training courses like this one for students to take. I wish I had a course like this when I was first coming out of college or high school. It was honestly a data analyst course that's geared in the way like this one is, if you've already taken some of the videos, really prepares you to do anything you want. It'll open all of those doors that you want for any of those roles inside of the data curriculum. Well, what are some of those roles? There are so many different career paths for someone who's interested in data. Generally, if you're like me, you'll come in through the door as a data analyst, and you'll be working with spreadsheets, you'll be working with small, medium, and large databases, but all you have to remember is 3 different core roles. Now, there's many, and there's specialties within each of these different careers, but these 3 are the data analyst, which is generally someone who works with SQL, spreadsheets, databases, might work as a business intelligence team creating those dashboards. Now, where does all that data come from? Generally, a data analyst will work with a data engineer to turn that raw data into actionable pipelines. So you have data analysts, data engineers, and then lastly, you might have data scientists who basically say, the data engineers have built these beautiful pipelines. Sometimes the analysts do that too. The analysts have provided us clean and actionable data, and the data scientists then work to actually turn it into really cool machine learning models or statistical inferences that are just well beyond anything you could have ever imagined. And we'll share a lot of resources and links for ways that you can get excited for each of these different roles. And the best part is, if you're like me, when I went into school, I didn't know what I wanted to do. And you don't have to know at the outset which path you want to go down. Try them all. See what you really, really like. It's very personal. Becoming a data analyst is so exciting. Why? Because it's not just like a means to an end. It's taking on a career path where so many bright people have gone before and have made the tools and technologies that much easier for you and me today. For example, when I was starting to learn SQL, or the structured query language that you're going to be learning as part of this course, I was doing it on my local laptop, and each of the queries would take like 20, 30 minutes to run. And it was very hard for me to keep track of the different SQL statements that I was writing or share them with somebody else. That was about 10 or 15 years ago. Now, through all the different companies and all the different tools that are making data analysis tools and technologies easier for you, you're going to have a blast creating these insights with a lot less of the overhead that I had when I first started out. So I'm really excited to hear what you think and what your experience is going to be.
Welcome back. Now it's time to go even further and build on what you've learned about problem solving in data analytics and crafting effective questions. Coming up, we'll cover a wide range of topics. You'll learn about how data can empower our decisions, big and small, the difference between quantitative and qualitative analysis, and when to use them, the pros and cons of different data visualization tools, what metrics are and how analysts use them, and how to use mathematical thinking to connect the dots. To be honest, I'm still learning more about these things every day, and so will you. Like how quantitative and qualitative data can work together. In my role in finance, most of my work is quantitative. But recently, I was working on a project that focused a lot on empathy and trust, and that was really new for me. But we took those more qualitative things into account during analysis, and that really helped me understand how quantitative and qualitative data can come together to help us make powerful decisions. And now you're on your way to building your own data analyst toolkit. Before you know it, you'll be analyzing all kinds of data yourself and learning new things while you do it. But first, let's start small with the power of observation. We've talked a lot about what data is and how it plays into decision making. So what do we know already? Well, we know that data is a collection of facts. We also know that data analysis reveals important patterns and insights about that data. And finally, we know that data analysis can help us make more informed decisions. Now, we'll look at how data plays into the decision-making process and take a quick look at differences between data-driven and data-inspired decisions. Let's look at a real-life example. Think about the last time you searched restaurants near me and sorted the results by rating to help you decide which one looked best. That was a decision you made using data. Businesses and other organizations use data to make better decisions all the time. There's two ways they can do this, with data-driven or data-inspired decision-making. We'll talk more about data-inspired decision-making later on, but here's a quick definition for now. Data-inspired decision-making explores different data sources to find out what they have in common. Here at Google, we use data every single day, in very surprising ways too. For example, we use data to help cut back on the amount of energy spent cooling our data centers. After analyzing years of data collected with artificial intelligence, we were able to make decisions that help reduce the energy we use to cool our data centers by over 40%. Google's people operation team also uses data to improve how we hire new Googlers and how we get them started on the right foot. We wanted to make sure we weren't passing over any talented applicants and that we made their transition into their new roles as smooth as possible. So after analyzing data on applications, interviews, and new hire orientation processes, we started using an algorithm. An algorithm is a process or set of rules to be followed for a specific task. With this algorithm, we reviewed applicants that didn't pass the initial screening process to find great candidates. Data also helped us determine the ideal number of interviews that lead to the best possible hiring decisions. And we've created new onboarding agendas to help new employees get started at their new jobs. Data is everywhere. Today, we create so much data that scientists estimate 90% of the world's data has been created in just the last few years. Think of the potential here. The more data we have, the bigger the problems we can solve, and the more powerful our solutions can be. But responsibly gathering data is only part of the process. We also have to turn data into knowledge that helps us make better solutions. I'm going to let fellow Googler Ed talk more about that.
Just having tons of data isn't enough. We have to do something meaningful with it. Data in itself provides little value. To quote Jack Dorsey, the founder of Twitter and Square, every single action that we do in this world is triggering off some amount of data. And most of that data is meaningless until someone adds some interpretation of it, or someone adds a narrative around it. Data is straightforward. Facts collected together, values that describe something. Individual data points become more useful when they're collected and structured, but they're still somewhat meaningless by themselves. We need to interpret data to turn it into information. Look at Michael Phelps' time in a 200-meter individual medley swimming race. 1 minute, 54 seconds. Doesn't tell us much. When we compare it to his competitors' times in the race, however, we can see that Michael came in first place and won the gold medal. Our analysis took data, in this case a list of Michael's races and times, and turned it into information by comparing it with other data. Context is important. We needed to know that this race was an Olympic final and not some other random race, to determine that this was a gold medal finish. But this still isn't knowledge. When we consume information, understand it, and apply it, that's when data is most useful. In other words, Michael Phelps is a fast swimmer.
It's pretty cool how we can turn data into knowledge that helps us in all kinds of ways, whether it's finding the perfect restaurant or making environmentally friendly changes. But keep in mind, there are limitations to data analytics. Sometimes we don't have access to all of the data we need, or data is measured differently across programs, which can make it difficult to find concrete examples. We'll cover these more in details later on, but it's important to start thinking about them now. Now that you know how data drives decision making, you know how key your role as a data analyst is to the business. Data is a powerful tool for decision making, and you can help provide businesses with the information they need to solve problems and make new decisions. But before that, you'll need to learn a little more about the kinds of data you'll be working with and how to deal with it. Hi again. So, when it comes to decision making, data is key. But we've also learned that there are a lot of different kinds of questions that data might help us answer. And these different questions make different kinds of data. There are two kinds of data that we'll talk about in this video: quantitative and qualitative. Quantitative data is all about the specific and objective measures of numerical facts. This can often be the what, how many, and how often about a problem. In other words, things you can measure, like how many commuters take the train to work every week. As a financial analyst, I work with a lot of quantitative data. I love the certainty and accuracy of numbers. On the other hand, qualitative data describes subjective or explanatory measures of qualities and characteristics, or things that can't be measured with numerical data, like your hair color. Qualitative data is great for helping us answer why questions. For example, why people might like a certain celebrity or snack food more than others. With quantitative data, we can see numbers visualized as charts or graphs. Qualitative data can then give us a more high-level understanding of why the numbers are the way they are. This is important because it helps us add context to a problem. As a data analyst, you'll be using both quantitative and qualitative analysis, depending on your business task. Reviews are a great example of this. Think about a time you used reviews to decide whether you wanted to buy something or go somewhere. These reviews might have told you how many people dislike that thing and why. Businesses read these reviews too, but they use the data in different ways. Let's look at an example of a business using data from customer reviews to see qualitative and quantitative data in action. Now, say a local ice cream shop has started using their online reviews to engage with their customers and build their brand. These reviews give the ice cream shop insight into their customers' experiences, which they can use to inform their decision making. The owner notices that their rating has been going down. He sees that lately his shop has been receiving more negative reviews. He wants to know why, so he starts asking questions. First are measurable questions. How many negative reviews are there? What's the average rating? How many of these reviews use the same keywords? These questions generate quantitative data, numerical results that help confirm their customers aren't satisfied. This data might lead them to ask different questions. Why are customers unsatisfied? How can we improve their experience? These are questions that lead to qualitative data. After looking through the reviews, the ice cream shop owner sees a pattern. 17 of negative reviews use the word frustrated. That's quantitative data. Now we can start collecting qualitative data by asking why this word is being repeated. He finds that customers are frustrated because the shop is running out of popular flavors before the end of the day. Knowing this, the ice cream shop can change its weekly order to make sure it has enough of what the customers want. With both quantitative and qualitative data, the ice cream shop owner was able to figure out his customers were unhappy and understand why. Having both types of data made it possible for him to make the right changes and improve his business. Now that you know the difference between quantitative and qualitative data, you know how to get different types of data by asking different questions. It's your job as a data detective to know which questions to ask to find the right solution. Then you can start thinking about cool and creative ways to help stakeholders better understand the data. For example, interactive dashboards, which we'll learn about soon. Data is great, but if we can't communicate the story data is telling, it isn't useful to anyone. So we need ways to organize data that helps us turn it into information. There are all kinds of tools out there to help you visualize and share your data analysis with stakeholders. Here, we'll talk about two kinds of data presentation tools, reports and dashboards. Reports and dashboards are both useful for data visualization, but there are pros and cons for each of them. A report is a static collection of data given to stakeholders periodically. A dashboard, on the other hand, monitors live incoming data. Let's talk about reports first. Reports are great for giving snapshots of high-level historical data for an organization. For example, a finance firm's monthly sales. Reports come with a lot of benefits too. They can be designed and sent out periodically, often on a weekly or monthly basis, as organized and easy to reference information. They're quick to design and easy to use as long as you continually maintain them. And finally, because reports use static data, or data that doesn't change once it's been recorded, they reflect data that's already been cleaned and sorted. There are some downsides to keep in mind too. Reports need regular maintenance and aren't very visually appealing. And because they aren't automatic or dynamic, reports don't show live evolving data. For a live reflection of incoming data, you'll want to design a dashboard. Dashboards are great for a lot of reasons. They give your team more access to information being recorded. You can interact with data by playing with filters. And because they're dynamic, they have long-term value. If stakeholders need to continually access information, a dashboard can be more efficient than having to pull reports over and over, which is a big time saver for you. And last but not least, they're just nice to look at. But dashboards do have some cons too. For one thing, they take a lot of time to design and can actually be less efficient than reports if they're not used very often. And if the base table breaks at any point, they need a lot of maintenance to get back up and running again. Dashboards can sometimes overwhelm people with information too. If you aren't used to looking through data on a dashboard, you might get lost in it. As a data analyst, you need to decide the best way to communicate information to your stakeholders. For example, what if your stakeholders are interested in the company's social media engagement? Would a monthly report that tells them the number of new followers for their page be useful? Or a dashboard that monitors live social media engagement across multiple platforms? Later on, you'll create your own reports and dashboards to practice using these tools. But for now, I want to show you what a report and a dashboard might look like. We'll start by using a tool we're already familiar with, spreadsheets. Let's see one way spreadsheet data could be visualized in a report. This spreadsheet has data set with order details from a wholesale company. That's a lot of information. From the headers, we can see different things recorded here, like the order date, the salesperson, the unit price, and revenue for each transaction recorded. It's all useful information, but a little hard to wrap your head around. We want a report that's easier to read. Let's say your stakeholders want a quick look at the revenue by salesperson. Using the data, you could make them a pivot table with a graph that shows that information. A pivot table is a data summarization tool that is used in data processing. Pivot tables are used to summarize, sort, reorganize, group, count, total, or average data stored in a database. It allows its users to transform columns into rows and rows into columns. We'll actually learn more about pivot tables later, but I'll show you one really quick. We'll select the Data menu and click Pivot Table button. It can pull data from this table, so we can just press Create and it'll pull up a new worksheet. Over here, it gives us the pivot table fields we can choose from. Let's select Salesperson and Revenue. And just like that, it made a chart for us. At this point, you can play around with how the graph looks, but the information is all there. Alright, let's move on to dashboards. If you need a more dynamic way to share information with your stakeholders, dashboards are your friend. You might create something like this Tableau dashboard, with interactive graphs that showcase multiple views of the data. With this, users can change location, date range, or any other aspect of the data they're viewing by clicking through different elements on the dashboard. Pretty cool, right? Later in this program, we'll look into how you can make your own data visualizations. We have a lot to learn before we get to that, but I hope this was an exciting first peek at the different visualization tools you'll be using as a data analyst. In the last video, we learned how you can visualize your data using reports and dashboards to show off your findings in interesting ways. In one of our examples, the company wanted to see the sales revenue of each salesperson. That specific measurement of data is done using metrics. Now, I want to tell you a little bit more about the difference between data and metrics and how metrics can be used to turn data into useful information. A metric is a single quantifiable type of data that can be used for measurement. Think of it this way. Data starts as a collection of raw facts until we organize them into individual metrics that represent a single type of data. Metrics can also be combined into formulas that you can plug your numerical data into. In our earlier sales revenue example, all that data doesn't mean much unless we use that specific metric to organize it. So let's use revenue by individual salesperson as our metric. Now we can see whose sales brought in the highest revenue. Metrics usually involve simple math. Revenue, for example, is the number of sales multiplied by the sales price. Choosing the right metric is key. Data contains a lot of raw details about the problem we're exploring, but we need the right metrics to get the answers we're looking for. Different industries will use all kinds of metrics to measure things in a data set. Let's look at some more ways businesses in different industries use metrics, so you can see how you might apply metrics to your collected data. Ever heard of ROI? Companies use this metric all the time. ROI, or return on investment, is essentially a formula designed using metrics that let a business know how well an investment is doing. The ROI is made up of two metrics, the net profit over a period of time and the cost of investment. By comparing these two metrics, profit and cost of investment, the company can analyze the data they have to see how well their investment is doing. This can then help them decide how to invest in the future and which investments to prioritize. We see metrics used in marketing too. For example, metrics can be used to help calculate customer retention rates or a company's ability to keep its customers over time. Customer retention rates can help the company compare the number of customers at the beginning and the end of a period to see their retention rates. This way, the company knows how successful their marketing strategies are and if they need to research new approaches to bring back more repeat customers. Different industries use all kinds of different metrics, but there's one thing they all have in common. They're all trying to meet a specific goal by measuring data. This metric goal is a measurable goal set by a company and evaluated using metrics. And just like there are a lot of possible metrics, there are lots of possible goals too. Maybe an organization wants to meet a certain number of monthly sales, or maybe a certain percentage of repeat customers. By using metrics to focus on individual aspects of your data, you can start to see the story your data is telling. Metric goals and formulas are great ways to measure and understand data, but they're not the only ways. We'll talk more about how to interpret and understand data throughout this course. So far, you've learned a lot about how to think like a data analyst. We've explored a few different ways of thinking, and now I want to take that one step further by using a mathematical approach to problem solving. Mathematical thinking is a powerful skill you can use to help you solve problems and see new solutions. So let's take some time to talk about what mathematical thinking is and how you can start using it. Using a mathematical approach doesn't mean you have to suddenly become a math whiz. It means looking at a problem and logically breaking it down step by step so you can see the relationship of patterns in your data and use that to analyze your problem. This kind of thinking can also help you figure out the best tools for analysis because it lets you see the different aspects of a problem and choose the best logical approach. There's a lot of factors to consider when choosing the most helpful tool for your analysis. One way you could decide which tool to use is by the size of your data set. When working with data, you'll find that there's big and small data. Small data can be really small. These kinds of data tend to be made up of data sets concerned with specific metrics over a short, well-defined period of time, like how much water you drink in a day. Small data can be useful for making day-to-day decisions, like deciding to drink more water, but it doesn't have a huge impact on bigger frameworks like business operations. You might use spreadsheets to organize and analyze smaller data sets when you first start out. Big data, on the other hand, has larger, less specific data sets covering a longer period of time. They usually have to be broken down to be analyzed. Big data is useful for looking at large-scale questions and problems, and they help companies make big decisions. When you're working with data on this larger scale, you might switch to SQL. Let's look at an example of how a data analyst working in a hospital might use mathematical thinking to solve a problem with the right tools. The hospital might find that they are having a problem with over or underuse of their beds. Based on that, the hospital could make bed optimization a goal. They want to make sure that beds are available to patients who need them, but not waste hospital resources like space or money on maintaining empty beds. Using mathematical thinking, you can break this problem down into a step-by-step process to help you find patterns in their data. There's a lot of variables in this scenario, but for now, let's keep it simple and focus on just a few key ones. There are metrics that are related to this problem that might show us pattern in the data. For example, maybe the number of beds open and the number of beds used over a period of time. There's actually already a formula for this. It's called the bed occupancy rate, and it's calculated using the total number of inpatient days and the total number of available beds over a given period of time. What we want to do now is take our key variables and see how their relationship to each other might show us patterns that can help the hospital make a decision. To do that, we have to choose the tool that makes sense for this task. Hospitals generate a lot of patient data over a long period of time, so logically, a tool that's capable of handling big data sets is a must. SQL is a great choice. In this case, you discover that the hospital always has unused beds. Knowing that, they can choose to get rid of some beds, which saves them space and money that they can use to buy and store protective equipment. By considering all of the individual parts of this problem logically, mathematical thinking helped us see new perspective that led us to a solution. Well, that's it for now. Great job. You've covered a lot of material already. You've learned about how empowering data can be in decision making, the difference between quantitative and qualitative analysis, using reports and dashboards for data visualization, metrics, and using a mathematical approach to problem solving. Coming up next, we'll be tackling spreadsheet basics. You'll get to put what you've learned into action and learn a new tool to help you along the data analysis process. See you soon. Hi again, I'm glad you're back. In this part of the program, we'll revisit the spreadsheet. Spreadsheets are a powerful and versatile tool, which is why they're a big part of pretty much everything we do as data analysts. There's a good chance a spreadsheet will be the first tool you reach for when trying to answer data-driven questions. So after you've defined what you need to do with the data, you'll turn to spreadsheets to help build evidence that you can then visualize and use to support your findings. Spreadsheets are often the unsung heroes of the data world. They don't always get the appreciation they deserve, but as a data detective, you'll definitely want them in your evidence collection kit. I know spreadsheets have saved the day for me more than once. I've added data for purchase orders into a sheet, set up formulas in one tab, and had the same formulas do the work for me in other tabs. This frees up time for me to work on other things during the day. I couldn't imagine not using spreadsheets. Math is a core part of every data analyst's job, but not every analyst enjoys it. Luckily, spreadsheets can make calculations more enjoyable, and by that I mean easier. Let's see how. Spreadsheets can do both basic and complex calculations automatically. Not only does this help you work more efficiently, but it also lets you see the results and understand how you got them. Here's a quick look at some of the functions that you'll use when performing calculations. Many functions can be used as part of a math formula as well. Functions and formulas also have other uses, and we'll take a look at those too. We'll take things one step further with exercises that use real data from databases. This is your chance to reorganize a spreadsheet, do some actual data analysis, and have some fun with data. Data analysts spend a lot of time organizing data and performing calculations. Luckily, there's lots of different tools to help them do just that, including spreadsheets. In this video, we'll take a look at some of the ways data analysts use spreadsheets to help them with their day-to-day responsibilities. Later, you'll get to test out some of these things yourself. But for now, let's start with a quick look at how data analysts use spreadsheets to do their jobs. This will change depending on the work you need to complete, but here's an overview of a few of the major tasks. Imagine you work for a construction company. Your company needs your spreadsheet skills to analyze some data about their expenses. So you access the appropriate data and add it to your spreadsheet. We won't cover all the details of this project right now, but you will get a chance to see lots of spreadsheet features up close and personal as we move forward. What do you do with the data now that it's in your spreadsheet? Again, this will be different for each job, but you might start by organizing your data with the task you've been given. For example, you might put your data in a pivot table. We've talked about pivot tables before in this course. We'll cover them in more detail later on, but for now, just think of them as a well-organized and very useful tables. Next, you might filter the data in the pivot table. Sorting and filtering data is a common part of most jobs. This lets you focus only on the data you'll need for your analysis. In our example, maybe you only need the expenses for a certain time frame, like the last 3 months. After you've filtered your data, you could perform some calculations to learn more about it. Maybe you need to find out which construction projects ended up costing the most money. This is where formulas and functions are really handy. We'll talk about them in just a bit, but formulas and functions are great for doing some quick math, especially once you run out of fingers and toes to count on. Now you've seen some of the ways data analysts are using spreadsheets in their day-to-day work for a lot of different tasks, including organizing their data and making calculations. Before you know it, we'll have you working in your own spreadsheets.
Welcome to Quick Labs. Now it's time to get hands-on practice on a lot of the amazing data analyst concepts that you've learned so far. Here's where you get to prove that you've learned some great technologies, and then you'll get credit for it back inside of Coursera. But before you jump right in, let me just give you a quick walkthrough of what a Quick Lab is, and then we'll get started. First and foremost, in the upper left-hand corner, you notice a gigantic tempting button called Start Lab in green. I want to go ahead and start that. Click this box that says I'm not a robot. Select a few of the different items for captures. You can see this is the hardest part of the lab, is trying to actually get through the anti-robot technology that they have here. Now, a couple things happen in the background. As author of these labs, this is some of our best work that we're getting you hands-on practice for. And what we're going to do next is just make sure that that timer starts counting down, because then that's going to give you the account logins that you need to practice the work inside of the lab. Now, here's what you're going to do. There's going to be a gigantic big button that says Open Google Cloud Console. I want you to go ahead and click on that. And now you have 3 browser tab windows open, or 100 if you're like me. And in the second browser, this is your Quick Labs login. All the way under username, what I want you to do is copy that username. And here's the number one mistake that I've seen students make. When you're back into Google, everyone sees this Google sign-in screen here, and they immediately start typing in their personal Gmail address. You don't want to be charged for any of the resources that you're going to be using. That's why we're providing you with this Quick Labs account yourself. All I'm going to do is paste in the email that's been given to me by the Quick Lab for use for an hour, and then click Next. And then I'm going to go ahead and grab the password, paste that in here, and then you're going to see a bunch of terms and conditions because this is a brand new account. Scroll through the terms and conditions, read them at your leisure, click Accept. And as you work through the terms of service here, eventually you'll land on the homepage for Google Cloud. Scroll down, read the terms of service, accept terms of service. All the steps that I'm walking you through right now are also available inside of the lab written instructions as well. So once you've gotten that out of the way, let's take a look at what this particular Quick Lab is going to teach you. At a high level, I'm not going to do the lab for you, but don't worry, it's step by step. You'll have a blast doing it. And you have way more than enough time you need in this timer before your lab timer runs out. Generally, as lab authors, we try to double the budget of allowed time, so don't worry about lab timeouts. So inside the lab, every lab will start with an overview, and then what specifically it is that you're going to do. Inside of this lab, since you're a data analyst, you're going to be creating spreadsheets and adding files and sharing files with some of your other data analysts. If you forget what section you're in, another pro tip that I like to do is on the right-hand side, you can actually click between each of the different header sections right here as I'm doing now, and you can jump to a particular section inside of the workbook. So say you and your friends are working on this together, you can say, hey, I'm having trouble on the share and collaborate section. You can just click on that and it'll jump right to that section. Well, that's pretty much it. A few more housekeeping items and then you're off to the races. As you work your way through the lab, you want to make sure that you're completing the objectives and making sure that you're staying on track. There is intelligence built into the Quick Labs to prevent any kind of behavior that's not part of the lab. So make sure you're following the lab as is. And when you're done with the lab, say I was completed here, all you have to do is click on End Lab, click on OK, and that's going to bring you to a pop-up screen that asks you to rate the lab, add in any comments for the lab authors like me, submit it, and then automatically your score for the work that you've done in the lab is fed back to Coursera, which is pretty cool. And that's it. That was a quick tour of Quick Labs, about 5 minutes, but honestly, you'll have a blast going through these. Good luck.
We've talked about how spreadsheets are great for organizing data and performing calculations. Now it's time to get our hands dirty and start building a real spreadsheet. In this video, I'm going to demonstrate some basic tasks we know data analysts use spreadsheets for, including entering and organizing data. We'll start with a step-by-step process to show you some tools to organize your data in a spreadsheet. Consider these steps the basics. You won't always have to use them when working with a data set, but if your data is a bit messy when you get it, these steps can help you get it ready for analysis. Let's start by opening a new spreadsheet. As a data analyst, you might not start with a blank spreadsheet, but it's good to know how to do it, just in case. Start by opening Excel, Google Sheets, or whatever spreadsheet software you're using. Then, select a new blank file. The first thing you'll want to do when you open a new spreadsheet is give it a title. Here's a pro tip. Make your title short, clear, and have it state exactly what the data in this spreadsheet is about. Trust me, it'll make searching for it a lot easier. Creating a folder on your computer specifically for spreadsheets and related files can also make it easier to find them. For this spreadsheet, it's already saved in our drive, so we'll open our File menu to click Move. Then we'll create a new folder. Name it Population Data, and move the spreadsheet there. Our spreadsheet now has a new home. This will save you a lot of unnecessary clicks and headaches when you look for this file. There's a few different ways data analysts get data they work with. Depending on the job, you might use data from an open source. You might be given data to work with, or you might be asked to find your own data. You'll experience all of these later in the program. There's a lot of open data sources online where data is made available to the public. For example, we'll use data from worldbank.org that's already in a spreadsheet. The data shows the population of Latin American and Caribbean countries from 2010 through 2019. Let's open this spreadsheet. Okay, time to get the data ready for analysis. We'll start by selecting the whole sheet and making our columns wider by dragging the boundary of one of the columns. This will help us see the data clearly. Then we can adjust any individual columns that need it. You can make columns wider in other ways as well, but this will work for now. The first row of the spreadsheet is for data attributes, or variables, so it's basically labeling the type of data in each column. Let's make the attributes stand out from the rest of the rows by selecting it and filling it with color. We'll also make the labels bold. If we want to add another data attribute between two of the other attributes, we can always add a new column. Just click on any cell within a column and use the Insert menu to add a new one. It will appear next to the column you originally clicked. Pretty simple, right? Deleting a column is just as simple. To delete, right-click in a cell in the column you want to get rid of. The steps we're showing may be different depending on the spreadsheet program you're using, but should be pretty similar. Let's add one more thing to our data table, borders. This can help you see each piece of data more clearly. To add borders, start by clicking the Select All button at the top left corner of your spreadsheet. This is kind of like a magic button because you can click it whenever you need to make changes to every cell in your spreadsheet. Then click the border button in the menu and choose the type of borders you want. To keep our spreadsheets uniform, we'll choose borders for all cells. And just like that, we've gone from raw to refined. Now our spreadsheet is filled with data, and it's nice to look at too. Using these organization tools before you analyze can help you focus on the data once you start your analysis. Now that we've gone over some ways spreadsheets can be used to organize data, you're ready to start working on them yourself. Later, you'll learn more about spreadsheets, including some common errors and how to fix them. So far, we've covered how to start a new spreadsheet, enter in data, and make it look refined and ready for some serious analysis. Now we'll learn how to perform calculations in your spreadsheet. You may need to calculate everything from sums to averages to finding minimums and maximum amounts. You'll use calculations for a lot of different kinds of tasks. So in this video, we'll focus on learning the basics and then do a little math with some sales data to practice. Let's talk about formulas first. You might remember that a formula is a set of instructions that perform a specific calculation. Basically, formulas can do the math for you. Now, they don't only do math, they can do a lot more. And soon you'll learn different ways you can use them throughout the data analysis processes. Formulas are built on operators, which are symbols that name the type of operation or calculation to be performed. For example, a plus sign is a common operator. The formulas you use as a data analyst will usually include at least one operator. Now let's talk about math expressions or equations. These can take a lot of different forms, but you might be familiar with them already. 3 minus 1, 15 plus 8 divided by 2, 846 times 513. These are all examples of expressions. Is this bringing back memories of grade school? Well, back in math class, you most likely learned to complete an expression by including an equal sign and the solution. It's slightly different with spreadsheets. When you create a formula using an expression in a spreadsheet, you start the formula with an equal sign. For example, if we want to subtract, we type an equal sign followed by the rest of the expression without any spaces in the formula. Now let's try an expression that's a bit more challenging. We'll type 31982, then a hyphen for a minus sign, then 17795. And to calculate, we press enter. You'll most likely use formulas this way when dealing with large numbers or expressions with multiple steps. Here are the operators you'll use to complete formulas: the plus sign for addition, the minus or hyphen for subtraction, the asterisk for multiplication, and the forward slash for division. The division and multiplication symbols might be different than what you're used to. Small changes, but important to keep in mind. If you already have data in your spreadsheet, you can use cell references in your formulas instead. A cell reference is a single cell or range of cells in a worksheet that can be used in a formula. Cell references contain the letter of the column and the number of the row where the data is. A range of cells is a collection of 2 or more cells. A range can include cells from the same row or column or from different columns and rows collected together. We'll show you an example in an upcoming video. Now let's apply what we just learned to some sales data. If we want to add these figures to find the total sales for the first row of data, you can click cell F2. From there, we'll start with an equal sign and use the cell references to input values in your expression. We're starting with cell B2 because the year in A2 is not a value we want to add to the total. Then press enter. And just like that, your total sales has been calculated for you. But what if you realized one of the values in your data was wrong? No problem. You can change the value in any cell used in the formula and the total will update automatically. The great thing about using cell references is that they also automatically update when a formula is copied to a new cell. Talk about a time saver. So instead of entering the same formula again for every new set of cell references, just copy the formula using the menu or a keyboard shortcut like Ctrl+C. Then paste the formula where you want to apply it using Ctrl+V. And presto, the formula updates all the new cells and values correctly. Now, let's say you also wanted to find the average sales. For this, you create a new formula in a different cell. To group values in a formula, use parentheses. This lets your spreadsheet know which values to calculate together and the order of the operations to be performed. For example, open parentheses, then B2 plus C2 plus D2 plus E2, and close parentheses. Then divide the value of all of this by 4 by typing /4. So you are adding the values in the 4 cells together and then using the slash to divide the total by 4. And just like the last one, we can copy and paste the formula. Here's another formula you can use if you want to find the percent change in sales between June and July. Once the formula calculates the value, you can then use the percent button to change the value to a percentage. When you apply the formula to the other rows, both the formula and the percent will automatically update. Uh-oh, that doesn't look like the right answer. Looks like we've got an error. Don't worry, errors can happen at any stage of data analysis, and that includes when you're using spreadsheets. A formula has to be airtight. If there's something wrong with one of the cell references, it won't work. So what's our error? Well, we can see that the value in cell D4 is missing. It might take some time and research on your part to find the correct value, but it's worth it. You want your analysis to be as accurate as possible. When you do add the value, the formula takes care of the rest. That was a lot to take in. Thanks for staying with me. You'll be able to apply what you learned about formulas here and later in the program to make your analysis more efficient and your job a little easier. And soon, you'll work in your own spreadsheet. Happy spreadsheeting! Formulas are a great way to become more efficient when using spreadsheets, especially when you add shortcuts like copying and pasting into the mix. As you progress as a data analyst, you'll most likely learn more shortcuts to help your process. But now it's time to move on to functions. While they're closely related to formulas, they're not exactly the same. By the end of this video, you'll understand the difference and know when to use them both. In the world of spreadsheets, a function is a preset command that automatically performs a specific process or task using the data. You might remember some of the shortcuts we learned that can be used with formulas. Think of functions as the most useful of these shortcuts. The good news is a lot of spreadsheet functions have names that tell you what they do. There are tons of functions out there, and as you continue to work with spreadsheets, you'll find that you use certain ones a lot and others rarely or not at all. For now, let's take a look at some of the functions that we can apply to our sales data from the previous video. We'll start with total sales. Let's use the sum function for this in cell F2. The first steps are pretty similar to what we did in the last video. First, we'll select the cell where we want the calculation to appear, type equals, then add the word sum as our function. One of the great things about functions is they don't always need operators, like a plus sign for addition. In this case, after the open parentheses, you can go ahead and select the range of cells you're adding. A colon between the cell references shows that you're using a range. In this case, the range includes cells from the same row. After the close parentheses, we press enter, and just like that, our total sales number appears. Just like the formula we used before, functions can be copied and pasted into other cells in the same column. But let's undo that step so that you can see another way to copy a function or formula. Spreadsheets have something called a fill handle. It's a little box that appears in the lower right-hand corner when you click on a cell. If you rest your cursor on the box, you can then drag the fill handle to the other boxes in the same row or column. Any formula or function in that cell will automatically be added to the cells you fill. Plus, the fill handle will update the formula so the cell references match the row of the columns of the cells you fill. This means the formula is calculated based on the data in each separate row or column. Filling won't work for every situation, but it's still a pretty great trick. Now let's find the average sale for each month using the average function. Different functions perform different calculations, but they work in the same way. Keep in mind, not every calculation you'll come across has its own function to help you. For example, to find the percent change in sales between June and July, you'd use the same formula you used in an earlier video. Let's say you're asked to find the lowest monthly sales in this dataset. There is a function for that. It's called the min function, which stands for minimum. Here's how it works. Say you need to find the lowest monthly sales for the whole set. All you have to do is set up the function. Then, after the open parentheses, select the values from all 3 rows. This might be important information for your stakeholders, so let's add color to the cell with that value in your dataset to make it stand out. In this case, click on cell D2 and then fill color icon, which looks like a paint can. Then choose a color. I'll use yellow here. You can follow the same steps for the highest sales by using the, wait for it, max function. Looks like we have an error message. What could be wrong? We forgot to include an open parentheses after the function. No worries, it's a quick fix. But this is a good reminder to continually check the format of your functions and formulas as you use them. We'll learn more about error messages and how to work with them later. Okay, that's better. Now we'll add color to the cell with the highest sales too. This is just one way to highlight key data. You'll find out about some others later. You've now had a peek at some ways you can add and organize data in a spreadsheet. You've also seen how powerful formulas and functions can be when applied to real-world data. As a data analyst, this is just the beginning of your experience with spreadsheets. You'll soon find out how much more spreadsheets have to offer. In the meantime, you're free to practice some of these formulas, functions, and other processes on your own. It can be fun to experiment and see all that spreadsheets can do. Soon, you'll switch from spreadsheets to structured thinking. The data analytics pieces are starting to fit together. Exciting stuff is coming right up, so stick around.
Welcome to Quick Labs. Now it's time to get hands-on practice on a lot of the amazing data analyst concepts that you've learned so far. Here's where you get to prove that you've learned some great technologies, and then you'll get credit for it back inside of Coursera. But before you jump right in, let me just give you a quick walkthrough of what a Quick Lab is, and then we'll get started. First and foremost, in the upper left-hand corner, you notice a gigantic tempting button called Start Lab in green. I want to go ahead and start that. Click this box that says I'm not a robot. Select a few of the different items for captures. You can see this is the hardest part of the lab, is trying to actually get through the anti-robot technology that they have here. Now, a couple things happen in the background. As author of these labs, this is some of our best work that we're getting you hands-on practice for. And what you're going to do next is just make sure that that timer starts counting down, because then that's going to give you the account logins that you need to practice the work inside the lab. Now, here's what you're going to do. There's going to be a gigantic big button that says Open Google Cloud Console. I want you to go ahead and click on that. And now you have 3 browser tab windows open, or 100 if you're like me. And in the second browser, this is your Quick Labs login. All the way under username, what I want you to do is copy that username. And here's the #1 mistake that I've seen students make. When you're back into Google, everyone sees this Google sign-in screen here, and they immediately start typing in their personal Gmail address. You don't want to be charged for any of the resources that you're going to be using. That's why we're providing you with this Quick Labs account yourself. And all I'm going to do is paste in the email that's been given to me by the Quick Lab for use for an hour, and then click Next. And then I'm going to go ahead and grab the password, paste that in here, and then you're going to see a bunch of terms and conditions because this is a brand new account. Scroll through the terms and conditions, read them at your leisure, click Accept. And as you work through the terms of service here, eventually you'll land on the homepage for Google Cloud. Scroll down, read the terms of service, accept terms of service. All the steps that I'm walking you through right now are also available inside of the lab written instructions as well. So once you've gotten that out of the way, let's take a look at what this particular Quick Lab is going to teach you. At a high level, I'm not going to do the lab for you, but don't worry, it's step by step. You'll have a blast doing it. And you have way more than enough time you need in this timer before your lab timer runs out. Generally, as lab authors, we try to double the budget of allowed time, so don't worry about lab timeouts. So inside the lab, every lab will start with an overview, and then what specifically it is that you're going to do. Inside of this lab, since you're a data analyst, you're going to be creating spreadsheets and adding files and sharing files with some of your other data analysts. If you forget what section you're in, another pro tip that I like to do is on the right-hand side, you can actually click between each of the different header sections right here as I'm doing now, and you can jump to a particular section inside of the workbook. So say you and your friends are working on this together, you can say, hey, I'm having trouble on the share and collaborate section. You can just click on that and it'll jump right to that section. Well, that's pretty much it. A few more housekeeping items and then you're off to the races. As you work your way through the lab, you want to make sure that you're completing the objectives and making sure that you're staying on track. There is intelligence built into the Quick Labs to prevent any kind of behavior that's not part of the lab. So make sure you're following the lab as is. And when you're done with the lab, say I was completed here, all you have to do is click on End Lab, click on OK, and that's going to bring you to a pop-up screen that asks you to rate the lab, add in any comments for the lab authors like me, submit it, and then automatically your score for the work that you've done in the lab is fed back to Coursera, which is pretty cool. And that's it. That was a quick tour of a Quick Lab. It was about 5 minutes, but honestly, you'll have a blast going through these. Good luck.
Albert Einstein once said, if I were given 1 hour to save the planet, I would spend 59 minutes defining the problem and 1 minute resolving it. Now, that might seem extreme, but it does show us just how important it is to define the problems before trying to solve them. A lot of times, teams jump right into data analysis before realizing a few months later that they are either solving the wrong problem or they don't have the right data. In this video, we will learn how to develop a structured approach to defining the problem domain. This is important because if you define the problem clearly from the start, it'll be easier to solve, which saves a lot of time, money, and resources. In the data world, we call this first piece the problem domain, the specific area of analysis that encompasses every activity affecting or affected by the problem. Before we can do anything else, we need to understand the problem domain and all of its parts and relationships so that we can discover the whole story. Actually, calling it the first piece makes me think of a jigsaw puzzle. Say you have a puzzle. Let's think of that puzzle as our problem domain. You have all 500 pieces, but you lost the box, so you don't know what the image the puzzle will reveal. Will it be an animal, a waterfall, a bowl of oranges? Whatever it is, it's going to be tough trying to put it together without an image you can refer to. Even the greatest puzzler in the galaxy would need a new process and lots of time to complete that puzzle. Data analysts face the same kinds of challenges too. You might remember that data analysts aren't always given the complete picture at the start of a project. A big part of their job is to develop a structured approach and use critical thinking to find the best solution. And that starts with understanding the problem domain. This is where structured thinking comes into play. To successfully solve a problem as a data analyst, you need to train your brain to think structurally. And that's exactly what you'll learn coming up. See you there. So, earlier I told you that carefully defining a business problem can ultimately save time, money, and resources. All of this is achieved through structured thinking. Structured thinking is the process of recognizing the current problem or situation, organizing available information, revealing gaps and opportunities, and identifying the options. In other words, it's a way of being super prepared. It's having a clear list of what you are expected to deliver, a timeline for major tasks and activities, and checkpoints so the team knows you're making progress. In this video, we'll look at how structured thinking helps us save time and effort, but also makes our job as data analysts easier because it allows us to better understand the work we are doing. In the business world, it's common for teams to spend hours of valuable time trying to solve an important problem, only to end up back where they started. Not only is the initial problem not resolved, but they've spent hours not resolving it. This outcome negatively affects you, your team, and the organization as a whole. But it can usually be prevented. Many times, the situation is a result of not fully understanding the issue. Structured thinking will help you understand problems at a high level so that you can identify areas that need deeper investigation and understanding. The starting place for structured thinking is the problem domain, which you might have remembered from earlier. Once you know the specific area of analysis, you can set your base and lay out all your requirements and hypotheses before you start investigating. With a solid base in place, you'll be ready to deal with any obstacles that come up. What kind of obstacles? Well, let's say you're asked to predict the future value of an apartment building based on a given data set. You have hundreds of variables, and every one is crucial to your analysis. But what if one variable accidentally gets left out, like square footage, for example? You'd have to go back and redo all your hard work. That's because missing variables can lead to inaccurate conclusions. Another way that you can practice structured thinking and avoid mistakes is by using a scope of work. A scope of work, or SOW, is an agreed upon outline of the work you're going to perform on a project. For many businesses, this includes things like work details, schedules, and reports that the client can expect. Now, as a data analyst, your scope of work will be a bit more technical. It'll include those basic items we just mentioned, but you'll also focus on things like data preparation, validation, analysis of quantitative and qualitative data sets, initial results, and maybe even some visuals to really get the point across. Let's bring a scope of work to life with a simple example. Say a couple has hired a wedding planner. We'll focus on just one task, the wedding invitations. Here's what might be in scope of work: deliverables, timeline, milestones, and reports. Let's break down just one of these, deliverables. The wedding planner and couple will need to decide on the invitation, make a list of people to invite, collect their addresses, print the invitations, address the envelopes, stamp them, and mail them out. Now let's check out the timelines. You'll notice the dates and the milestones, which keep us on track. Finally, we have the reports, which give our couple some peace of mind by telling them when each stop is complete. A scope of work can be a simple but powerful tool. With a solid scope of work, you'll be able to address any confusion, contradictions, or questions about the data up front and make sure these sneaky setbacks don't stand in your way. This is a simple example of what a scope of work might look like, but later you'll be able to practice building your own. Next up in our scope, we'll check out setbacks from a different angle by learning the importance of contextualizing data and avoiding bias. Looking forward to sharing some cool insights with you. Welcome back. In this video, we'll explore the importance of contextualizing data and recognizing data bias. Let's get started. Data doesn't live in a vacuum. It needs context. Earlier, we learned that context is the condition in which something exists or happens. So actions can be appropriate in some contexts but inappropriate in others. For example, yelling "move" is rude in one context, like if your friend is standing in front of the TV. but it's entirely appropriate in another, like if that friend is about to get hit by a kid on a tricycle. Do you see the difference? In the world of data, numbers don't mean much without context. I'll let my fellow Googler, Ed, tell you a little bit more about that.
As we have more and more data available to us, we can leverage that data in increasingly sophisticated ways and generate more powerful insights from it. We use data at many different levels. Sometimes our data is descriptive, answering questions like, how much did we spend on travel last month? Data becomes more valuable as we generate diagnostic and predictive insights, like understanding why travel spend increased last month. Data is most valuable, however, when we can generate prescriptive insights. For example, how can we leverage data to incentivize more efficient travel?
Figuring out what data means is just as important as collecting it. As a data analyst, a big part of your job is putting data into context. It's also up to you to remain objective and recognize all sides of an argument before drawing conclusions. The thing about context is that it's very personal. If two people curate the same data set and follow the same directions, there's a chance they will end up with different results. Why? Because there is no universal set of contextual interpretations. Everyone approaches it in their own way. And even if the data collection process is correct, the analysis can still be misinterpreted. Conclusions can be influenced by your own conscious and subconscious biases, which are based on cultural, social, and market norms. For example, if you ask a Boston resident which baseball team is the best, chances are they're going to say Boston Red Sox, which brings us to a major limitation of data analytics. If the analysis is not objective, the conclusions can be misleading. To really understand what the data is about, you have to think through who, what, where, when, how, and why. It's good to ask yourself questions like, who collected the data, and what is it about? What does the data represent in the world, and how does it relate to other data? When was the data collected? Data collected a while ago may have certain limitations given the present-day situation. For example, if we collected phone numbers over the past century, at some point mobile phones would have been introduced, leading to the need for an additional phone number field. You should also think about where was the data collected. A lot can change across cities, states, and countries. And how was it collected? A survey might not be as effective as an in-person interview, for example. And of course, there's the why. The why can have a particularly strong relationship with bias. Why? Because sometimes data is collected or even made up to serve an agenda. The best thing you can do for the fairness and accuracy of your data is to make sure you start with an accurate representation of the population and collect the data in the most appropriate and objective way. Then you'll have the facts that you can pass on to your team. Hopefully, you now understand the importance of fair and objective data and how important context is when it comes to understanding and interpreting it. Next up, we'll figure out how we can bring it to life. Hey, welcome back! So far, you've learned about things like spreadsheets, analytical thinking skills, metrics, and mathematics. These are all super important technical skills that you'll build on throughout your data analytics career. You should also keep in mind that there are some non-technical skills that you can use to create a positive and productive working environment. These skills will help you consider the way you interact with your colleagues as well as your stakeholders. We already know that it's important to keep your team members and stakeholders' needs in mind. Coming up, we'll talk about why that is, and we'll start learning some communication best practices you can use in your day-to-day work. Remember, communication is key. We'll start by learning all about effective communication and how to balance team member and stakeholder needs. Think of these skills as new tools that'll help you work with your team to find the best possible solutions. Alright, let's head on to the next video and get started. As a data analyst, you'll be required to focus on a lot of different things, and your stakeholders' expectations are one of the most important. we're going to talk about why stakeholder expectations are so important to your work and look at some examples of stakeholder needs on a project. By now you've heard me use the term stakeholder a lot, so let's refresh ourselves on what a stakeholder is. Stakeholders are people that have invested time, interest, and resources into the projects that you'll be working on as a data analyst. In other words, they hold stakes in what you're doing. There's a good chance they'll need the work you do to perform their own needs. That's why it's so important to make sure your work lines up with their needs, and why you need to communicate effectively with all of the stakeholders across your team. Your stakeholders will want to discuss things like the project objective, what you need to reach that goal, and any challenges or concerns you have. This is a good thing. These conversations help build trust and confidence in your work. Here's an example of a project with multiple team members. Let's explore what they might need from you at different levels to reach the project's goal. Imagine you're a data analyst working with a company's human resources department. The company has experienced an increase in its turnover rate, which is the rate at which employees leave a company. The company's HR department wants to know why that is, and they want you to help them figure out potential solutions. The vice president of HR at this company is interested in identifying any shared patterns across employees who quit and seeing if there's a connection to employee productivity and engagement. As a data analyst, it's your job to focus on the HR department's question and to help find them an answer. But the BP might be too busy to manage day-to-day tasks or might not be your direct contact. For this task, you'll be updating the project manager more regularly. Project managers are in charge of planning and executing a project. Part of the project manager's job is keeping the project on track and overseeing the progress of the entire team. In most cases, you'll need to give them regular updates. Let them know what you need to succeed and tell them if you have any problems along the way. You might also be working with other team members. For example, HR administrators will need to know the metrics you're using so that they can decide ways to effectively gather employee data. You might even be working with other data analysts who are covering different aspects of the data. It's so important that you know who the stakeholders and other team members are in a project so that you can communicate with them effectively and give them what they need to move forward in their own roles on the project. You're all working together to give the company vital insights into this problem. So back to our example. By analyzing company data, you see a decrease in employee engagement and performance after their first 13 months at the company, which could mean that employees started feeling demotivated or disconnected from their work, and then often quit a few months later. Another analyst who focuses on hiring data also shares that the company had a large increase in hiring around 18 months ago. You communicate this information with all your team members and stakeholders, and they provide feedback on how to share this information with your VP. In the end, your VP decides to implement an in-depth manager check-in with employees who are about to hit their 12-month mark at the firm to identify career growth opportunities, which reduces the employee turnover starting at the 13-month mark. This is just one example of how you might balance needs and expectations across your team. You'll find that in pretty much every project you work on as a data analyst, different people on your team, from the VP of HR to your fellow data analysts, will need all your focus and communication to carry the project to success. Focusing on stakeholder expectations will help you understand the goal of a project, communicate more effectively across your team, and build trust in your work. Coming up, we'll discuss how to figure out where you fit on your team and how you can help move a project forward with focus and determination. So now that we know the importance of finding the balance across your stakeholders and your team members, I want to talk about the importance of staying focused on the objective. This can be tricky when you find yourself working with a lot of people with competing needs and opinions. But by asking yourself a few simple questions at the beginning of each task, you can ensure that you're able to stay focused on your objective while still balancing stakeholder needs. Let's think about our employee turnover example from the last video. There, we were dealing with a lot of different team members and stakeholders, like managers, administrators, even other analysts. As a data analyst, you'll find that balancing everyone's need can be a little chaotic sometimes. But part of your job is to look past the clutter and stay focused on the objective. It's important to concentrate on what matters and not get distracted. As a data analyst, you could be working on multiple projects with lots of different people. But no matter what project you're working on, there are 3 things you can focus on that will help you stay on task. 1. Who are the primary and secondary stakeholders? 2. Who is managing the data? And 3. Where can you go for help? Let's see if we can apply those questions to our example project. The first question you can ask is about who the stakeholders are. The primary stakeholder of this project is probably the vice president of HR who's hoping to use this project's findings to make new decisions about company policy. You'd also be giving updates to your project manager, team members, or other data analysts who are depending on your work for their own task. These are your secondary stakeholders. Take time at the beginning of every project to identify your stakeholders and their goals. Then, see who else is on your team and what their roles are. Next, you'll want to ask who's managing the data. For example, think about working with other analysts on this project. You're all data analysts, but you may manage different data within your project. In our example, there was another data analyst who was focused on managing the company's hiring data. Their insights around search and new hires 18 months ago turned out to be a key part of your analysis. If you hadn't communicated with this person, you might have spent a lot of time trying to collect or analyze hiring data yourself. Or you may not have even been able to include it in your analysis at all. Instead, you were able to communicate your objectives with another data analyst and use existing work to make your analysis richer. By understanding who's managing the data, you can spend your time more productively. Next up, you need to know where you can go when you need help. This is something you should know at the beginning of any project you work on. If you run into bumps in the road on your way to completing a task, you need someone who is best positioned to take down those barriers for you. When you know who's able to help, you'll spend less time worrying about other aspects of the project and more time focused on the objective. So, who could you go to if you ran into a problem on this project? Project managers support you and your work by managing the project timeline, providing guidance and resources, and setting up efficient workflows. They have a big picture view of the project because they know what you and the rest of the team are doing. This makes them a great resource if you run into a problem. In the employee turnover example, you would need to be able to access employee departure survey data to include in your analysis. If you're having trouble getting approvals for that access, you can speak with your project manager to remove those barriers for you so that you can move forward with your project. Your team depends on you to stay focused on your task, so that as a team, you can find solutions. By asking yourself 3 easy questions at the beginning of new projects, you'll be able to address stakeholder needs, feel confident about who is managing the data, and get help when you need it, so that you can keep your eyes on the prize, the project objective. So far, we've covered the importance of working effectively on a team while maintaining your focus on stakeholder needs. Coming up, we'll go over some practical ways to become better communicators so that we can help make sure the team reaches its goals. Welcome back! We've talked a lot about understanding your stakeholders and your team so that you can balance their needs and maintain a clear focus on your project objectives. A big part of that is building good relationships with the people you're working with. And how do you do that? 2 words: clear communication. Now we're going to learn about the importance of clear communication with your stakeholders and team members, and start thinking about who you'll want to communicate with and when. First, it might help to think about communication challenges you might already experience in your daily life. Have you ever been in the middle of telling a really funny joke only to find out your friend already knows the punchline? Or maybe they just didn't get what was funny about it? This happens all the time, especially if you don't know your audience. This kind of thing can happen at the workplace too. Here's a secret to effective communication. Before you put together a presentation, send an email, or even tell that hilarious joke to your coworker, think about who your audience is, what they already know, what they need to know, and how you can communicate that effectively to them. When you start by thinking about your audience, they'll know it and appreciate the time you took to consider them and their needs. Let's say you're working on a big project analyzing annual sales data and you discover that all of the online sales data is missing. This could affect your whole team and significantly delay the project. By thinking through these 4 questions, you can map out the best way to communicate across your team about this problem. First, you'll need to think about who your audience is. In this case, you'll want to connect with other data analysts working on the project, as well as your project manager, and eventually the VP of Sales, who is your stakeholder. Next up, you'll think through what this group already knows. The other data analysts working on this project know all the details about which data set you are using already. And your project manager knows the timeline you're working towards. Finally, the VP of Sales knows the high-level goals of the project. Then, you'll ask yourself what they need to know to move forward. Your fellow data analysts need to know the details of what you have tried so far and any potential solutions you've come up with. Your project manager would need to know the different teams that could be affected and the implications for the project, especially if this problem changes the timeline. Finally, the VP of Sales will need to know that there's a potential issue that would delay or affect the project. Now that you've decided who needs to know what, you can choose the best way to communicate with them. Instead of a long, worried email which could lead to lots back and forth, you decide to quickly book in a meeting with your project manager and fellow analysts. In the meeting, you let the team know about the missing online sales data and give them more background info. Together, you discuss how this impacts other parts of the project. As a team, you come up with a plan and update the project timeline if needed. In this case, the VP of Sales didn't need to be invited to your meeting, but would appreciate an email update if there were changes to the timeline, which your project manager might send along herself. When you communicate thoughtfully and think about your audience first, you'll build better relationships and trust with your team members and stakeholders. And that's important because those relationships are key to the project's success, and your own too. So, when you're getting ready to send an email, organize a meeting, or put together a presentation, think about who your audience is, what they already know, what they need to know, and how you can communicate that effectively to them. Next up, we'll talk more about communicating at work, and you'll learn some useful tips to make sure you get your message across clearly. No matter where you work, you'll probably need to communicate with other people as part of your day-to-day job. Every organization and every team in that organization will have different expectations for communication. Coming up, we'll learn some practical ways to help you adapt to those different expectations and some things that you can carry over from team to team. Let's get started. When you start at a new job or a new project, you might find yourself feeling a little out of sync with the rest of your team and how they communicate. That's totally normal. You'll figure things out in no time if you're willing to learn as you go and ask questions when you aren't sure of something. For example, if you find your team uses acronyms you aren't familiar with, don't be afraid to ask what they mean. When I first started at Google, I had no idea what TLDR meant, and I was always seeing it at the top of emails. Well, I learned it stands for Too Long Didn't Read, and I use it all the time now if I need to give someone a quick summary at the beginning of a long email. That was one of the many acronyms I've learned, and I come across new ones all the time, so I'm never afraid to ask. Every work setting has some form of etiquette. Maybe your team members appreciate eye contact and a firm handshake, Or it might be more polite to bow, especially if you find yourself working with international clients. You might also discover some specific etiquette rules just by watching your coworkers communicate. And it won't just be in-person communications you'll deal with. Almost 300 billion emails are sent and received every day, and that number is only growing. Fortunately, there are useful skills you can learn from those digital communications too. You'll want your emails to be just as professional as your in-person communications. Here are some things that can help you do that. Good writing practices will go a long way to making your emails professional and easy to understand. Emails are naturally more formal than text, but that doesn't mean you have to write the next great novel. Just taking the time to write complete sentences that have a proper spelling and punctuation will make it clear you took the time and consideration in your writing. Emails often get forwarded to other people to read, so write clearly enough so that anyone could understand you. I like to read important emails out loud before I hit send. That way, I can hear if they make sense and catch any typos. And keep in mind, the tone of your emails can change over time. If you find that your team is fairly casual, that's great. Once you get to know them better, you can start being more casual too. But being professional is always a good place to start. A good rule of thumb, would you be proud of what you had written if it were published on the front page of a newspaper? If not, revise it until you are. You also don't want your emails to be too long. Think about what your team member needs to know and get to the point instead of overwhelming them with a wall of text. You'll want to make sure that your emails are clear and concise so that they don't get lost in the shuffle. Otherwise, be sure to give them a TLDR. Let's take a quick look at 2 emails so you can see what I mean. Here's the first email. There's so much written here that it's kind of hard to see where the important information is. And this first paragraph doesn't give me a quick summary of the important takeaways. It's pretty casual too. The greeting is just, hey, and there's no sign-off. Plus, I can already spot some typos. Now, let's take a look at the second email. Already, it's less overwhelming, right? Just a few sentences telling me what I need to know. It's clearly organized, and there's a polite greeting and sign-off. This is a good example of an email. Short and to the point, polite and well written, all of the things we've been talking about so far. But what do you do if what you need to say is too long for an email? Well, you might want to set up a meeting instead. It's important to answer in a timely manner as well. You don't want to take so long replying to emails that your coworkers start wondering if you're okay. I always try to answer emails in 24 to 48 hours, even if it's just to give them a timeline for when I'll have the actual answers they're looking for. That way, I can set expectations and they know I'm working on it. That works the other way around too. If you need a response on something specific from one of your team members, be clear about what you need and when you need it so that they can get back to you. I'll even include a date in my subject line and bold dates in the body of my email so it's really clear. Remember, being clear about your need is a big part of being a good communicator. We covered some great ways to improve our professional communication skills, like asking questions, practicing good writing habits, and some email tips and tricks. These will help you communicate clearly and effectively with your team members on any project. It might take some time, but you'll find a communication style that works for you and your team, both in person and online. As long as you're willing to learn, you won't have any problems adapting to different communication expectations you'll see in future jobs. We discussed before how data has limitations. Sometimes you don't have access to the data you need, or your data sources aren't aligned, or your data is unclean. This can definitely be a problem when you're analyzing data, but it can also affect your communication with your stakeholders. That's why it's important to balance your stakeholders' expectations with what is actually possible for a project. We're going to learn about the importance of setting realistic, objective goals and how to best communicate with your stakeholders about problems you might run into. Keep in mind that a lot of things depend on your analysis. Maybe your team can't make a decision without your report, or maybe your initial data work will determine how and where additional data will be gathered. You might remember that we've talked about some situations where it's important to loop stakeholders in. For example, telling your project manager if you're on schedule or if you're having a problem. Now let's look at a real-life example where you need to communicate with stakeholders and what you might do if you run into a problem. Let's say you're working on a project for an insurance company. The company wants to identify common causes of minor car accidents so that they can develop educational materials that encourage safer driving. There's a few early questions you and your team need to answer. What driving habits will you include in your dataset? How will you gather this data? How long will it take you to collect and clean that data before you can use it in your analysis? Right away, you'll want to communicate clearly with your stakeholders to answer these questions, so you and your team can set a reasonable and realistic timeline for the project. It can be tempting to tell your stakeholders that you'll have this done in no time, no problem, but setting expectations for a realistic timeline will help you in the long run. Your stakeholders will know what to expect when, and you won't be overworking yourself and missing deadlines because you overpromised. I find that setting expectations early helps me spend my time more productively. So as you're getting started, you'll want to send a high-level schedule with different phases of the project and their approximate start dates. In this case, you and your team establish that you'll need 3 weeks to complete the analysis and provide recommendations. And you let your stakeholders know so they can plan accordingly. Now, let's imagine you're further along in the project and you run into a problem. Maybe drivers have opted into sharing data about their phone usage in the car, but you discover that some sources count GPS usage and some don't in their data. This might add time to your data processing and cleaning and delay some project milestones. You'll want to let your project manager know and maybe work out a new timeline to present to stakeholders. The earlier you can flag these problems, the better. That way, your stakeholders can make necessary changes as soon as possible. Or what if your stakeholders want to add car model or age as possible variables? You'll have to communicate with them about how that might change the model you've built, if it can be added in before the deadlines, and any other obstacles that they need to know so they can decide if it's worth changing at this stage of the project. To help them, you might prepare a report on how their request changes the project timeline or alters the model. You could also outline the pros and cons of that change. You want to help your stakeholders achieve their goals, but it's important to set realistic expectations at every stage of the project. This takes some balance. You've learned about balancing the needs of your team members and stakeholders, but you also need to balance stakeholder expectations and what's possible with the project's resources and limitations. That's why it's important to be realistic and objective and communicate clearly. This will help stakeholders understand the timeline and have confidence in your ability to achieve those goals. So we know communication is key, and we have some good rules to follow our professional communication. Coming up, we'll talk even more about answering stakeholder questions, delivering data, and communicating with your team.
I'm Sarah, and I'm a senior analytical lead at Google. As a data analyst, there's going to be times where you have different stakeholders who have no idea about the amount of time that it takes you to do each project. And in the very beginning, when I'm asked to do a project or to look into something, I always try to give a little bit of expectation settings on the turnaround, because most of your stakeholders don't really understand what you do with data and how you get it and how you clean it and put together the story behind it. The other thing that I want to make clear to everyone is that you have to make sure that the data tells you the stories. Sometimes people think that data can answer everything, and sometimes we have to acknowledge that that is simply untrue. I recently worked with a state to figure out why people weren't signing up for the benefits that they needed and deserved. We saw people coming to the site and where they would sign up for those benefits and see if they're qualified, but for some reason there was something stopping them from taking the step of actually signing up. So I was able to look into it using Google Analytics to try to uncover what is stopping people from taking the action of signing up from these benefits that they need and deserve. And so I go into Google Analytics, I see people are going back between the service page and the unemployment page, back to the service page, back to the unemployment page. And so I came up with a theory that, hey, people aren't finding the information that they need in order to take the next step to see if they qualify for these services. The only way that I can actually know why someone left the site without taking action is if I ask them. I would have to survey them. Google Analytics did not give me the data that I would need to 100% back my theory or deny it. So when you're explaining to your stakeholders, hey, I have a theory, this data is telling me a story, however, I can't 100% know due to the limitations of data, you just have to say it. So the way that I communicate that is I say, I have a theory that people are not finding the information that they need in order to take action. Here's the proof points that I have that supports that theory. So what we did was we then made it a little bit easier to find that information. Even though we weren't 100% sure that my theory was correct, we were confident enough to take action. And then we looked back and we saw all the metrics that pointed me to this theory improve. And so that always feels really good when you're able to help a cause that you believe in do better and help more people through data. It makes all the nerdy learning about SQL and everything completely worth it.
We live in a world that loves instant gratification. Whether it's overnight delivery or on-demand movies, we want what we want and we want it now. But in the data world, speed can sometimes be the enemy of accuracy, especially when collaboration is required. We're going to talk about how to balance speedy answers with right ones, and how to best address these issues by reframing questions and outlining problems. That way, your team members and stakeholders understand what answers they can expect when. As data analysts, we need to know the why behind things like a sales slump, a player's batting average, or rainfall totals. It's not just about the figures, it's about the context too. And getting to the bottom of these things takes time. So if a stakeholder comes knocking on your door, a lot of times that person may not really know what they need. They just know they want it at light speed. But sometimes the pressure gets to us, and even the most experienced data analysts can be tempted to cut corners and provide flawed or unfinished data in the interest of time. When that happens, so much of the story in the data gets lost. That's why communication is one of the most valuable tools for working with teams. It's important to start with structured thinking and a well-planned scope of work, which we talked about earlier. If you start with a clear understanding of your stakeholders' expectations, you can then develop a realistic scope of work that outlines agreed upon expectations, timelines, milestones, and reports. This way, your team always has a roadmap to guide their actions. And if you're pressured for something that's outside of the scope, you can feel confident setting more realistic expectations. At the end of the day, it's your job to balance fast answers with the right answers, not to mention figuring out what the person is really asking. Now seems like a good time for an example. Imagine your VP of HR shows up at your desk demanding to see how many new hires are completing a training course they've introduced. She says, there's no way people are going through each section of the course. The human resources team is getting slammed with questions. We should probably just cancel the program. How would you respond? Well, you could log into the system, crunch some numbers, and hand them to your supervisor. That would take no time at all. But the quick answer might not be the most accurate one. So instead, you could reframe her question, outline the problem, challenges, potential solutions, and time frame. You might say, I can certainly check out the rates of completion, but I sense there may be more to the story here. Could you give me 2 days to run some reports and learn what's really going on? With more time, you can gain context. You and the VP of HR decide to expand the project timeline so that you can spend time gathering anonymous survey data from new employees about the training course. Their answers provide data that can help you pinpoint exactly why completion rates are so low. Employees are reporting that the course feels confusing and outdated. Because you were able to take time to address the bigger problem, the VP of HR has a better idea about why new employees aren't completing the course and can make new decisions about how to update it. Now the training course is easy to follow and the HR department isn't getting as many questions. Everybody benefits. Redirecting the conversation will help you find the real problem, which leads to more insightful and accurate solutions. But it's important to keep in mind, sometimes you need to be the bearer of bad news, and that's okay. Communicating about problems, potential solutions, and different expectations can help you move forward on a project instead of getting stuck. When it comes to communicating answers with your teams and stakeholders, the fastest answer and most accurate answers aren't usually the same answer. But by making sure that you understand their needs and setting expectations clearly, you can balance speed and accuracy. Just make sure to be clear and upfront and you'll find success. Data has the power to change the world. Think about this. A bank identifies 15 new opportunities to promote a product, resulting in $120 million in revenue. A distribution company figures out a better way to manage shipping, reducing their cost by $500,000. Google creates a new tool that can identify breast cancer tumors in nearby lymph nodes. These are all amazing achievements, but do you know what they have in common? They're all the results of data analytics. You absolutely have the power to change the world as a data analyst, and it starts with how you share data with your team. In this video, we will think through all of the variables you should consider when sharing data. When you successfully deliver data to your team, you can ensure that they're able to make the best possible decisions. Earlier, we learned that speed can sometimes affect accuracy when sharing data-based information with a team. That's why you need a solid process that weights the outcomes and actions of your analysis. So, where do you start? Well, the best solutions start with questions. You might remember from our last video that stakeholders will have a lot of questions, but it's up to you to figure out what they really need. So ask yourself, does your analysis answer the original question? Are there other angles you haven't considered? Can you answer any questions that may get asked by your data and analysis? That last question brings up something else to think about. How detailed should you be when sharing your results? Would a high-level analysis be okay? Above all else, your data analysis should help your team make better, more informed decisions. Here's another example. Imagine a landscaping company is facing rising costs and they can't stay competitive in the bidding process. One question you could ask to solve this problem is, can the company find new suppliers without compromising quality? If you gave them a high-level analysis, you'd probably just include the number of clients and cost of supplies. Here, your stakeholder might object. She's worried that reducing quality will limit the company's ability to stay competitive and keep customers happy. Well, she's got a point. In that case, you need to provide a more detailed data analysis to change her mind. This might mean exploring how customers feel about different brands. You might learn that customers don't have a preference for specific landscape brands, so the company can change to the more affordable suppliers without compromising quality. If you feel comfortable using the data to answer all these questions and considerations, you've probably landed on a solid conclusion. Nice! Now that you understand some of the variables involved with sharing data with a team, like process and outcome, you're one step closer to making sure that your team has all the information they need to make informed, data-driven decisions. Now, it's time to discuss meetings. Meetings are a huge part of how you communicate with team members and stakeholders. Let's cover some easy-to-follow do's and don'ts you can use for meetings, both in person or online, so that you can use these communication best practices in the future. At their core, meetings make it possible for you and your team members or stakeholders to discuss how a project is going. But they can be so much more than that. Whether they're virtual or in person, team meetings can build trust and team spirit. They give you a chance to connect with the people you're working with beyond emails. Another benefit is that knowing who you're working with can give you a better perspective of where your work fits into the larger project. Regular meetings also make it easier to coordinate team goals, which makes it easier to reach your objectives. And with everyone on the same page, your team will be in the best position to help each other when you run into problems too. So whether you're leading a meeting or just attending it, there are best practices you can follow to make sure your meetings are a success. There are some really simple things you can do to make a great meeting. Come prepared, be on time, pay attention, and ask questions. This applies to both meetings you lead and ones you attend. Let's break down how you can follow these to-dos for every meeting. So what do I mean when I say come prepared? Well, a few things. First, bring what you need. If you like to take notes, have your notebook and pens in your bag or your work device on hand. Being prepared also means you should read the meeting agenda ahead of time and be ready to provide any updates on your work. If you're leading the meeting, make sure to prepare your notes and presentations and know what you're going to talk about. And of course, be ready to answer questions. These are some other tips that I like to follow when I'm leading a meeting. First, every meeting should focus on making a clear decision and include the person needed to make that decision. And if there needs to be a meeting in order to make a decision, schedule it immediately. Don't let progress stall by waiting until next week's meeting. Lastly, try to keep the number of people at your meeting under 10 if possible. More people makes it hard to have a collaborative discussion. It's also important to respect your team members' time. The best way to do this is to come to meetings on time. If you're leading the meeting, show up early and set up beforehand so you're ready to start when people arrive. You can do the same thing for online meetings. Try to make sure your technology is working beforehand and that you're watching the clock so you don't miss a meeting accidentally. Staying focused and attentive during a meeting is another great way to respect your team members' time. You don't want to miss something important because you were distracted by something else during a presentation. Paying attention also means asking questions when you need clarification, or if you think there may be a problem with a project plan. And don't be afraid to reach out after a meeting. If you didn't get to ask your question, follow up with the group afterwards and get your answer. When you're the person leading the meeting, make sure you build and send out an agenda beforehand so your team members can come prepared and leave with clear takeaways. You'll also want to keep everyone involved. Try to engage with all your attendees so you don't miss out on any insights from your team members. And let everyone know that you're open to questions after the meeting too. It's a great idea to take notes even when you're leading the meeting. This makes it easier to remember all questions that were asked. Then afterwards, you can follow up with individual team members to answer those questions or send an update to your whole team, depending on who needs that information. Now let's go over what not to do in meetings. There are some obvious don'ts here. You don't want to show up unprepared, late, or distracted for meetings. You also don't want to dominate the conversation, talk over others, or distract people with unfocused discussion. Try to make sure you give other team members a chance to talk and always let them finish their thought before you start speaking. Everyone who is attending your meeting should be giving their input. Provide opportunities for people to speak up, ask questions, call for expertise, and solicit their feedback. You don't want to miss out on their valuable insights. And try to have everyone put their phones or computers on silent when they're not speaking, you included. Now we've learned some best practices you can follow in meetings, like come prepared, be on time, pay attention, and ask questions. We also talked about using meetings productively to make clear decisions and promoting collaborative discussions, and to reach out after a meeting to address questions you or others might have had. You also know what not to do in meetings: showing up unprepared, late, or distracted, or talking over others and missing out on their input. With these tips in mind, you'll be well on your way to productive, positive team meetings. But of course, sometimes there will be conflict in your team. We'll discuss conflict resolution soon. Joining a new team was definitely scary at the beginning, especially at a company like Google where it's really big and everyone is extremely smart. But I really leaned on my manager to understand what I could bring to the table, and that made me feel a lot more comfortable in meetings while sharing my abilities. I found that my best projects start off when the communication is really clear about what's expected. If I leave the meeting where the project is being asked of me, knowing exactly where to start and what I need to do, that allows for me to get it done faster, more efficiently, and getting to the real goal of it, and maybe going an extra step further because I didn't have to spend any time confused on what I needed to be doing. Communication is so important because it gets you to the finish line the most efficiently and also makes you look really good. When I first started, I had a good amount of projects thrown at me and I was really excited, so I went into them without asking too many questions. At first, that was an obstacle because while you can thrive in ambiguity as to what the project objective is can be really harmful when you're actually trying to get the goal done. And I overcame that by simply taking a step back when someone asked me to do the project and just clarifying what that goal was. Once that goal was crisp, I was happy to go into the ambiguity of how to get there, but the goal has to be really objective and clear. I'm Jimena and I'm a financial analyst. It's normal for conflict to come up in your work life. A lot of what you've learned so far, like managing expectations and communicating effectively, can help you avoid conflict. But sometimes you'll run into conflict anyways. If that happens, there are ways to resolve it and move forward. In this video, we will talk about how conflict could happen and the best ways you can practice conflict resolution. A conflict can pop up for a variety of reasons. Maybe a stakeholder misunderstood the possible outcomes for your project. Maybe you and your team member have very different work styles. Or maybe an important deadline is approaching and people are on edge. Mismatched expectations and miscommunications are some of the most common reasons conflicts happen. Maybe you weren't clear on who was supposed to clean a data set and nobody cleaned it, delaying a project. Or maybe a teammate sent out an email with all of your insights included, but didn't mention it was your work. And while it can be easy to take conflict personally, it's important to try and be objective and stay focused on the team's goals. Believe it or not, tense moments can actually be opportunities to reevaluate a project and maybe even improve things. So when a problem comes up, there are a few ways you can flip the situation to be more productive and collaborative. One of the best ways you can shift a situation from problematic to productive is to just reframe the problem. Instead of focusing on what went wrong or who to blame, change the question you're starting with. Try asking, how can I help you reach your goal? This creates an opportunity for you and your team members to work together to find a solution instead of feeling frustrated by the problem. Discussion is key to conflict resolution. If you find yourself in the middle of a conflict, try to communicate, start a conversation, or ask things like, are there other important things I should be considering? This gives your team members or stakeholders a chance to fully lay out your concerns. But if you find yourself feeling emotional, give yourself some time to cool off so you can go into the conversation with a clearer head. If I need to write an email during a tense moment, I'll actually save it to drafts and come back to it the next day to reread it before sending, to make sure that I'm being level-headed. And if you find you don't understand what your team member or stakeholder is asking you to do, try to understand the context of their request. Ask them what their end goal is, what story they're trying to tell with the data, or what the big picture is. By turning moments of potential conflict into opportunities to collaborate and move forward, you can resolve tension and get your project back on track. So instead of saying, there's no way I can do that in this time frame, try to reframe it by saying, I would be happy to do that, but it'll just take this amount of time. Let's take a step back so I can better understand what you'd like to do with the data, and we can work together to find the best path forward. And with that, we've reached the end of this section. Great job! Learning how to work with new team members can be a big challenge in starting a new role or a new project. But with the skills you've picked up in these videos, you'll be able to start on the right foot with any new team you join. So far, you've learned about balancing the needs and expectations of your team members and stakeholders. You've also covered how to make sense of your team's roles and focus on the project objective, the importance of clear communication and communication expectations in a workplace, and how to balance the limitation of data with stakeholder asks. Finally, we covered how to have effective team meetings and how to resolve conflicts by thinking collaboratively with your team members. Hopefully now you understand how important communication is to the success of a data analyst. These communication skills might feel a little different from some of the other skills you've been learning in this program, but they're also an important part of your data analyst toolkit and your success as a professional data analyst. And just like all of the other skills you're learning right now, your communication skills will grow with practice and experience.
Hey, I'm Nathan. I'm a principal data analyst in the Trust and Safety organization at Google. I joined the Marine Corps Reserves when I was attending college, and the reserve unit I joined was a field artillery unit. So after a challenging Marine Corps boot camp, I went to Field Artillery Fire Direction Control School. And for those of you that might not know, fire direction control is considered the brains of field artillery. And we used all sorts of computers to do our artillery calculations. But just in case the computers went down, we also were trained how to use slide rules as a backup. And then a year later, had the opportunity to be activated as a truck driver instead of my primary job as a field artilleryman, and was deployed to Iraq to drive trucks for an infantry company. After I got back from Iraq, I finished up my bachelor's degree and then worked as an applications engineer in Austin, Texas, and eventually saw the need to pivot more, to focus more on business. And that's when I really fell in love with data analysis, was when I was learning a lot more about business. It actually took me a couple years when I really sparked an interest in data analysis to land a role where I got to do it full time and really get my hands dirty with the data. Some of the things I did to lay the groundwork to be ready and be qualified for that was I took a Coursera course on R, and I also did some data science hackathons where you spend an entire weekend at some university and they release the data set Friday night, and by Sunday afternoon you have to come up with some recommendations. So those were two really good ways to really prepare myself, get good experience, and really show a strong interest in data analysis. My first job where I got to do data analysis full time was at a large bank, and I was just in heaven. I got to really do SQL for real. And also I got to use Tableau a ton, got to go to a Tableau conference. It was really cool. Then I was fortunate enough to get an opportunity to move to Google into my current role that's in trust and safety. And what's super exciting and fulfilling about that is that, similar to the military, it has an overall mission of protecting people. So that's super exciting for me. The things that were instilled in me in the Marines that I use to this very day would be attention to detail. That's super important in the military overall, but especially in field artillery. Secondly is the importance of communication. You have your own details locked in. You need to make sure that those are communicated really clearly to other people that you're working with. And the third would be collaboration. In the military, teamwork makes the dream work. You really rely on the team. That's definitely been the case in my post-Marine Corps career and jobs.
Congrats! You've made it through another course. And you know what that means? It's time for the course challenge. You'll take everything you've learned in this course and apply it in these upcoming activities. As always, feel free to review any of the work we did to refresh your memory before the challenge. Once you've finished, we'll meet back here to find out what's coming in the next course. Good luck, you got this. Okay, now that you're done, you're officially ready to take on the next course. Awesome job. But before I tell you about what's ahead, let's take a moment to think about what we've covered so far in the first step of the data analysis process. In this course, we explored effective questions, and we learned how to use quantitative and qualitative data, metrics, and math to connect the dots. We also covered spreadsheet basics, how to apply structured thinking, and key communication skills for working with stakeholders and team members. That's a lot. And now it's time to take what you learned into the next course, where you'll tackle the next step of the data analysis process. Prepare your data. Hallie is going to take over from here. You might remember her from the beginning of the first course. She'll guide you as you learn new, important tools for your work like data types and data structures, bias and credibility in analytics, databases, organizing and protecting your data, and the data community. Thanks for sticking with me through this course. When you're ready, you can go ahead to the first video in the next course. Good luck. You're going to do great.
Picture this. You're working on a project. You've asked all the right questions, applied structured thinking, and you're completely in sync with your stakeholders. You're off to a great start. But there's another step in the process, preparing the data correctly. This is where understanding the different types of data and data structures comes in. Knowing this lets you figure out what type of data is right for the question you're answering. Plus, you'll gain practical skills about how to extract, use, organize, and protect your data. Hey, my name's Hallie, and I'm an analytical lead at Google. I work with companies in the healthcare industry. I'm so excited to welcome you to this course. You've been building up your data analyst skills in lots of different ways so far. You've learned how to ask the right questions, define the problem, and present your analysis in a way that matches up with the needs of your stakeholders. In other words, you've learned how to tell a story using data. Now we'll learn more about the data that you'll need to tell the best story possible. But before we do that, I'd love to tell you my story. I use analytics to help healthcare companies develop digital marketing solutions that make their business and their brand stronger. My team and I find business and media opportunities based on the latest industry and data insights. I've been working in healthcare for about 5 years, and it's great. I really enjoy being able to use data to help spark change in such an important industry. As you'll discover in this course, data can be the main character in a very powerful story. I absolutely love using analysis to tell that story in a way that's compelling and informative. Here's a real-life example of how I've used data to tell a story. In my job, we analyze Medicare enrollment data over time and make connections to how people research Medicare plans on Google. As people 65 and older become more informed decision makers for their health, I use the data to learn if there's an increase in Medicare enrollments and what part Google searches play if there is an increase in demand. Now, it's very important that I make sure the data is relevant and valid. I also have to pay attention to questions around access and equity while maintaining the privacy of those conducting searches. The happy ending of my story is that the data in my findings is useful to medical professionals and their patients. There's so much useful data out there, and you're building the skills you'll need to find and use the right data in the best way. In this course, you'll continue sharpening those skills. So you've already heard a lot about the data analysis process steps: ask, prepare, process, analyze, share, and act. Now it's time to learn how to prepare the data. You'll learn to identify how data is generated and collected, and you'll explore different formats, types, and structures of data. We'll make sure you know how to choose and use data that'll help you understand and respond to a business problem. And because not all data fits each need, you'll learn how to analyze data for bias and credibility. We'll also explore what clean data means. But wait, there's more. You'll also get up close and personal with databases. We'll cover what they are and how analysts use them. You'll even get to extract your own data from a database using a couple of tools that you're already familiar with: spreadsheets and SQL. The key here is patience. Like anything worth doing, this will take time and practice, and I'll be with you every step of the way. Still with me? Great. The last few things we'll cover are the basics of data organization and the process of protecting your data. Data works best when it's organized, and if you're organizing your data, you'll want to protect it too. I'll show you how to do both and apply it to your own analysis. I'm so excited to help you write your own personal story as you continue exploring the world of data analytics. So let's do it. Healthcare is just a really fascinating place in the US. I find it's a really incredible industry to work in because it is so historically traditional. And healthcare companies, unlike other tech companies, just really have not used data to inform decisions. When I was in college, I had a professor who didn't want us to have textbooks because he just said the healthcare industry was changing so rapidly and it wouldn't make sense to have a textbook, which is just a static piece of text when things were just really evolving. And so I would say healthcare and data and the two together is a newer concept, using big data, using machine learning and artificial intelligence to help the healthcare industry. I started analyzing large sums of patient data. That was the first time I had really worked with such huge data sets. And I found it really fascinating that we can take all of these data sets and synthesize them and allow us to really deliver some cool insights and trends to our hospital systems. That was the first time I started thinking about data analysis, data analytics as a possible career for me. And so that's really what brought me to this analytical lead role at Google, where I could take that knowledge and that skill set of analyzing data sets and do that on a daily basis, so that really every conversation I was having with the client was a data-informed conversation. I work within the healthcare vertical, so we have companies who market on our platforms like Google Search and YouTube, and so we help them understand the healthcare industry so that they can better market to the audience that they're trying to reach. Whether you're a healthcare insurer or you're a healthcare provider, maybe a hospital system, they all have different needs on how they want to reach their audience using Google's platforms. So we help them optimize their marketing spend, but we also do a lot of research in the healthcare industry, some user research, some understanding of how users are really just searching on Google to give them a sense of what's really happening in the industry and how they can market effectively. I would say that my technical skills with data analytics came with time. And the most important skill I found, which has also come with time and grown with me, is just the creativity side of data analysis. I mean, you can really learn a lot of the SQL skills and R, and I know some of that is within the course. But really the creativity side is something that just comes with experience. So when you're looking at a data set, you might look at it one way and analyze it one way, and then have someone else look at it or look at it a week later, and then all of a sudden the trend that you're seeing is completely different. So you have to take a lot of these pieces of information, these nuggets I like to call them, and just piece together a really nice narrative using data. And so that skill set is something I learned when I was working in consulting, and I've taken that to Google and really been able to polish a lot of those skills and some of the more technical skills. So technical and the creative side are what I've grown to love. My name is Hallie. I'm an analytical lead at Google, working specifically in the healthcare vertical. Right now, data is being generated all around the world, and we're talking tons of data. Every minute of every day, millions of texts and hundreds of millions of emails are sent. On top of that, millions of online searches are made and videos viewed. And those numbers are only growing. That's a lot of data. So let's learn more about how it's made and used. In this video, we'll talk about the ways that data can be generated and how industries collect data themselves. Every piece of information is data, and all that data is usually generated as a result of our activity in the world. These days, we spend a lot of time online. With social media and mobile devices, millions and millions of people are adding to the huge amount of data out there, each and every day. Think about it like this. Every digital photo online is one piece of data. And every photo itself holds even more data, from the number of pixels to the colors contained in each of those pixels. But that's not the only way data is made. We can also generate data by collecting information. This kind of data generation and collection comes with a few more things to think about. It needs to be done with consideration to ethics so that we maintain people's rights and privacy. We'll learn more about that later on. For now, let's check out a real-world example. The United States Census Bureau uses forms to collect data about the country's population. This data is used for a number of reasons, like funding for schools, hospitals, and fire departments. The Bureau also collects information about things like U.S. businesses, creating their own data in the process. The great thing about this is that others can then use the data for their own needs, including analysis. The annual business survey is used to figure out the needs of businesses and how to provide them with resources to help them succeed. I actually generate data in the analytics I do for the healthcare industry. We run a lot of surveys to learn how patients feel about certain things related to their healthcare. For example, one survey asked how patients feel about telemedicine versus in-person doctor visits. The data we collected help the companies we work with improve the care that their patients receive. Survey data is just one example. There's all kinds of data being generated all the time, and there's lots of different ways to collect it. Even something as simple as an interview can help someone collect data. Imagine you're in a job interview. To impress the hiring manager, you'll want to share information about yourself. The hiring manager collects that data and analyzes it to help them decide whether to hire you or not. But it goes both ways. You could also collect your own data about the company to help you decide if the company is a good fit for you. Or you can use the data you collect to come up with thoughtful questions to ask the interviewer. Scientists also generate data. They use a lot of observations in their work. For example, they might collect data by studying animal behavior or looking at bacteria under a microscope. Earlier, we talked about the forms that the U.S. Census Bureau uses to collect data. Forms, questionnaires, and surveys are commonly used ways to collect and generate data. One thing to note, data that's generated online doesn't always happen directly. Have you ever wondered why some online ads seem to make really accurate suggestions? Or how some websites remember your preferences? This is done using cookies, which are small files stored on computers that contain information about users. Cookies can help inform advertisers about your personal interests and habits based on your online surfing, without personally identifying you. As a real-world analyst, you'll have all kinds of data right at your fingertips, and lots of it too. Knowing how it's been generated can help add context to the data, and knowing how to collect it can make the data analysis process more efficient. Coming up, you'll learn how to decide what data to collect for your analysis, so stay tuned. Welcome back. We've talked a lot about all the data out there in the world, but as a data analyst, you'll need to decide what kind of data to collect and use for every project. And with a nearly endless amount of data out there, this can be quite a bit of a data dilemma. But there's good news. In this video, you'll learn which factors to consider when collecting data. Usually, you'll have a head start in figuring out the right data for the job because the data you need will be given to you, or your business task or problem will narrow down your choices. So let's start with a question like, what's causing increased rush hour traffic in your city? First, you need to know how the data will be collected. You might use observations of traffic patterns to count the number of cars on city streets during particular times. You notice that cars are getting backed up on a specific street. That brings us to data sources. In our traffic example, your observations would be first-party data. This is data collected by an individual or group using their own resources. Collecting first-party data is typically the preferred method because you know exactly where it came from. You might also have second-party data, which is data collected by a group directly from its audience and then sold. So in our example, if you aren't able to collect your own data, you might buy it from an organization that's led traffic pattern studies in your city. This data didn't start with you, but it's still reliable because it came from a source that has experience with traffic analysis. The same can't always be said about third-party data, or data collected from outside sources who did not collect it directly. This data might have come from a number of different sources before you investigated it, so it might not be as reliable. But that doesn't mean it can't be useful. You'll just want to make sure you check it for accuracy, bias, and credibility. Actually, no matter what kind of data you use, it needs to be inspected for accuracy and trustworthiness. We'll learn more about that process later. For now, just remember that the data you choose should apply to your needs and it must be approved for use. As a data analyst, it's your job to decide what data to use. And that means choosing the data that can help you find answers and solve problems, and not getting distracted by other data. In our traffic example, financial data probably wouldn't be that helpful, but existing data about high volume traffic times would be. Okay, now let's talk about how much data to collect. In data analytics, a population refers to all possible data values in a certain data set. So if you're analyzing data about car traffic in a city, your population would be all of the cars in that area. But collecting data from the entire population can be pretty challenging. That's why a sample can be useful. A sample is a part of a population that is representative of the population. You might collect a data sample about one spot in the city and analyze the traffic there. Or you might pull a random sample from all existing data in the population. How you choose your sample will depend on your project. As you collect data, you'll also want to make sure you select the right data type. For traffic data, an appropriate data type could be the dates of traffic records stored in a date format. The dates could help you figure what days of the week there is likely to be a high volume of traffic in the future, We'll explore this topic in more detail soon. Finally, you need to determine the time frame for data collection. In our example, if you needed an answer immediately, you'd have to use historical data, which is data that already exists. But let's say you needed to track traffic patterns over a long period of time. That might affect the other decisions you make during data collection. And now you know more about the different data collection considerations you'll use as a data analyst. And because of that, you'll be able to find the right data when you start collecting it yourself. There's still more to learn about data collection, so stay tuned. I don't know about you, but when I'm choosing a movie to watch, I sometimes get stuck between a couple of choices. If I'm in the mood for excitement or suspense, I might go for a thriller. But if I need a good laugh, I'll choose a comedy. If I really can't decide between two movies, I might even use some of my data analysis skills to compare and contrast them. Come to think of it, there really needs to be more movies about data analysts. I'd watch that. But since we can't watch a movie about data, at least not yet, we'll do the next best thing. Watch data about movies. We're going to take a look at this spreadsheet with movie data. We know we can compare different movies and movie genres. Turns out you can do the same with data and data formats. Let's use our movie data spreadsheet to understand how that works. We'll start with quantitative and qualitative data. If we check out column A, we'll find titles of the movies. This is qualitative data because it can't be counted, measured, or easily expressed using numbers. Qualitative data is usually listed as a name, category, or description. In our spreadsheet, the movie titles and cast members are qualitative data. Next up is quantitative data, which can be measured or counted and then expressed as a number. This is data with a certain quantity, amount, or range. In our spreadsheet here, the last two columns show the movie's budget and box office revenue. The data in these columns is listed in dollars, which can be counted, so we know that data is quantitative. We can go even deeper into quantitative data and break it down into discrete or continuous data. Let's check out discrete data first. This is data that's counted and has a limited number of values. Going back to our spreadsheet, we'll find each movie's budget and box office returns in columns M and N. These are both examples of discrete data. They can be counted and have a limited number of values. For example, the amount of money a movie makes can only be represented with exactly 2 digits after the decimal to represent cents. There can't be anything between 1 and 2 cents. Continuous data can be measured using a timer, and its value can be shown as a decimal with several places. So let's imagine a movie about data analysts that I'm definitely going to star in someday. You could express that movie's runtime as 110.0356 minutes. You could even add fractional data after the decimal point if you needed to. There's also nominal and ordinal data. Nominal data is a type of qualitative data that's categorized without a set order. In other words, this kind of data doesn't have a sequence. Here's a quick example. Let's say you're collecting data about movies. You ask people if they've watched a given movie. Their responses would be in the form of nominal data. They could respond yes, no, or not sure. These choices don't have a particular order. Ordinal data, on the other hand, is a type of qualitative data with a set order or scale. If you asked a group of people to rank a movie from 1 to 5, some might rank it as a 2, others a 4, and so on. These rankings are in order of how much each person liked the movie. Now let's talk about internal data, which is data that lives within a company's own systems. For example, if a movie studio had compiled all of the data in the spreadsheet using only their own collection methods, then it would be their internal data. The great thing about internal data is that it's usually more reliable and easier to collect. But in this spreadsheet, it's more likely that the movie studio had to use data owned or shared by other studios and sources because it includes movies they didn't make. That means they'd be collecting external data. External data is, you guessed it, data that lives and is generated outside of an organization. External data becomes particularly valuable when your analysis depends on as many sources as possible. A great thing about this data is that it's structured. Structured data is data that's organized in a certain format, such as rows and columns. Spreadsheets and relational databases are two examples of software that can store data in a structured way. You might remember our earlier exploration of structured thinking, which helps you add a framework to a problem so that you can solve it in an organized and logical manner. You can think of structured data in the same way. Having a framework for the data makes the data easily searchable and more analysis ready. As a data analyst, you'll work with a lot of structured data, which will usually be in the form of a table, spreadsheet, or relational database. But sometimes you'll come across unstructured data. This is data that is not organized in any easily identifiable manner. Audio and video files are examples of unstructured data because there's no clear way to identify or organize their content. Unstructured data might have internal structure, but the data doesn't fit neatly in rows and columns like structured data. And there you have it. Hopefully you're now more familiar with data formats and how you might use them in your work. And in just a bit, you'll continue to explore structured data and learn even more about the data you'll use most often as an analyst, coming soon to a screen near you. Hi, great to see you again. Earlier, we compared some data formats, including structured and unstructured data. Most of the data being generated right now is actually unstructured. Audio files, video files, emails, photos, and social media are all examples of unstructured data. These can be harder to analyze in their unstructured format. But here's the good news. You'll be working with structured data most of the time. For example, if you need to analyze data about the unstructured data in emails, photos, and social media sites, it'll most likely be structured for analysis before you even get to it. Because of that, I want to explore structured data a bit more. As a quick refresher, structured data is data organized in a format like rows and columns, but there's definitely more to it than that. Structured data works nicely within a data model, which is a model that is used for organizing data elements and how they relate to one another. What are data elements? They're pieces of information, such as people's names, account numbers, and addresses. Data models help to keep data consistent and provide a map of how data is organized. This makes it easier for analysts and other stakeholders to make sense of their data and use it for business purposes. In addition to working well within data models, structured data is also useful for databases. This makes it easy for analysts to enter, query, and analyze the data whenever they need to. This also helps make data visualization pretty easy because structured data can be applied directly to charts, graphs, heat maps, dashboards, and most other visual representations of data. All right, so now we know that spreadsheets and databases that store datasets are widely used sources of structured data. After you explore some other data structures, you'll check out more data types using a spreadsheet. The adventure continues. By now you've learned a lot about data. From generated data to collected data to data formats, it's good to know as much as you can about the data you'll use for analysis. In this video, we'll talk about another way you can describe data, the data type. A data type is a specific kind of data attribute that tells what kind of value the data is. In other words, a data type tells you what kind of data you're working with. Data types can be different depending on the query language you're using. For example, SQL allows for different data types depending on which database you're using. For now, though, let's focus on the data types that you'll use in spreadsheets. To help us out, we'll use a spreadsheet that's already filled with data. We'll call it Worldwide Interest in Suites through Google searches. Now, a data type in a spreadsheet can be one of three things: a number, a text, or string, or a Boolean. You might find spreadsheet programs that classify them a bit differently or include other types, but these value types cover just about any data you'll find in spreadsheets. We'll look at all of these in just a bit. Looking at columns B, D, and F, we find number data types. Each number represents the search interest for the terms cupcakes, ice cream, and candy for a specific week. The closer a number is to 100, the more popular that search term was during that week. 100 represents peak popularity. Keep in mind that, in this case, 100 is a relative value, not the actual number of searches. It represents the maximum number of searches during a certain time. Think of it like a percentage on a test. All other searches are then also valued out of 100. You might notice this in other data sets as well. Gold star for 100. If you needed to, you could change the numbers into percents or other formats like currency. These are all examples of number data types. In column H, the data shows the most popular treat for each week, based on the search data. So as we'll find in cell H4, for the week beginning July 28, 2019, the most popular treat was ice cream. This is an example of a text data type, or a string data type, which is a sequence of characters and punctuation that contains textual information. In this example, that information would be the treats and people's names. These can also include numbers like phone numbers or numbers and street addresses. But these numbers wouldn't be used for calculations. So in this case, they're treated like text, not numbers. In columns C, E, and G, it seems like we've got some text. But the text here isn't a text or string data type. Instead, it's a Boolean data type. A Boolean data type is a data type with only two possible values, true or false. Columns C, E, and G show Boolean data for whether the search interest for each week is at least 50 out of 100. Here's how it works. To get this data, we've created a formula that calculates whether the search interest data in columns B, D, and F is 50 or greater. In cell B4, the search interest is 14. So in cell C4, we find the word false, because for this week of data, the search interest is less than 50. So for each cell in columns C, E, and G, the only two possible values are true or false. We could change the formula so other words appear in these cells instead, but it's still Boolean data. You'll get a chance to read more about the Boolean data type soon. Let's talk about a common issue that people encounter in spreadsheets: mistaking data types with cell values. For example, in cell B57, we can create a formula to calculate data in other cells. This will give us the average of the search interest in cupcakes across all weeks in the dataset, which is about 15. The formula works because we calculated using a number data type. But if we tried it with a text or string data type, like the data in column C, we'd get an error. Error values usually happen if a mistake is made in entering the values in the cells. So the more you know your data types and which ones to use, the less errors you'll run into. There you have it, a data type for everyone. And we're not done yet. Coming up, we'll go deeper into the relationship between data types, fields, and values. See you soon. Here's a riddle for you. What do a music playlist, a calendar agenda, and an email inbox have in common? I'll give you a hint. It's not a weekly jam session. The answer is they're all arranged in tables. Go ahead and check out your email inbox or a favorite playlist, or look at your calendar agenda. There's tables in every one. A data table, or tabular data, has a very simple structure. It's arranged in rows and columns. You can call the rows records and the columns fields. They basically mean the same thing. But records and fields can be used for any kind of data table, while rows and columns are usually reserved for spreadsheets. When talking about structured databases, people in data analytics usually go with records and fields. Sometimes, a field can also refer to a single piece of data, like the value in a cell. In any case, you'll hear both versions of these terms used throughout this program and your job. Let's go back to our playlist example. We'll use the new terms we just introduced. So each song is a record. Each record has the same fields as the other records, in the same order. In other words, the playlist has the same information about each song. Each song characteristic, like the title and the artist, is a field. Each separate field has the same data type, but different fields can have different types. Let me show you what I mean. For the song list, the song titles are a text or string type, while the song's length could be a number type if you're using it for calculations, or it could be a date and time type. The column for favorites is Boolean, since it has two possible values, favorite or not favorite. We can view spreadsheets in the same way. The records in a spreadsheet might be about all sorts of things: clients, products, invoices, or really anything else. Each record has several fields, which reveal more about the clients, products, or invoices. The value in every cell contains a specific piece of data, like the address of a client or the dollar amount of an invoice. As a data analyst, lots of data will come your way, and records, fields, and values in data tables will help you navigate analysis. Understanding the structures of the tables you're working with is a part of that. And hopefully, while you're working hard on your analysis in those tables, you can have a little fun with a different data table, the one with your favorite playlist. You probably use the words wide and long all the time. You might use wide to describe the size of something from side to side, like a wide river, but a river can also travel great distances, so you might call it long as well. Wait, before you stop the video, I promise you didn't accidentally click in the wrong course. I'm not here to teach you words you already know, but the words wide and long can be used to describe data too. So I am here to help you understand wide data and long data. So far, you've dealt with data arranged mostly in a wide format. With wide data, every data subject has a single row with multiple columns to hold the values of various attributes of the subject. Here's some wide data in a spreadsheet. You might remember we discussed this data about the population of Latin and Caribbean countries earlier. For this data set, each row provides all of the population information about one country. Each column shows the population for a different year. Wide data lets you easily identify and quickly compare different columns. In our example, the data is arranged alphabetically by country, so you can compare the annual populations of Antigua and Barbuda, Aruba, and the Bahamas by just checking out the values in each column. The wide data format also makes it easy to find and compare the country's populations at different periods of time. For example, by sorting the data, we discover that Brazil had the highest population of all countries in 2010. And the British Virgin Islands had the lowest population of all countries in 2013. Okay, now let's explore this data in a long format. Here, the data is no longer organized into columns by year. All the years are now in one column with each country, like Argentina appearing in multiple rows, one for each year of data. This is how long data usually looks. Long data is data in which each row is one time point per subject, so each subject will have data in multiple rows. Our spreadsheet is formatted to show each year of population data. Here we see Antigua and Barbuda first. Long data is a great format for storing and organizing data when there's multiple variables for each subject at each time point that we want to observe. With this long data format, we can store and analyze all of this data using fewer columns. Plus, if we added a new variable, like the average age of a population, we'd only need one more column. If we'd use a wide data format instead, we would have needed 10 more columns, one for each year. The long data format keeps everything nice and compact. If you're wondering which format you should use, the simple answer is, it depends. Sometimes you'll have to transform wide data into a long data format, or other times vice versa. You'll probably work with both formats in your job, and you'll definitely revisit both formats again later in this program. That reminds me, earlier we defined data as a collection of facts. As you've discovered over the last few videos, that collection of facts can take on lots of different formats, structures, types, and more. Learning about all of the ways that data can be presented will be a big help to you throughout the data analysis process. The more you work with data in all its forms, the quicker you'll start to recognize which data to use and when to use it. And in just a bit, you'll use all that data stored in your brain to help you take an assessment. After that, you'll learn how to identify and avoid bias in data and how to embrace credibility, integrity, and ethics. The data adventure moves forward. I'm so glad you're moving with it. Welcome back. In an earlier course, we talked about how to prepare data in a way that helps you tell a meaningful story. Now let's find out what comes next. Like all good tales, your data story will be filled with characters, questions, challenges, conflict, and hopefully a resolution. The trick is to avoid the conflict, overcome the challenges, and answer the questions. That's what this course is all about. Here's how we'll do it. First, you'll learn how to analyze data for bias and credibility. This is very important because even the most sound data can be skewed or misinterpreted. Then we'll learn about the importance of being good and bad. Yep, just like when we were kids. But in this case, we'll be exploring good data sources and learning how to steer clear of their nemesis, bad data. After that, we'll learn more about the world of data ethics, privacy, and access. As more and more data becomes available and the algorithms we create to use this data become more complex and sophisticated, new issues keep popping up. We need to ask questions like, who owns all this data? How much control do we have over the privacy of data? Can we use and reuse data however we want to? As a data analyst, it's important to understand data ethics and privacy because in your work, you'll make a lot of judgment calls on the correct use and application of data. I'm excited to walk you through some of the questions, answers, risks, and rewards involved. Let's open up the first chapter of this data story in our next video. Let's kick things off by traveling back in time. Well, in our minds at least. My real time machine's in the shop. Imagine you're back in middle school and you've entered a project for the science fair. You worked hard for weeks perfecting every element and they're about to announce the winners. You close your eyes, take a deep breath, and you hear them call your name. For second place. Bummer. You really wanted that first place trophy, but hey, you'll take the ribbon for recognition. The next day, you learn the judge was the winner's uncle. How is that fair? Can he really be expected to choose a winner fairly when his own family member is one of the contestants? He's probably biased. Well, maybe his niece deserved to win, and maybe not. But the point is, it's very easy to make a case for bias in that scenario. Now, this is a super simple example, but the truth is, we run into bias all the time in everyday life. Our brains are biologically designed to streamline thinking and make quick judgments. Bias has evolved to become a preference in favor of or against a person, group of people, or thing. And it can be conscious or subconscious. The good news is, once we know and accept that we have bias, we can start to recognize our own patterns of thinking and learn how to manage it. It's important to know that bias can also find its way into the world of data. Data bias is a type of error that systematically skews results in a certain direction. Maybe the questions on a survey had a particular slant to influence answers, or maybe the sample group wasn't truly representative of the population being studied. For example, if you're going to take the median age of the US patient population with health insurance, you wouldn't just use a sample of Medicare patients who are 65 and older. Bias can also happen if a sample group lacks inclusivity. For example, people with disabilities tend to be underidentified, underrepresented, or excluded in mainstream health research. The way you collect data can also bias a dataset. For example, if you give people only a short time to answer questions, their responses will be rushed. When we're rushed, we make more mistakes, which can affect the quality of our data and create biased outcomes. As a data analyst, you have to think about bias and fairness from the moment you start collecting data to the time you present your conclusions. After all, those conclusions can have serious implications. Think about this. It's been acknowledged that clinical studies of heart health tend to include a lot more men than women. This has led to women failing to recognize symptoms and ultimately having their heart conditions go undetected and untreated. That's just one way bias can have a very real impact. While we've come a long way in recognizing bias, it's still led to you losing out to the judge's niece at that science competition. And it's still influencing business decisions, healthcare choices and access, governmental action, and more. So we've still got work to do. Coming up, we'll show you how to identify bias in the data itself and explore some scenarios when you may actually benefit from it. I may be biased, but I think learning about the good and the bad traits of data is pretty fascinating. Next up, we'll discover that there's lots of different types of data bias besides sampling bias, which we covered earlier. As a quick refresher, sampling bias is when a sample isn't representative of the population as a whole. For example, if you're doing research on commuters and only survey people walking by on the sidewalk, you'll miss out on input from people who ride bicycles, drive, or take the subway. You need all sides of the story to avoid sampling bias. In this video, we'll explore 3 more types of data bias: observer bias, interpretation bias, and confirmation bias, and we'll learn how to avoid them. Let's start with observer bias, which is sometimes referred to as experimenter bias or research bias. Basically, it's the tendency for different people to observe things differently. You might remember earlier we learned that scientists use observations a lot in their work, like when they're looking at bacteria under a microscope to gather data. Well, 2 scientists looking into the same microscope might see different things. That's observer bias. Another time observer bias might happen is during manual blood pressure readings. Because the pressure meter is so sensitive, healthcare workers often get pretty different results. Usually, they'll just round up to the nearest whole number to compensate for the margin of error. But if doctors consistently round up or down the blood pressure readings on their patients, health conditions may be missed and any studies involving their patients wouldn't have precise and accurate data. Another common type of data bias is interpretation bias, the tendency to always interpret ambiguous situations in a positive or negative way. Here's an example. Let's say you're having lunch with a colleague when you get a voicemail from your boss asking you to call her back. You put the phone down in a huff, certain that she's angry and you're on the hot seat for something. But when you play the message for your friend, he doesn't hear anger at all. He actually thinks she sounds calm and straightforward. Interpretation bias can lead to 2 people seeing or hearing the exact same thing and interpreting it in a variety of different ways because they have different backgrounds and experiences. Your history with your boss made you interpret the call one way, while your friend interpreted it in another way because they're strangers. Add these interpretations to a data analysis, and you can get biased results. The last type of bias we'll cover reminds me of the saying, people see what they want to see. That pretty much sums up confirmation bias in a nutshell. Confirmation bias is the tendency to search for or interpret information in a way that confirms pre-existing beliefs. Someone might be so eager to confirm a gut feeling that they only notice things that support it, ignoring all other signals. This happens all the time in everyday life. We might get our news from a certain website because the writers share our beliefs, or we socialize with people because we know that they hold similar views. After all, conflicting viewpoints might cause us to question our worldview, which can lead us to changing our whole belief system. And let's face it, change is tough, but you know what's even tougher? Doing good work when you have bad data. So it's important to keep bias out of it. The 4 types of data bias we covered, sampling bias, observer bias, interpretation bias, and confirmation bias, are all unique, but they do have one thing in common. They each affect the way we collect and make sense of the data. Unfortunately, they're also just a small sample, pun intended, of the types of bias you may encounter in your career as a data analyst. But the good news is, once you know a few, you'll find yourself constantly on guard for bias in any form. It's also important to remember that no matter what kind of data you use, all of it needs to be inspected for accuracy and trustworthiness. We'll talk more about that soon when we start exploring bad data. Bye for now. Hey, what's good? No, really. I want to know, what is good? Let me put it this way. If I asked you to name a good song, I might not like it. That's because good is subjective. What I think is good and what you think is good might be different. So what about good data sources? Are those subjective too? In some ways they are, but luckily there's some best practices to follow that'll help you measure the reliability of data sets before you use them. That's what we'll discuss in this video. I think we can all agree that we all want good data. The more high-quality data we have, the more confidence we can have in our decisions. So let's learn how we can go about finding and identifying good data sources. First things first, we need to learn how to identify them, a process I like to call ROCC. R-O-C-C-C. Okay, I just made that up, but I think acronyms are a really great way to help new information to stick in the brain. Kicking things off, R for reliable. Like a good friend, good data sources are reliable. With this kind of data, you can trust that you're getting accurate, complete, and unbiased information that's been vetted and proven fit for use. Okay, on to O. O is for original. There's a good chance you'll discover data through a second or third-party source. To make sure you're dealing with good data, be sure to validate it with the original source. Time for the first C. C is for comprehensive. The best data sources contain all critical information needed to answer the question or find the solution. Think about it like this. You wouldn't want to work for a company just because you found one great online review about it. You'd research every aspect of the organization to make sure it was the right fit. It's important to do the same for your data analysis. The next C is for current. The usefulness of data decreases as time passes. If you wanted to invite all current clients to a business event, you wouldn't use a 10-year-old client list. The same goes for data. The best data sources are current and relevant to the task at hand. The last C is for cited. If you've ever told a friend where you heard that a new movie sequel was in the works, you've cited a source. Citing makes the information you're providing more credible. So when you're choosing a data source, think about 3 things. Who created the data set? Is it part of a credible organization? And when was the data last refreshed? If you have original data from a reliable organization and it's comprehensive, current, and cited, it rocks. There's lots of places that are known for having good data. Your best bet is to go with vetted public data sets, academic papers, financial data, and governmental agency data. Now that you know how to spot the good data, which rocks, you're ready to learn about the mountain of bad data and how to avoid it. Let's get moving. Welcome back. Last time we met, we learned how to identify and find good data sources, a process I ended up coining ROCC. We found that if the data set is reliable, original, comprehensive, current, and cited, it rocks. Or more seriously, it's good. Hopefully, this is refreshing your memory. Now it's time to pull from what we learned about good data and apply it to today's lesson, bad data sources that don't rock. They're not reliable, original, comprehensive, current, or cited. Even worse, they could be flat out wrong or filled with human error. We'll start again with R. R is for not reliable. Bad data can't be trusted because it's inaccurate, incomplete, or biased. This could be data that has sample selection bias because it doesn't reflect the overall population, or it could be data visualizations and graphs that are just misleading. Check out these two bar graphs, for example. The one on the left uses a y-axis starting point of 3.14%, and the one on the right uses 0. This makes it seem like interest rates have skyrocketed over a 4-year period when they've actually remained pretty flat. Okay, on to O. O is for not original. If you can't locate the original data source and you're just relying on second or third-party information, that can signal you may need to be extra careful in understanding your data. Now, C is for not comprehensive. Bad data sources are missing important information needed to answer the question or find the solution. What's worse, they may contain human error too. The next C is for not current. Bad data sources are out of date and irrelevant. Many respected sources refresh their data regularly, giving you confidence that it's the most current info available. For example, you can always trust data.gov, which is home to the US government's open data. The last C is for not cited. If your source hasn't been cited or vetted, it's a no-go. So to sum up, good data should be original data from a reliable organization, comprehensive, current, and cited. It should rock. Otherwise, it's bad data. If you need a great, reliable data source, check out the US Census Bureau, which regularly updates their information. It's important for data analysts to understand and keep an eye out for bad data because it can have serious and lasting impacts. Whether it's an incorrect conclusion leading to one bad business decision, or inaccurate information causing processes to fail and putting populations at risk, every good solution is found by avoiding bad data. For good data, stick with vetted public data sets, academic papers, financial data, and governmental agency data. And with that, we've come to the end of our adventure with bias and credibility. After a few more exercises, you'll be ready for what lies ahead. I look forward to your progress.
Welcome to Quick Labs. Now it's time to get hands-on practice on a lot of the amazing data analyst concepts that you've learned so far. Here's where you get to prove that you've learned some great technologies, and then you'll get credit for it back inside of Coursera. But before you jump right in, let me just give you a quick walkthrough of what a Quick Lab is, and then we'll get started. First and foremost, in the upper left-hand corner, you notice a gigantic tempting button called Start Lab in green. I want to go ahead and start that. Click this box that says I'm not a robot. Select a few of the different items here for captures. You can see this is the hardest part of the lab, is trying to actually get through the anti-robot technology that they have here. Now, a couple things happen in the background. As author of these labs, this is some of our best work that we're getting you hands-on practice for. And what we're going to do next is just make sure that that timer starts counting down, because then that's going to give you the account logins that you need to practice the work inside the lab. Now, here's what you're going to do. There's going to be a gigantic big button that says Open Google Cloud Console. I want you to go ahead and click on that. And now you have 3 browser tab windows open, or 100 if you're like me. And in the second browser, this is your Quick Labs login. All the way under username, what I want you to do is copy that username. And here's the number one mistake that I've seen students make. When you're back into Google, everyone sees this Google sign-in screen here, and they immediately start typing in their personal Gmail address. You don't want to be charged for any of the resources that you're going to be using. That's why we're providing you with this Quick Labs account yourself. All I'm going to do is paste in the email that's been given to me by the Quick Lab for use for an hour, and then click Next. And then I'm going to go ahead and grab the password, paste that in here, and then you're going to see a bunch of terms and conditions because this is a brand new account. Scroll through the terms and conditions, read them at your leisure, click Accept. And as you work through the terms of service here, eventually you'll land on the homepage for Google Cloud. Scroll down, read the terms of service, accept terms of service. All the steps that I'm walking you through right now are also available inside of the lab written instructions as well. So once you've gotten that out of the way, let's take a look at what this particular Quick Lab is going to teach you. At a high level, I'm not going to do the lab for you, but don't worry, it's step by step. You'll have a blast doing it. And you have way more than enough time you need in this timer before your lab timer runs out. Generally, as lab authors, we try to double the budget of allowed time, so don't worry about lab timeouts. So inside the lab, every lab will start with an overview, and then what specifically it is that you're going to do. Inside of this lab, since you're a data analyst, you're going to be creating spreadsheets and adding files and sharing files with some of your other data analysts. If you forget what section you're in, another pro tip that I like to do is on the right-hand side, you can actually click between each of the different header sections right here as I'm doing now, and you can jump to a particular section inside of the workbook. So say you and your friends are working on this together, you can say, hey, I'm having trouble on the share and collaborate section. You can just click on that and it'll jump right to that section. Well, that's pretty much it. A few more housekeeping items and then you're off to the races. As you work your way through the lab, you want to make sure that you're completing the objectives and making sure that you're staying on track. There is intelligence built into the quick labs to prevent any kind of behavior that's not part of the lab. So make sure you're following the lab as is. And when you're done with the lab, say I was completed here, all you have to do is click on End Lab, click on OK, and that's going to bring you to a pop-up screen that asks you to rate the lab, add in any comments for the lab authors like me, submit it, and then automatically your score for the work that you've done in the lab is fed back to Coursera, which is pretty cool. And that's it. That was a quick tour of a quick lab. It was about 5 minutes, but honestly, you'll have a blast going through these. Good luck.
Hi again. Let me ask you something. What comes to your mind when you think of the word ethics? For me, it's a set of principles to live by. Most people have a personal code of ethics that helps them navigate the world. When we're young, it could be as simple as never lie, cheat, or steal. But as we get older, it's a much broader list of do's and don'ts. Our personal ethics evolve and become more rational, giving us a sort of moral compass to use as we face life's questions, challenges, and opportunities. When we analyze data, we're also faced with questions, challenges, and opportunities. But we have to rely on more than just our personal code of ethics to address them. As we learned earlier, we all have our own personal biases, not to mention subconscious biases that make ethics even more difficult to navigate. That's why we have data ethics, an important aspect of analytics that we'll explore right here in this video. But first, let's go back to the general idea of ethics. While an exact definition is still under discussion in philosophy, one practical view is that ethics refers to well-founded standards of right and wrong that prescribe what humans ought to do, usually in terms of rights, obligations, benefits to society, fairness, or specific virtues. And just like humans, data has standards to live up to as well. Data ethics refers to well-founded standards of right and wrong that dictate how data is collected, shared, and used. Since the ability to collect, share, and use data in such large quantities is relatively new, the rules that regulate and govern the process are still evolving. The importance of data privacy has been recognized by governments worldwide, and they've started creating data protection legislation to help protect people and their data. The GDPR of the European Union was created to do just this. While policymakers continue their work, companies like Google have a responsibility to lead the effort, and will do so in the same spirit we always have, by offering products that make privacy a reality for everyone. The concept of data ethics and issues related to transparency and privacy are a part of the process. Data ethics tries to get to the root of the accountability companies have in protecting and responsibly using the data they collect. There are lots of different aspects of data ethics, but we'll cover 6: ownership, transaction transparency, consent, currency, privacy, and openness. We'll explore data privacy and openness a bit later. First up is ownership. This answers the question, who owns data? It isn't the organization that invested time and money collecting, storing, processing, and analyzing it. It's individuals who own the raw data they provide, and they have primary control over its usage, how it's processed, and how it's shared. Next, we have transaction transparency, which is the idea that all data processing activities and algorithms should be completely explainable and understood by the individual who provides their data. This is in response to concerns over data bias, which we discussed earlier is a type of error that systematically skews results in a certain direction. Biased outcomes can lead to negative consequences, so to avoid them, it's helpful to provide transparent analysis, especially to the people who share their data. This lets people judge whether the outcome was fair and unbiased, and allows them to raise potential concerns. Now let's talk about another aspect of data ethics, consent. This is an individual's right to know explicit details about how and why their data will be used before agreeing to provide it. They should know answers to questions like, why is the data being collected? How will it be used? How long will it be stored? The best way to give consent is probably a conversation between the person providing the data and the person requesting it. But with so much activity happening online these days, consent usually just looks like a terms and conditions checkbox with links to more details. Let's face it, not everyone clicks through to read those details. Consent is important because it prevents all populations from being unfairly targeted, which is a very big deal for marginalized groups who are often disproportionately misrepresented by biased data. Next, there's currency. Individuals should be aware of financial transactions resulting from the use of their personal data and the scale of these transactions. So if your data is helping to fund a company's efforts, you should know what those efforts are all about and be given the opportunity to opt out. The last two aspects of data ethics, privacy and openness, deserve their own spotlight on this data stage. Coming up, you'll see why.
Hi, I'm Alex. I'm a research scientist at Google. My team is called the Ethical AI team, and we're a group of folks that really are concerned not only about how AI and the technology operates, but how it interacts with society and how it might help or harm marginalized communities. So when we talk about data ethics, we think about, what is the good and right way of using data? What are going to be ways that are going to be uses of data that are going to be beneficial to people? When it comes to data ethics, it's not just about minimizing harm, but it's actually this concept of beneficence. How do we actually improve the lives of people by using data? When we think about data ethics, we're thinking about who's collecting the data, why are they collecting it, how are they collecting it, and for what purpose? Because of the way that organizations have imperatives to make money or to report to somebody or provide some kind of analysis, we also have to keep strongly in mind how this is actually going to benefit people at the end of the day. Are the people represented in this data going to be benefited by this? And I think that's the thing you never want to lose sight of as a data scientist or a data analyst. I think aspiring data analysts need to keep in mind that a lot of the data that you're going to encounter is data that comes from people. So at the end of the day, data are people. And you want to have a responsibility to those people that are represented in those data. Second is thinking about how to keep aspects of their data protected and private. We don't want to go through our practice thinking about data instances as something we could just throw on the web. No, there needs to be considerations about how to keep that information and likenesses like their images or their voices or their text. How do we keep that private? We also need to think about how we can have mechanisms of giving users and giving consumers more control over their data. It's not going to be sufficient just to say we collect all this data and trust us with all these data, but we need to ensure that there's actionable ways in which people can consent to giving those data and ways that they can ask for it to be revoked or removed. So data is growing, and at the same time, we need to empower people to have control over their own data. The future is that data is always growing. We haven't seen any kind of evidence that data is actually shrinking. And with the knowledge that data is growing, these issues become more and more peaked and more important to think about.
We've been exploring some important aspects of data ethics, and one of the most personal areas involves privacy. Privacy is personal. We may all define privacy in our own way, and we're all entitled to it. Whether it's family members wanting privacy when using a shared computer, a teenager wanting to share a selfie with only specific people, or a company wanting to keep their customers' credit card info secure. We're all concerned how our data is used and shared. Data privacy is big in today's culture, so let's explore it fully. When talking about data, privacy means preserving a data subject's information and activity anytime a data transaction occurs. This is sometimes called information privacy or data protection. It's all about access, use, and collection of data. It also covers a person's legal right to their data. This means someone like you or me should have protection from unauthorized access to our private data, freedom from inappropriate use of our data, the right to inspect, update, or correct our data, ability to give consent to use our data, and legal right to access our data. For companies, it means putting privacy measures in place to protect the individual's data. Data privacy is important, even if you're not someone who thinks about it on a day-to-day basis. The importance of data privacy has been recognized by governments worldwide, and they've started creating data protection legislation to help protect people and their data. Being able to trust companies with your data is important. It's what makes people want to use a company's product, share their information, and more. Trust is a really big responsibility that can't be taken lightly. The final aspect involving data ethics is one that's constantly being discussed: the idea of openness, free access, usage, and sharing of data. We'll cover that in another video. You're well on your way to becoming an ethical data analyst.
My name is Andrew. I am a senior developer advocate on the Ethical AI Research Group at Google. As a senior developer advocate, I try and help the larger community build socially responsible AI systems. One consequence of not using this technology responsibly is the possibility of amplifying or reinforcing unfair biases. Now, these algorithms, these data sets are often being used in settings where they are deciding the outcome, whether it's curating content for an individual or determining whether or not they're eligible for a loan. All of these different decision-making processes depend on the algorithms and the data sets that are being used in that context. And so if this were to be handled irresponsibly, then the very outcomes of these systems could potentially harm underrepresented communities, minority groups. There's a lot that the field, the industry, the community is learning about the responsible use of data and AI. So what I try to do is I try to collate all those different elements, whether it's working with various research groups within Google, working with various product teams at Google, engaging with the larger community. We have to go above and beyond and actually educate those that are striving to build this technology for good, but may not necessarily have the resources or the institutional community wisdom to actually carry out their good intentions. So the truth of the matter is that AI, data, and any technology that's built around that, there's a lot of great benefits to that. You know, it's improving the lives of many people out there. It's enabling us to do things we couldn't ordinarily do. It's providing us with affordances to think about other things in life. This is all the more reason why it's important that we together collectively, not just, one organization, but the entire community, and even non-technologists too. Everyone needs to be involved. That's the role that I play here, is that I try to help AI evolve ethically together. And to do that is contingent on the democratization of the responsible use of AI.
Ready to get back into it? Great. There's just something so liberating about being able to find information on any subject at all on the internet. Can't remember the third line of your favorite childhood song? Curious who had the most home runs in 1986? Want to teach yourself sign language? Just pop open your laptop, type up some text, and poof, you have what you need. Many groups think we should also have this level of access to data. There's even a global movement that believes the openness of data can transform society and how decisions are made. So far, we've talked a lot about the power of data and the importance of data ethics concerns, including ownership, transaction transparency, consent, currency, and privacy. Now, let's talk about openness. When referring to data, openness refers to free access, usage, and sharing of data. Sometimes we refer to this as open data, but it doesn't mean we ignore the other aspects of data ethics we covered. We should still be transparent, respect privacy, and make sure we have consent for data that's owned by others. This just means we can access, use, and share that data if it meets these high standards. For example, there are standards around availability and access. Open data must be available as a whole, preferably by downloading over the internet in a convenient and modifiable form. The website data.gov is a great example of this. You can download science and research data for a wide range of industries in simple file formats like a spreadsheet. Another standard surrounds reuse and redistribution. Open data must be provided under terms that allow reuse and redistribution, including the ability to use it with other datasets. And the last area is universal participation. Everyone must be able to use, reuse, and redistribute the data. There shouldn't be any discrimination against fields, persons, or groups. No one can place restrictions on the data, like making it only available for use in a specific industry. Now let's talk a little more about why open data is such a great thing and how it can help you as a data analyst. One of the biggest benefits of open data is that credible databases can be used more widely. More importantly, all of that good data can be leveraged, shared, and combined with other data. Just imagine the impact that would have on scientific collaboration, research advances, analytical capacity, and decision-making. For example, in human health, openness allows us to access and combine diverse data to detect diseases earlier and earlier. In government, it can help hold leaders accountable and provide better access to community services. The possibilities and the benefits are almost endless. But of course, every big idea has its challenges. A whole lot of resources are needed to make the technological shift to open data. Interoperability is key to open data's success. Companies have to cooperate and work together to make data useful. Databases must be accessible with common formats and terminology. And then there's the bigger cultural shift that needs to happen, where we stop seeing databases as restricted intellectual property and start looking at them as a common good. While there's serious potential in the open, timely, fair, and simple sharing of data, its future will depend on how effectively these challenges are addressed. As a data analyst, I say the sooner the better. Speaking of which, we're going to talk more about open data and see its use in action in an upcoming video. Now that you've learned all about data ethics, you have some very important principles to guide you on your data journey. Anytime you're not sure of your data, remember what you've learned here. Happy trails.
My name is Andrew. I am a senior developer advocate on the ethical AI research group at Google. As an analyst, there's quite a few things you can do as you're evaluating your data set in order to ensure that you are looking at it through the various ethical lenses. One of which is being to self-reflect and understand what it is that you're doing and the impact that it has. And the best way to challenge that is to question who we are. We being like, okay, we in this team are trying to build this because we think that that's going to help improve this product, or that's going to help inform decisions about what we want to do next. Think about not just those that sit laterally next to you, but also think about those that are represented in this data set and those that aren't represented in this data set. And then use that intuition to then continue to question the integrity, the quality, the representation that is present in that data set. And then also think about the various harms and risks associated with the work that you're doing. You know, for example, if you find that you think that you'll benefit from keeping the data set longer, you may want to also understand what's the risk of holding on to this data set? What's the potential harm that could arise if you continue to look at this data set and continue to store it and continue to retrieve this data? And going beyond that, also understanding like what's the consent process like? Are you informing those that you're collecting data from how it's going to be used? What's the communication channel like? Putting on the various ethical lenses, taking a more nuanced approach to your analysis, being cognizant of all the possible risks and harms that can arise when not just analyzing your data set, but also presenting your data set, how you portray the results, how they're being used in the decision-making process, whether you are presenting this to management or presenting this to executives or presenting this to a larger audience. All of that matters in the responsible use of the data set. As a data analyst, you stand in the intersection between the very people that will stand to benefit from the technology that's being developed and those in your organization that are trying to make a more informed decision as to whether or not to move forward with the productionization of the technology. It may feel like there's a lot of weight there, and there is, but it's also very pivotal, and it speaks to the volume of the impact of your work.
Hello again. So far you've seen how data can be gathered and analyzed to solve all kinds of problems. Next up, we're going to learn all about databases. As a refresher, a database is a collection of data stored in a computer system, but storage is just the beginning. You'll discover how databases make it possible to find the exact piece of information you need for your analysis. You'll also learn how to sort data in order to zoom in on what you need, to generate insightful reports, and much more. Then we'll go even deeper, and I mean really, really deep. I'm talking about metadata. You've probably heard someone say, "Wow, that's so meta." Usually, they're talking about something referencing back to itself or being completely self-aware. For example, if a character in a book knows she's in a book, that's meta. If you make a documentary about making documentaries, that's also meta. And here at Google, I constantly analyze how I analyze data. That's definitely meta. I do that to give my work a quality check, to make sure my methods are fair, and to be certain that I'm paying attention to any biases that might affect the outcome. As an analyst, you should do this too. Sometimes we get a little too close to our data, so stepping back and asking ourselves if our processes make sense is key. But let's back up just a bit and define metadata. Metadata is data about data. Like I said, deep. Metadata is extremely important when working with databases. Think of it like a reference guide. Without the guide, all you have is a bunch of data with no context explaining what it means. Metadata tells you where the data comes from, when and how it was created, and what it's all about. Up next, you'll learn how to take data from a database or another source and bring it into a spreadsheet. You'll do this either by importing it directly or by using SQL to generate the request. And once you have data in a spreadsheet, the possibilities are endless. Everything we're about to cover is a very important part of the prepare phase of the data analysis process. It's how data analysts figure out which kind of data is going to be most helpful to them. And if you have the right data, you're much more likely to be able to solve your business problems successfully. So ready to tap into the incredible power of databases? Let's go. Databases are essential tools for data analysts. I use them constantly. Just about all of the data I access is stored within databases. Databases store and organize data, making it much easier for data analysts to manage and access information. They help us get insights faster, make data-driven decisions, and solve problems. You've already heard a bit about what databases are and how they're used by data analysts. Now, let's learn more about database features and components. As you've learned, a database is a collection of data stored in a computer system. Here's a simple database structure. It contains tables with information from a car manufacturer. The top level includes car dealerships, product details, and repair parts. Then, if you drill down to the next level by selecting one of those tables, you'll find more specific details about each item. This is called a relational database. A relational database is a database that contains a series of tables that can be connected to form relationships. For two tables to have a relationship, one or more of the same fields must exist inside both tables. For example, here, branch ID exists in this table and this one. If a field exists within both tables, we can use it to connect the tables together. Certain fields can also be referred to as a primary key. A primary key is an identifier that references a column in which each value is unique. So in our car manufacturer example, we can see that branch ID is the primary key in the dealership table, VIN is the primary key in the product details table, and part ID is the primary key in the repair parts table. Primary keys are unique and can only exist once within a given table. There's also foreign keys. A foreign key is a field within a table that's a primary key in another table. So in our example, the VIN is the foreign key in the repair parts table. As you can see, a table can only have one primary key, but it can have multiple foreign keys. Relational databases are great for keeping data consistent, no matter where it's accessed. Mobile banking is an interesting example of this. Let's say you deposit a check into your bank account using your mobile banking app. Then you check your account balance on your computer. The database relationship makes sure that the deposit shows up immediately on both platforms. Or let's say you work on a team of data analysts located in different offices. Relational databases make sure everyone's looking at the exact same data and can collaborate using a single set of accurate information. Now let's explore some different types of relational databases. First, a normalized database is a database in which only related data is stored in each table. The main idea behind database normalization is that a table should be about a specific topic and only include supporting related data. This is important because it minimizes the chances of having redundancies. A redundancy occurs when the same piece of data is stored in two or more separate places. Redundancies waste time and space in your database. For example, if you needed to change a piece of data in a database with redundancies, you'd have to make the same update in every place where the data exists. That would take a lot of time and could easily lead to typos or other errors. Next up, we have schemas. A schema is a way of describing the way something is organized. You can think about data schemas like blueprints of how the database is constructed. Schemas are useful when you're learning about a new data set or designing a relational database. You'll learn more about different types of schemas in an upcoming reading. All right, you've learned a lot about databases and how data analysts use them to gain important insights every day. Soon you'll begin practicing how to access and analyze data from actual databases. That will be a great opportunity to improve your understanding of database organization, the benefits of each method, and how you might use databases in your future analytics career. Now that you understand the different ways to organize data in a database, let's talk about how you can describe that data. In this video, we'll start exploring metadata, which is a very important aspect of database management. Metadata is kind of an abstract concept, though. So let's kick things off with a simple, everyday example. Did you know that every time a photo is taken with a smartphone, data is automatically collected and stored within that photo? Take a look. Choose any photo on your computer. Here's a cute shot of my friend's dogs, Rudy and Matilda. On your photo, right-click on Get Info or Properties. This will give you the photo's metadata, which may tell you the type of file it is, the date and time it was taken, the geolocation or where it was taken, what kind of device was used to take the photo, and much more. Pretty amazing, right? Here's another example. Every time you send or receive an email, metadata is sent right along with that message. You can find it by clicking on Show Original or View Message Details. An email message's metadata includes its subject, who it's from, who it's to, and the date and time it was sent. The metadata even knows how quickly it was delivered after the sender pressed send. Okay, so metadata is information that's used to describe the data that's contained in something, like a photo or an email. Keep in mind that metadata is not the data itself. Instead, it's data about the data. In data analytics, metadata helps data analysts interpret the contents of the data within a database. That's why metadata is so important when working with databases. It tells an analyst what the data is all about. That makes it possible to put the data to work solving problems and making data-driven decisions. As a data analyst, there are three common types of metadata that you'll come across: descriptive, structural, and administrative. Descriptive metadata is metadata that describes a piece of data and can be used to identify it at a later point in time. For instance, the descriptive metadata of a book in a library would include the code you see on its spine, known as a unique international standard book number. also called the ISBN. It would also include the book's author and title. Next is structural metadata, which is metadata that indicates how a piece of data is organized and whether it's part of one or more than one data collection. Let's head back to the library. An example of structural data would be how the pages of a book are put together to create different chapters. It's important to note that structural metadata also keeps track of the relationship between two things. For example, it can show us that the digital document of a book manuscript was actually the original version of a now printed book. Finally, we have administrative metadata. Administrative metadata is metadata that indicates the technical source of a digital asset. When we looked at the metadata inside the photo, that was administrative metadata. It showed you the type of file it was, the date and time it was taken, and much more. Here's one final thought to help you understand metadata. If you're on your way to the library to pick out a book, you could research a book's title, author, length, and number of chapters. That's all metadata, and it can tell you a lot about the book. But you have to actually read the book to know what it's all about. Likewise, you can read about data analytics, but you have to take this course to earn the Google Data Analytics certificate. So keep moving forward to gain that new perspective. Now that you know what metadata is, it's time to explore why data analysts use it. You already know that data needs to be identified and described before it can help you solve a problem or make an effective business decision. Putting data into context is probably the most valuable thing that metadata does. But there are still many more benefits of using metadata. Here's one. Metadata creates a single source of truth by keeping things consistent and uniform. We data analysts love consistency, so we always aim for this kind of uniformity in our data and our databases. After all, data that's uniform can be organized, classified, stored, accessed, and used effectively. Plus, when a database is consistent, it's so much easier to discover relationships between the data inside it and the data elsewhere. Metadata also makes data more reliable by making sure it's accurate, precise, relevant, and timely. This also makes it easier for data analysts to identify the root causes of any problems that might pop up. The bottom line is, when the data we work with is high quality, it makes things easier and improves our results. One of the ways data analysts make sure their data is consistent and reliable is by using something called a metadata repository. A metadata repository is a database specifically created to store metadata. Metadata repositories can be stored in a physical location or they can be virtual, like data that exists in the cloud. These repositories describe where metadata came from, keep it in an accessible form so it can be used quickly and easily, and keeps it in a common structure for everyone who may need to use it. Metadata repositories make it easier and faster to bring together multiple sources for data analysis. They do this by describing the state and location of the metadata, the structure of the tables inside, and how data flows through the repository. They even keep track of who accesses the metadata and when. Here's a real-world example. As a healthcare analyst at Google, I use second and third-party data. As you learn, second-party data is data that's collected by a group directly from its audience and then sold. And third-party data comes from outside sources, which are not the original collectors of that data. They get it from websites or programs that pull the data from the various platforms where it was originally generated. It's a bit complex, but the main thing to remember is that third-party data doesn't come from inside your own business. So if my team needs to work with data that wasn't created at Google, that means we sometimes don't know very much about its quality and credibility. But we need to be certain that our data can be trusted and was collected responsibly. After all, if the data is unreliable, our results can be unreliable too. That's why understanding the metadata of the external database is so important. It lets us confirm that the data is clean, accurate, relevant, and timely. This is particularly important if the data comes from another organization. One other important step when working with external data is confirming that we're allowed to use it. We'll often reach out to the owner to make sure we can access or purchase it. So to sum up, metadata repositories are useful for all these reasons. Plus, they help ensure that my team is pulling the right content for the particular project and using it appropriately. We can confirm this because the metadata clearly describes how and when the data was collected, how it's organized, and much more. Soon you'll learn even more about using metadata in data analytics. And if you're finding metadata particularly fascinating, you'll discover some really exciting career choices that focus on metadata. Stay tuned. Metadata and metadata repositories are very powerful tools in the data analyst toolbox. As we discussed previously, data analysts use them to create a single source of truth, keep data consistent and uniform, and ensure that the data we work with is accurate, precise, relevant, and timely. These tools also make it easier to access and use data by standardizing our processes. In this video, we'll explore more components of metadata and learn how metadata analysts work to keep things organized. We know that the amount of data out there continues to grow, but lots of businesses just aren't using their data. Sometimes they don't know what they have. Sometimes they can't find it. Or sometimes a business just doesn't trust it. Especially in bigger companies, data can span numerous different processes and systems. And pulling together data from so many places can be a big challenge. For example, let's say a company starts out with a traditional data storage system in its offices. But then, as the amount of data it owns continues to expand, cloud storage is needed too. Plus, this company could also be accessing and using second or third-party data from a partner organization. Each of these systems has its own rules and requirements, so each organizes the data in a completely different way, adding even more complexity. It's no wonder so many organizations struggle to find the right data at the right moment. On the other hand, metadata is stored in a single, central location and gives the company standardized information about all of its data. This is done in two ways. First, metadata includes information about where each system is located and where the datasets are located within those systems. Second, the metadata describes how all of the data is connected between the various systems. Another important aspect of metadata is something called data governance. Data governance is a process to ensure the formal management of a company's data assets. This gives an organization better control of their data and helps a company manage issues related to data security and privacy, integrity, usability, and internal and external data flows. It's important to note that data governance is about more than just standardizing terminology and procedures. It's about the roles and responsibilities of the people who work with the metadata every day. These are metadata specialists, and they organize and maintain company data, ensuring that it's of the highest possible quality. These people create basic metadata identification and discovery information, describe the way different datasets work together, and explain the many different types of data resources. Metadata specialists also create very important standards that everyone follows and the models used to organize the data. And there's one thing they all have in common. Whether they work at a tech company, a nonprofit association, or a financial institution, metadata analysts are great team players. They're passionate about making data accessible by sharing with colleagues and other stakeholders. So if you're looking for a role that encourages you to explore all the data that the digital world has to offer, following the path to becoming a metadata analyst may be the right choice for you. But either way, businesses of all kinds face market trends and competition, and they need to understand why one process works while another doesn't. Data analytics allows them to answer key questions and keep improving.
My name is Megan, and I am an agency measurement lead here at Google. Basically, I help to demystify measurement and analytics for advertising agencies. So people that are tasked with executing media plans for advertisers, but also people that are interested in measuring the impact that media is having for their clients. So I've been doing this for about 17 years now and have seen a lot of evolution in the space, from data availability, from different modeling techniques becoming more advanced, but also more accessible. And it's just been a really cool journey to see how it's evolved, how analytics has become more mainstream, and how people are getting more excited about it. Metadata is basically the key to your larger data set. It helps describe what's in the rows and the columns of the data that you'll be working with. Metadata is kind of a shorthand or a CliffsNotes version of a much more complex set of information. It can be helpful in just kind of helping you get a handle on what's in a single data set that you may have access to. It's an important part of the discovery process of any analytics project as you're working with either a client or a vendor to understand the resources that you'll have to address a problem and what might be missing. It just gives you, the keys to unlock that data in a really simple and straightforward way, and is a great communication tool. When I was working for an advertiser, one of the things that we were trying to do was build something called a data lake. So essentially, this is bringing together all of the sources of data that you might want to use in an analysis into one place, which can be really, really tricky. One of the benefits of metadata was figuring out where we had sources that may overlap, where we had data sources that had things in common, and what the unique pieces of information were that we were getting from each of those data sets. So as we thought about tackling this really huge and important project, we were able to use metadata to quickly and easily get to the basic constructs that we were trying to tackle. When you're working with people who maybe don't have analytics as their day job, getting that aha moment, helping them understand how measurement and analytics are tools that can help them achieve their goals is really important. And just getting to that idea of, you made something that was previously inaccessible a little bit more accessible for that team and something they feel comfortable putting into practice is really important and really kind of a great way to come out of a partnership.
In this video, we'll discuss the different places data analysts go to connect with data. There's all kinds of data out there, and it's important to know how to access it. Earlier, you learned that there are two basic types of data used by data analysts: internal and external. Internal data is data that lives within a company's own systems. It's typically also generated from within the company. You may also hear internal data described as primary data. External data is data that lives and is generated outside an organization. It can come from a variety of places, including other businesses, government sources, the media, professional associations, schools, and more. External data is sometimes called secondary data. Gathering internal data can be complicated. Depending on your data analytics project, you might need data from lots of different sources and departments, including sales, marketing, customer relationship management, finance, human resources, and even the data archives. But the effort is worth it. Internal data has plenty of advantages for a business. It provides information that's relevant to problems you're trying to solve, and it's free to access because the company already owns it. With internal data, analysts can work on all sorts of data projects without ever looking beyond their own walls. But sometimes internal data doesn't give you the full picture. In those cases, data analysts can turn to external data and apply that information to their analysis. For instance, as healthcare analysts, we often partner with other healthcare organizations or nonprofits and use their data to create deeper analyses and add some more industry-level perspective. In an earlier video, you learned that openness has created a lot of data for analysts to use, largely through open data initiatives. As a reminder, openness or open data refers to the free access, usage, and sharing of data. For example, the United States government makes hundreds of thousands of data sets available to the public on data.gov. These data sets contain information on weather patterns, educational progress, crime rates, transportation, and much more. There are lots of reasons for these open data initiatives. One is to make government activities more transparent, like letting the public see where money is spent. It also helps educate citizens about voting and local issues. Open data also improves public service by giving people ways to be a part of public planning or provide feedback to the government. And finally, open data leads to innovation and economic growth by helping people and companies better understand their markets. Google actually hosts lots of public databases with information on science, transportation, economics, climate, and more. So as an example, a bike-sharing company could use traffic data from within our public transportation database to see where the roads are busiest, then choose those locations for their bikes in order to reduce cars on the road and give people another transportation option. So now you're familiar with internal and external data and how you can access both. Coming up, we'll learn how to import all the data you collect from different sources into a spreadsheet. At this point, you've learned all about internal and external data and how to prepare it for use. Now we'll go through the process of actually importing data from different sources. Sometimes you'll want to upload a spreadsheet from your files, such as a CSV file. CSV stands for comma separated values. A CSV file saves data in a table format. Now let's bring that file into a fresh spreadsheet. We'll start by selecting a file, then import. Then we'll choose to upload a file. Navigate to it, open it, and insert it as a new sheet. CSV files use plain text and they're delineated by characters, so each column or field is clearly distinct from another when importing. As you learned, CSVs are comma separated, and usually the spreadsheet app will auto-detect those separations, but sometimes you might need to indicate that the separator is another character or a space by selecting the different options in this window. Also, if you are planning to work with the dataset, you would usually convert to text, numbers, or other options here. But plain text is okay for reporting purposes, so we can leave those fields alone. Finally, select Import Data. Now our CSV file is ready to work with in our spreadsheet. I spend most of my time at work analyzing spreadsheets full of healthcare information. I typically start by looking at a larger dataset, then I pull a subset of it into a spreadsheet so I can work with it. Maybe I want to analyze year-over-year growth in user demand on Google Search for certain healthcare services like telemedicine. Or maybe I want to look at data sets from external healthcare organizations or agencies for more insight into this trend. For example, with telemedicine, maybe I'll look at a spreadsheet that lists telemedicine providers. There are so many ways spreadsheets can help you find the insights you need. One source I use a lot is the World Health Organization's data repository. This is a place where anybody can access open source data. As you can see, there's tons of data available. You can search by theme, category, indicator, and country. You can also access World Health Organization metadata if you want to learn more about the data in the repository. For our example, we'll look at medical doctors by country and year. This information would be useful for a data analysis project looking into how many doctors are available to treat patients within a certain population, compared to other populations. To get this data, we'll start on this webpage, which contains the dataset we want. Then we'll download the data as a CSV file. Then open a new spreadsheet and import the file by selecting File, Import. Next, upload your file and select Import Data. After reviewing the data to make sure it looks clean, we can title it and begin our work. I know this is a lot of information to take in, but you'll get much more comfortable with this the more you practice. Coming up, we'll learn how to sort and filter your data to focus on the information relevant to you. In the past few videos, you've learned about both internal and external data. Now I'll show you how to focus on only the data that's relevant to the problem you're trying to solve. This is useful if you're working with a very large, complex spreadsheet, which data analysts encounter all the time. Having lots of data can make it difficult to quickly find and analyze the information you need. No two analytics projects are the same. Often, data analysts process, view, and use data very differently, even if it comes from the exact same source. Here's an example. Check out this spreadsheet that shows a company's sales reps and where they work. Different data analysts might want different information from this spreadsheet, and that's where sorting and filtering comes in. Sorting and filtering the data in a spreadsheet helps us customize the way data is presented. They can also organize data so analysts can zoom in on the pieces that matter. Think of it like a magnifying glass for our data. Let's begin with sorting. Sorting involves arranging data into a meaningful order to make it easier to understand, analyze, and visualize. Data can be sorted in ascending or descending order, and alphabetically or numerically. Sorting can be done across all of a spreadsheet or just in a single column or table. You can also sort by multiple variables. For instance, if our dataset contains both city and state fields, we can sort first by city and then by state. Anytime you're sorting data, it's always a good idea to freeze the header row first. To do this, we'll highlight the row. Then from the View menu, choose Freeze and One Row. This locks the row in place. Now, when we scroll down the sheet, the header row stays visible so we know the category of each column. Looks good to me. Now let's sort the entire spreadsheet. We'll sort by city first. To do this, select the city column. Then use the drop-down arrow to sort the sheet. Select A to Z. This will sort all of the columns from A to Z by row, with the selected column being the primary sort criteria. The cities are now sorted alphabetically, and they're still grouped with the corresponding states, sales reps, and auto parts. The details across each row are automatically kept together when sorting a particular section, as you can see here. Multiple criteria sorting is another very useful data analysis tool. For instance, let's say we want to see a list of sales reps by the cities and states in which they work. First, we select the entire dataset. Then choose Data and Sort Range. In the dialog box, make sure that Data has header row is highlighted. That way, row A, city, states, sales rep, and auto parts, won't be part of the sort. Then in the Sort By drop-down menu, select State and the sort order A to Z. Now add another sort column. In the Then By drop-down, select City and the sort order A to Z. Finally, select Sort. Now we can search the data to easily find a sales rep who works in a particular state and city. Sorting is useful when you want to look at everything in a spreadsheet in alphabetical or numerical order, but sometimes data analysts want to isolate a particular piece of information. To do this, they use a filter. Filtering means showing only the data that meets a specific criteria while hiding the rest. A filter simplifies a spreadsheet by only showing us the information we need. For example, we could add a filter to see only the sales reps who work with a particular product. To do this, we first select Data and create a filter. Choose the column with the data we need, in this case, auto parts. Filter buttons will appear in the corner of each column header. To filter our spreadsheet by auto part, click the button in the auto parts header. In this example, let's say we want to only see sales reps who work with rims. Remove the check marks from the categories we don't want to see, which is everything except for rims. Then select OK. The filter temporarily hides anything that doesn't meet the condition, but note that even though they aren't visible, they're still there. When it's time to view the entire area spreadsheet again, simply turn off the filter. Sorting and filtering are very important tools in the data analyst toolbox. In the next video, you'll discover even more ways to narrow in on the exact information you need for any data analysis project. You've learned how sorting and filtering data in spreadsheets helps data analysts customize the information. Customizing data makes it more meaningful and easier to understand, analyze, and visualize. You also discovered that some spreadsheets can be extremely long and complex, so knowing how to zero in on the exact data you need while setting aside the rest helps you focus on your analysis. This is also true for databases. Sometimes a dataset is too large to download, or it won't fit in a spreadsheet. So a data analyst will use SQL to create a query to view the specific data that they want from within the larger set. We've learned that a database is a collection of data stored in a computer system, and that SQL stands for Structured Query Language. Data analysts use query languages to communicate with the database. In an earlier video, you also learned that a relational database contains a series of tables that can be connected to form relationships. These relationships are represented by primary and foreign keys. Data analysts write queries in order to get data from these tables. Let's see how this works. We'll start with our table viewer. Here we can see what public data sets are available. We'll scroll through the data before we start using it to get a feel for what it's all about and to make sure it's clean. Some table viewers let you preview a few rows before even writing a query. This is helpful if you want to take a quick look to be sure the dataset will be right for your project. To show you how this works, let's check out a sample dataset. This one shows how much sunlight hits rooftops in a year. This would be very useful for a data analyst working on a solar energy project, for example. We'll start by previewing the dataset. Click on it like this. Then we'll select a subset of this data where we find regions, states, yearly sunlight, and more. Now to see the entire dataset, let's write a query. The first step is finding out the complete correct name of the dataset. To do this, select the dataset, solar potential by postal code, and select Query Table. The name of the dataset is shown inside the two backticks. This is to help us read the query more easily. We can also remove the backticks in this case, and our query would still run. The words you see before the dot represent the database name. And the words after the dot represent the table name. Let's select and copy the dataset name now, because we'll need it in a second. Now we'll click on the plus sign to compose a new query. Most queries begin with the word select. Then we add a space. Because we want to see the entire dataset, we'll put an asterisk next. The asterisk says we want to include all columns. This is a great shortcut because without it, we'd have to type in every single field name. Next, we'll press return and type from. From does just what it sounds like. It indicates where the data is coming from. After that, we'll add another space. Now we paste in the name of the dataset that we copied earlier. And finally, run the query. Now we can carefully inspect the dataset before we begin working with it. One important thing to keep in mind, SQL queries can be written in a lot of different ways, but still provide the same results. For example, we could have written this query as one long line of instructions, like this. And we'd still get the same results. The additional lines and spaces don't impact the query's outcome, but they keep your query organized and easier to read for yourself and others. Now, if the project doesn't require all of these fields, we can use SQL to view a particular piece or pieces of data. To do this, we specify a certain column name in the query. For example, maybe we only want to see data from Pennsylvania. So we'd begin our query the same way we just learned. Select, space, add an asterisk. Then, from our solar potential database. But this time, we'll add where. Where also does exactly what it sounds like. It tells the database where to look for information. In this case, the state name column. So add a space and state_name, the name of the column. Now, because we only want to see data from Pennsylvania, we add an equal sign and the word Pennsylvania with single quotes around it. In SQL, single quotes indicate the beginning and ending of a string. Finally, rerun the query. Now we can review the data on solar potential for only Pennsylvania. Now we've got the data we want, and we're ready to start putting it to work, which we'll cover later on. But for now, let's celebrate finishing another module. You've covered a lot of complex and highly technical information. As you keep practicing though, things will start to feel a lot more natural. For now, take a moment to sit back and think about all you've learned. You discovered metadata and how it keeps data organized by describing what that data is all about. You've seen how internal and external data are accessed and how data analysts use them to find compelling insights to solve business problems. And you can sort and filter your data to really pinpoint the information you need. Finally, you just learned about queries, and you even practiced writing some. Coming up, you'll have a few readings and then a weekly challenge to test your knowledge. This will help you confirm that you've understood what we've worked on in these videos. And as always, if you're ever unsure about a question, I highly encourage you to review the videos and readings to find the answer. You're the data detective now, so use those skills. Keep up the great work, and I'll see you after the weekly challenge. Hey, good to have you back. Up until now, we focused on preparing your data for processing and analysis. In these next videos, we'll explore another big part of that process, organizing and protecting your data. Keeping your data organized is important for a few reasons. It makes it easier to find and use, helps you avoid making mistakes during your analysis, and helps to protect it. Coming up, we'll go over the basics of organizing data for personal and professional use and file naming conventions. Then we'll take a look at some security features for spreadsheets. By the end of these next few videos, you'll be able to do all these things, and you'll be able to explain these steps to stakeholders so they can feel confident that your data practices are safe and secure. When you're ready to get started, go ahead to the next video. There, we'll get started with organizing data for personal use. Hey, welcome back. Whether you're organizing your personal data for your own use or organizing project data for work, there are certain procedures you want to follow to make sure your data is easy to find and use. In this video, we'll cover some best organization practices and also check out some different ways project data can be organized. There are plenty of best practices you can use when organizing data, including naming conventions, foldering, and archiving older files. We've talked about file naming before, which is also known as naming conventions. These are consistent guidelines that describe the content, date, or version of a file in its name. Basically, this means you want to use logical and descriptive names for your files to make them easier to find and use. And speaking of easily finding things, organizing your files into folders helps keep project-related files together in one place. This is called foldering. For example, all of the files related to your vacation plan might go in the Vacation 2025 folder. You might then break that folder down even further by creating subfolders like itinerary or photos, depending on what else you'd like to easily access. It can also be useful to move old projects to a separate location to create an archive and cut down on clutter. It's so much easier to find and use my files when I name them something meaningful and searchable, and when I organize them into folders. It makes all my data more accessible and useful. In addition to these 3 best practices, there are 2 more things you'll want to consider when organizing data for work use. First, the project data you'll be using for work could be accessed and used by multiple people. So it's important to align your naming and storage practices with your team to avoid any confusion. Your team might also develop metadata practices like creating a file that outlines project naming conventions for easy reference. We'll get to talk more about naming conventions for work files in more detail later. Secondly, you want to think about how often you're making copies of data and storing it in different places. Most importantly, because if data is stored in lots of different databases or spreadsheets, it can contradict itself and lead to mistakes later on. Also, storing data in multiple places takes up a lot of space. Relational databases can help you avoid data duplication and store your data more efficiently. You can use these practices to organize data in different ways according to your project. So let's look at some examples of data organization. I have some sample project folders here, each organized in a slightly different way. Let's open them up and see what they look like. We'll start with the high-level Finances folder. The Finances folder has been organized categorically. There are subfolders like Budget, Invoices, and Payroll that represent different categories. Let's click on Invoices to see what's in there. So in the Invoices folder, you can see that we have another set of subfolders labeled by year. 2014, 2015. Yep, looks like these are in chronological order. Sometimes the way files are organized can tell us how the data within those files is also organized. Let's open a file to see if that's right. So in the 2014 subfolder, there's a file with invoices from June. If we open it, we can see that they've been organized by date, just like the folders. There's different ways to organize data depending on what you need it for. The categorical organization of the subfolders in Finances made it easy for me to go straight to the invoices, but the chronological organization of the Invoices subfolder can help us find financial data from the exact date we're looking for. There's other ways to organize data too, in order of importance or even by location. For example, a company might use hierarchical organization so that employee data mirrors the structure of their employee organization. Or a company working with geographical data might choose to organize by location. It's a good idea to take time early on in a project to consider what the best organization methods will be for you and your team to stick to. Here's another way to think about it. Unorganized data is like a messy room. It's overwhelming, hard to find anything in, and gets worse the longer you avoid cleaning it up. But by making sure early on you know where to put your files, you can keep your work data organized, easy to use, and error-free. Now that you see how important it is to keep data organized for both personal and work use, we'll take a closer look at file naming conventions and how they carry over into your databases. See you in the next video. Hey again, so you've heard me mention the idea of using meaningful and logical file names to help organize your data. But using consistent file names can also streamline or even automate your analysis process, saving you time and energy in the long run. When used consistent guidelines that describe the content, date, or version of a file and its name, you're using file naming conventions. And as we've already discovered, these file naming conventions help us organize, access, process, and analyze our data. So here's some general tips on creating file naming conventions that are both logical and functional. Here are some quick file naming do's. Work out your conventions early to avoid having to spend time redoing it later. Align your file naming with your team, and make sure your file names are meaningful, with references to the project name, creation date, revision version, or any other useful information needed to understand what's in that file. Now there's some other simple things you can do to make sure your file naming conventions are on point. First of all, you want to keep your file names short and sweet. They're supposed to be quick reference points that tell you what's in a file. From earlier videos, we know that we want to include dates and revision numbers in our file names. I recommend formatting it by year, month, and day because that follows the International Date Standard. Different countries have different date conventions, so keep that in mind. And when you include revision numbers in a file name, lead with a 0 so that if you run into double digits of revisions, it's already built into your conventions. And another good rule is to use hyphens, underscores, or capitalized letters instead of using spaces. Spaces and special characters might not be recognized by your software. Plus, avoiding spaces definitely makes it easier to work in SQL. And my last bit of advice, create a text file that lays out all your naming conventions on a project. This is really helpful if someone new joins your team, or if you just need a quick reminder while you're working on something. We talked about this earlier when we covered metadata, which is data about data. It helps explain what data there is and how it's being organized. When you use consistent, meaningful file naming conventions throughout your project, your data will be easy to find and use, and you can save yourself time too. Up next, we'll keep looking at spreadsheets, and we'll talk about security features and how you can use them to protect your data now that it's organized. See you there. You're back. Okay, now that our data is organized and easy to find, it's time to start thinking about how to protect it. The good news is that spreadsheets come with security features already built in. In this video, we'll look at different spreadsheet programs and how their security features, like sheet protections and access control, are similar. When I say security features, you might be imagining ways to protect data from other people, but that's just one kind of security. Security features can be designed to keep unauthorized users from viewing certain files or just lock your worksheets so that you don't accidentally break your formulas. This is called data security. Data security means protecting data from unauthorized access or corruption by adopting safety measures. Whatever spreadsheet program you're using will have similar security measures built in. As a data analyst, you'll run into Google Sheets and Excel a lot. So let's talk about what they have in common. First, both programs have features that let you protect your spreadsheets or parts of your spreadsheets from being edited, from the entire worksheet down to single cells in a table. So if you're collaborating with other users, you can easily lock down your formulas so that they aren't accidentally broken. Speaking of collaborating, Excel and Google Sheets both have access control features like password protection and user permissions. This gives you more control over who can do what to your spreadsheet. Because these programs are located in different places, these features are slightly different. For Excel spreadsheets, you can encrypt files and worksheets with passwords before emailing them to other users. In Google Sheets, these settings are found under the Sharing menu, which allows you to control who can see or edit the sheet online. Google Sheets can also be copied so that users can work with that data without altering the original. Tabs can also be hidden and unhidden in Sheets and Excel, allowing you to change what data is being viewed. But remember, even hidden tabs can be unhidden by someone else, so be sure you're okay with those tabs still being accessible. As a data analyst, data security will be a priority. But no matter which program you use to create spreadsheets, there's security features to help you keep your work safe and secure. There are some other basic best practices you can take to keep your data more secure overall, which we'll cover later in a reading. You've made it to the end of this module. Congrats! In these videos, we've covered strategies for organizing data for personal and work use, how to develop functional file naming conventions, and some security measures you can take advantage of in spreadsheets. Before you move on to the next step in the data analysis lifecycle, it's important that you make sure your data is prepared, and that includes organizing and securing it. As usual, after this video, you'll have your weekly challenge. I know you've got this. Then, after the weekly challenge, there's some optional material all about connecting to the online data community. As you start building your career in data analytics, it'll be really valuable to connect with others, learn about new trends in the field, and share your own work. I think you'll get a lot out of those videos. They'll help you develop a professional online presence and find ways to communicate with people in your field, which is key as networking becomes more and more online and remote work opportunities become the norm. But if you feel pretty confident about your online presence, you can move into the course challenge instead. Good luck on this weekly challenge, and I'll see you soon. Hey, it's great to have you back. So far, we've covered everything from using SQL to the key aspects of data ethics. You've developed a huge range of skills, and they're all going to help you on your journey to a career in data analytics. But you don't have to do everything on your own. As a data analyst, you'll be part of a growing data community. By building a consistent and professional online presence, you'll be able to connect to others in your field and expand your network. Coming up, you'll learn how you can get started building your online presence, or if you're already part of the community, how you can take your online network even further. With remote online work becoming more and more common, so is online networking. That means having and maintaining a well-developed online presence could open the door to so many new opportunities. I find myself reaching out to people I've worked with throughout my career to stay in touch, ask them questions about their experiences, and just see what interesting things they're doing. And that's only possible because I keep up my online presence. Join me in the next video to get started building your online presence and get connected. Hey again, today a lot of us spend a lot of time connecting with people online. We stay in touch with family and friends we can't see every day, or post about what we're doing, eating, and watching on social media. But our presence online goes beyond the personal. A consistent and professional online presence is an important tool in building a career in data analytics. A professional online presence is important for a few key reasons. First, it can help potential employers find you. Second, it lets you make connections with other data analysts in your field, learn and share data findings, and maybe even participate in community events. Keep in mind that a lot of networking happens online now, so if you aren't keeping up your online presence, you might be missing out on great opportunities without even knowing it. There are lots of different professional sites that you can take advantage of as you start building your own online presence. For now, though, we'll focus on LinkedIn and GitHub. LinkedIn is specifically designed to help people make connections with other people in their field. It's a great way to follow trends in your industry, learn from industry leaders, and stay engaged with wider professional community. And if you're actively looking for a new job, LinkedIn has job boards that you can search. You can even narrow down your location to see who's hiring near you. Plus, job recruiters frequently use LinkedIn to find potential data analysts for new projects. So it's always a good idea to keep your LinkedIn profile up to date with your resume. You might find yourself being recruited. LinkedIn also lets you connect with people and build a network. You can share exciting things happening in your professional life and keep up with where your connections go. You never know when you might end up working with someone again. With LinkedIn, you can be endorsed for having job skills or endorse other people. So if you impress someone at a previous job, they could let other people know just how awesome you were to work with. GitHub, the other website I mentioned earlier, is a little different. GitHub is part code sharing site, part social media. It has an active community collaborating and sharing insights to build resources. You can talk with other GitHub users on the forum, use the community-driven wikis, or even use it to manage team projects. GitHub also hosts community events where you can meet other people in the field and learn some new things. GitHub has a lot of features for you to check out, and the best way to learn more about it is to check it out for yourself. We'll also be talking more about GitHub later in the program. Sometimes, if you're looking for a new career, finding someone who has something in common with you, like shared interests or the same hometown, and reaching out to them can help a lot. Just a 15-minute conversation with someone could set you on the path to a new career, whether that's on a professional networking site like LinkedIn or at a community event hosted by GitHub. LinkedIn has become one of the standard professional social media sites, so it's a good starting place for building your online presence. And GitHub offers a lot of really great tools for data analysts in the community. So if you don't already have accounts on these sites, challenge yourself to set them up now. Connect with other people, share some updates about what you're working on right now. And if you're already using LinkedIn and GitHub, great news. We're going to talk more about how to enhance your existing social media presence next time. See you soon. Hello, let's talk about social media. Today there's 3.8 billion people using social media around the world. So there's a good chance you probably already have an online presence. That's great. It means you're already connecting with people online, maybe even professionally on websites like LinkedIn. And if you aren't, getting started is as easy as signing up today. But there's some really easy ways you can enhance your online presence even more and use your existing profiles to build your professional identity. One of the first things you should ask yourself when looking at your new or existing online presence is this: would you be okay with potential employers and colleagues seeing your social media profiles? Try putting yourself in their shoes. When a potential employer is looking at your public profiles, they're asking themselves if you're the right person to represent their company and values. Is there anything on your current accounts that could make them think otherwise? If you want to limit what you share, be sure to check the privacy settings on your accounts. If they're set to public, anyone can see everything you post. You can also make specific photos or albums private, but remember, this doesn't erase them from the internet. Keep in mind, changing your privacy settings doesn't necessarily keep all of your posts secure, so you should always think carefully before you post. Now, the best way to make sure that your posts and photos are appropriate and professional is to delete any that you wouldn't want your future boss to see. And if you're getting ready to upload photos for the first time, think about how those pictures represent you before posting them. Feel free to back up these photos for your personal files, but maybe don't put them on Facebook or Instagram. Speaking of Facebook and Instagram, there's some easy options for deleting posts on these platforms. Both Facebook and Instagram have an archive function that allows you to remove posts from your profile. You can even mass delete posts on Facebook. And while you're at it, check your Twitter. Your social media profiles are probably connected, so it's important to make sure that they're all representing you the way you want to be seen professionally. A good rule of thumb, your posts should be family friendly. This goes for photos and text posts. Check to make sure your content and language is appropriate for the whole family. And while we're working on enhancing your online persona, a professional profile picture is a great touch. Even if your account is set to private, recruiters will likely still be able to see your profile picture. Having a photo for your LinkedIn profile is important because it significantly increases your chances of being contacted. So make your profile picture one that represents your professional side in the best way possible. Once you've gotten your profiles up and running, post mindfully. Think about the professional image you're trying to create and stick to it. This means curating posts for different platforms. Decide which platform you want to use for family and friends, like Facebook and Instagram, and keep updates about your personal life on those platforms. Use professional platforms like LinkedIn for posts related to your work life and building professional relationships. A huge number of companies and hiring managers use online sources to identify and pick candidates. So it's important to make sure that your online presence has a positive impact on your real life. Make sure your online presence is job appropriate by making your accounts private, deleting posts you wouldn't want your boss or colleagues to see, and posting mindfully. And don't be afraid to ask someone you respect professionally to take a look and give you some feedback. That can be a big help in building that online presence and using it to make connections within your professional community. Now that we've built and enhanced our online presence, let's learn more about building networks and reaching out to other professionals. See you soon. Which profession does the best networking? The fishing industry. But in all seriousness, the work we do has everything to do with people. So once you've learned the skills and developed a strong portfolio, the next step is to connect with people in your profession or industry who can help you use those strengths to build a career. So in this video, we're going to talk about networking. Networking can be called professional relationship building. It's all about meeting people, both on and offline, and building relationships with them. Networking will help you meet people who are similar and different from you, and also stay current with what's going on in your field. Even within the organization you're in, you want to network with other teams to better understand the projects you're working on. Here's the truth. Lots of the best opportunities aren't posted on job boards. They're out there in the real world. Problems waiting to be solved, innovations just waiting for inspiration. So building your network with other data analysts could really increase your odds of breaking into the field. Actually, networking with any industry professionals could help you do that. Here's a few things you can start with. Search for public meetups in your area. There's usually at least one in every major city. Just Google data analytics meetups near you, or search on meetup.com. Then you can learn more about different types of data analytics or share your interests with other people in the field. It's also good to remember that we live in a digital world, so don't feel confined to in-person networking. Some of the best data analysis influencers are on social media. Follow interesting companies or thought leaders on LinkedIn, Twitter, Facebook, and Instagram. Interact with them and share their content. If there's a post you like, maybe leave a comment explaining why. Digital networking can take you anywhere these days. On top of that, there's also plenty of great data podcasts to follow, like Partially Derivative and the O'Reilly Data Show. Not only can they help you stay up to date with how the industry is evolving, but hearing the concepts repeated over time can help build your confidence in your own knowledge. There's also a ton of blogs and online communities, like O'Reilly, Kaggle, KD Nuggets, GitHub, and Medium that can help you connect with peers and experts. The possibilities are virtually limitless when it comes to building your network. And in our next video, we'll talk about one of the most effective methods, finding a mentor. Trust me, you don't want to miss this. It was Maya Angelou for Oprah Winfrey, Steven Spielberg for J.J. Abrams, and Warren Buffett for Bill Gates. It's a mentor, and having one can have a huge impact in your career and your life in general. Basically, a mentor is a professional who shares their knowledge, skills, and experience to help you develop and grow. About 3 out of 4 people think that having a mentor is an important part of professional development, but studies found only 37% actually have a mentor. As a data analyst, you're not required to have a mentor, but those who find a good one never forget them. Mentors come in many forms. They can be trusted advisors, sounding boards, critics, resources, or all of the above. Sometimes the relationship happens naturally, but usually you need to formally ask them to mentor you, because they might not know you're interested in their mentorship. I've tried to seek out mentors at every stage of my career, from school to my current role at Google. It's always good to make sure your mentors have the time to support your growth, and it's just as important for you to keep up a professional relationship with them. On top of a mentor, a sponsor can also help you in your career development, but we'll talk more about that a bit later. It's very important to figure out what you're looking for in a mentor. This will help narrow down your list of potential professionals. Try thinking about your strengths and challenges at work and how you'd like to grow as a data analyst, and share that openly with potential mentors. It's also great to think about shared experiences or common ground. Maybe you're a veteran who'd benefit from the guidance of a data analyst for the military, or maybe you just think you could really benefit from talking with someone from your hometown. There's no one right way to find the perfect mentor. Your mentor doesn't even have to work with you. If there's no one you can connect with in your current work environment, you can find mentors anywhere from a social media platform, networking event, or mentor matching program. For instance, websites like score.org and micromentor.org and an app called Mentorship allow you to look for specific credentials that match your needs. You can then arrange dedicated times, maybe on the platform, to meet up or talk on the phone. Personally, I like reaching out with a friendly email or message on a professional networking site. If you go this route, take some time to describe your career goals and how they might align with their own experiences. Try mentioning some things you particularly like about their work or published content. From there, you can easily suggest a coffee chat, virtual meetup, or email exchange to get things going. Once you've had a few exchanges, be sure to check in with yourself. Make sure it's a natural fit and that you're getting everything you need. It's also a good idea to check in with your mentor to make sure it's working well for them too. Remember, this is a partnership. You and your mentor are equal participants, so the more authentic and honest you are about it, the better it will go. For example, it's always a good idea to share your gratitude for their time and effort. Now, while a mentor will help you gain critical skills and navigate challenges at work, a lot of people find that having a sponsor can take their career even further. A sponsor is a professional advocate who's committed to moving a sponsee's career forward with an organization. To understand the difference between these two roles, think of it like this. A mentor helps you skill up. A sponsor helps you move up. Having the support of a sponsor is like having a safety net. They can give you the confidence to take risks at work, like asking for a new assignment or a promotion. So let's talk about how you get a sponsor. Well, unlike mentors, you don't get to choose the sponsor. The sponsor almost always chooses you. So the best course of action is to commit yourself to doing your best work at all times. And there's a good chance someone with influence will take notice. Now that we've seen the importance of networking and relationships, it's a good idea to take some proactive steps. First, build and nurture your LinkedIn presence. Next, look at your current social media presence and make sure it's helping you put your best foot forward. Finally, always be open to connecting with peers and colleagues. You never know what great things a conversation will bring.
Hi, my name is Rachel, and I'm the Business Systems and Analytics Lead at Verily. I've been lucky enough to have some really great mentors over the course of my career, and I cannot emphasize enough how important it is to have someone in your corner as you're navigating all of the different ins and outs of your career. For me, I've had some wonderful mentors who have guided me through some really tough career decisions, starting way back at the very beginning. My first mentor was a professor at school. And this professor gave me wonderful advice of how to follow my dreams and how to lean into what I was interested in. I think it's very important to also have great mentors at work. My mentor helps me navigate all the ins and outs of my organization, all the ins and outs of the politics sometimes, and also helps me make decisions on what to do next. And so it's nice to have a mentor who's outside of what's going on, but it's also really nice to sometimes have a mentor who understands the environment. I catch up with my mentor regularly, just to touch base, just to see how we're doing, to maintain a relationship. But I specifically will schedule time with my mentor when I'm wrestling with some sort of tough question or when I have a pivotal moment coming up. For example, I've had some great conversations with my mentor about whether I really lean in on the finance side of my career or whether I want to lean in on the IT side and the system side, and helping make some of those decisions about where to focus and what to take some classes in, what to continue education on, and where to lean in with upcoming projects. Talking that through with somebody has really helped me make sense of some jumbled thoughts and figure out where to go next. I think the most important thing to look for in a mentor is somebody who you will get along with and somebody that you trust. This is a person that you're going to go to with some of potentially the toughest choices of your career, looking to them for guidance and for help and for support. My most successful mentors, the most successful mentoring relationships that I've had, have been with people who I'm close to, personally or professionally, and who I trust and who I feel comfortable sharing potentially deep thoughts with, and a lot of potentially sensitive details about what I'm thinking, what I'm going through, and what I want, to help so that they can help me make sense of that and figure out what to do. And I love now that I can pay that forward and share some of the wisdom that I've learned from my mentors and from some of the experiences that I've had in my career, and help share that with someone else so that they can navigate some of their same decisions and some of those same situations, and hopefully learn from some of my experiences and some of my mistakes. And helping pay that forward is what's really exciting about being a mentor.
Welcome back. Before we get started, let's take a moment to celebrate how far you've come and everything you've learned in this course. You're almost halfway through this program. Thanks for sticking with it. So far, you've learned about data types and data structures and discovered the importance of bias and credibility in data preparation and analysis. We also explored databases, different ways to organize and protect your data, and even how to join the data analytics community. All of this will help you prepare your data for the next step in the data analysis lifecycle, processing. Processing your data to make sure that it's clean and complete is the last step you take before you start analyzing it. And that's exactly what the next course is all about. I'm excited to reintroduce fellow Googler Sally, Performance Measurement and Analytical Lead. She's going to be your guide throughout this next course, which is all about cleaning and processing your data for analysis. Coming up, you're going to learn about integrity in data analytics, basic data cleaning skills, and data cleaning in SQL. We'll also learn how to verify and report your data cleaning results, and, if you're up for it, adding data to your resume. Before you go, let me just say one more time. Fantastic job. When you're ready, you can go ahead and start the next course. Sally will be there to guide you through it.
Hi, good to see you. My name's Sally, and I'm here to teach you all about processing data. I'm a measurement and analytical lead at Google. My job is to help advertising agencies and companies measure success and analyze their data. So I get to meet with lots of different people to show them how data analysis helps with their advertising. Speaking of analysis, you did great earlier learning how to gather and organize data for analysis. It's definitely an important step in the data analysis process. So well done. Now let's talk about how to make sure that your organized data is complete and accurate. Clean data is the key to making sure your data has integrity before you analyze it. We'll show you how to make sure your data is clean and tidy. Cleaning and processing data is one part of the overall data analysis process. As a quick reminder, that process is ask, prepare, process, analyze, share, and act. Which means it's time for us to explore the process phase. And I'm here to guide you the whole way. I'm very familiar with where you are right now. I'd never heard of data analytics until I went through a program similar to this one. Once I started making progress, I realized how much I enjoyed data analytics and the doors it can open. And now I'm excited to help you open those same doors. One thing I've realized as I work for different companies is that clean data is important in every industry. For example, I learned early in my career to be on the lookout for duplicate data, a common problem that analysts come across when cleaning. I used to work for a company that had different types of subscriptions. In our dataset, each user would have a new row for each subscription type they bought, which meant users would show up more than once in my data. So if I had counted the number of users in a table without accounting for duplicates like this, I would have counted some users twice instead of once. As a result, my analysis would have been wrong, which would have led to problems in my reports and for the stakeholders relying on my analysis. Imagine if I told the CEO that we had twice as many customers as we actually did. That's why clean data is so important. So the first step in processing data is learning about data integrity. You'll find out what data integrity is and why it's important to maintain it throughout the data analysis process. Sometimes you might not even have the data that you need, so you'll have to create it yourself. This will help you learn how sample size and random sampling can save you time and effort. Testing data is another important step to take when processing data. We'll share some guidance on how to test data before your analysis officially begins. Just like you'd clean your clothes and your dishes in everyday life, analysts clean their data all the time too. The importance of clean data will definitely be a focus here. You'll learn data cleaning techniques for all scenarios, along with some pitfalls to watch out for as you clean. You'll explore data cleaning in both spreadsheets and databases, building on what you've already learned about spreadsheets. We'll talk more about SQL and how you can use it to clean data and do other useful things too. When analysts clean their data, they do a lot more than a spot check to make sure it was done correctly. You'll learn ways to verify and report your cleaning results. This includes documenting your cleaning process, which has lots of benefits that we'll explore. It's important to remember that processing data is just one of the tasks you'll complete as a data analyst. Actually, your skills with cleaning data might just end up being something you highlight in your resume when you start job hunting. Speaking of resumes, you'll be able to start thinking about how to build your own from the perspective of a data analyst. Once you're done here, you'll have a strong appreciation for clean data and how important it is in the data analysis process. So let's get started. Welcome back. In this video, we're going to discuss data integrity and some risks you might run into as a data analyst. A strong analysis depends on the integrity of the data. If the data you're using is compromised in any way, your analysis won't be as strong as it should be. Data integrity is the accuracy, completeness, consistency, and trustworthiness of data throughout its life cycle. That might sound like a lot of qualities for the data to live up to, but trust me, it's worth it to check for them all before proceeding with your analysis. Otherwise, your analysis could be wrong. Not because you did something wrong, but because the data you were working with was wrong to begin with. When data integrity is low, it can cause anything from the loss of a single pixel in an image to an incorrect medical decision. In some cases, one missing piece can make all of your data useless. Data integrity can be compromised in lots of different ways. There's a chance data can be compromised every time it's replicated, transferred, or manipulated in any way. Data replication is the process of storing data in multiple locations. If you're replicating data at different times, in different places, there's a chance your data will be out of sync. This data lacks integrity because different people might not be using the same data for their findings, which can cause inconsistencies. There's also the issue of data transfer, which is the process of copying data from a storage device to memory, or from one computer to another. If your data transfer is interrupted, you might end up with an incomplete data set, which might not be useful for your needs. The data manipulation process involves changing the data to make it more organized and easier to read. Data manipulation is meant to make the data analysis process more efficient, but an error during the process can compromise that efficiency. Finally, data can also be compromised through human error, viruses, malware, hacking, and system failures, which can all lead to even more headaches. I'll stop there. That's enough potentially bad news to digest. Let's move on to some potentially good news. In a lot of companies, the data warehouse or data engineering team takes care of ensuring data integrity. Coming up, we'll learn about checking data integrity as a data analyst. But rest assured, someone else will usually have your back too. After you found out what kind of data you're working with, it's important to double check that your data is complete and valid before analysis. This will help ensure that your analysis and eventual conclusions are accurate. Checking data integrity is a vital step in processing your data to get it ready for analysis, whether you or someone else at your company is doing it. Coming up, you'll learn even more about data integrity. See you soon. Hey there! It's good to remember to check for data integrity. It's also important to check that the data you use aligns with the business objective. This adds another layer to the maintenance of data integrity because the data you're using might have limitations that you'll need to deal with. The process of matching data to business objectives can actually be pretty straightforward. Here's a quick example. Let's say you're an analyst for a business that produces and sells auto parts. If you need to address a question about the revenue generated by the sale of a certain part, then you'd pull up the revenue table from the dataset. If the question is about customer reviews, then you'd pull up the reviews table to analyze the average ratings. But before digging into any analysis, you need to consider a few limitations that might affect it. If the data hasn't been cleaned properly, then you won't be able to use it yet. You would need to wait until a thorough cleaning has been done. Now, let's say you're trying to find how much an average customer spends, and you notice the same customer's data showing up in more than one row. This is called duplicate data. To fix this, you might need to change the format of the data, or you might need to change the way you calculate the average. Otherwise, it'll seem like the data is for two different people, and you'll be stuck with misleading calculations. You might also realize there's not enough data to complete an accurate analysis. Maybe you only have a couple of months' worth of sales data. There's a slim chance you could wait for more data, but it's more likely that you'll have to change your process or find alternate sources of data while still meeting your objective. I like to think of a data set like a picture. Take this picture. What are we looking at? Unless you're an expert traveler or know the area, it may be hard to pick out from just these two images. Visually, it's very clear when we aren't seeing the whole picture. When you get the complete picture, you realize you're in London. With incomplete data, it's hard to see the whole picture to get a real sense of what is going on. We sometimes trust data because if it comes to us in rows and columns, it seems like everything we need is there if we just query it. But that's just not true. I remember a time when I found out I didn't have enough data and had to find a solution. I was working for an online retail company and was asked to figure out how to shorten customer purchase to delivery time. Faster delivery times usually lead to happier customers. When I checked the dataset, I found very limited tracking information. We were missing some pretty key details. So the data engineers and I created new processes to track additional information like the number of stops in a journey. Using this data, we reduced the time it took from purchase to delivery and saw an improvement in customer satisfaction. That felt pretty great. Learning how to deal with data issues while staying focused on your objective will help set you up for success in your career as a data analyst. And your path to success continues. Next up, you'll learn more about aligning data to objectives. Keep it up. Every analyst has been in a situation where there is insufficient data to help with their business objective. Considering how much data is generated every day, it may be hard to believe, but it's true. So let's discuss what you can do when you have insufficient data. We'll cover how to set limits for the scope of your analysis and what data you should include. At one point, I was a data analyst at a support center. Every day, we received customer questions which were logged in as support tickets. I was asked to forecast the number of support tickets coming in per month to figure out how many additional people we needed to hire. It was very important that we had sufficient data spanning back at least a couple years because I had to account for year-to-year and seasonal changes. If I just had the current year's data available, I wouldn't have known that a spike in January is common and has to do with people asking for refunds after the holidays. Because I had sufficient data, I was able to suggest we hire more people in January to prepare. Challenges are bound to come up. But the good news is that once you know your business objective, you'll be able to recognize whether you have enough data. And if you don't, you'll be able to deal with it before you start your analysis. Now let's check out some of those limitations you might come across and how you can handle different types of insufficient data. Say you're working in the tourism industry and you need to find out which travel plans are searched most often. If you only use data from one booking site, you're limiting yourself to data from just one source. Other booking sites might show different trends that you would want to consider for your analysis. If a limitation like this impacts your analysis, you can stop and go back to your stakeholders to figure out a plan. If your dataset keeps updating, that means the data is still incoming and might not be complete. So if there's a brand new tourist attraction that you're analyzing interest and attendance for, there's probably not enough data for you to determine trends. For example, you might want to wait a month to gather data. Or you can check in with the stakeholders and ask about adjusting the objective. For example, you might analyze trends from week to week instead of month to month. You could also base your analysis on trends over the past 3 months and say, here's what attendance at the attraction for month 4 could look like. You might not have enough data to know if this number is too low or too high, but you would tell stakeholders that it's your best estimate based on the data that you currently have. On the other hand, your data could be older and no longer be relevant. Outdated data about customer satisfaction won't include the most recent responses. So you'd be relying on ratings for hotels or vacation rentals that might no longer be accurate. In this case, your best bet might be to find a new data set to work with. Data that's geographically limited could also be unreliable. If your company's global, you wouldn't want to use data limited to travel in just one country. You'd want a dataset that includes all countries. So that's just a few of the most common limitations you'll come across, and some ways you can adjust them. You can identify trends with the available data, or wait for more data if time allows. You can talk with stakeholders and adjust your objective, or you can look for a new dataset. The need to take these steps will depend on your role in your company, and possibly the needs of the wider industry. But learning how to deal with insufficient data is always a great way to set yourself up for success. Your data analyst powers are growing stronger, and just in time. After you learn more about limitations and solutions, you'll learn about statistical power, another fantastic tool for you to use. See you soon. Okay, so earlier we talked about having the right kind of data to meet your business objective. and the importance of having the right amount of data to make sure your analysis is as accurate as possible. You might remember that for data analysts, a population is all possible data values in a certain data set. If you're able to use 100% of a population in your analysis, that's great. But sometimes collecting information about an entire population just isn't possible. It's too time-consuming or expensive. For example, let's say a global organization wants to know more about pet owners who have cats. You're tasked with finding out which kinds of toys cat owners in Canada prefer. But there's millions of cat owners in Canada, so getting data from all of them would be a huge challenge. Fear not. Allow me to introduce you to sample size. When you use sample size, or sample, you use a part of a population that's representative of the population. The goal is to get enough information from a small group within a population to make predictions or conclusions about the whole population. The sample size helps ensure the degree to which you can be confident that your conclusions accurately represent the population. So for the data on cat owners, a sample size might contain data about hundreds or thousands of people, rather than millions. Using a sample for analysis is more cost-effective and takes less time. If done carefully and thoughtfully, you can get the same results using a sample size instead of trying to hunt down every single cat owner to find out their favorite cat toys. There is a potential downside though. When you only use a small sample of a population, it can lead to uncertainty. You can't really be 100% sure that your statistics are a complete and accurate representation of the population. This leads to sampling bias, which we covered earlier in the program. Sampling bias is when a sample isn't representative of the population as a whole. This means some members of the population are being overrepresented or underrepresented. For example, if the survey used to collect data from cat owners only included people with smartphones, then cat owners who don't have a smartphone wouldn't be represented in the data. Using random sampling can help address some of those issues with sampling bias. Random sampling is a way of selecting a sample from a population so that every possible type of the sample has an equal chance of being chosen. Going back to our cat owners again. Using a random sample of cat owners means cat owners of every type have an equal chance of being chosen. So cat owners who live in apartments in Ontario would have the same chance of being represented as those who live in houses in Alberta. As a data analyst, you'll find that creating sample sizes usually takes place before you even get to the data. But it's still good for you to know that the data you're going to analyze is representative of the population and works with your objective. It's also good to know what's coming up in your data journey. In the next video, you'll have the option to become even more comfortable with sample sizes. See you there! Hey there! We've all probably dreamed of having a superpower at least once in our lives. I know I have. I'd love to be able to fly. But there's another superpower you might not have heard of: statistical power. Statistical power is the probability of getting meaningful results from a test. I'm guessing that's not a superpower any of you have dreamed about. Still, it's a pretty great data superpower. For data analysts, your projects might begin with a test or study. Hypothesis testing is a way to see if a survey or experiment has meaningful results. Here's an example. Let's say you work for a restaurant chain that's planning a marketing campaign for their new milkshakes. You need to test the ad on a group of customers before turning it into a nationwide ad campaign. In the test, you want to check whether customers like or dislike the campaign. You also want to rule out any factors outside of the ad that might lead them to say they don't like it. Using all your customers would be too time-consuming and expensive. So you'll need to figure out how many customers you'll need to show that the ad is effective. 50 probably wouldn't be enough. Even if you randomly chose 50 customers, you might end up with customers who don't like milkshakes at all. And if that happens, you won't be able to measure the effectiveness of your ad in getting more milkshake orders, since no one in the sample size would order them. That's why you need a larger sample size, so you can make sure you get a good number of all types of people for your test. Usually,
The larger the sample size, the greater the chance you'll have statistically significant results with your test. And that's statistical power. In this case, using as many customers as possible will show the actual differences between the groups who like or dislike the ad versus people whose decision wasn't based on the ad at all. There are ways to accurately calculate statistical power, but we won't go into them here. You might need to calculate it on your own as a data analyst. For now, you should know that statistical power is usually shown as a value out of 1. So if your statistical power is 0.6, that's the same thing as saying 60%. In the milkshake ad test, if you found a statistical power of 60%, that means there's a 60% chance of you getting a statistically significant result on the ad's effectiveness. Statistically significant is a term that is used in statistics. If you want to learn more about the technical meaning, you can search online. But in basic terms, if a test is statistically significant, it means the results of the test are real and not an error caused by random chance. So there's a 60% chance that the results of the milkshake ad test are reliable and real, and a 40% chance that the result of the test is wrong. Usually, you need a statistical power of at least 0.8 or 80% to consider your results statistically significant. Let's check out one more scenario. We'll stick with milkshakes because I like milkshakes. Imagine you work for a restaurant chain that wants to launch a brand new birthday cake flavored milkshake. This milkshake will be more expensive to produce than your other milkshakes. Your company hopes that the buzz around the new flavor will bring in more customers and money to offset this cost. They want to test this out in a few restaurant locations first. So let's figure out how many locations you'd have to use to be confident in your results. First, you'd have to think about what might prevent you from getting statistically significant results. Are there restaurants running any other promotions that might bring in new customers? Do some restaurants have customers that always buy the newest item no matter what it is? Do some locations have construction that recently started that would prevent customers from even going to the restaurant? To get a higher statistical power, you'd have to consider all of these factors before you decide how many locations to include in your sample size for your study. You want to make sure any effect is most likely due to the new milkshake flavor, not another factor. The measurable effects would be an increase in sales or the number of customers at the locations in your sample size. That's it for now. Coming up, we'll explore sample sizes in more detail, so you can get a better idea of how they impact your tests and studies. In the meantime, you've gotten to know a little bit more about milkshakes and superpowers, and of course, statistical power. Sadly, only statistical power can truly be useful for data analysts. Though putting on my cape and flying to grab a milkshake right now does sound pretty good. Great to see you again. In this video, we'll go into more detail about sample sizes and data integrity. If you've ever been to a store that hands out samples, you know it's one of life's little pleasures. For me, anyway. Those small samples are also a very smart way for businesses to learn more about their products from customers without having to give everyone a free sample. A lot of organizations use sample size in a similar way. They take one part of something larger, in this case, a sample of a population. Sometimes they'll perform complex tests on their data to see if it meets their business objectives. We won't go into all the calculations needed to do this effectively. Instead, we'll focus on a big picture look at the process and what it involves. As a quick reminder, sample size is a part of a population that is representative of the population. For businesses, it's a very important tool. It can be both expensive and time-consuming to analyze an entire population of data. So using sample size usually makes the most sense and can still lead to valid and useful findings. There are handy calculators online that can help you find sample size. You need to input the confidence level, population size, and margin of error. We've talked about population size before. To build on that, we'll learn about confidence level and margin of error. Knowing about these concepts will help you understand why you need them to calculate sample size. The confidence level is the probability that your sample accurately reflects the greater population.
You can think of it the same way as confidence in anything else. It's how strongly you feel that you can rely on something or someone. Having a 99% confidence level is ideal, but most industries hope for at least a 90 or 95% confidence level. Industries like pharmaceuticals usually want a confidence level that's as high as possible when they are using a sample size. This makes sense because they're testing medicines and need to be sure they work and are safe for everyone to use. For other studies, organizations might just need to know that the test or survey results have them heading in the right direction. For example, if a paint company is testing out new colors, a lower confidence level is okay. You also want to consider the margin of error for your study. You'll learn more about this soon, but it basically tells you how close your sample size results are to what your results would be if you use the entire population that your sample size represents. Think of it like this. Let's say that the principal of a middle school approaches you with a study about students' candy preferences. They need to know an appropriate sample size and they need it now. The school has a student population of 500, and they're asking for a confidence level of 95% and a margin of error of 5%. We've set up a calculator in a spreadsheet, but you can also easily find this type of calculator by searching sample size calculator on the internet. And just like those calculators, our spreadsheet calculator doesn't show any of the more complex calculations for figuring out sample size. So all we need to do is input the numbers for our population, confidence level, and margin of error. And when we type 500 for our population size and 95 for our confidence level percentage and 5 for our margin of error percentage, the result is about 218. That means for this study, an appropriate sample size would be 218. So if we surveyed 218 students and found that 55% of them preferred chocolate, then we could be pretty confident that would be true of all 500 students. 218 is the minimum number of people we need to survey based on our criteria of a 95% confidence level and a 5% margin of error. And in case you're wondering, the confidence level and margin of error don't have to add up to 100%. They're independent of each other. So let's say we change our margin of error from 5% to 3%. Then we find that our sample size would need to be larger, about 341 instead of 218, to make the results of the study more representative of the population. Feel free to practice with an online calculator. Knowing sample size and how to find it will help you when you work with data. And we've got more useful knowledge coming your way, including learning about margin of error. See you soon! Hey there! Earlier, we touched on margin of error without explaining it completely. Well, we're going to write that wrong in this video by explaining margin of error more. We'll even include an example of how to calculate it. As a data analyst, it's important for you to figure out sample size and variables like confidence level and margin of error before running any kind of test or survey. It's the best way to make sure your results are objective, and it gives you a better chance of getting statistically significant results. But if you already know the sample size, like when you're given survey results to analyze, you can calculate the margin of error yourself. Then you'll have a better idea of how much of a difference there is between your sample and your population. We'll start at the beginning with a more complete definition. Margin of error is the maximum amount that the sample results are expected to differ from those of the actual population. Let's think about an example of margin of error. It would be great to survey or test an entire population, but it's usually impossible or impractical to do this. So instead, we take a sample of the larger population. Based on the sample size, the resulting margin of error will tell us how different the results might be compared to the results if we had surveyed the entire population. Margin of error helps you understand how reliable the data from your hypothesis testing is. The closer to zero the margin of error, the closer your results from your sample would match results from the overall population. For example, Let's say you completed a nationwide survey using a sample of the population. You asked people who work 5-day work weeks whether they like the idea of a 4-day work week. So your survey tells you that 60% prefer a 4-day work week. The margin of error was 10%, which tells us that between 50 and 70% like the idea. So if we were to survey all 5-day workers nationwide, between 50 and 70% would agree with our results. Keep in mind, our range is between 50 and 70%. That's because the margin of error is counted in both directions from the survey results of 60%. If you set up a 95% confidence level for your survey, there will be a 95% chance that the entire population's responses will fall between 50 and 70% saying, yes, they want a 4-day work week. Since your margin of error overlaps with that 50% mark, you can't say for sure that the public likes the idea of a 4-day work week. In that case, you'd have to say your survey was inconclusive. Now, if you wanted a lower margin of error, say 5% with a range between 55 and 65%, you could increase the sample size. But if you've already been given the sample size, you can calculate the margin of error yourself. Then you can decide yourself how much of a chance your results have of being statistically significant based on your margin of error. In general, the more people you include in your survey, the more likely your sample is representative of the entire population. Decreasing the confidence level would also have the same effect, but that would also make it less likely that your survey is accurate. So to calculate margin of error, you need 3 things: population size, sample size, and confidence level. And just like with sample size, you can find lots of calculators online by searching margin of error calculator. But we'll show you in a spreadsheet, just like we did when we calculated sample size. Let's say you're running a study on the effectiveness of a new drug. You have a sample size of 500 participants, whose condition affects 1% of the world's population. That's about 80 million people, which is the population for your study. Since it's a drug study, you need to have a confidence level of 99%. You also need a low margin of error. Let's calculate it. We'll put the numbers for population and confidence level and sample size in the appropriate spreadsheet cells. And our result is a margin of error of close to 6%, plus or minus. When the drug study is complete, you'd apply the margin of error to your results to determine how reliable your results might be. Calculators like this one in the spreadsheet are just one of the many tools you can use to ensure data integrity. And it's also good to remember that checking for data integrity and aligning the data with your objectives will put you in good shape to complete your analysis. Knowing about sample size, statistical power, margin of error, and other topics we covered will help your analysis run smoothly. That's a lot of new concepts to take in. If you'd like to review them at any time, you can find them all in the glossary, or feel free to rewatch the video. Soon you'll explore the ins and outs of clean data. The data adventure keeps moving. I'm so glad you're moving along with it. You got this! Can you guess what inaccurate or bad data costs businesses every year? Thousands of dollars? Millions? Billions? Well, according to IBM, the yearly cost of poor quality data is $3.1 trillion in the US alone. That's a lot of zeros. Now, can you guess the #1 cause of poor quality data? It's not a new system implementation or a computer technical glitch. The most common factor is actually human error. Here's a spreadsheet from a law office. It shows customers, the legal services they bought, the service order number, how much they paid, and the payment method. Dirty data can be the result of someone typing in a piece of data incorrectly.
inconsistent formatting, blank fields, or the same piece of data being entered more than once, which causes duplicates. Dirty data is data that's incomplete, incorrect, or irrelevant to the problem you're trying to solve. When you work with dirty data, you can't be sure that your results are correct. In fact, you can pretty much bet they won't be. Earlier, you learned that data integrity is critical to reliable data analytics results. And clean data helps you achieve data integrity. Clean data is data that's complete, correct, and relevant to the problem you're trying to solve. When you work with clean data, you'll find that your projects go much more smoothly. I remember the first time I witnessed firsthand how important clean data really is. I had just started using SQL and I thought it worked like magic. I could have the computer sum up millions of numbers, saving me tons of time and effort. But I quickly discovered that only works when the data is clean. If there was even one accidental letter in a column that should only have numbers, the computer wouldn't know what to do. So it would throw an error, and suddenly I was stuck. And there's no way I can add up millions of numbers by myself. So I had to clean up that data to make it work. The good news is that there's plenty of effective processes and tools to help you do that. Coming up, you'll gain the skills and knowledge you need to make sure the data you work with is always clean. Along the way, we'll dig deeper into the difference between clean and dirty data and why clean data is so important. We'll also talk about different ways to clean your data and common problems to look for during the process. Ready to start? Let's do it! Clean data is incredibly important for effective analysis. If a piece of data is entered into a spreadsheet or database incorrectly, or if it's repeated, or if a field is left blank, or if data formats are inconsistent, the result is dirty data. Small mistakes can lead to big consequences in the long run. Now, I'll be completely honest with you. Data cleaning is like brushing your teeth. It's something you should do and do properly because otherwise it can cause serious problems. For teeth, that might be cavities or gum disease. For data, that might be costing your company money or an angry boss. But here's the good news. If you keep brushing twice a day, every day, it becomes a habit. Soon, you don't even have to think about it. And it's the same with data. Trust me, it'll make you look great when you take the time to clean up that dirty data. As a quick refresher, dirty data is incomplete, incorrect, or irrelevant to the problem you're trying to solve. It can't be used in a meaningful way, which makes analysis very difficult, if not impossible. On the other hand, clean data is complete, correct, and relevant to the problem you're trying to solve. This allows you to understand and analyze the information and identify important patterns, connect related information, and draw useful conclusions. Then you can apply what you learn to make effective decisions. In some cases, you won't have to do a lot of work to clean data. For example, when you use internal data that's been verified and cared for by your company's data engineers and data warehouse team, it's more likely to be clean. Let's talk about some people you'll work with as a data analyst. Data engineers transform data into a useful format for analysis and give it a reliable infrastructure. This means they develop, maintain, and test databases, data processors, and related systems. Data warehousing specialists develop processes and procedures to effectively store and organize data. They make sure that data is available, secure, and backed up to prevent loss. When you become a data analyst, you can learn a lot by working with the person who maintains your databases to learn about their systems. If data passes through the hands of a data engineer or a data warehousing specialist first, you know you're off to a good start on your project. There's a lot of great career opportunities as a data engineer or a data warehousing specialist. If this kind of work sounds interesting to you, maybe your career path will involve helping organizations save lots of time, effort, and money by making sure their data is sparkling clean. But even if you go in a different direction with your data analytics career and have the advantage of working with data engineers and warehousing specialists, you're still likely to have to clean your own data. And it's important to remember, No dataset is perfect. It's always a good idea to examine and clean data before beginning analysis. Here's an example. Let's say you're working on a project where you need to figure out how many people use your company's software program. You have a spreadsheet that was created internally and verified by a data engineer and a data warehousing specialist. Check out the column labeled username. Now, it might seem logical that you can just scroll down and count the rows to figure out how many users you have. But that won't work because one person sometimes has more than one username. Maybe they registered from different email addresses, or maybe they have a work and personal account. In situations like this, you would need to clean the data by eliminating any rows that are duplicates. Once you've done that, there won't be any more duplicate entries. Then your spreadsheet's ready to be put to work. Okay, so far we've discussed working with internal data. But data cleaning becomes even more important when working with external data, especially if it comes from multiple sources. Let's say the software company from our example surveyed its customers to learn how satisfied they are with its software product. But when you review the survey data, you find that you have several nulls. A null is an indication that a value does not exist in a dataset. Note that it's not the same as a zero. In the case of our survey, a null would mean the customer skipped that question. A zero would mean they provided zero as their response. To do your analysis, you would first need to clean this data. Step 1 would be to decide what to do with those nulls. You could either filter them out and communicate that you now have a smaller sample size, or you can keep them in and learn from the fact that the customers did not provide responses. There's lots of reasons why this could have happened. Maybe your survey questions weren't written as well as they could be. Maybe they were confusing or biased, something we learned about earlier. Okay, we've touched on the basics of cleaning internal and external data, but there's lots more to come. Soon we'll learn about the common errors to be aware of to ensure your data is complete, correct, and relevant. See you soon!
I'm Angie. I'm a program manager of engineering at Google. I truly believe that cleaning data is the heart and soul of data. It's how you get to know your data, its quirks, its flaws, its mysteries. I love a good mystery. I remember one time I found somebody had purchased, I think it was $1 million worth of chicken sandwiches in one transaction. And this mystery drove me nuts. You know, I had all these questions. Could this have really happened? You know, maybe it was a really big birthday party. How did they make $1 million worth of chicken sandwiches? And I, was cleaning my data and trying to figure out where did it go wrong. And we ended up finding out that we had been squaring and multiplying all of our transactions for a very specific case. It took us about 3 days to figure this out. I will never forget the moment when it was like, aha, we got to the bottom of it. The result is our data, was cleaned and we had this great data set that we could use for analysis. But what I loved was just the mystery of it, and getting to know all these weird intricacies about my data set. And it felt like a superpower almost. Like I was a detective and I'd gone in there and I'd really solved something. So I love cleaning data.
Hey there! In this video, we'll focus on common issues associated with dirty data. These include spelling and other text errors, inconsistent labels, formats, and field length, missing data, and duplicates. This will help you recognize problems quicker and give you the information you need to fix them when you encounter something similar during your own analysis. This is incredibly important in data analytics. Okay, let's go back to our law office spreadsheet. As a quick refresher, we'll start by checking out the different types of dirty data it shows. Sometimes, someone might key in a piece of data incorrectly. Other times, they might not keep data formats consistent. It's also common to leave a field blank. That's also called a null, which we learned about earlier. And if someone adds the same piece of data more than once, that creates a duplicate.
So let's break that down. Then we'll learn about a few other types of dirty data and strategies for cleaning it. Misspellings, spelling variations, mixed up letters, inconsistent punctuation, and typos in general happen when someone types in a piece of data incorrectly. As a data analyst, you'll also deal with different currencies. For example, one dataset could be in US dollars and another in euros, and you don't want to get them mixed up. We want to find these types of errors and fix them like this. You'll learn more about this soon. Clean data depends largely on the data integrity rules that an organization follows, such as spelling and punctuation guidelines. For example, a beverage company might ask everyone working in its database to enter data about volume in fluid ounces instead of cups. It's great when an organization has rules like this in place. It really helps minimize the amount of data cleaning required. But it can't eliminate it completely. Like we discussed earlier, there's always the possibility of human error. The next type of dirty data our spreadsheet shows is inconsistent formatting. In this example, something that should be formatted as currency is shown as a percentage. Until this error is fixed, like this, the law office will have no idea how much money this customer paid for its services. We'll learn about different ways to solve this and many other problems soon. We discussed nulls previously, but as a reminder, nulls are empty fields. This kind of dirty data requires a little more work than just fixing a spelling error or changing a format. In this example, the data analysts would need to research which customer had a consultation on July 4th, 2020. Then, when they find the correct information, they'd have to add it to the spreadsheet. Another common type of dirty data is a duplicate. Maybe two different people added this appointment on August 13th, not realizing that someone else had already done it. Or maybe the person entering the data hit copy and paste by accident. Whatever the reason, it's the data analyst's job to identify this error and correct it by deleting one of the duplicates. Okay, now let's continue on to some other types of dirty data. The first has to do with labeling. To understand labeling, imagine trying to get a computer to correctly identify panda bears among images of all different kinds of animals. You need to show the computer thousands of images of panda bears. They're all labeled as panda bears. Any incorrectly labeled picture, like the one here that's just bear, will cause a problem. The next type of dirty data is having an inconsistent field length. You learned earlier that a field is a single piece of information from a row or a column of a spreadsheet. Field length is a tool for determining how many characters can be keyed into a field. Assigning a certain length to the fields in your spreadsheet is a great way to avoid errors. For instance, if you have a column for someone's birth year, you know the field length is 4 because all years are 4 digits long. Some spreadsheet applications have a simple way to specify field lengths and make sure users can only enter a certain number of characters into a field. This is part of data validation. Data validation is a tool for checking the accuracy and quality of data before adding or importing it. Data validation is a form of data cleansing, which you'll learn more about soon. But first, you'll get familiar with more techniques for cleaning data. This is a very important part of the data analyst's job, and I look forward to sharing these data cleaning strategies with you. Hi! Now that you're familiar with some of the most common types of dirty data, it's time to clean them up. As you've learned, clean data is essential to data integrity and reliable solutions and decisions. The good news is that spreadsheets have all kinds of tools you can use to get your data ready for analysis. The techniques for data cleaning will be different depending on the specific data set you're working with. So we won't cover everything you might run into. But this will give you a great starting point for fixing the types of dirty data analysts find most often. Think of everything that's coming up as a teaser trailer of data cleaning tools. I'm going to give you a basic overview of some common tools and techniques, and then we'll practice them again later on. Here, we'll discuss how to remove unwanted data, clean up text to remove extra spaces and blanks, fix typos, and make formatting consistent. However, before removing unwanted data, it's always a good practice to make a copy of the dataset. That way, if you remove something that you end up needing in the future, you can easily access it and put it back in the dataset. Once that's done, then you can move on to getting rid of the duplicates or data that isn't relevant to the problem you're trying to solve. Typically, duplicates appear when you're combining datasets from more than one source, or using data from multiple departments within the same business. You've already learned a bit about duplicates, but let's practice removing them once more now using this spreadsheet, which lists members of a professional logistics association. Duplicates can be a big problem for data analysts, so it's really important that you can find and remove them before any analysis starts. Here's an example of what I'm talking about. Let's say this association has duplicates of one person's $500 membership in its database. When the data is summarized, the analyst would think there was $1,000 being paid by this member and would make decisions based on that incorrect data. But in reality, this member only paid $500. These problems can be fixed manually, but most spreadsheet applications also offer lots of tools to help you find and remove duplicates. Now, irrelevant data, which is data that doesn't fit the specific problem that you're trying to solve, also needs to be removed. Going back to our association membership list example, let's say a data analyst was working on a project that focused only on current members. They wouldn't want to include information on people who are no longer members. Or who never joined in the first place. Removing irrelevant data takes a little more time and effort because you have to figure out the difference between the data you need and the data you don't. But believe me, making those decisions will save you a ton of effort down the road. The next step is removing extra spaces and blanks. Extra spaces can cause unexpected results when you sort, filter, or search through your data. And because these characters are easy to miss, they can lead to unexpected and confusing results. For example, if there's an extra space in a member ID number, when you sort the column from lowest to highest, this row will be out of place. To remove these unwanted spaces or blank cells, you can delete them yourself. Or, again, you can rely on your spreadsheets, which offer lots of great functions for removing spaces and blanks automatically. The next data cleaning step involves fixing misspellings, inconsistent capitalization, incorrect punctuation, and other typos. These types of errors can lead to some big problems. Let's say you have a database of emails that you use to keep in touch with your customers. If some emails have misspellings, a period in the wrong place, or any other kind of typo, not only do you run the risk of sending an email to the wrong people, you also run the risk of spamming random people. Think about our association membership example again. Misspelling might cause the data analyst to miscount the number of professional members if they sorted this membership type, and then counted the number of rows. Like the other problems we've come across, you can also fix these problems manually. Or you can use spreadsheet tools such as spell check, autocorrect, and conditional formatting to make your life easier. There's also easy ways to convert text to lowercase, uppercase, or proper case, which is one of the things we'll check out again later. All right, we're getting there. The next step is removing formatting. This is particularly important when you get data from lots of different sources. Every database has its own formatting, which can cause the data to seem inconsistent. Creating a clean and consistent visual appearance for your spreadsheets will help make it a valuable tool for you and your team when making key decisions. Most spreadsheet applications also have a clear formats tool, which is a great time saver. Cleaning data is an essential step in increasing the quality of your data. Now you know lots of different ways to do that. In the next video, you'll take that knowledge even further and learn how to clean up data that's come from more than one source. Welcome back! So far, you learned a lot about dirty data and how to clean up the most common errors in a dataset. Now we're going to take that a step further and talk about cleaning up multiple datasets. Cleaning data that comes from 2 or more sources is very common for data analysts, but it does come with some interesting challenges. A good example is a merger, which is an agreement that unites 2 organizations into a single new one. In the logistics field, there's been lots of big changes recently, mostly because of the e-commerce boom. With so many people shopping online, it makes sense that the companies responsible for delivering these products to their homes are in the middle of a big shakeup. When big things happen in an industry, it's common for 2 organizations to team up and become stronger through a merger. Let's talk about how that'll affect our logistics association. As a quick reminder, this spreadsheet lists association member ID numbers, first and last names, addresses, how much each member pays in dues, when the membership expires, and the membership types. Now, let's think about what would happen if the International Logistics Association decided to get together with the Global Logistics Association in order to help their members handle the incredible demands of e-commerce. First, all the data from each organization would need to be combined using data merging. Data merging is the process of combining 2 or more datasets into a single dataset. This presents a unique challenge because when 2 totally different datasets are combined, the information is almost guaranteed to be inconsistent and misaligned. For example, the Global Logistics Association spreadsheet has a separate column for a person's suite, apartment, or unit number. But the International Logistics Association combines that information with their street address. This needs to be corrected to make the number of address columns consistent. Next, check out how the Global Logistics Association uses people's email addresses as their member ID, while the International Logistics Association uses numbers. This is a big problem because people in a certain industry, such as logistics, typically join multiple professional associations. So there's a very good chance that these datasets include membership information on the exact same person, just in different ways. It's super important to remove those duplicates. Also, the Global Logistics Association has many more member types than the other organization. On top of that, it uses the term young professional instead of student associate. But both describe members who are still in school or just starting their careers. If you were merging these 2 datasets, you need to work with your team to fix the fact that the 2 associations describe memberships very differently. Okay, now you understand why the merging of organizations also requires the merging of data, and that can be tricky. But there's lots of other reasons why data analysts merge datasets. For example, in one of my past jobs, I merged a lot of data from multiple sources to get insights about our customers' purchases. The kinds of insights I gained helped me identify customer buying patterns. When merging datasets, I always begin by asking myself some key questions to help me avoid redundancy and to confirm that the datasets are compatible. In data analytics, compatibility describes how well 2 or more datasets are able to work together. So the first question I would ask is, do I have all the data I need? To gather customer purchase insights, I wanted to make sure I had data on customers, their purchases, and where they shopped. Next, I would ask, does the data I need exist within these datasets? As you learned earlier in this program, this involves considering the entire data set analytically. Looking through the data before I start using it lets me get a feel for what it's all about, what the schema looks like, if it's relevant to my customer purchase insights, and if it's clean data. That brings me to the next question. Do the datasets need to be cleaned, or are they ready for me to use? And because I'm working with more than one source, I'll also ask myself, are the datasets cleaned to the same standard? For example, what fields are regularly repeated? How are missing values handled? How recently was the data updated? Finding the answers to these questions and understanding if I need to fix any problems at the start of a project is a very important step in data merging. In both the examples we explored here, a data analyst could use either the spreadsheet tools or SQL queries to clean up, merge, and prepare the datasets for analysis. Depending on the tool you decide to use, the cleanup process can be simple or very complex. Soon you'll learn how to make the best choice for your situation. And as a final note, programming languages like R are also very useful for cleaning data. You'll learn more about how to use R and the other concepts we covered soon. Hi again. As you learned earlier, there's a lot of different ways to clean up data. I've shown you some examples of how you can clean data manually, such as searching for and fixing misspellings, or removing empty spaces and duplicates. We also learned that lots of spreadsheet applications have tools that help simplify and speed up the data cleaning process. There's a lot of great efficiency tools that data analysts use all the time, such as conditional formatting, removing duplicates, formatting dates, fixing text strings and substrings, and splitting text to columns. We'll explore those in more detail now. The first is something called conditional formatting. Conditional formatting is a spreadsheet tool that changes how cells appear when values meet specific conditions. Likewise, it can let you know when a cell does not meet the conditions you've set. Visual cues like this are very useful for data analysts, especially when we're working in a large spreadsheet with lots of data. Making certain data points stand out makes the information easier to understand and analyze. And for cleaning data, knowing when the data doesn't follow the condition is very helpful. Let's return to the Logistics Association spreadsheet to check out conditional formatting in action. We'll use conditional formatting to highlight blank cells. That way, we know where there's missing information, so we can add it to the spreadsheet. To do this, we'll start by selecting the range we want to search. For this example, we're not focused on address 3 and address 5. So the fields will include all the columns in our spreadsheets except for F and H. Next, we'll go to Format and choose Conditional Formatting. Great. Our range is automatically indicated in the field. The format rule will be to format cells if the cell is empty. Finally, we'll choose the formatting style. I'm going to pick a shade of bright pink so my blanks really stand out. Then click Done, and the blank cells are instantly highlighted. Okay, the next spreadsheet tool removes duplicates. As you've learned before, it's always smart to make a copy of the dataset before removing anything. So let's do that now. Great, now we can continue. You might remember that our example spreadsheet has one association member listed twice. To fix that, go to Data and select Remove Duplicates. Remove Duplicates is a tool that automatically searches for and eliminates duplicate entries from a spreadsheet. Choose Data has Header Row, because our spreadsheet has a row at the very top that describes the contents of each column. Next, select All, because we want to inspect our entire spreadsheet. Finally, remove duplicates.
you'll notice the duplicate row was found and immediately removed. Another useful spreadsheet tool enables you to make formats consistent. For example, some of the dates in this spreadsheet aren't in a standard date format. This could be confusing if you wanted to analyze when association members joined, how often they renewed their memberships, or how long they've been with the association. To make all of our dates consistent, first select column J. Then go to Format, select Number, then Date. Now all of our dates have a consistent format. Before we go over the next tool, I want to explain what a text string is. In data analytics, a text string is a group of characters within a cell, most often composed of letters. An important characteristic of a text string is its length, which is the number of characters in it. You'll learn more about that soon. For now, it's also useful to know that a substring is a smaller subset of a text string. Okay, now let's talk about split. Split is a tool that divides a text string around a specified character and puts each fragment into a new and separate cell. Split is helpful when you have more than one piece of data in a cell, and you want to separate them out. This might be a person's first and last name listed together, or it could be a cell that contains someone's city, state, country, and zip code, but you actually want each of those in its own column. So let's say this association wanted to analyze all of the different professional certifications its members have earned. To do this, you want each certification separated out into its own column. Right now, the certifications are separated by a comma. That's the specified text separating each item, also called the delimiter. Let's get them separated. Highlight the column, then select Data, and split text to columns. This spreadsheet application automatically knew that the comma was the delimiter and separated each certification. But sometimes you might need to specify what the delimiter should be. You can do that here. Split text to columns is also helpful for fixing instances of numbers stored as text. Sometimes values in your spreadsheet will seem like numbers, but they're formatted as text. This can happen when copying and pasting from one place to another, or if the formatting's wrong. For this example, let's check out a new spreadsheet from a cosmetics maker. If a data analyst wanted to determine total profits, they could add up everything in column F. But there's a problem. One of the cells has an error. If you check into it, you learn that the 707 in this cell is text and can't be changed into a number. So when the spreadsheet tries to multiply the cost of the product by the number of units sold, it's unable to make the calculation. But if we select the orders column and choose split text to columns, the error is resolved because now it can be treated as a number. Coming up, you'll learn about a tool that does just the opposite. Concatenate is a function that joins multiple text strings into a single string. Spreadsheets are a very important part of data analytics. They save data analysts time and effort and help us eliminate errors each and every day. Here, you learn about some of the most common tools that we use, but there's a lot more to come. Next, we'll learn even more about data cleaning with spreadsheet tools. Bye for now. Welcome back. You've learned about some very useful data cleaning tools that are built right into spreadsheet applications. Now we'll explore how functions can optimize your efforts to ensure data integrity. As a reminder, a function is a set of instructions that performs a specific calculation using the data in a spreadsheet. The first function we'll discuss is called COUNTIF. COUNTIF is a function that returns the number of cells that match a specified value. Basically,
It counts the number of times a value appears in a range of cells. Let's go back to our professional association spreadsheet. In this example, we want to make sure the association membership prices are listed accurately. We'll use countif to check for some common problems, like negative numbers or a value that's much less or much greater than expected. To start, let's find the least expensive membership, $100 for student associates. So that'll be the lowest number that exists in this column. If any cell has a value that's less than 100, countif will alert us. We'll add a few more rows at the bottom of our spreadsheet. Then beneath column H, type member dues less than $100. Next, type the function in the cell next to it. Every function has a certain syntax that needs to be followed for it to work. Syntax is a predetermined structure that includes all required information and its proper placement. The syntax of a countif function should be like this: equals countif, open parentheses, range, comma, the specified value in quotation marks, and a closed parentheses. So it will show up like this. Where I2 through I72 is the range, and the value is less than 100. This tells the function to go through column I and return a count of all cells that contain a number less than 100. Turns out there is one. Scrolling through our data, we find that one piece of data was mistakenly keyed in as a negative number. Let's fix that now. Now, we'll use countif to search for any values that are more than we would expect. The most expensive membership type is $500 for corporate members. Type the function in the cell. This time it'll appear like this. I2 through I72 is still the range, but the value is greater than 500. There's one here too. Check it out. This entry has an extra 0. It should be $100. Okay. The next function we'll discuss is called len. Len is a function that tells you the length of a text string by counting the number of characters it contains. This is useful when cleaning data if you have a certain piece of information in your spreadsheet that you know must contain a certain length. For example, this association uses 6-digit member identification codes. So if we just import this data and wanted to be sure our codes are all the correct number of digits, we'd use len. The syntax of len is equals len, open parentheses, the range, and the close parentheses. So we'll insert a new column after member ID, then type an equal sign and len. Add an open parentheses. The range is the first member ID number in A2. Finish the function by closing the parentheses. It tells us that there are 6 characters in cell A2. Let's continue the function through the entire column and find out if any results are not 6. But instead of manually going through our spreadsheet to search for these instances, we'll use conditional formatting. We talked about conditional formatting earlier. It's a spreadsheet tool that changes how cells appear when values meet specific conditions. Let's practice that now. Select all of column B except for the header, then go to Format and choose Conditional Formatting. The format rule is to format cells if not equal to 6.
Click Done. And the cell with the 7 inside is highlighted. All right, now we're going to talk about left and right. Left is a function that gives you a set number of characters from the left side of a text string. Right is a function that gives you a set number of characters from the right side of a text string. As a quick reminder, a text string is a group of characters within a cell, commonly composed of letters, numbers, or both. To see these functions in action, let's go back to the spreadsheet from the cosmetics maker from earlier. This spreadsheet contains product codes. Each has a 5-digit numeric code and then a 4-character text identifier. But let's say we only want to work with one side or the other. You can use left or right to give you the specific set of characters or numbers you need. We'll practice cleaning up our data using the left function first. The syntax of left is equals left, open parentheses, the range, a comma, and the number of characters from the left side of the text string we want. Then we finish it with the close parentheses. Here, our project requires just the 5-digit numeric codes. So in a separate column, type equals left, open parentheses, then add the range. Our range is A2. Then add a comma, and the number 5 for our 5-digit product code. Finally, finish the function with the close parentheses. Our function should show up like this. Press Enter, and now we have a substring, which is the number part of the product code only. Click and drag this function through the entire column to separate out the rest of the product codes by number only. Okay, now let's say our project only needs the 4-character text identifier. For that, we'll use the right function. In the next column, we'll begin the function. The syntax is equals right, open parentheses, the range, a comma, and the number of characters we want. Then we finish with the close parentheses. Let's key that in now. Equals right, open parentheses, and the range is still A2. Add a comma, and this time we'll tell it that we want the first 4 characters from the right. Close up the parentheses and press Enter. Then drag the function throughout the entire column. Now we can analyze the products in our spreadsheet based on either substring, the 5-digit numeric code, or the 4-character text identifier. So hopefully that makes it clear how you can use left and right to extract substrings from the left and right sides of a string. Now let's learn how you can extract something in between. Here's where we'll use something called mid. Mid is a function that gives you a segment from the middle of a text string. This cosmetics company lists all of its clients using a client code. It's composed of the first 3 letters of the city where the client's located, its state abbreviation, and then a 3-digit identifier. But let's say a data analyst needs to work with just the states in the middle. The syntax for mid is equals mid, open parentheses, the range, then a comma. When using mid, you always need to supply a reference point. In other words, you need to set where the function should start. After that, place another comma and how many middle characters you want. In this case, our range is D2. Let's start the function in a new column. Type equals mid, open parentheses, D2. Then the first 3 characters represent a city name. So that means the starting point is the 4th. Add a comma and 4.
we also need to tell the function how many middle characters we want. Add one more comma and 2, because the state abbreviations are 2 characters long. Press enter, and bam! We just get the state abbreviation. Continue the mid function through the rest of the column. So we've learned about a few functions that help separate out specific text strings. But what if we want to combine them instead? For that, we'll use concatenate, which is a function that joins together 2 or more text strings. The syntax is equals concatenate, then an open parentheses. Inside, indicate each text string you want to join, separated by commas. Then finish the function with the closed parentheses. So just for practice, let's say we needed to rejoin the left and right text strings back into complete product codes. In a new column, let's begin our function. Type equals concatenate, then an open parentheses. The first text string we want to join is in H2. Then add a comma. The second part is in I2. Add a closed parentheses and press enter. Drag it down through the entire column. And just like that, all of our product codes are back together. Okay, the last function we'll learn about here is trim. Trim is a function that removes leading, trailing, and repeated spaces in data. Sometimes, when you import data, your cells have extra spaces which can get in the way of your analysis. For example, if this cosmetics maker wanted to look up a specific client name, it won't show up in the search if it has extra spaces. You can use trim to fix that problem. The syntax for trim is equals trim, open parentheses, your range, and close parentheses. So in a separate column, type equals trim and an open parentheses. The range is C2, as you want to check out the client names. Close the parentheses and press enter. Finally, continue the function down the column. Trim fixed the extra spaces. So now we know some very useful functions that can make your data cleaning even more successful. This was a lot of information. So as always, feel free to go back and review the video and then practice on your own. We'll continue building on these tools soon. And you'll also have a chance to practice. Pretty soon, these data cleaning steps will become second nature, like brushing your teeth. Hi, let's get into it. Motivational speaker Wayne Dyer once said, "If you change the way you look at things, the things you look at change." This is so true in data analytics. No two analytics projects are ever exactly the same. So it only makes sense that different projects require us to focus on different information differently. In this video, we'll explore different methods that data analysts use to look at data differently, and how that leads to more efficient and effective data cleaning. Some of these methods include sorting and filtering, pivot tables, a function called VLOOKUP, and plotting to find outliers. Let's start with sorting and filtering. As you learned earlier, sorting and filtering data helps data analysts customize and organize the information the way they need for a particular project. But these tools are also very useful for data cleaning. You might remember that sorting involves arranging data into a meaningful order to make it easier to understand, analyze, and visualize. For data cleaning, you can use sorting to put things in alphabetical or numerical order so you can easily find a piece of data. Sorting can also bring duplicate entries closer together for faster identification. Filters, on the other hand, are very useful in data cleaning when you want to find a particular piece of information. You learned earlier that filtering means showing only the data that meets a specific criteria while hiding the rest. This lets you view only the information you need. When cleaning data, you might use a filter to only find values above a certain number, or just even or odd values. Again, this helps you find what you need quickly and separates out the information you want from the rest. That way, you can be more efficient when cleaning your data. Another way to change the way you view data is by using pivot tables. You've learned that a pivot table is a data summarization tool that is used in data processing. Pivot tables sort, reorganize, group, count, total, or average data stored in a database. In data cleaning, pivot tables are used to give you a quick, clutter-free view of your data. You can choose to look at the specific parts of a data set you need and get a visual in the form of a pivot table. Let's create one now, using our cosmetic makers spreadsheet again. To start, select the data we want to use. Here, we'll choose the entire spreadsheet. Select Data, then Pivot Table. Choose New Sheet and Create. Let's say we're working on a project that requires us to look at only the most profitable products, items that earn the cosmetics maker at least $10,000 in orders. So the row we'll include is total, for total profits. We'll sort in descending order to put the most profitable items at the top, and we'll show totals. Next, we'll add another row for products, so that we know what those numbers are about. We can clearly determine that the most profitable products have the product codes 15143EXFO and 32729MASC. We can ignore the rest for this particular project because they fall below 10,000 in orders. Now, we might be able to use context clues that assume we're talking about exfoliants and mascaras. But we don't know which ones or if that assumption is even correct. So we need to confirm what the product codes correspond to. And this brings us to the next tool. It's called VLOOKUP. VLOOKUP stands for vertical lookup. It's a function that searches for a certain value in a column to return a corresponding piece of information. When data analysts look up information for a project, it's rare for all of the data they need to be in the same place. Usually, you'll have to search across multiple sheets or even different databases. The syntax of VLOOKUP is equals VLOOKUP, open parentheses, then the data you want to look up. Next is a comma, and where you want to look for that data. In our example, this will be the name of a spreadsheet, followed by exclamation point. The exclamation point indicates that we're referencing a cell in a different sheet from the one we're currently working in. Again, that's very common in data analytics. Okay, next is the range in the place where you're looking for data, indicated using the first and last cell separated by a colon. After one more comma is the column in the range containing the value to return. Next, another comma and the word false, which means that an exact match is what we're looking for. Finally, complete your function by closing the parentheses. To put it simply, VLOOKUP searches for the value in the first argument in the leftmost column of the specified location. Then, the value of the third argument tells VLOOKUP to return the value in the same row from the specified column. The false tells VLOOKUP that we want an exact match. Soon, you'll learn the difference between exact and approximate matches, But for now, just know that VLOOKUP takes the value in one cell and searches for a match in another place. Let's begin. We'll type equals VLOOKUP, then add the data we want to look for, which is the product code. The dollar signs make sure that the corresponding part of the reference remains unchanged or locked. You can lock just the column, just the row, or both at the same time. Next, we'll tell it to look at sheet 2 in both columns. We added 2 to represent the second column. The last term, false, says we want an exact match. With this information, we can now analyze the data for only the most profitable products. Going back to the 2 most profitable products, we can search for 15143EXFO and 32729MASC. Go to Edit, and then Find. Type in the product codes, and search for them. Now we can learn which products we'll be using for this particular project. The final tool we'll talk about is something called plotting. When you plot data, you put it in a graph, chart, table, or other visual to help you quickly find what it looks like. Plotting is very useful when trying to identify any skewed data or outliers. For example, if we wanted to make sure the price of each product is correct, we could create a chart. This would give us a visual aid that helps us quickly figure out if anything looks like an error. So let's select the column with our prices. Then we'll go to Insert and choose Chart. Pick a column chart as the type. One of these prices looks extremely low. If we look into it, we discover that this item has a decimal point in the wrong place. It should be $7.30, not 73 cents. That would have a big impact on our total profits, so it's a good thing we caught that during data cleaning. Looking at data in new and creative ways helps data analysts identify all kinds of dirty data. Coming up, you'll continue practicing these new concepts so you can get more comfortable with them. You'll also learn additional strategies for ensuring your data is clean, and we'll provide you with effective insights. Great work so far! Hello! So far, you learned about a lot of different tools and functions that analysts use to clean up data for analysis. Now, we'll take a step back and talk about some of the really big picture aspects of clean data. Knowing how to fix specific problems, either manually with spreadsheet tools or with functions, is extremely valuable. But it's also important to think about how your data has moved between systems and how it's evolved along its journey to your data analysis project. To do this, data analysts use something called data mapping. Data mapping is the process of matching fields from one database to another. This is very important to the success of data migration, data integration, and lots of other data management activities. As you learned earlier, different systems store data in different ways. For example, the state field in one spreadsheet might show Maryland spelled out, but another spreadsheet might store it as MD. Data mapping helps us note these kinds of differences, so we know when data is moved and combined, it will be compatible. As a quick reminder, compatibility describes how well two or more datasets are able to work together. So the first step to data mapping is identifying what data needs to be moved. This includes the tables and the fields within them. We also need to define the desired format for the data once it reaches its destination. To figure out how this works, let's go back to the merger between our two logistics associations. Starting with the first data field, we'll identify that we need to move both sets of member IDs. And to define the desired format, we'll choose whether to use numbers, like this spreadsheet, or email addresses, like the other spreadsheet. Next comes mapping the data. Depending on the schema and number of primary and foreign keys in a data source, data mapping can be simple or very complex. As a reminder, a schema is a way of describing how something is organized. A primary key references a column in which each value is unique. And a foreign key is a field within a table that is a primary key in another table. For more challenging projects, there's all kinds of data mapping software programs you can use. These data mapping tools will analyze field by field how to move data from one place to another. Then they automatically clean, match, inspect, and validate the data. They also create consistent naming conventions, ensuring compatibility when the data is transferred from one source to another. When selecting a software program to map your data, you want to be sure that it supports the file types you're working with, such as Excel, SQL, Tableau, and others. Later on, you'll learn more about selecting the right tool for a particular task. For now, let's practice mapping data manually. First, we need to determine the content of each section to make sure the data ends up in the right place. For example, the data on when memberships expire would be consolidated into a single column. This step makes sure that each piece of information ends up in the most appropriate place in the merged data source. Now, you might remember that some of the data was inconsistent between the two organizations, like the fact that one uses a separate column for suite, apartment, or unit number, but the other doesn't. This brings us to the next step, transforming the data into a consistent format. This is a great time to use concatenate. As you learned before, concatenate is a function that joins together two or more text strings, which is what we did earlier with our cosmetics company example. So we'll insert a new column and then type equals concatenate. Then the two text strings we want to make one. Drag that through the entire column. And now we have the consistency in the new merged association lists of member addresses. Okay, now that everything's compatible, it's time to transfer the data to its destination. There's a lot of different ways to move data from one place to another, including querying, import wizards, and even simple drag and drop. All right, here's our merged spreadsheet. It looks good, but we still want to make sure everything was transferred properly. So we'll go into the testing phase of data mapping. For this, you inspect a sample piece of data to confirm that it's clean and properly formatted. It's also a smart practice to do spot checks on things such as the number of nulls. For the test, You can use a lot of the data cleaning tools we discussed previously, such as data validation, conditional formatting, count if, sorting, and filtering. Finally, once you've determined that the data is clean and compatible, you can start using it for analysis. Data mapping is so important because even one mistake when merging data can ripple throughout an organization, causing the same error to appear again and again. This leads to poor results. On the other hand, data mapping can save the day by giving you a clear roadmap you can follow to make sure your data arrives safely at its destination. And that's why you learn how to do it. Welcome back, and great job on that last weekly challenge. Now that we know the difference between clean and dirty data and some general data cleaning techniques, let's focus on data cleaning using SQL. Coming up, we'll learn about the different data cleaning functions in spreadsheets and SQL, and how SQL can be used to clean large datasets. I'll also show you how to develop some basic search queries for databases, and how to apply basic SQL functions for transforming data and cleaning strings. Cleaning your data is the last step in the data analysis process before you can move on to the actual analysis. And SQL has a lot of great tools that can help you do that. But before we start cleaning databases, we'll take a closer look at SQL and when to use it. I'll see you there. Advertising agencies get money from their clients to advertise their brand, right? And so these agencies use our products, use certain Google platforms, advertising platforms, and I help them with how to best use those platforms, different strategies they can use to be best in class. A lot of the folks at the advertising agencies have reports that they have to send out to their clients. And so these reports take a lot of time to create and visualize. And so what I do is I help the practitioners and the analytics teams use a particular product that enables them to create those reports much faster and much easier. If you're going to start off as a data analyst, it opens tons of doors because everybody is tracking data, is using data, needs to use data, regardless of industry. So anywhere from healthcare to advertising to e-commerce to entertainment, anything and everything, everybody uses data. So everybody needs you as a data analyst. SQL makes our lives easier when we're analyzing lots of different data. It's only somewhat recently that the SQL programs that we use now can give us instant results for analyzing millions or billions of data. Years ago, maybe about like 5 years ago or so, even though we can still analyze those millions of rows, we would end up having to wait 15 minutes, 30 minutes for the queries to run, but now it's instantaneous. And so that's really exciting, and we can do so much more with that power. So SQL has helped a lot in my career because it's one of those fundamental things you have to know as a data analyst. Back in the day, not everyone used SQL, so knowing SQL was definitely a competitive advantage. Nowadays, I would say more and more people, maybe most people know it. It's a core skill and highly sought after by everybody. So knowing SQL, becoming a data analyst makes you quite popular from recruiters. So I think that's really fun. I taught myself SQL. So my knowledge about SQL is something I hold near and dear, close to my heart, since it's something that almost I've made for myself. And I feel so much satisfaction from it. So that's why I really like SQL. One of the fun things about SQL, and another reason why I really enjoy using it, is because when you type something in, that query, and you just hit Control-Enter, or once you run the query, you get the results almost instantly, depending on the platform you use. But it's fascinating to see, if you think conceptually, how much analysis the computer is doing for you based on that little bit of command code or the little bit of code you wrote. And it's just so powerful if you think about what's happening behind the scenes. So I think that's kind of fun to look at. We live in a world of big data, and it keeps getting bigger. The computing power is also increasing exponentially. So with all the data that we can track, the more and more we can track that data, the more and more we need data analysts. And so our career prospects are basically skyrocketing. I'm Sally. I'm a measurement and analytical lead at Google. Hello again. So before we go over all the ways data analysts use SQL to clean data, I want to formally introduce you to SQL. We've talked about SQL a lot already. You've seen some databases and some basic functions in SQL. And you've even seen how SQL can be used to process data. But now let's actually define SQL. SQL is structured query language that analysts use to work with databases. Data analysts usually use SQL to deal with large data sets because it can handle huge amounts of data, and I mean trillions of rows. That's a lot of rows to wrap your head around. So let me give you an idea about how much data that really is. Imagine a data set that contains the name of all 8 billion people in the world. It would take the average person 101 years to read all 8 billion names. SQL can process this in seconds. Personally, I think that's pretty cool. Other tools like spreadsheets might take a really long time to process that much data, which is one of the main reasons data analysts choose to use SQL when dealing with big data sets. Let me give you a short history on SQL. Development on SQL actually began in the early 70s. In 1970, Edgar F. Codd developed a theory about relational databases. You might remember learning about relational databases a while back. This is a database that contains a series of tables that can be connected to form relationships. At the time, IBM was using a relational database management system called System R. Well, IBM computer scientists were trying to figure out a way to manipulate and retrieve data from IBM's System R. Their first query language was hard to use, so they quickly moved on to the next version, SQL. In 1979, after extensive testing, SQL, now just spelled SQL, was released publicly. By 1986, SQL had become the standard language for relational database communication, and it still is. This is another reason why data analysts choose SQL. It's a well-known standard within the community. The first time I used SQL to pull data from a real database was for my first job as a data analyst. I didn't have any background knowledge about SQL before that. I only found out about it because it was a requirement for that job. The recruiter for that position gave me a week to learn it. So I went online and researched it and ended up teaching myself SQL. They actually gave me a written test as part of the job application process. I had to write SQL queries and functions on a whiteboard. But I've been using SQL ever since, and I really like it. And just like I learned SQL on my own, I wanted to remind you that you can figure things out yourself too. There's tons of great online resources for learning, so don't let one job requirement stand in your way without doing some research first. Now that we know a little more about why analysts choose to work with SQL when they're handling a lot of data, and a little bit about the history of SQL, we'll move on and learn some practical applications for it. Coming up next, we'll check out some of the tools we learned in spreadsheets and figure out if any of those apply to working in SQL. Spoiler alert, they do. See you soon. Hey there! So far, we've learned about both spreadsheets and SQL. While there's lots of differences between spreadsheets and SQL, you'll find some similarities too. So let's check out what spreadsheets and SQL have in common and how they're different. Spreadsheets and SQL actually have a lot in common. Specifically, there's tools you can use in both spreadsheets and SQL to achieve similar results. We've already learned about some tools for cleaning data in spreadsheets, which means you already know some tools that you can use in SQL. For example, you can still perform arithmetic, use formulas, and join data when you're using SQL. So we'll build on the skills we've learned in spreadsheets and use them to do even more complex work in SQL. Here's an example of what I mean by more complex work. If we were working with health data for a hospital, we need to be able to access and process a lot of data. We might need demographic data like patients' names, birthdays, and addresses, information about their insurance or past visits, public health data, or even user-generated data to add to their patient records. All of this data is being stored in different places, maybe even in different formats. And each location might have millions of rows and hundreds of related tables. This is way too much data to input manually, even for just one hospital. That's where SQL comes in handy. Instead of having to look at each individual data source and record it in our spreadsheet, we can use SQL to pull all this information from different locations in our database. Now, let's say we want to find something specific in all this data, like how many patients with a certain diagnosis came in today. In a spreadsheet, we can use the COUNTIF function to find that out. Or we can combine the count and where queries in SQL to find out how many rows match our search criteria. This will give us similar results, but works with a much larger and more complex set of data. Next, let's talk about how spreadsheets in SQL are different. First, it's important to understand that spreadsheets and SQL are different things. Spreadsheets are generated with a program like Excel or Google Sheets. These programs are designed to execute certain built-in functions. SQL, on the other hand, is a language that can be used to interact with database programs like Oracle MySQL or Microsoft SQL Server. The differences between the two are mostly in how they're used. If a data analyst was given data in the form of a spreadsheet, they'll probably do their data cleaning and analysis within that spreadsheet. But if they're working with a large data set with more than 1 million rows or multiple files within a database, it's easier, faster, and more repeatable to use SQL. SQL can access and use a lot more data because it can pull information from different sources in the database automatically, unlike spreadsheets, which only have access to the data you input. This also means the data is stored in multiple places. A data analyst might use spreadsheets stored locally on their hard drive or their personal cloud when they're working alone. But if they're on a larger team with multiple analysts who need to access and use data stored across a database, SQL might be a more useful tool. Because of these differences, spreadsheets and SQL are used for different things. As you already know, spreadsheets are good for smaller data sets and when you're working independently. Plus, spreadsheets have built-in functionalities like spell check that can be really handy. SQL is great for working with larger data sets, even trillions of rows of data. And because SQL has been the standard language for communicating with databases for so long, it can be adapted and used for multiple database programs. SQL also records changes in queries, which makes it easy to track changes across your team if you're working collaboratively. Next, we'll learn more queries and functions in SQL that will give you some new tools to work with. You might even learn how to use spreadsheet tools in brand new ways. See you next time. Hey, welcome back. So far, we've learned that SQL has some of the same tools as spreadsheets, but on a much larger scale. In this video, we'll learn some of the most widely used SQL queries that you can start using for your own data cleaning and eventual analysis. Let's get started. We've talked about queries as requests you put into the database to ask it to do things for you. Queries are a big part of using SQL. It's structured query language after all. Queries can help you do a lot of things, but there's some common ones that data analysts use all the time. So let's start there. First, I'll show you how to use the select query. I've called this one out before, but now I'll add some new things for us to try out. Right now, the table viewer is blank because we haven't pulled anything from the database yet. For this example, the store we're working with is hosting a giveaway for customers in certain cities. We have a database containing customer information that we can use to narrow down which customers are eligible for the giveaway. So let's do that now. We can use select to specify exactly what data we want to interact with in a table. And if we combine select with from, we can pull data from any table in this database, as long as we know what the columns and rows are named. We might want to pull the data about customer names and cities from one of the tables. To do that, we can input select name, city from customer underscore data dot customer underscore address. To get this information from the customer underscore address table, which lives in the customer underscore data dataset. So select and from help specify what data we want to extract from the database and use. We can also insert new data into a database or update existing data. For example, maybe we have a new customer that we want to insert into this table. We can use the insert into query to put that information in. So let's start with where we're trying to insert this data, the customer underscore address table. We also want to specify which columns we're adding this data to by typing their names in the parentheses. That way, SQL can tell the database exactly where we're inputting new information. Then, we'll tell it what values we're putting in. Run the query, and just like that, it added it to our table for us. Now, let's say we just need to change the address of a customer. Well, we can tell the database to update it for us. To do that, we need to tell it we're trying to update the customer underscore address table. Then, we need to let it know what value we're trying to change. But we also need to tell it where we're making that change specifically, so that it doesn't change every address in the table. There. Now, this one customer's address has been updated. If we want to create a new table for this database, we can use the create table if not exists statement. Keep in mind, just running a SQL query doesn't actually create a table for the data we extract. It just stores it in our local memory. To save it, we'll need to download it as a spreadsheet or save the results into a new table. As a data analyst, there's a few situations where you might need to do just that. It really depends on what kind of data you're pulling and how often. If you're only using a total number of customers, you probably don't need a CSV file or new table in your database. If you're using the total number of customers per day to do something like track a weekend promotion in a store, you might download that data as a CSV file so you can visualize it in a spreadsheet. But if you're being asked to pull this trend on a regular basis, you can create a table that will automatically refresh with the query you've written. That way, you can directly download the results whenever you need them for a report. Another good thing to keep in mind, if you're creating lots of tables within a database, you'll want to use the drop table if exists statement to clean up after yourself. It's good housekeeping. You probably won't be deleting existing tables very often. After all, that's the company's data, and you don't want to delete important data from their database. But you can make sure you're cleaning up the tables you've personally made so that there aren't old or unused tables with redundant information cluttering the database. There. Now you've seen some of the most widely used SQL queries in action. There's definitely more query keywords for you to learn, and unique combinations that'll help you work within databases. But this is a great place to start. Coming up, we'll learn even more about queries in SQL and how to use them to clean our data. See you next time.
Hi, I'm Evan, and I'm a learning portfolio manager here at Google. I don't think I'm a computer science or a super engineering type, but I really like working with numbers. So naturally, I went into accounting. And about after 2 years of accounting, I said, wow, I really don't want to do all of this by hand. So I took my first information systems class where they taught me the language SQL or SQL, and it completely opened up my mind. Between a working knowledge of spreadsheets where you change one cell and the whole spreadsheet changes because of those amazing calculated fields, and SQL, where I can query billions of rows of data in a matter of seconds, I was completely sold on my love for data. And I've dedicated my life and my career to just communicating that passion and getting folks excited about the things that they can do with their data. Why is SQL such an amazing first language to pick up? Well, there's so many things that you can do with it. I will first caveat and say, I am not a computer science major. I don't know deep down Java and Python, and I was a little bit apprehensive of learning a computer language. It's kind of like a pseudo-programming language, but in reality, you can write your first SQL statement, as you're going to find out here, in just 5 minutes or less. SQL, honestly, it's one of those languages that's easy to learn and even more fun to master. I've been learning SQL for 15 years. I've been teaching it for 10. As you're going to see in some of these hands-on labs you'll be working through, it's very easy to return data from within a database or a data set. Just select whatever columns from whichever database that you're pulling from, and immediately you get the data back. Now, the really fun part is actually teasing apart and saying, I wonder if I change my query, add these more columns, filter this data set a different way, share it with my colleagues. It's meant to be an interactive querying language. And query means asking a question. So if I could challenge you one thing, it's that the syntax for picking up SQL, much like the rules of a chess game, are very, very easy to pick up. But the hard part is actually not the syntax writing, much like with any programming language, but the actual what question do you want to ask of your data. So what I would encourage you to do is be super curious about whatever data set that you're given. Spend a lot of time, even before you touch your keyboard, in thinking about what data set or what insights you can get from your data, and then start having fun. There's many different ways to write the same correct SQL statement. So try one out, share it with your friends, and then start returning that data back for insights. Good luck.
It's so great to have you back. Now that we know some basic SQL queries and spent some time working in a database, let's apply that knowledge to something else we've been talking about: preparing and cleaning data. You already know that cleaning and completing your data before you analyze it is an important step. So in this video, I'll show you some ways SQL can help you do just that, including how to remove duplicates as well as 4 functions to help you clean string variables. Earlier, we covered how to remove duplicates in spreadsheets using the Remove Duplicates tool. In SQL, we can do the same thing by including distinct in our select statement. For example, let's say the company we work for has a special promotion for customers in Ohio. We want to get the customer IDs of customers who live in Ohio, but some customer information has been entered multiple times. We can get these customer IDs by writing select customer underscore ID from customer underscore data dot customer underscore address. This query will give us duplicates if they exist in the table. If customer ID 9080 shows up 3 times in our table, our results will have 3 of that customer ID. But we don't want that. We want a list of all unique customer IDs. To do that, we add distinct to our select statement by writing select distinct customer underscore ID from customer underscore data dot customer underscore address. Now, the customer ID 9080 will show up only once in our results. You might remember we talked before about text strings as a group of characters within a cell, commonly composed of letters, numbers, or both. These text strings need to be cleaned sometimes. Maybe they've been entered differently in different places across your database, and now they don't match. In those cases, you'll need to clean them before you can analyze them. So here are some functions you can use in SQL to handle string variables. You might recognize some of these functions from when we talked about spreadsheets. Now it's time to see them work in a new way. Pull up the dataset we shared right before this video, and you can follow along step by step with me during the rest of this video. The first function I want to show you is length, which we've encountered before. If we already know the length our string variables are supposed to be, we can use length to double check that our string variables are consistent. For some databases, this query is written as len, but it does the same thing. Let's say we're working with the customer underscore address table from our earlier example. We can make sure that all country codes have the same length by using length on each of these strings. So to write our SQL query, let's first start with select and from. We know our data comes from the customer underscore address table within the customer underscore data dataset. So we add customer underscore data dot customer underscore address after the from clause. Then under select, we'll write length and then the column we want to check, country. To remind ourselves what this is, we can label this column in our results as letters underscore in underscore country. So we add as letters underscore in underscore country after length parentheses country. The result we get is a list of the number of letters in each country listed for each of our customers. It seems that almost all of them are 2s, which means the country field contains only 2 letters. But we notice one that has 3. That's not good. We want our data to be consistent. So let's check out which countries were incorrectly listed in our table. We can do that by putting the length parentheses country parentheses function that we created into the where clause, because we're telling SQL to filter the data to show only customers whose country contains more than 2 letters. So now we'll write select country from customer underscore data dot customer underscore address, where length parentheses country parentheses greater than 2. When we run this query, we now get the 2 countries where the number of letters is greater than the 2 we expect to find. The incorrectly listed countries show up as USA instead of US. If we created this table, then we could update our table so that this entry shows up as US instead of USA. But in this case, we didn't create this table, so we shouldn't update it. We still need to fix this problem so we can pull a list of all the customers in the US, including the 2 that have USA instead of US. The good news is that we can account for this error in our results by using the substring function in our SQL query. To write our SQL query, let's start by writing the basic structure. Select from where. We know our data is coming from the customer underscore address table from the customer underscore data dataset. So we type in customer underscore data dot customer underscore address after from. Next, we tell SQL what data we want it to give us. We want all the customers in the US by their IDs, so we type in customer underscore ID after select. Finally, we want SQL to filter out only American customers. So we use the substring function after the where clause. We're going to use the substring function to pull the first 2 letters of each country so that all of them are consistent and only contain 2 letters. To use the substring function, we first need to tell SQL the column where we found this error, country. Then we specify which letter to start with. We want SQL to pull the first 2 letters, so we're starting with the first letter. So we type in 1. Then we need to tell SQL how many letters including this first letter to pull. Since we want the first 2 letters, we need SQL to pull 2 total letters. So we type in 2. This will give us the first 2 letters of each country. We want US only, so we'll set this function to equals US. When we run this query, we get a list of all customer IDs of customers whose country is the US, including the customers that had USA instead of US. Going through our results, it seems like we have a couple duplicates where the customer ID is shown multiple times. Remember how we get rid of duplicates? We add distinct before customer underscore ID. So now when we run this query, we have our final list of customer IDs of the customers who live in the US. Finally, let's check out the trim function, which you've come across before. This is really useful if you find entries with extra spaces and need to eliminate those extra spaces for consistency. For example, let's check out the state column in our customer underscore address table. Just like we did for the country column, we want to make sure the state column has the consistent number of letters. So let's use the length function again to learn if we have any state that has more than 2 letters, which is what we would expect to find in our data table. We start writing our SQL query by typing the basic SQL structure of select from where. We're working with the customer underscore address table in the customer underscore data dataset, so we type in customer underscore data dot customer underscore address after from. Next, we tell SQL what we want it to pull. We want it to give us any state that has more than 2 letters. So we type in state after select. Finally, we want SQL to filter for states that have more than 2 letters. This condition is written in the where clause. So we type in length, parentheses, state, parentheses, and that it must be greater than 2, because we want the states that have more than 2 letters. We want to figure out what the incorrectly listed states look like, if we have any. When we run this query, we get one result. We have one state that has more than 2 letters. But hold on. How can this state that seems like it has 2 letters, O and H for Ohio, have more than 2 letters? We know that there are more than 2 characters because we use the length, parentheses, state, parentheses, greater than 2 statement in the where clause when filtering our results. So that means the extra characters that SQL is counting must then be a space. There must be a space after the H. This is where we would use the trim function. The trim function removes any spaces. So let's write a SQL query that accounts for this error. Let's say we want a list of all customer IDs of the customers who live in OH for Ohio. We start with the basic SQL structure. Select from where. We know the data comes from the customer underscore address table and the customer underscore data dataset. So we type in customer underscore data dot customer underscore address after from. Next, we tell SQL what data we want. We want SQL to give us the customer IDs of customers who live in Ohio. So we type in customer underscore ID after select. Since we know we have some duplicate customer entries, we'll go ahead and type in distinct before customer ID to remove any duplicate customer IDs from appearing in our results. Finally, we want SQL to give us the customer IDs of the customers who live in Ohio. We're asking SQL to filter the data, so this belongs in the where clause. Here's where we'll use the trim function. To use the trim function, we tell SQL the column we want to remove spaces from, which is state in our case. And we want only Ohio customers, so we type in equals OH. That's it. We have all customer IDs of the customers who live in Ohio, including that customer with the extra space after the H. Making sure that your string variables are complete and consistent will save you a lot of time later by avoiding errors or miscalculations. That's why we clean data in the first place. Hopefully, functions like length, substring, and trim will give you the tools you need to start working with string variables in your own datasets. Next up, we'll check out some other ways you can work with strings and more advanced cleaning functions. Then you'll be ready to start working in SQL on your own. See you soon. Hi there, and welcome back. So far, we've gone over some basic SQL queries and functions that can help you clean your data. We've also checked out some ways you can deal with string variables in SQL to make your job easier. Get ready to learn more functions for dealing with strings in SQL. Trust me, these functions will be really helpful in your work as a data analyst. In this video, we'll check out strings again and learn how to use the cast function to correctly format data. When you import data that doesn't already exist in your SQL tables, the data types from the new dataset might not have been imported correctly. This is where the cast function comes in handy. Basically, cast can be used to convert anything from one data type to another. Let's check out an example. Imagine we're working with Lauren's Furniture Store. The owner has been collecting transaction data for the past year. But she just discovered that they can't actually organize their data because it hadn't been formatted correctly. So we'll help her by converting her data to make it useful again. For example, let's say we want to sort all purchases by purchase_price in descending order. That means we want the most expensive purchase to show up first in our results. To write the SQL query, we start with the basic SQL structure. Select, from, where. We know the data is stored in the customer_purchase table in the customer_data dataset. So we write customer_data dot customer_purchase after from. Next, we tell SQL what data to give us in the select clause. We want to see the purchase_price data, so we type purchase_price after select. Next is the where clause. We are not filtering out any data since we want all purchase prices shown, so we can take out the where clause. Finally, to sort the purchase_price in descending order, we type order by purchase_price DESC at the end of our query. Let's run this query. We see that 89.85 shows up at the top with 799.99 below it. But we know that 799.99 is a bigger number than 89.85. The database doesn't recognize that these are numbers, so it didn't sort them that way. If we go back to the customer_purchase table and take a look at its schema, we can see what data type the database thinks purchase_price is. It says here, the database thinks purchase_price is a string, when in fact it is a float, which is a number that contains a decimal. That is why 89.85 shows up before 799.99. When we sort letters, we start from the first letter before moving on to the second letter. So if we want to sort the words apple and orange in descending order, we start with the first letters, A and O. Since O comes after A, orange will show up first, then apple. The database did the same with 89.85 and 799.99. It started with the first letter, which in this case was a 8 and 7, respectively. Since 8 is bigger than 7, the database sorted 89.85 first and then 799.99 because the database treated these as text strings. The database doesn't recognize these strings as floats because they haven't been typecast to match that data type yet. Typecasting means converting data from one type to another, which is what we'll do with the cast function. We use the cast function to replace purchase_price with a new purchase_price that the database recognizes as float instead of string. We start by replacing purchase_price with cast. Then we tell SQL the field we want to change, which is the purchase_price field. Next is the data type we want to change purchase_price to, which is the float data type. We also need to sort by this new field, so we change purchase_price after order by to cast parentheses purchase_price as float 64. This is how we use the cast function to allow SQL to recognize the purchase_price column as floats instead of text strings. Now we can sort our purchases by purchase_price. And just like that, Lauren's furniture store has data that can actually be used for analysis. As a data analyst, you'll be asked to locate and organize data a lot, which is why you want to make sure you convert between data types early on. Businesses like our furniture store are interested in timely sales data, and you need to be able to account for that in your analysis. The cast function can be used to change strings into other data types too, like date and time. As a data analyst, you may find yourself using data from various sources. Part of your job is to make sure the data from those sources is recognizable and usable in your database so that you won't run into any issues with your analysis. And now you know how to do that. The cast function is one great tool you can use when you're cleaning data. And coming up, we'll cover some other advanced functions that you can add to your toolbox. See you soon! Hey there! Great to see you again! So far, we've seen some SQL functions in action. In this video, we'll go over more uses for cast and then learn about concat and coalesce. Let's get started! So earlier, we talked about the cast function, which lets us typecast text strings into floats. I called out that the cast function can be used to change into other data types too. So let's check out another example of how you can use cast in your own data work. We've got the transaction data we were working with from our Lawrence Furniture Store example. But now we'll check out the purchase date field. The furniture store owner has asked us to look at purchases that occurred during their sales promotion period in December. Let's write a SQL query that will pull date and purchase underscore price for all purchases that occurred between December 1st, 2020 and December 31st, 2020. We start by writing the basic SQL structure. Select from where. We know the data comes from the customer underscore purchase table in the customer underscore data dataset. So we write customer underscore data dot customer underscore purchase after from. Next, we tell SQL what data to pull. Since we want date and purchase underscore price, we add them into the select statement. Finally, we want SQL to filter for purchases that occurred in December only. So we type date between 2020-12-01 and 2020-12-31 in the where clause. Let's run the query. 4 purchases occurred in December, but the date field looks odd. That's because the database recognizes the date field as date time, which consists of the date and time. Our SQL query still works correctly even if the date field is date time instead of date. But we can tell SQL to convert the date field into the date data type, so we see just the date and not the time. To do that, we use the cast function again. So we'll use the cast function to replace the date field in our select statement with the new date field that will show the date and not the time. We can do that by typing cast and adding the date as the field we want to change. Then we tell SQL the data type we want instead, which is the date data type. There. Now we can have cleaner results for purchases that occurred during the December sales period. Cast is a super useful function for cleaning and sorting data, which is why I wanted you to see it in action one more time. Next up, let's check out the concat function. Concat lets you add strings together to create new text strings that can be used as unique keys. Going back to our customer underscore purchase table, we see that the furniture store sells different colors of the same product. The owner wants to know if customers prefer certain colors, so the owner can manage store inventory accordingly. The problem is, the product underscore code is the same regardless of the product color. We need to find another way to separate products by color, so we can tell if customers prefer one color over the others. So we'll use concat to produce a unique key that'll help us tell the products apart by color and count them more easily. Let's write our SQL query by starting with the basic structure. Select from where. We know our data comes from the customer underscore purchase table in the customer underscore data dataset. So we type customer underscore data dot customer underscore purchase after from. Next, we tell SQL what data to pull. We use the concat function here to get that unique key of product and color. So we type concat. The first column we want, product underscore code, and the other column we want, product underscore color. Finally, let's say we want to look at couches. So we filter for couches by typing product equals couch in the where clause. Now we can count how many times each couch was purchased and figure out if customers preferred one color over the others. With concat, the furniture store can find out which color couches are the most popular and order more. I've got one last advanced function to show you, coalesce. Coalesce can be used to return non-null values in a list. Null values are missing values. If you have a field that's optional in your table, it'll have null in that field for rows that don't have appropriate values to put there. Let's open the customer underscore purchase table so I can show you what I mean. In the customer underscore purchase table, we can see a couple rows where product information is missing. That is why we see nulls there. But for the rows where product name is null, we see that there is product underscore code data that we can use instead. We'd prefer SQL to show us the product name, like bed or couch, because it's easier for us to read. But if the product name doesn't exist, we can tell SQL to give us the product underscore code instead. That is where the coalesce function comes into play. Let's say we wanted a list of all products that were sold. We want to use the product name column to understand what kind of product was sold. So we write our SQL query with the basic SQL structure, select from where. We know our data comes from customer underscore purchase table in the customer underscore data dataset. So we type customer underscore data dot customer underscore purchase after from. Next, we tell SQL the data we want. We want a list of product names, but if names aren't available, then give us the product code. Here is where we type coalesce. Then we tell SQL which column to check first, product, and which column to check second if the first column is null, product underscore code. We'll name this new field as product underscore info. Finally, we are not filtering out any data, so we can take out the where clause. This gives us product information for each purchase. Now we have a list of all products that were sold for the owner to review. Coalesce can save you time when you're making calculations too, by skipping any null values and keeping your math correct. Those were just some of the advanced functions you can use to clean your data and get it ready for the next step in the analysis process. You'll discover more as you continue working in SQL. But that's the end of this video and this module. Great work! We've covered a lot of ground. You learned the different data cleaning functions in spreadsheets and SQL, and the benefits of using SQL to deal with large data sets. We also added some SQL formulas and functions to your toolkit. And most importantly, we got to experience some of the ways that SQL can help you get data ready for your analysis. After this, you'll get to spend some time learning how to verify and report your cleaning results so that your data is squeaky clean and your stakeholders know it. But before that, you've got another weekly challenge to tackle. You've got this. Some of these concepts might seem challenging at first, but they'll become second nature to you as you progress in your career. It just takes time and practice. Speaking of practice, feel free to go back to any of these videos and rewatch or even try some of these commands on your own. Good luck, and I'll see you again when you're ready. Hi there, great to have you back. You've been learning a lot about the importance of clean data and explored some tools and strategies to help you throughout the cleaning process. In these videos, we'll be covering the next step in the process, verifying and reporting on the integrity of your clean data. Verification is a process to confirm that a data cleaning effort was well executed and the resulting data is accurate and reliable. It involves rechecking your clean dataset, doing some manual cleanups if needed, and taking a moment to sit back and really think about the original purpose of the project. That way, you can be confident that the data you collected is credible and appropriate for your purposes. Making sure your data is properly verified is so important because it allows you to double check that the work you did to clean up your data was thorough and accurate. For example, you might have referenced an incorrect cell phone number or accidentally keyed in a typo. Verification lets you catch mistakes before you begin analysis. Without it, any insights you gain from analysis can't be trusted for decision-making. You might even risk misrepresenting populations or damaging the outcome of a product that you're actually trying to improve. I remember working on a project where I thought the data I had was sparkling clean because I'd used all the right tools and processes. But when I went through the steps to verify the data's integrity, I discovered a semicolon that I had forgotten to remove. Sounds like a really tiny error, I know, but if I hadn't caught the semicolon during verification and removed it, it would have led to some big changes in my results. And that, of course, could have led to different business decisions. So there's an example of why verification is so crucial. But that's not all. The other big part of the verification process is reporting on your efforts. Open communication is a lifeline for any data analytics project. And reports are a super effective way to show your team that you're being 100% transparent about your data cleaning. Reporting is also a great opportunity to show stakeholders that you're accountable, build trust with your team, and make sure you're all on the same page about important project details. Coming up, you'll learn different strategies for reporting, like creating data cleaning reports, documenting your cleaning process, and using something called the changelog. A changelog is a file containing a chronologically ordered list of modifications made to a project. It's usually organized by version and includes the date, followed by a list of added, improved, and removed features. Changelogs are very useful for keeping track of how a dataset evolved over the course of a project. They're also another great way to communicate and report on data to others. Along the way, you'll also see some examples of how verification and reporting can help you avoid repeating mistakes and save you and your team time. Ready to get started? Let's go! In this video, we'll discuss how to begin the process of verifying your data cleaning efforts. Verification is a critical part of any analysis project. Without it, you have no way of knowing that your insights can be relied on for data-driven decision-making. Think of verification as a stamp of approval. To refresh your memory, verification is a process to confirm that a data cleaning effort was well executed and the resulting data is accurate and reliable. It also involves manually cleaning data to compare your expectations with what's actually present. The first step in the verification process is going back to your original unclean dataset and comparing it to what you have now. Review the dirty data and try to identify any common problems. For example, maybe you had a lot of nulls. In that case, you check your clean data to ensure no nulls are present. To do that, you could search through the data manually or use tools like conditional formatting or filters. Or maybe there was a common misspelling, like someone keying in the name of a product incorrectly over and over again. In that case, you'd run a find in your clean data to make sure no instances of the misspelled word occur. Another key part of verification involves taking a big picture view of your project. This is an opportunity to confirm you're actually focusing on the business problem that you need to solve and the overall project goals, and to make sure that your data is actually capable of solving that problem and achieving those goals. It's important to take the time to reset and focus on the big picture, because projects can sometimes evolve or transform over time without us even realizing it. Maybe an e-commerce company decides to survey 1,000 customers to get information that would be used to improve a product. But as responses begin coming in, the analysts notice a lot of comments about how unhappy customers are with the e-commerce website platform altogether. So the analysts start to focus on that. While the customer buying experience is of course important for any e-commerce business, it wasn't the original objective of the project. The analysts, in this case, need to take a moment to pause, refocus, and get back to solving the original problem. Taking a big picture view of your project involves doing 3 things. First, consider the business problem you're trying to solve with the data. If you've lost sight of the problem, you have no way of knowing what data belongs in your analysis. Taking a problem-first approach to analytics is essential at all stages of any project. You need to be certain that your data will actually make it possible to solve your business problem. Second, you need to consider the goal of the project. It's not enough just to know that your company wants to analyze customer feedback about a product. What you really need to know is that the goal of getting this feedback is to make improvements to that product. On top of that, you also need to know whether the data you've collected and cleaned will actually help your company achieve that goal. And third, you need to consider whether your data is capable of solving the problem and meeting the project objectives. That means thinking about where the data came from and testing your data collection and cleaning processes. Sometimes data analysts can be too familiar with their own data, which makes it easier to miss something or make assumptions. Asking a teammate to review your data from a fresh perspective and getting feedback from others is very valuable in this stage. This is also the time to notice if anything sticks out to you as suspicious or potentially problematic in your data. Again, step back, take a big picture view, and ask yourself, do the numbers make sense? Let's go back to our e-commerce company example. Imagine an analyst is reviewing the cleaned up data from the customer satisfaction survey. The survey was originally sent to 1,000 customers. But what if the analyst discovers there's more than 1,000 responses in the data? This could mean that the customer figured out a way to take the survey more than once. Or it could also mean that something went wrong in the data cleaning process and the field was duplicated. Either way, this is a signal that it's time to go back to the data cleaning process and correct the problem. Verifying your data ensures that the insights you gain from analysis can be trusted. It's an essential part of data cleaning that helps companies avoid big mistakes. This is another place where data analysts can save the day. Coming up, we'll go through the next steps in the data cleaning process. See you there. Hey there! In this video, we'll continue building on the verification process. As a quick reminder, the goal is to ensure that our data cleaning work was done properly and the results can be counted on. You want your data to be verified so you know it's 100% ready to go. It's sort of like car companies running tons of tests to make sure a car is safe before it hits the road. You learn that the first step in verification is returning to your original, uncleaned dataset and comparing it to what you have now. This is an opportunity to search for common problems. After that, you clean up the problems manually, for example, by eliminating extra spaces or removing an unwanted quotation mark. But there's also some great tools for fixing common errors automatically, such as trim and remove duplicates. Earlier, you learned that trim is a function that removes leading, trailing, and repeated spaces in data. And remove duplicates is a tool that automatically searches for and eliminates duplicate entries from a spreadsheet. Now, sometimes you have an error that shows up repeatedly, and it can't be resolved with a quick manual edit or a tool that fixes the problem automatically. In these cases, it's helpful to create a pivot table. A pivot table is a data summarization tool that is used in data processing. Pivot tables sort, reorganize, group, count, total, or average data stored in a database. We'll practice that now using the spreadsheet from a party supply store. Let's say this company was interested in learning which of its 4 suppliers is most cost-effective. So an analyst pulled this data on the products the business sells, how many were purchased, which supplier provides them, the cost of the products, and the ultimate revenue. The data's been cleaned, but during verification, we noticed that one of the suppliers' names was keyed in incorrectly. We could just correct the word as plus, But this might not solve the problem, because we don't know if this was a one-time occurrence or if the problem's repeated throughout the spreadsheet. There are two ways to answer that question. The first is using find and replace. Find and replace is a tool that looks for a specified search term in a spreadsheet and allows you to replace it with something else. So we'll choose Edit, then Find and Replace. We're trying to find PLOS, the misspelling of plus in the supplier's name. In some cases, you might not want to replace the data. You just want to find something. No problem. Just type the search term, leave the rest of the options as default, and click Done. But right now, we do want to replace it with PLUS. So we'll type that in here. Then click Replace All, and Done. There we go. Our misspelling has been corrected. That was, of course, the goal. But for now, let's undo our find and replace so we can practice another way to determine if errors are repeated throughout a dataset, like with the pivot table. We'll begin by selecting the data we want to use. Choose column C, select Data, then Pivot Table. Choose New Sheet, and Create. We know this company has 4 suppliers. So if we count the suppliers and the number doesn't equal 4, we know there's a problem. So first, add a row for suppliers. Next, we'll add a value for our suppliers. And summarize by count A. Count A counts the total number of values within a specified range. Here, we're counting the number of times a supplier's name appears in column C. Note that there's also a function called count, which only counts the numerical values within a specified range. If we used it here, the result would be 0, not what we have in mind. But in other spreadsheet applications, count would give us information we want for a current example. As you continue learning more about formulas and functions, you'll discover more interesting options. If you want to keep learning, search online for spreadsheet formulas and functions. There's a lot of great information out there. Okay, so our pivot table has counted the number of misspellings, and it clearly shows that the error occurs just once. Otherwise, our 4 suppliers are accurately accounted for in our data. Now we can correct the spelling, and we've verified that the rest of the supplier data is clean. This is also useful practice when querying a database. If you're working in SQL, you can address misspellings using a case statement. The case statement goes through 1 or more conditions and returns a value as soon as a condition is met. Let's discuss how this works in real life using our customer_name table. Check out how our customer Tony Magnolia shows up as Tony and Tinoy. Tony's name was misspelled. Let's say we want a list of our customer IDs and the customer's first names, so we can write personalized notes thanking each customer for their purchase. We don't want Tony's note to be addressed incorrectly to Tinoy. So here's where we can use the case statement. We'll start our query with the basic SQL structure. Select from where. We know the data comes from the customer_name table in the customer_data dataset, so we can add customer_data.customer_name after from. Next, we tell SQL what data to pull in the select clause. We want customer_ID and first_name. We can go ahead and add customer_ID after select. But for our customers' first names, we know that Tony was misspelled. So we'll correct that using case. We'll add case, and then when, and type first_name equal Tinoy. Next, we'll use the then command and type Tony, followed by the else command. Here we'll type first underscore name, followed by end as, and then we'll type cleaned underscore name. Finally, we are not filtering our data, so we can eliminate the where clause. As I mentioned, a case statement can cover multiple cases. If we wanted to search for a few more misspelled names, our statement would look similar to the original, with some additional names like this. And there you go. Now that you've learned how you can use spreadsheets and SQL to fix errors automatically, we'll explore how to keep track of our changes next. Hi again. Now that you've learned how to make your data squeaky clean, it's time to address all the dirt you've left behind. When you clean your data, all the incorrect or outdated information is gone, leaving you with the highest quality content. But all those changes you made to the data are valuable too. In this video, we'll discuss why keeping track of changes is important to every data project, and how to document all your cleaning changes to make sure everyone stays informed. This involves documentation, which is the process of tracking changes, additions, deletions, and errors involved in your data cleaning effort. You can think of it like a crime TV show. Crime evidence is found at the scene and passed on to the forensics team. They analyze every inch of the scene and document every step, so they can tell a story with the evidence. A lot of times, the forensic scientist is called to court to testify about that evidence, and they have a detailed report to refer to. The same thing applies to data cleaning. Data errors are the crime, data cleaning is gathering evidence, and documentation is detailing exactly what happened for peer review or court. Having a record of how a dataset evolved does three very important things. First, it lets us recover data cleaning errors. Instead of scratching our heads, trying to remember what we might have done 3 months ago, we have a cheat sheet to rely on if we come across the same errors again later. It's also a good idea to create a clean table rather than overwriting your existing table. This way, you still have the original data in case you need to redo the cleaning. Second, documentation gives you a way to inform other users of changes you've made. And if you ever go on vacation or get promoted, the analyst who takes over for you will have a reference sheet to check in with. Third, documentation helps you determine the quality of the data to be used in analysis. The first two benefits assume the errors aren't fixable. But if they are, a record gives the data engineer more information to refer to. It's also a great warning for ourselves that the dataset is full of errors and should be avoided in the future. If the errors were time-consuming to fix, it might be better to check out alternative datasets that we can use instead. Data analysts usually use a changelog to access this information. As a reminder, a changelog is a file containing a chronologically ordered list of modifications made to a project. You can use and view a changelog in spreadsheets and SQL to achieve similar results. Let's start with the spreadsheet. We can use Sheets version history, which provides a real-time tracker of all the changes and who made them, from individual cells to the entire worksheet. To find this feature, click the File tab, and then select Version History. In the right panel, choose an earlier version. We can find who edited the file and the changes they made in the color next to their name. To return to the current version, go to the top left and click Back. If you want to check out changes in a specific cell, we can right-click and select Show Edit History. That's it. Also, if you want others to be able to browse the Sheet's version history, you'll need to assign permission. Okay, now let's switch gears and talk about SQL. The way you create and view a changelog with SQL depends on the software program you're using. Some companies even have their own separate software that keeps track of changelogs and important SQL queries. This gets pretty advanced, but essentially all you have to do is specify exactly what you did and why when you commit a query to the repository as a new and improved query. This lets the company revert back to a previous version if something you've done crashes the system, which has happened to me before. Another option is to just add comments as you go while you're cleaning data in SQL. This will help you construct your changelog after the fact. For now, we'll check out BigQuery's query history, which tracks all the queries you've run. You can click on any of them to revert back to a previous version of your query, or to bring up an older version to find what you've changed. Here's what we've got. I'm in the Query History tab. Listed on the bottom right are all the queries I've run by date and time. You can click on this icon to the right of each individual query to bring it up to the query editor. Changelogs like these are a great way to keep yourself on track. It also lets your team get real-time updates when they want them. But there's another way to keep the communication flowing, and that's reporting. Stick around and you'll learn some easy ways to share your documentation, and maybe impress your stakeholders in the process. See you in the next video. Great, you're back. Let's set the stage. The crime is dirty data. We've gathered the evidence. It's been cleaned, verified, and cleaned again. Now it's time to present our evidence. We'll retrace the steps and present our case to our peers. As we discussed earlier, data cleaning, verifying, and reporting is a lot like a crime drama. Now it's our day in court. Just like a forensic scientist testifies on the stand about the evidence, data analysts are counted on to present their findings after a data cleaning effort. Earlier, we learned how to document and track every step of the data cleaning process, which means we have solid information to pull from. As a quick refresher, documentation is the process of tracking changes, additions, deletions, and errors involved in a data cleaning effort. Changelogs are a good example of this. Since it's saved chronologically, it provides a real-time account of every modification. Documenting will be a huge time saver for you as a future data analyst. It's basically a cheat sheet you can refer to if you're working with a similar dataset or need to address similar errors. While your team can view changelogs directly, stakeholders can't and have to rely on your report to know what you did. Let's check out how we might document our data cleaning process using an example we worked with earlier. In that example, we found that this association had 2 instances of the same membership for $500 in its database. We decided to fix this manually by deleting the duplicate info. There are plenty of ways we could go about documenting what we did. One common way is to just create a doc listing out the steps we took and the impact they had. For example, first on your list would be that you removed the duplicate instance. Which decreased the number of rows from 33 to 32. And lowered the membership total by $500. If we were working with SQL, we could include a comment in the statement describing the reason for a change, without affecting the execution of the statement. That's something a bit more advanced, which we'll talk about later. Regardless of how we capture and share our changelogs, we're setting ourselves up for success by being 100% transparent about our data cleaning. This keeps everyone on the same page and shows project stakeholders that we're accountable for effective processes. In other words, this helps build our credibility as witnesses who can be trusted to present all the evidence accurately during testimony. For dirty data, it's an open and shut case. Welcome back. By now, it's safe to say that verifying, documenting, and reporting are valuable steps in the data cleaning process. You have proof to give stakeholders that your data is accurate and reliable, and the effort to attain it was well executed and documented. The next step is getting feedback about the evidence and using it for good, which we'll cover in this video. Clean data is important to the task at hand, but the data cleaning process itself can reveal insights that are helpful to a business. The feedback we get when we report on our cleaning can transform data collection processes and ultimately business development. For example, one of the biggest challenges of working with data is dealing with errors. Some of the most common errors involve human mistakes, like mistyping or misspelling, flawed processes, like poor design of a survey form, and system issues, where older systems integrate data incorrectly. Whatever the reason, data cleaning can shine a light on the nature and severity of error-generating processes. With consistent documentation and reporting, we can uncover error patterns in data collection and entry procedures, and use the feedback we get to make sure common errors aren't repeated. Maybe we need to reprogram the way the data is collected, or change specific questions on a survey form. In more extreme cases, the feedback we get can even send us back to the drawing board to rethink expectations and possibly update quality control procedures. For example, sometimes it's useful to schedule a meeting with the data engineer or data owner to make sure the data is brought in properly and doesn't require constant cleaning. Once errors have been identified and addressed, stakeholders have data they can trust for decision-making. And by reducing errors and inefficiencies in data collection, the company just might discover big increases to its bottom line. Congratulations! You now have the foundation you need to successfully verify and report on your cleaning results. Stay tuned to keep building on your new skills. Hey there! Thanks for stopping by once again. So earlier we checked out some potential career paths that might open up for you once you complete the program. You might also have explored the advantages of networking and building an online presence. And I want to tell you, just by being here now, you've shown you're committed. You're taking a big step in your future career. Coming up, we'll spend some time building your resume. You might already have a resume that you've used or been saving, and that's great. There's a good chance you'll still be able to use it, even if you're planning to switch careers. Together, we'll find out what kinds of changes to your resume you might want to make. But before that, we'll figure out what the whole application process is like. Then we'll explore the best way to write or adjust your resume to make it as professional looking as possible and ready for your role as a data analyst. We'll also take a peek at some examples of other resumes. After that, we'll have you do a little self-analysis as we review the different types of data analyst jobs out there, so you can think about which ones might be best for you. While I'm definitely not a career counselor, we can still think of this as a kind of career counseling session. You'll get a better idea of how to build your resume while thinking about your bigger career picture at the same time. So let's get started. Hi again. Right now seems like the perfect time to take a step back from learning about data analytics, so you can get excited about what comes after you're done here. The road to finding a job can be challenging, but you're building up your skill set and learning what it takes to be a data analyst. In this video, we'll cover what you can expect from your job search, plus some tips to using your newfound skills and knowledge to make your search easier. I remember when I first started out, I reached out to as many people as I could to learn about their career paths, their companies, and their roles. I wanted to get a good idea of what to expect. And that's what we're doing now, giving you an idea of what to expect during your own job search. It's important to remember that everyone's search will be different. It might depend on where you live, what your interests are within the field, and personal preferences, like the type of work environment you feel comfortable in. This is all part of making this journey your own, as you hunt for a job that's perfect for you. The most common way to start is by checking out available jobs. There's a lot of job sites that are built specifically for people seeking employment. You can also go to company websites, where they usually post job listings too. These sites might even have an option to send you an alert when a role matching your search becomes available. Once you find a few that you like, do some research to learn more about the companies and the details about the specific positions you'll be applying for. Then you can update your resume or create a new one. You'll want it to be specific and reflect what each company is looking for, but you can definitely have a master resume that you tweak for each position. It can also help to create a spreadsheet with all of your experiences and accomplishments to help you decide what to include in your resume for each position. If you're using a professional networking site like LinkedIn, you might already have connections who can help you with your job search. Maybe you know someone who can write a referral for you, or knows of a job within their company that would suit you. And even if you don't have any luck with your connections, you can also reach out to employees of the companies you're interested in. They might be able to give you some insight on the best ways to highlight your skills and experience when applying. And it's okay if they don't write back. Keep trying. This is probably a good time to tell you of the most challenging part of a job search: hearing the word no. You'll probably hear it a lot, and that's 100% okay. It's part of everyone's experience, especially when switching career paths. People you reach out to might not be able to help you. Companies you would love to work for might not have any openings. Jobs you applied for might be filled by someone else, and that's all part of the process. The key is to stay focused. Don't get discouraged. And above all else, believe in yourself. Okay, speech over, but don't forget it or I'll be forced to give more speeches. So back to your search. If the company you're applying to is interested, your first point of contact might be a recruiter. A recruiter might also reach out to you based on their own research. They may find your professional profile online and think you're a good match for a position. Speaking of which, that's another reason to keep building and refreshing your online profile. Recruiters are there to make sure you're a legitimate candidate for the job posted in the description. So when you talk with the recruiter, whether on the phone, online, or in person, be professional and personable. It's natural to feel nervous here, so it can help to refer back to your resume to wow them with your knowledge of the data analytics industry. And remember, recruiters are also looking for someone, and they're hoping it'll be you. Here's another tip. Using technical terms like SQL and clean data will show recruiters that you know what you're doing. Recruiters probably won't go into too much detail about the ins and outs of the job, but they want to see that you know what you're talking about. They might also give you prep materials or other recommendations. Take advantage of these because recruiters want you to do well. Next up is usually the hiring manager. This is the most important step. The hiring manager's job is to evaluate whether you have the ability to do the work and whether you'd be a good fit for their team. Your job is to convince them that yes, you do, and yes, you would be. A good thing you can do here is use LinkedIn or other professional sites to research the hiring managers or even other analysts who have a similar role to the one you're applying for. The more information you have about the job, the better your chances of actually getting it. You should also use this opportunity to ask lots of questions to help you figure out if the company's a good fit for you. You can do this when you talk to recruiters too. Now, if the hiring manager sees you as a fit, it's very possible you'll have at least one more interview. The point of these interviews is to give your future stakeholders and teammates a chance to decide if you're the best candidate for the position. The next step is the best step. If all goes well, you'll get an official offer. Usually by phone first and maybe followed by an official letter. At this point, feel free to celebrate, call everyone, and celebrate some more. But even if it's your dream job, make sure it's a competitive offer before you sign. Remember, if they reach out to you with an offer, that means they want you as much as you want them. If you're interviewing at other places, you can leverage this to figure out if negotiating for a more competitive offer is possible. You should also research salaries, benefits, vacation time, and any other factors that are important to you for similar jobs. If you can show specific research like company X gives Y amount more for the same role, there's usually some room to negotiate your salary, vacation days, or something else. Keep in mind, you'll need to find a balance between what you want, what they want to give you, and what's fair. So know your own worth, but also understand that the company hiring you has already placed a certain value on your role. Okay, let's say that everything works out, and you're happy with the negotiated deal and excited to join your new team. Even then, hit pause and give yourself at least 2 weeks before you officially start. Why? Well, if you're already employed somewhere else during your job search, it's customary and polite to give at least a 2-week notice at your old job before starting at the new one. Plus, it's good to give yourself a break before starting your exciting new adventure. You've earned it. By now, you should have a pretty good idea of what to expect when you start your data analyst job search. Coming up, we'll talk more about building your resume. See you in the next video. Great, you're back. When you take a picture, you usually try to capture lots of different things in one image. Maybe you're taking a picture of the sunset and want to capture the clouds, the tree line, and the mountains. Basically, you want a snapshot of that entire moment. You can think of building your resume in the same way. You want your resume to be a snapshot of all that you've done both in school and professionally. In this video, we'll go through the process of building a resume, which you'll be able to add your own details to. Keep in mind this is a snapshot. So when managers and recruiters look at what you've included in your resume, they should be able to tell right away what you can offer their company. The key here is to be brief. Try to keep everything in one page and each description to just a few bullet points. 2 to 4 bullet points is enough, but remember to keep your bullet points concise. Sticking to one page will help you stay focused on the details that best reflect who you are or who you want to be professionally. One page might also be all that hiring managers and recruiters have time to look at. They're busy people, so you want to get their attention with your resume as quickly as possible. Now let's talk about actually building your resume. This is where templates come in. They're a great way to build a brand new resume or reformat one you already have. Programs like Microsoft Word or Google Docs, and even some job search websites, all have templates you can use. A template has placeholders for the information you'll need to enter and its own design elements to make your resume look inviting. You'll have a chance to explore this option a little later. For now, we'll go through the steps you can take to make your resume professional, easy to read, and error-free. If you already have a resume document, you can use these steps to tweak it. Now, there's more than one way to build a resume, but most have contact information at the top of the document. This includes your name, address, phone number, and email address. If you have multiple email addresses or phone numbers, use the ones that are most reliable and sound professional. It's also great if you can use your first and last name in your email address, like janedoe17@email.com. You should also make sure that your contact information matches the details that you've included on professional websites. And while most resumes have contact information in the same place, it's up to you on how you organize that info. A format that focuses more on skills and qualifications and less on work history is great for people who have gaps in their work history. It's also good for those who are just starting out their career or making a career change. And that might be you. If you do want to highlight your work history, feel free to include details of your work experience, starting with your most recent job. If you've had lots of jobs that are related to a new position you're applying for, this format makes sense. If you're editing a resume you already have, you can keep it in the same format and adjust the details. If you're starting a new one or building a resume for the first time, choose the format that makes the most sense for you. There's lots of resume resources online. You should browse through a bunch of different resumes to get an idea of the formats you think works best for you. Once you've decided on your format, you can start adding your details. Some resumes begin with the summary, but this is optional. A summary can be helpful if you have experience that is not traditional for a data analyst, or if you're making a career transition. If you decide to include a summary, keep it to 1 or 2 sentences that highlight your strengths and how you can help the company you're applying to. You'll also want to make sure your summary includes positive words about yourself, like dedicated and proactive. You can support those words with data like the number of years you've worked or the tools you're experienced in, like SQL and spreadsheets. A summary might start off with something like hardworking customer service representative with over 5 years of experience. And once you've completed this program and have your certificate, you'll be able to include that too, which could sound like this. Entry-level data analytics professional. Recently completed the Google Data Analytics Professional Certificate. Sounds pretty good, doesn't it? Another option is leaving a placeholder for your summary while you build the rest of your resume, and then writing it after you finish the other sections. This way, you can review the skills and experience you've mentioned and grab 2 or 3 of the highlights to use in your summary. It's also good to note that the summary might change a little as you apply for different jobs. If you're including a work experience section, there's lots of different types of experience you could add. Outside of jobs with other companies, you could also include volunteer positions you've had and any freelance or side work you've done. The key here is the way in which you describe these experiences. Try to describe the work you did in a way that relates to the position you're applying for. Most job descriptions have minimum qualifications or requirements listed. These are the experiences, skills, and education you'll need to be considered for the job. So it's important to clearly state them in your resume. If you're a good match, the next step is checking out preferred qualifications, which lots of job descriptions also include. These aren't required, but every additional qualification you match makes you a more competitive candidate for the role. Including any part of your skills and experience that matches a job description will help your resume rise above the competition. So if a job listing describes a job responsibility as effectively managing data resources, you'll want to have your own description that reflects that responsibility. For example, if you volunteered or worked at a local school or community center, you might say that you effectively manage resources for after-school activities. Later on, you'll learn more ways to make your work history work for you. It's helpful to describe your skills and qualifications in the same way. For example, if a listing talks about organization and partnering with others, try to think about relevant experiences you've had. Maybe you've helped organize the food drive or partnered with someone to start an online business. In your descriptions, you want to highlight the impact you've had in your role, as well as the impact the role had on you. If you helped a business get started or reach new heights, talk about that experience and how you played a part in it. Or if you worked at a store when it first opened, you can say that you helped launch the successful business by ensuring quality customer service. If you use data analytics in any of your jobs, you'll definitely want to include that as well. We'll cover how to add specific data analysis skills a little bit later. One way to do this is to follow a formula in your descriptions. Accomplished X as measured by Y by doing Z. Here's an example of how this might read on a resume. Selected as one of 275 participants nationwide for this 12-month professional development program for high-achieving talent based on leadership potential and academic success. And if you've gained new skills in one of your experiences, be sure to highlight them all and how they helped. This is probably as good a spot as any to bring up data analytics. Even if this program is the first time you really thought about data analytics, now that you're equipped with some knowledge, you'll want to use that to your benefit. So if you've ever managed money, maybe that means you helped a business analyze future earnings, or maybe you created a budget based on your analysis of previous spending. Even if it was for your own or a friend's small business, it's still data that you've analyzed. Now you can reflect on when and how and use it in your resume. After you've added work experience and skills, you should include a section for any education you've completed. And yes, this course absolutely counts. You can add this course as part of your education, and you can also refer to it in your summary and skills sections. Depending on the format of your resume, you might want to add a section for technical skills you've acquired, both in this course and elsewhere. Besides technical skills like SQL, you could also include language proficiencies in this section. Having some ability in a language other than English can only help your job search. So now you have an idea of how to make your resume look professional and appealing. As you move forward, you'll learn even more about how to make your resume shine. By the end, you'll have a resume you can be proud of. Next up, we'll talk about how to make your resume truly unique. See you soon! Great to see you again. Building a strong resume is a great way to find success in your job hunt. You've had the chance to start building your resume, and now we'll take the next step by showing you how to refine your resume for data analytics jobs. Let's get started. For data analysts, one of the most important things your resume should do is show that you're a clear communicator. Companies looking for analysts want to know that the people they hire can do the analysis, but also can explain it to any audience in a clear and direct way. Your first audience as a data analyst will most likely be hiring managers and recruiters. So being direct and coherent in your resume will go a long way with them as well. Let's start with the summary section. While you won't go into too much detail in this section about any of your work experiences, it's a good spot to point out if you're transitioning into a new career role. You might add something like transitioning from a career in the auto industry and seeking a full-time role in the field of data analytics. One strategy you can use in your summary and throughout your resume is PAR, or PAR statements. PAR stands for Problem, Action, Result. This is a great way to help you write clearly and concisely. So instead of saying something like, was responsible for writing 2 blogs a month, you'd say, earned little-known website over 2,000 new clicks through strategic blogging. The website being little-known is the problem. The strategic action is the strategic blogging, and the result is the 2,000 new clicks. Adding PAR statements to your job descriptions or skills section can help with the organization and consistency in your resume. They definitely helped me when I changed jobs. Speaking of the skills section, make sure you include any skills and qualifications you've acquired through this course and on your own. You don't need to be super technical, but talking about your experience with spreadsheets, SQL, Tableau, and R, which is a programming language that we'll get to later, will enhance your resume and your chances of getting a job. So if you're listing qualifications or skills, you might include a spot for programming languages and then list SQL and R, which are both a part of the Google Data Analytics certificate. You might even add in the top functions, packages, or formulas that you're comfortable with in each. It also makes sense to include skills you've acquired in spreadsheets like pivot tables. Pivot tables, SQL, R, and lots of other terms we covered here might get you noticed by hiring managers and recruiters. But you definitely want your resume to accurately represent your skills and abilities. So only add these skills after you've completed the certificate. Once you start applying the ideas we talked about here to your resume, you'll be well on your way to setting yourself apart from other candidates. And after you've completed your final course, you'll have the opportunity to complete a case study and link it on your resume. This will be a great opportunity to show recruiters and hiring managers the skills you've learned while earning your certificate. Before you know it, you'll have a pretty great resume that you can update quickly whenever you're searching for a data analyst job. Nothing wrong with that. Up next, we'll talk more about adding experience to your resume. Bye for now.
Hello, my name is Joseph. I'm a people analyst at Google. As a people analyst, my job is to work with executives and HR business partners to use data to make informed people decisions. Inclusion is very essential to the work that we do. As you know, sometimes you can tell a story with data and have your own bias in it. So for us in this field that is very sensitive, it requires that we have a diverse set of people who have different backgrounds to have this lens of data to it. So being a Black professional, I can better tell a story about people of color that is a lot more personal to me. Being an analyst, it requires me to take data and tell a story with it. On a personal standpoint, I'm very passionate about this space of increasing representation in the tech industry. For example, outside of work, I run a nonprofit called Sankofa Tech, and our whole goal is essentially to help develop the next generation of Black engineers who can essentially be in this field and represent our experience using data as a foundation and also technology as the powering moving factor going forward. And it's critical that we have more Black people in the technology sector. As you all know, the next 10, 20 years, AI and machine learning will be like just speaking English in this country or even the entire world. So the more we can have more Black people in this field, the more we can represent it in the products that are being built, and the more that our experiences are being influenced in every single product that these companies do build. So definitely critical that we have more Black engineers, we have more Black data scientists to do the analysis, and also just Black data analysts to help tell a story that's more inclusive of our experience as well. So it's definitely essential that we do have people from different backgrounds, color, creed, to really understand data and have the lens to it and tell the story and make it very personal to our audience.
Welcome back. Everyone out there has their own personal work history. We all started somewhere, whether part-time or full-time. What matters for your resume is how you present the work you've done. In this video, we'll hone in on work history and how you can translate yours effectively for your data analyst resume. If you don't have a specific section for work history in your resume, that's okay. You can use the same basic ideas to adjust your skills and qualifications section. The good news is that you already have a lot of the skills that recruiters and hiring agents look for when they hire data analysts. You've probably used lots of them in previous jobs. We call these transferable skills. Transferable skills are skills and qualities that can transfer from one job or industry to another. So think about all the positions you've held: associate, owner, team member, manager, and how they might be used as a data analyst. Let's start with the big one that we talked about before: communication. When job descriptions say they want strong communication skills for a data analyst, it usually means they want someone who can speak about what they do to people who aren't as technical or analytical. If someone who's not familiar with data analytics can understand what you're talking about when you try to explain it to them, your communication skills are usually good to go. You've probably had to communicate in other jobs you've had, whether with employees, customers or clients, team members, or managers. You might have had to give presentations too, whether formal or informal. In your work history section, you can highlight how your effective communication skills have helped you. You can also refer to specific presentations you've made and the outcomes of those presentations. And you can even include the audience for your presentations, especially if you presented to large groups or people in senior positions. After listing job details like the place and length of employment, you might add something like effectively implemented and communicated daily workflow to fellow team members, resulting in an increase in productivity. Here you change the details based on the work you did. Since you'll be working in the world of data, including any quantitative data would be ideal. For example, the increase in productivity might have been a 15% increase. As long as you have a way to back up your data, hopefully with more data, then you can put it in your resume. This example brings us to the next transferable skill. Data analysts are problem solvers. When problems arise in a database or lines of code, data analysts need to be able to find and troubleshoot the problem. If you have no prior experience working with data, you can still talk about your problem-solving skills. That last example we shared does a great job of showing an ability to problem solve. It's actually written as a PAR, or problem action result statement, which we talked about earlier. So the problem is that the daily workflow procedures were not in place. The action is that you put the procedures into effect and communicated them to your team. And the result is that productivity increased by 15%. This makes it clear that there was a problem and you solved it. We can also use the statement to point out teamwork as an important quality to bring to the data analyst world. While you might have plenty of work to do on your own, it'll always be for the benefit of the team. Team means not only the data team you're a part of, but the whole company as well. So that's a few skills you can add to your work experience and skills and qualifications sections. All of these are known as soft skills. Soft skills are non-technical traits and behaviors that relate to how you work. Being detail-oriented and demonstrating perseverance are two more examples of soft skills that anyone hiring a data analyst will look for. Companies want to know that you will do your analysis carefully and to completion, no matter what setbacks you might face along the way. If you worked at a retail job, you can talk about how your attention to detail helped you find discrepancy while handling a high volume of money. And you could add how you continue to practice customer service at a high level, despite a high turnover rate at the management level. These are just some examples to think about and apply to your work details. Take a moment and think back to your last job, or maybe it's your current job. What soft skills do you use to find success? Are you starting to understand how those are transferable to the world of data analytics? Using PAR statements and focusing on your transferable soft skills can really add to the power of your resume. So now you can keep powering on to the next step to continue learning about the data analytics field and your future job in it. See you in the next video.
Hi, I'm Kate. I'm a senior product analyst at Google. I have always been perhaps an annoyingly curious person. Even as a child, I remember I would take things apart just to see how they worked. I just love seeing how things work together. And I love asking new questions. I love having more information. I think that makes me a more well-rounded person and definitely a better analyst. Every step in my career, including the first step in the Army, I kind of always picked at what I could in terms of trying to self-teach on things like databases and things like data. One of my first forays into data was, I had been deployed, and when I came back, I worked with a personnel office, and we had to do things like track where everybody was and what their pay was and their rank, and if they were getting awards. And there wasn't a single system to work through in that. And so I used an Access database. It took me forever to learn what a foreign key was and what a primary key was. And I will be totally honest, I did really poorly. I ended up going back to Excel, but it was a really good learning experience. After my time in the Army, I didn't really have a sense of what I wanted to do. I had been doing personnel, but I really did still enjoy the technology piece. And I somehow spun my Army career into logistics and got a job doing logistics for what they call the Roundhouse. It's where they work on the locomotive engines. I did a lot of database maintenance. So when I left the railroad, I went to a welding company where I started out as a logistics person working on trucks and truck parts, but then I was able to transition into kind of a more database, data-focused role. After my time at the welding company, I was kind of ready to try something a lot more technical. I actually ended up working for a small consulting firm that was very boutique-y and did a lot of work with Tableau, where we started to work with companies and taught them how to do data visualization. I did Tableau training for a while. But really, I was there for over 6 years. And through my time there, I did database engineering. I did data engineering. I got to run a team of analysts. I got to teach people how to do consulting. There was a lot of growth for me in that 6-year time period. After that, I decided to come to Google. I get to work with stakeholders on translations throughout the Google world. So if anybody wants to translate something from one language to another, I get to work on the analytics of that. So that means that if you take 500 different languages or 40 different languages, what does it cost? How many words do we translate? What does that translation quality look like? If I look back on my career, I would have told myself 5-10 years ago to focus on something. Don't try to feel too overwhelmed. The important thing to be able to do is to be able to ask the right question and know how to answer it. I have confidence. Confidence is really important because people are coming to me for answers. That's my job, is to think really hard about the questions and give them answers that make them better and make the company better. The fact that I know that I can do this now that I've put that kind of time and effort into it, it's really, really rewarding.
Hello. So if you haven't done a search for a data analyst job yet, give it a try. One thing you might notice is how many variations of data analyst jobs there are. You'll find some that just say data analyst in the job title, and others that include more details like market research analyst and digital data analyst. This variety is a good thing. It means that as a data analyst, you'll have a pretty wide range of job opportunities available. So while you might not be the right fit for every position that's posted, every position that's posted might not be the right fit for you. As you continue moving forward, it's important to keep your own interests in mind. There might be certain topics that we've covered or will cover that you find yourself especially interested in. When you're job hunting, you might want to tailor your search to find jobs that are focused on or include your areas of interest. For example, if a job description lists data cleaning as a job responsibility, and you think that you'd really enjoy that process, you could make that job your top priority. At the same time, think about your other interests. If you have a background in retail or medicine or finance, and have had a good experience with it, you might apply for jobs that match your background. As an added bonus, your experience will look great on your resume. But it's also okay to search for jobs in an area of personal interest where you have no professional experience. If you've always loved cars, check out what positions the auto industry has. If you're fascinated by how utility companies work, hunt for jobs in the energy and utilities industry. Finding a job is great. Finding a job you love is even better. Always keep in mind that data analytics is constantly evolving within lots of different industries. So job titles and hiring needs might also change. But the opportunities, no matter what they are when you're searching, will be there. So now let's preview some of the many kinds of data analyst jobs that are out there. The certificate you earn here will be most applicable to junior or associate data analyst positions. But that doesn't mean you have to limit your job search to only postings for junior or associate analysts. Job titles come in all shapes and sizes. New analysts work in a wide range of industries. Healthcare analysts gather and interpret data from sources like electronic health records and patient surveys. Their work helps organizations improve the quality of their care. Healthcare analysts might also look for ways to lower the cost of care and improve patient experience. Data analysts in marketing complete quantitative and qualitative market analysis. They identify important statistics and interpret and present their findings to help stakeholders understand the data behind their marketing strategies. Business intelligence analysts help companies use data they've collected to increase their efficiency and maximize their profits. These analysts usually work with large amounts of data to identify trends and generate business insights. Financial analysts also work with lots of data. Really, all analysts do. But financial analysts use the data to identify and potentially recommend business and investment opportunities. If you're a junior analyst in this field, you'll probably start off doing a lot of data gathering and financial modeling as well as spreadsheet maintenance. This is just a small taste of the types of data analyst jobs out there. Each type we've covered can branch out into other industries as well. For example, business intelligence analysts can work in healthcare, government, e-commerce, and more. It's exciting to think about the possibilities. There's more work for you to do, of course, but there's nothing wrong with looking ahead. And when you get to that place you're looking ahead to, you'll be able to take charge and find the best job for you. For the time being, we'll keep exploring your resume. See you soon. Great job on finishing this course. You've covered a lot of ground already and learned so much. There's only one thing left to do. Keep going. But if you ever need to check back on what you've learned, these videos will still be available to you. Right now, I'm excited for you to meet your instructor for the next course, Ayana. She's ready to guide you through the next part of the program as you continue your journey to becoming a data analyst. You've learned how to prepare and process data, and in the next course, Ayana will show you how to analyze it. We'll explore how to make sense of all the data you've collected and cleaned, and you'll learn how to ask the right questions and use data to find answers. We'll also show you how to organize and format the data once again, so it's completely ready for analysis. We'll talk about aggregation and joins, two processes that allow you to gather all the data you need and summarize it for your stakeholders. Both spreadsheets and SQL will make an appearance too. We'll give you some more practice with using them for calculations, and we'll explain how temporary tables in SQL work. Awesome job so far, and best of luck on what's next.
Hey there, future data analysts. You've made a lot of progress so far. It's not an easy journey, but you're doing great. Before you started this program, something inside of you convinced you to get your Google Data Analytics certificate. You had an idea, did some research, and made the time to get started. Then you made the decision to commit to your goal. Now look where you are. That is something to be proud of. Early on, we jumped right into the world of data analytics and saw how data played a part in your everyday life. You learned how to navigate spreadsheets and why structured thinking was key to solving problems. You also explored the best way to collect and store your data, and from there, you gained an understanding of clean data and data integrity. You've identified how to ask the right questions and learned to clean data. Now we'll take your skills to the next level. Next up, you'll learn how to come up with clear and objective answers to any data question you encounter. Earlier, we learned about the data analysis process. As a quick reminder, the phases of that process are ask, prepare, process, analyze, share, and act. We'll explore the analyze phase more here, focusing on how to organize and format the data you have so that you can do all sorts of calculations. Knowing how to analyze the data you've collected and cleaned is essential to your work as an analyst. Before we get started, I'd like to introduce myself. My name is Ayana, and I'm excited to be your instructor for this course. I'm a Global Insights Manager at Google, and I've also taught at the Google Analytics Academy, which is a training resource for Google Analysts. In my job, I help advertisers determine the value of investing in Google products. When you search for something online, you'll often see an ad on the page. That's an investment an advertiser has made. I use data analysis to show advertisers the value they could gain from investing in those ads. That's what I love about being a data analyst, figuring out how to create value anytime I enter a situation. And the best way to know if you're creating value is if you have evidence. For me, that evidence is data. So now that you know a little bit about my love for data, let's talk about what you'll learn here. You'll start by covering best practices for organizing your data and the different ways you can sort through that data using spreadsheets and SQL. We'll also spend time learning 3 important ways to work with data that'll boost your analytical skills. Then we'll talk about saving time. You'll discover tips and tricks that can help you analyze data more efficiently. Last but not least, we'll work together to identify techniques to help you be as fair and unbiased as possible. Well, that's all you need to know for now. Coming up, we'll break down the basics of data analysis and bring you one step closer to a future in data. Welcome back. It's great to see you again. So let's talk about analysis. We've learned how to ask the right questions, prepare data for exploration, and then process that data to make sure it's squeaky clean. Now it's time for the heart of the process, the actual analysis. Finally, right? But what is analysis? Basically, analysis is the process used to make sense of the data collected. It means taking the right steps to perceive and think about your data in different ways. The goal of analysis is to identify trends and relationships within the data so that you can accurately answer the question you're asking. To do this, you should stick to the 4 phases of analysis: organize data, format and adjust data, get input from others, and transform data by observing relationships between data points and making calculations. Okay, let's apply the 4 phases of analysis to a real-world scenario. Imagine you want to buy a gift for your friend Zara's wedding. The problem is you're not sure what to get her. Fortunately, you have a ton of data from her wedding website. But instead of reading all the data on her website and scrolling through a photo album of her and her partner, you go straight to the online registry, a wish list of gifts they'd enjoy. The registry is like a data set that you can analyze to make a decision. Now that you're checking out organized data in the registry, you want to make sure that the list of data, or gifts in this case, is formatted in a way that's easy to reference. Formatting data streamlines things and saves you time. Scrolling through hundreds of gifts can be time-consuming, so instead, you can adjust the data in a way that makes it easy to digest by filtering and sorting your data. You have a budget you want to stick to, so you sort the gift prices from low to high. You then filter prices to include gifts that are within your budget of $60. So you're working with a newly formatted list of data. At this point, it's good to remember that input from other people can also be really helpful when analyzing information and making decisions. You can check the list of gifts to figure out if anyone else has already bought any of the items. You realize a few of the items in the list have been purchased, and this informs your decision. When analyzing data, gaining input from others is important because it gives you a viewpoint you might not understand or have access to. On top of gaining input from other people, it's also important to seek out others' perspectives early. That way, if they predict any obstacles or challenges, you'll know beforehand. The people you look to for input don't have to be experts to be helpful. Sometimes all you need is for someone who's familiar with the topic or data you're considering. In our example, that would be Zara's wedding guests who are purchasing gifts from the same online registry. They probably aren't wedding gift experts, but their collaborative effort to mark off the item they purchased can help you figure out what not to buy, which will prevent Zara from getting the same gift twice. So in the end, getting input is valuable to your analysis. This brings up the last step of the analysis, transforming data. Transforming data means identifying relationships and patterns between the data and making calculations based on the data you have. Going back to our example, you were able to find a gift that you knew Zara would like and one that fits your budget. You were also able to choose a gift that wasn't already purchased by someone else. By finding the relationship between these data points, you chose, purchased, and sent a gift that would answer the problem you wanted to solve. The beauty of the analysis process is that you probably already analyze situations in your everyday life. Whether you're analyzing data in your personal life or in your career, these 4 tasks can help you make better decisions. And the more you do it, the more comfortable you'll feel with the process. I hope this gives you a better understanding of the basics of analysis. As we move forward, we'll check out how to locate data for analysis, both in a spreadsheet and using SQL. When you're ready, you can go ahead. See you soon. I think one of the coolest things about working with data at Google is that we have one of the world's most valuable data sets. People refer to Google data as really a lens into human curiosity. We often look at Google as really a proxy for what's happening in the world. And so for many of our advertisers, they really value the data and the insights that we're able to give them from Google because they believe it's a proxy or a reflection of what's happening in their business or within their industry. And so I think the value of the data that we're able to work with at Google really keeps me interested and excited about the work that I do. So I came to Google about 3 years ago after spending a few years in consulting. And so I was really interested in switching into a role that was really focused on sales and marketing, but at the same time, I still wanted to be able to leverage the analytical skill set that I had gained prior. This role was a great complement to the skill sets that I already had and the interest that I had in moving into the sales and marketing function. I think one important thing for all students to realize is that no one learns this material overnight. Many of your colleagues you may look at as experts, but most likely they've been able to gain that level of expertise through their years within the field. I think one of the biggest attributes that students should keep in mind is that the most important thing that they need to have throughout this learning journey is grit. Grit to understand that it may be a struggle, it may be a challenge, but if you put in the work and you put in the time, these concepts will eventually click, and you'll be well on your way to becoming a data analyst. Hi, my name is Ayana, and I'm a Global Insights Manager here at Google. Hi again. Let's jump back in. Right now, we're in the analyze phase of the data analysis process. And even though each phase is unique, data analysts make decisions about organization throughout all of them. That's what we're talking about here, organization. It's super important that you keep your data organized throughout your analysis. How your data is classified and structured will impact your findings, whether you're working in a spreadsheet or a database. And once you know how your data is organized, you'll be able to capture or collect the information you need. Most of the data you'll use in your analysis will be organized in tables. Tables help you organize similar kinds of data into categories and subject areas that you can focus on as you analyze. For example, this basic database has tables for car dealerships, product details, and repair parts. Each table then has several fields of data like branch owner and the cost of repair parts. You can use these tables and fields to help you decide how to move forward with your analysis. The structure of this database can help you decide which data you need to pull to meet your objectives. For example, the total number of a particular brand of car sold, or a repair part for a specific make and model of a car at a certain branch. Tables allow you to make decisions about data types. They help you to figure out what variables you need and the data type those variables should have. So if you have a database where you need to convert a data type during your analysis, you can do that by using the cast command in SQL or any other method that you learn on the job or from your own research. Like this example, where we converted a purchase price column to be a float instead of a string so that it was in a numerical form we could use for calculations. If you're performing your analysis in a spreadsheet, you want to make sure that the columns and rows are effectively organized. You can even hide columns that you won't need for your analysis or that show duplicate information. Once you have the data organized and formatted, you'll be ready to sort and filter it to find the data you need. We'll cover sorting and filtering soon, but for now, just know that both filters and sorts are affected by the type of data we're working with. The bottom line is that it's important to have your data in the right format, so always be prepared to adjust no matter how far into your analysis you are. That's all for now. Coming up, we'll show you what filters are all about. Bye! Hey, great to see you again. Earlier we talked about why you should organize your data no matter what part of the life cycle it's in. Just like any collection, it's easier to manage and care for a group of things when there's structure around them. Now we should keep in mind that organization isn't just about making things look orderly. It's also about making it easier to search and locate the data you need in a quick and easy way. As a data analyst, you'll find yourself rearranging and sifting through databases pretty often. Two of the most common ways of doing this are with sorting and filtering. We briefly discussed sorting and filtering before, and it's important you know exactly what each one does. Sorting is when you arrange data into a meaningful order to make it easier to understand, analyze, and visualize. Sorting ranks your data based on a specific metric that you can choose. You can sort data in spreadsheets and databases that use SQL. We'll get to all the cool functions you can use in both a little later on. A common way to sort items when you're shopping on a website is from lowest to highest price, but you can also sort by alphabetical order, like books in a library. Or you can sort from newest to oldest, like the order of text messages in a phone. Or nearest to furthest away, like when you're searching for restaurants online. Another way to organize information is with a filter. Filtering is showing only the data that meets a specific criteria while hiding the rest. Typically, you can use filters when you want to narrow down the amount of data you want to sift through. Say you're searching for green sneakers online. To save time, you filter for green shoes only. Using a filter slims down larger data sets to smaller subsets that are relevant to what you need. Sorting and filtering are two actions you probably perform a lot online. Whether you're sorting movie showtimes from earliest to latest or filtering your search results to just images, you're probably already familiar with how helpful they can be for making sense of data. Now let's take that knowledge and apply it. When it comes to sifting through large, disorganized piles of data, filters are your friend. You might remember from a previous video that you can use filters in spreadsheet programs like Excel and Sheets to only display data from rows that match the range or condition you set. You can also filter data into SQL using the where clause. The where clause works similarly to filtering in a spreadsheet because it returns rows based on a condition you name. Let's learn how you can use a where clause in a database. We'll use BigQuery to access the database and run our query. If you're joining us, open up your tool of choice for using SQL and reference the earlier resource on how to access the dataset. Otherwise, watch as the where clause does its thing. Here's the database. You might recognize it from past videos. Basically, it's a long list of movies. Each row includes an entry for the columns named: movie title, release date, genre, director, cast members, budget, and total revenue. It also includes a link to the film's Wikipedia page. If you scroll down the list goes on for a long time. Of course, we won't need to go through everything to find the data we want. That's the beauty of a filter. In this case, we'll use the where clause to filter the database and narrow down the list to movies in the comedy genre. To start, we'll use the select command followed by an asterisk. In SQL, an asterisk selects all of the data. On a new line, we'll type from and the name of the database, movie_data.movies. To filter the movies by comedy, we're going to type where, then list the condition, which is genre. Genre is a column in the dataset, and we only want to select rows where the cell in the genre column exactly matches comedy. Next, we'll type the equal sign and write the specific genre we're filtering for, which is comedy. Since the data in the genre column is a string format, we have to use single or double quotations when writing it. And keep in mind that capitalization matters here, so we have to make sure that the letter casing matches the column name exactly. And now we can click Run to check out the results. What we're left with is a shorter list of comedy movies. Pretty cool, right? Here's something else that you should know. You can apply multiple filters to a database. You can even sort and filter data at the same time for even more precise results. As a data analyst, knowing how to sort and filter data will make you a superstar. That's all for now. Coming up, we'll get down to the nitty-gritty of sorting functions and spreadsheets. See you there. Hey there, Data Pro. Happy to see you back and ready to explore more of the organizational side of data analysis. In this video, we'll learn how to sort data in spreadsheets. We've done some sorting in spreadsheets earlier in the program. Now it's time to build on what we've covered and introduce some more advanced sorting techniques. Sorting is amazing. Not only does it add order and meaning to your spreadsheets, it also gives you the power to reimagine data altogether. When you sort data based on a specific metric, you can uncover new patterns and relationships within data sets you might not have otherwise noticed. This is especially true for spreadsheets, which you'll use a lot in your work as a data analyst. Knowing how to sort data in spreadsheets can make you a stronger and more confident analyst. In many ways, sorting relies on your creativity to reimagine the information you have in front of you. In spreadsheets, you can sort data by ascending or descending order using numbers or letters. If cells are labeled with color, you can sort them by color too. When sorting data in a spreadsheet, you can choose to sort sheet or sort range. If sort sheet is applied, all of the data in a spreadsheet is sorted by the conditions of a single column, but the related information across each row stays together. On the other hand, sort range doesn't keep the information across rows together. When you sort a range, you're selecting a specific collection of cells or the range that you want the sorting limited to. Nothing else on the spreadsheet gets rearranged but the specified cells. There's two methods for sorting spreadsheet data. One involves using the menu, the other involves writing out the sort function. For now, we'll focus on sorting with the menu. We'll get to writing out functions later on. Now, depending on the program you use, the process might seem slightly different, but the instructions and concepts we discuss will be basically the same. Okay, back to sorting with the data menu. To give you an idea of how to do it, we'll use the movie spreadsheet. Let's check it out. In this example, we'll sort movies by release date. So we'll head to column B, which is listed as release date, and click on the B button to highlight all the cells in the column. From there, we'll head to the Data tab in the menu. Now you have two choices, sort a sheet or a range of data. You'll notice that we've selected just the release dates, but these release dates are specifically related to the movies in their row. In this case, you want the release date and the movie title to stay in the same row as you sort because they're related. To do this, you'll want to sort sheet. This will keep all the data together by row, no matter how you sort it. Depending on the order you want the release dates to be in, you can sort from A to Z, which also ranks the dates numerically, Or you can sort from Z to A, which will sort data the opposite way. Since we want the release dates to be in order, we'll click Sort Sheet by column B from A to Z. And there you go. You just sorted a sheet of data using the menu. Now the movies are arranged in chronological order based on release date. Okay, let's say you want to sort data in a specific column, but don't need the cells in that column tied to a specific row of information. Instead, you want to isolate the column's data and sort it on its own without affecting how the rest of the sheet's arranged. For fun, we'll use the movie title column in this example. First, we'll select the column we want to sort, column A. Clicking on column A highlights all the cells in the column which contain the movie titles. Then we'll go to the menu and click Data. Because we're isolating the column from the rest of the sheet when we sort this time, we'll click Sort Range by column A. For this example, we'll sort the movie titles alphabetically from A to Z. And that's it. You'll notice that Sort Range doesn't keep the rows together, so the data's a bit jumbled. You'll probably end up using Sort Sheet more often, but it's important to understand them both so you don't accidentally get them mixed up. You've just sorted data in a spreadsheet using the menu, and you've learned how to sort data by an entire sheet or by a range of cells. That's something you'll be able to take with you wherever you go as a data analyst. Coming up, we'll learn about the second way to sort in a spreadsheet, by writing out a function. We'll also take sorting to the next level by custom sorting your data. See you there. Happy to have you back. Earlier in the program, we covered some basics of sorting in spreadsheets. We learned the differences between sorting a range and an entire sheet and how to sort a spreadsheet using the menu. Now that we've laid the groundwork, it's time to move on to more advanced ways to sort information. We've talked about how there's two methods of sorting data in spreadsheets. The first method uses the Data tab in the menu of your spreadsheet program. The second way to sort information in a spreadsheet is by writing a sort function. In spreadsheets, functions are preset commands that perform a specific process. So in this case, the sort function, as you might be able to guess, sorts your data. Let's check out this spreadsheet of party plans to witness the sort function in action. It's good to keep in mind that when you use the sort function, you're actually changing the existing data set, unlike when you use the Data tab in the menu, which rearranges the data in the original data set. The first arranged set of data is our original data set of guests and some information about them. So let's say you want to sort the party guests by table to get an idea of who will be sitting where. To do that, start by typing a function in an empty cell. Just like any function, you do this by typing the equal sign and then write sort after it. After your first open parentheses, reference the first cell in which data is collected from. In this case, that's A2. Then you'll include a colon and write the last cell you want included in the function, which is D6. A2 colon D6 is the range for this function. Next, write a comma to separate the range from what we're sorting by, which is column B. You should keep in mind that this part of the function doesn't recognize column letters. So in this case, we use the corresponding number instead, which is 2, since column B is the second column in our range. Now add another comma. In this next part, you'll need to decide whether you want the data in this column to be in ascending or descending order. A true statement is in ascending order, and false is descending. Because we want the tables to be listed starting from table number 1, we'll write true for ascending order and then end the function with a closed parentheses. Now let's see our function play out. Our party guests are now sorted by which table they're seated. Once you have an idea of the data you want to be sorted and how, applying functions to your data is simple. Now you have two different tools in your tool belt for sorting data. After you've tackled writing sort functions, you'll want to customize sort orders too. A customized sort order is when you sort data in a spreadsheet using multiple conditions. This means that sorting will be based on the order of the conditions you select. Let's go back to our party spreadsheet. Imagine you want the guests to be sorted by whether or not they've been sent an invitation. And based on that, we want those guest names to be listed alphabetically. You can do that easily with the sort range option under data. First, highlight all the data in the set from cells A1 to D6. Then under the Data tab in the menu, click Sort Range. In this case, check Data has a header row, which makes sure that the title of the column isn't mixed into the sorting. Then we'll make sure it's being sorted by sent invitation. Here we want the no responses first and the yes responses second. So we'll make sure A to Z is clicked to sort the responses in that order. Because we want to add an additional sorting condition, we'll now click on Add Another Sort column. The guest names should be in alphabetical order. So let's select guest names and sort from A to Z. Then we'll click Sort. And voila! You've officially applied a custom sort order like a champ. Okay, so you've tackled sorting in spreadsheets by sheet, by range, through the menu, and by using a function. On top of all that, you've added to your organizational skills by learning how to create custom sort orders. Pretty soon, you'll learn another powerful tool, how to sort data using SQL. Even though databases can sometimes be a lot to digest, learning these skills gives you the power to rearrange data in a way that makes sense to you. Once you've sorted data in a way that really clicks, you'll understand why it's so valuable to you as a data analyst. Bye for now.
I'm Emma, and I'm a product analyst on Google Health. The product that I am helping analyze data for is a tool for clinicians. And what this is going to allow clinicians to do is find their patients' health data just as easily as you can find data on Google search. What I specifically focus on is standardizing healthcare data, analyzing it to find anomalies or data quality issues, and talking to product managers about which features we should launch and why. I've worked on problems from solving locomotive failures and predicting them before they happen, to forecasting sales for handbags before the handbag is even launched, to now working with healthcare data to try to allow clinicians to easily have their patients' data at their fingertips. I was really interested in working in data analytics, but I was trying to figure out what type of data I wanted to work with or what field within data analytics I wanted to focus on because there are so many. And I was ultimately drawn towards working with healthcare data. I just really fell in love with all of the problems that we have today in healthcare and how just this vast amount of data that's available in the healthcare industry could be better utilized to help patients, to help clinicians, to improve population health. Working with meaningful data sets is what really makes me excited to come to work every day and excited to solve these problems. What I've found in my career is that following the data sets that interested me, the types of problems that interested me, always yielded better results because I was just that much more driven to go to work every day, to do my best, to solve these interesting problems because it's just what interested me. The amazing thing is there's data everywhere. There are data problems at every company in every field, and you really get to just follow what you're passionate about.
Hello there. If you're hoping to learn about sorting in SQL this time, you've definitely come to the right place. So far, we've sorted spreadsheets through the menu and with a written function, which brings us to the next part of our learning, more sort functions, but this time in SQL. Data analysts love playing with the way data is presented. Sorting is a useful way to rearrange data because it can help you understand the data you have in a different light. As you've probably already noticed, a lot of things you can do in spreadsheets can also be done in SQL. Sorting is one of those things. We've talked about using SQL with large data sets before. When a spreadsheet has too much data, you can get error messages or it can cause your program to crash. That's definitely something we want to avoid. SQL shortens processes that would otherwise take a very long time or be impossible to complete in a spreadsheet. Personally, I use SQL to pull and combine different data tables. It's much quicker than a spreadsheet, and that usually comes in handy. Here's something pretty helpful you can do with SQL. You can use the order by clause to sort results returned in a query. Let's go back to our movie spreadsheet to get a better idea of how this works. Feel free to follow along in a SQL tool of your choice as we go. As a quick refresher, we have a database of movies listed with data like release date, director, and more. We can sort this table in lots of different ways using the order by function. For this example, let's sort by release date. First, we have the select function and an asterisk. Keep in mind that the asterisk means all columns are selected. Then we have from and the name of the database and table we're in right now. Now let's check out the next line. It's empty, but that's what we'll write our order by function. The order by command is usually the last clause in your query. So back to the actual sorting. We'll type order by with a space. With this clause, you can choose to order data by fields in a certain column. Because we want to sort by release date, we'll type release date. By default, the order by clause sorts data in ascending order. If you run the query as it is right now, the movies will be sorted from oldest to the most recent release dates. Let's run the query and see what we've got. You can also sort the release dates in the reverse order from the most recent dates to the oldest. To do this, just specify descending order in the order by command written as DESC, D-E-S-C. Let's run this query. As you'll notice, the most recently released films are now at the top of the database. In spreadsheets, you can combine sorts and filters to display information differently. You can do something similar in SQL too. You might remember that while sorting puts data in a specific order, filters narrow down data so you only see data that fits the filter. So for example, let's say we want to filter movies by genre so that we're only working with comedies. But we still want release dates to be sorted in descending order, from most recent to oldest films. We can do this with the where clause. Let's try that now. First, we'll check that the order by clause is always the last line. That makes sure that all the results of the query you're running are sorted by that clause. Then we'll add a new line for the where clause after from and before order by. Here's what we've got so far. From there, we want to type the column we're filtering for. In this case, we want to filter the database for comedies. So after the where clause, we'll type the column list name as genre. Now we'll add an equal sign after genre because we only want to include genres that match what we're filtering for. In this case, we're filtering for comedy, so we'll type comedy between two apostrophes. Now, if you check out the entire query as a whole, you'll notice that we're selecting all columns. And we know it's all columns because that's what an asterisk means. The from clause specifies the name of the movie database we're using, and the where clause filters the data to include entries whose genre is specified as comedy. And then in the last line, we have the order by clause, which will sort the data we've chosen to filter by release dates in descending order. This means when we run the query, we'll only have comedy movies listed from newest releases to oldest releases. So let's run it and figure out if that's the case. Cool. Check out all those comedy movies and the way those dates are sorted. Now, let's take this query a step further. We'll filter for two conditions at once using the AND filter. Working off the query we've been using, we'll add a second condition in the WHERE clause. We'll keep the sorting the same. Let's say you wanted to filter by comedy movies and movies that earned over $300 million in the box office. In this case, after the AND function, you add the revenue condition by typing revenue. From there, you'll specify that you only want to return films with revenues over $300 million. To do that, type the greater than sign and then the complete number of 300 million without commas. Now let's run the query. Here, the data only shows comedy movies with revenues of over $300 million, and it's sorted in descending order by release date. It looks really good. You just filtered and sorted a database like it's your job, and with practice, one day it can be. And just like that, you finish another step in your data analyst journey. By now, you really dug and learned about the analysis process, with a special emphasis on how organization can change how you go through your data. You also learned about both spreadsheets and SQL, and how to sort and filter data in both types of programs. To help you get more comfortable using spreadsheet and SQL features, you'll be getting some materials you can use as a resource. Coming up, we'll check out how an organizational mindset can take your analytical skills even further. We'll also cover converting, formatting, and adjusting data to combine information in a way that makes sense. Learning those skills early on can make your work as a data analyst much more efficient and effective in the long run. See you soon. Hey, it's great to have you back. You've learned so much already, and now you're ready to start analyzing data. Coming up, we'll cover some final things you'll need to do for your analysis to make sure your data is formatted and adjusted correctly. We'll start converting and formatting your data using data validation in spreadsheets and conditional formatting. You'll also learn how to combine multiple pieces of data. And finally, we'll talk about how to get support during your analysis and find resources whenever you're stuck. These skills will help make sure that your data analysis process is as smooth as possible, even when it isn't. You'll know how to tackle any problems that might come up. A big piece of being an analyst is troubleshooting and problem solving. You're as good of an analyst as your ability to ask the right questions, which is why we'll spend some time learning about problem-solving strategies you can use during analysis. So whenever you're ready to start learning about data formatting and solving problems, head to the next video and we'll get started. Welcome back. While we're learning about formatting data, I want to talk to you about another spreadsheet feature, data validation. In this video, I'll teach you a little bit about data validation and show you how to use it. For now, when I say data validation, I'm talking about the function, which is different from the data validation process. We'll get into that later on. But first, let's talk about what data validation does in spreadsheets. Basically, it allows you to control what can and can't be entered in your worksheet. Usually, data validation is used to add drop-down lists to cells with predetermined options for users to choose from. If you have a spreadsheet with a lot of collaborators, this can make it easier for them to interact with your table. You can think of it like a multiple choice question on a quiz. And since you can control what's being entered into the worksheet, it cuts down on how much data cleaning you have to do later on. Let's figure out how we might do that. For this example, we'll work on a project with a lot of milestones and deadlines to keep track of. Let's say our team has a spreadsheet that tracks everyone's progress. But instead of making everyone write in where they are on their task individually, we can provide a drop-down menu with multiple options like Not Yet Started, In Progress, and Ready. So we'll select the column that we want to add the drop-down menus to, in this case, the status column. Then we'll go to the Data pull-down menu here at the top and click Data Validation. This brings up a pop-up menu with options for data validation. In this case, we know that we want to add a list of items for other users to choose from. So we'll select the List of Items option and the possible criteria and type in the selections we want to create. Then hit Save, and now all of those cells have drop-down menus that we can use to easily mark progress for each task. But there's other things that you can do with data validation in spreadsheets too, like creating custom checkboxes. To do this, let's select the cells under the Review column to make a checkbox that will let us know if tasks have been approved or not. We'll go back to the data validation menu. But instead of choosing List from a range, we'll choose Checkbox. There's an option to use custom cell values. Let's choose that and put in Approved and Not Approved. Now these tasks can be checked off by whoever's reviewing them, like a project manager, for example. Another way we can use data validation is to protect structured data and formulas. The more people that are working together in a spreadsheet, the more likely someone can accidentally break a formula. But good news, the data validation menu has an option to reject invalid inputs, which helps make sure our custom tools will continue to run correctly, even if someone puts the wrong data in by mistake. All right, now you know 3 uses for data validation in your spreadsheets: adding drop-down lists, creating custom checkboxes, and protecting structured data and formulas. Data validation can help your team track progress, protect your tables from breaking when working in big teams, and help you customize tables to your needs. Coming up, we'll learn more about conditional formatting and some ways you can use conditional formatting and data validation together. See you soon. Hi again. So earlier we talked about conditional formatting as a spreadsheet tool that changes how cells appear when values meet specific conditions. This lets you add visual cues to your spreadsheets that make it easier to understand your table at a glance, and it makes the information in the worksheet clearer to your stakeholders. In this video, we'll take that even further by combining conditional formatting and data validation to create custom tools for our spreadsheets. So far, we've used conditional formatting to highlight empty cells that still needed data so that we could quickly pinpoint what information our table was missing and add it in. Now, let's build on that by using it to make our scheduling table easier to read at a glance. Here's a table we worked with when we covered data validation. It's tracking the status of different tasks on our project for our team to check on. But now there's even more tasks than the last time we looked at it. This table has useful information, but it takes a second to understand. Right now, we don't have a visual on how many tasks are in progress or how many upcoming deadlines there are. But if we color-coded those elements of the table, we could quickly see key pieces of data really easily. Let's start with the status column, column C. In the last example, we created these drop-down menus with the data validation tool. Now we can use conditional formatting to add some color. Let's go to the conditional formatting option under the Format menu. This brings up a sidebar where we can select our range, rule, and formatting style. We need to decide which rows to apply our formatting to when the condition we set is met. We can click this button in the range options to select all of the rows we're applying the formatting to instead of typing it in. Now that we have those cells selected, we can choose the rule that we want to apply to these cells. We already have drop-down menus with specific text, so we can choose Format Cells if text is exactly from the rules. For our first rule, let's write Not Yet Started as the text condition. Then we'll choose a color to apply to those cells that have not yet started in them. Let's use red. Now all cells that have not yet started selected from the drop-down menu will be red. Let's hit the Add Another Rule button to add conditional formatting to our other status options. Let's add the condition In Progress next. We can make that one yellow. And then we'll add one last rule for ready. Let's choose green. And there. Now we have an easy to understand visual cue that tells us how many tasks are in progress and how many are completed. We can also combine data validation and conditional formatting to track upcoming deadlines. We have a column of dates called Review by this date. First, let's use the data validation functionality to make sure users only enter valid dates. We'll go back to the data dropdown at the top, pull up data validation, and select date as our criteria. Then we can go to the Format menu at the top. Go down to Conditional Formatting and open the sidebar again. We'll click the Select Range icon and select the Review by this date column. Now under Format Rules, we can select Date as After, which will give us another option. Let's choose Today. And finally, let's choose the color for these cells. So if the date listed in these rows is after today, it'll be filled in orange. You can also choose a specific locked date if needed. But for now, let's go with today. Now all of the upcoming review dates have an easy to see color code, so anyone using this table can quickly reference these deadlines. You'll find that some spreadsheet programs like Excel have built-in color codes that you can use too. And there you go. Now you know how to use data validation and conditional formatting to create custom tools and visual cues that make your information easy to understand. There's a lot of different ways to use these tools, so feel free to experiment with them in your own spreadsheets. Coming up, we'll keep learning about new tools for spreadsheets and SQL. Bye for now. Great to see you back. In this video, we'll build on what we learned about concatenate and import range by exploring a new SQL query, concat. You might remember that concatenate is a function that joins together two or more text strings. And as a quick reminder, a text string is a group of characters within a cell, most often composed of letters. You've seen how this works within a single spreadsheet. But there's a similar function in SQL that allows you to join multiple text strings from multiple sources, concat. Let's use concat to combine strings from multiple tables to create new strings. For this example, we'll use open data from City Bike, which is a public bike sharing system in New York. As you learned earlier, open data initiatives have created a ton of data for analysts to use. Openness, or open data, is free access, usage, and sharing of data. It's a great resource if you want to practice or experiment with the data analysis tools you've been learning here. We have open access to the New York City bike sharing data, which has information about the use of the shared bikes across the city. So now we can use concat to pull and concatenate data from the different columns stored here. The first thing we need to do is figure out which columns we need. That way, we can tell SQL where the strings we want are. For example, the bike sharing company has two different kinds of customers, one-time paying customers and subscribers. Let's say we want to find out what routes are most popular with different user types. To do that, we need to create strings of recognizable route names that we can count and sort. We know that the information we need is in the station and trips table. So we'll start building our query accordingly. First, we'll input select user type to let SQL know that we want it as a column. Then we'll use concat to combine the names of the beginning and ending stations for each trip in a new column. We'll type in as route to make a route column. This will make these route names easy for us to read and understand. After that, we'll want SQL to count the number of trips. So we'll input count and an asterisk to tell it to count up the number of rows in the data we're selecting, where each row represents a trip in a new column. Now, let's also create a column for trip duration, which we can just round up. Notice how our SQL functions first cast the values in the trip duration column as integers, then calculates the average value for the trip duration, and then rounds that value to 2 decimal places. Next, we'll tell SQL where this information is stored, so we'll use from and the location we're pulling from. Since we're using count and average functions in our select clause, we have to use group by to group together summary rows. Let's group by the start station, the end station, and the user type for this query. Finally, we'll use order by to tell it how we want to organize the data. For this, we want to figure out the most common trips, so we can input the number of trips column and use des to put it in descending order. Finally, we only want the top 10, so let's add limit 10. And now, thanks to concat, we can easily read the route names and trace them back to real places. We can see which kinds of customers are taking which routes, which can help the bike sharing company understand their user base in different parts of the city and where to keep more bikes for people to rent. Being able to combine multiple pieces of data can give you new ways to organize and analyze data, and there's a lot of different tools to help you do that. Now you've seen concat in action, and later you'll come across another similar query, join. But up next, we'll talk more about working with strings. See you soon. Hey, welcome back. So far, we've worked with strings in both SQL and spreadsheets before, and we've learned that they usually have similar functions. In this video, we'll take another look at len, left, right, and find. You've come across these functions used in SQL, but now you'll find out how they work in spreadsheets. Going back to our bike sharing dataset, let's check out one of their spreadsheets. This is one of the trip data spreadsheets. In the start time and stop time columns, there are strings that contain information about date and time of each ride. This is all useful data, but chances are we'll only need part of these strings to make a formula or answer a question. For example, these strings contain multiple data points, like date and time. But if we're trying to find the average time between start times, we won't need the date. We can actually use len, left, and right, and find to split the timestamps into separate columns if we want. Let's build a simple formula to separate the dates in these strings. We know that len tells us the length of a string. Let's check how long these date time strings are now. To start, we'll input the first part of the formula. And then we'll just select one of the cells with the date time string in it. These strings are 19 characters long. We can use the find function to locate specific characters in a string. Keep in mind, this is case sensitive. So if you're using find to pull a substring, make sure that you've input the substring correctly. We notice that all of the datetime strings have a space separating the date and the timestamp, so we can actually use find to figure out where the date ends. Okay, seems like the space is the 11th character in this string, so the timestamp substring will start at character 12. We can use the left and right functions to select which parts of the string we want to isolate in a new column. We'll use right on one of these cells to indicate that we want to grab the right side. And like we've come across before, left actually works exactly the same way. Now we can apply that to the rest of column C to pull those timestamps. As a data analyst, being able to work with strings is a key skill, especially when you find yourself working with data from outside sources. Hopefully you're a little bit more comfortable applying len, right, left, and find functions in both SQL and spreadsheets. Later on, we'll use these functions to perform even more complicated formulas, so feel free to try them out on some data yourself. Maybe even some open data like we've been using today. See you later. Hi there. So data analysts spend a lot of time problem solving, and that means there's going to be times when you get stuck. But the trick is knowing what to do when that happens. In this video, we'll talk about the importance of knowing how to get help, whether that means asking someone else for help or searching the internet for answers. Asking other people about a problem you're having can help you find new solutions that move a project forward. So it's always a good idea to reach out to your peers and mentors, especially if they're working with you on that project. Your team members have valuable knowledge and insight that can help you find the solution you need to get unstuck. Sometimes we spend a lot of time spinning our wheels saying, I can do this myself. But we can be way more productive if we engage with other people, find new resources to lean on, and try to get as many voices as we can involved. For example, let's say you're working with the bike trip time data from the previous videos. Maybe you're trying to find the average time between bike rides in a given month. Calculating the difference between bike rides before midnight is easy, but you can run into a problem if the elapsed time crosses into the next day. If someone went on a bike ride at 11 p.m., but the next ride wasn't until 6 a.m., your formula will return a negative number because the end time is less than the start time. You know that you can add 1 minus the start time if 2 bike rides start and end on different days, but that formula won't work on times that happen in the same day. And it's pretty inefficient to scroll through every bike ride to pinpoint these special cases. You need to find a way to build a conditional formula, but you aren't sure how. So you decide to check in with other analysts working on your team to see if they have any ideas. You could send them a quick email or stop by their desk to find out if they have a minute to talk it over with you. Turns out they had a similar problem on a previous project, and they're able to show you a conditional formula that you could use to speed up your calculations. Great. They suggest using an if formula like this. This basically says that if the end time is larger than the start time, replace the standard end time minus start time formula with 1 minus start time plus end time. Now, it's also possible that your team members don't have an answer. That's okay too. There's definitely someone else with the same problem asking the same questions online. Knowing how to find solutions online is an incredibly valuable problem-solving tool for data analysis. There's also all kinds of forums where spreadsheet users can ask questions, and you never know what you can turn up with just a basic search. For example, let's say you look at calculate number of hours between times spreadsheets and find a helpful walkthrough for a more complicated formula using mod. This flips the negative values into positive ones, solving your calculation problem. Whether you're asking someone you know or searching the internet for answers, reaching out for help can give you some really interesting solutions and new ways to solve problems for future analysis. Coming up, we'll learn even more about searching for solutions online. See you soon.
Hi, my name is Layla, and I'm an analytical lead at Google. So an analytical lead is someone who helps advertisers understand the value of their advertising dollars. We also help them understand if they were to spend another dollar on ads, where should they spend that dollar, and what could they expect to get from it. The skill set involved in this kind of role has all to do with being able to look at a data set and make sense of it, and then tell a story to people who maybe don't have that same experience level with data. What's going on in the data? What's driving growth for your client or your company? What could they do more of or less of to drive more of what they want to happen? The analyze stage is like preparing
a fabulous meal. You have done all the cleaning and the preparing and the cooking, and you're finally able to take a bite and to see if what you were originally hoping to happen or what you were expecting, to see if that is really the case. Is it delicious? Is it exactly like you expected? Or is the consistency a little off and you need to add a little bit more salt? The analysis stage begins once you've prepped and cleaned your data. You don't want to have those blank fields that will throw you off or duplicate entries that will enlarge your data set beyond what's actually true. The analyze stage is where you become the expert about your data set. Here you're going to understand all of the different fields. You're going to understand their averages, potentially the median of the data. You're going to understand how different rows in your data differ from each other. And it's where you're going to gain the confidence to be able to explain your findings to an audience that maybe does not have the same level of expertise with data that you have. When I analyze data, I often like to use SQL and spreadsheets. You can use these tools to, for example, sort your data and understand which entries are larger than others, or to understand how many times something happens by selecting maybe the distinct entries. Here you can also filter out data that you're specifically interested in analyzing, or in a spreadsheet, use conditional formatting to show which entries show a more positive outcome and which ones are maybe more negative. Using SQL and spreadsheets to help you through the analyze phase are absolutely crucial. With these tools, you can format your data set in a way that is digestible and then begin to tell a story with the data. My favorite part of working in a spreadsheet is when you finally have that data that you want cleaned up and exported from your SQL query. Then you get to turn it into a pivot table and chart out exactly the cut of data that you were interested in looking at in the first place and explore the trends that are happening there. When you get to do that, you basically unlock a whole world of information and you get to pick what story that you actually want to tell with your data without just saying, okay, this is the largest number, that's the smallest number. Here you get to show what is happening over time potentially, or what you should expect to see in the future.
Welcome back. Earlier, we talked a little bit about finding resources online to help you figure out solutions to problems during analysis. The internet has so much knowledge and advice to offer, but you need to know how to find it. So in this video, we'll talk more about finding answers online. You might think that great data analysts don't regularly rely on outside resources, but that's a myth. The best data analysts know that finding answers to their problems online can be empowering and give them new knowledge for the future. Being able to find new ideas and combine them with what you already know can help you come up with some amazing things. So don't be afraid to turn to the internet to find your answers. It's a great resource that lots of analysts use, me included. But let's talk more about how you can make sure you're using web resources in the best way possible. There's a combination of best practices that you can use to guide your search for answers online. By practicing the thinking skills we've learned in this program, using the right data analytics terms, and your basic knowledge of analysis tools, you have everything you need to find answers and apply them to your own work. And it starts with how you approach a problem mentally. You've learned about different kinds of thinking skills and how to practice them in your data analysis work, from analytical to mathematical to structured thinking. This helps build your mental model or your thought process and the way you approach a problem. Data analysts use these thinking skills to approach a problem logically and break it into smaller parts. Building this into your own problem-solving process can help you pinpoint specific questions which you can use to find resources more easily. For example, maybe you keep running into an error in your analysis. You narrow it down to two possibilities, your formula or the data itself. You double-check your formula and you see that it's correct. So now you know that you need to make sure that data has been entered correctly. You consider the problem logically and tracked it down to the source using your mental model. Next, it's important to use the right terms when searching for solutions. Knowing how to frame data analytics questions with the same language other analysts are using will help you get more search results, and it'll help you understand what other analysts are saying. For example, maybe you need to use the left 4 characters of a string for a column in SQL. How would you search for this? Searching for 4 characters in a column is a little vague and might not bring up specific resources, but left string query SQL uses some keywords that other data analysts are also using to talk about these things. On top of being able to use the right terms to search online, you also need to be familiar with basic tools. That way, when an online resource is walking you through a new function in a tool you've used before, you'll know how those tools work. For example, if you find a spreadsheet formula online, you need to understand how formulas work to apply it to your own spreadsheet. Or maybe the data set you're working with is too large for a single spreadsheet, and you'll need to switch to SQL. Having a variety of tools in your toolkit is important as a data analyst. But just as important is knowing when to use them. If you find yourself stuck on a problem, it can be a good idea to take a step back and reconsider how you're approaching a task. We've covered a lot of tools that you can use as a data analyst throughout this program. And later, you'll learn one more, R. We'll talk about R more later on, but here's a sneak peek to get you excited for it. R is another programming language, but it's not a database language like SQL. It's a programming language frequently used for statistical analysis, visualization, and other data analysis. R is a little different from other tools we've been working with, but it's a great complement for the tools you're already using, and it will give you more potential solutions when you run into problems. Using the thinking skills we've learned throughout this program, the right terms, and your understanding of different analysis tools will get you ready for the next steps of this process, actually searching for answers online. There's a lot of resources like program support websites and forums where other data analysts are asking and answering questions. In an earlier video, we ran into a problem trying to calculate the time elapsed between bike rides and the bike sharing data. Maybe our first search, calculate time in spreadsheets, didn't turn up the answers we needed. By thinking about our specific question and how other data analysts might be asking it, we could change that search into conditional formula for calculating elapsed time in spreadsheets. And now we have more specific solutions to our problem. Finally, being able to modify example code to fit your own needs is so useful. Understanding the syntax of formulas and functions for different tools will allow you to take what you learned online and make it work for you, and maybe even build on it to create a whole new solution. For example, the mod formula we built to account for trips that started and ended on different days in our bike sharing data. The mod formula we found online wasn't created for the data we were working with, but because we are familiar with spreadsheet tools, we were able to apply it to our data and use it as a solution to our problem. Great data analysts know how to find and use resources online to help them build new solutions to problems they face. By using the thinking skills you've already learned in this program and using your knowledge of data analytics tools and terms, you can too. And once you've found some answers to your problems, you can build them into your analysis work to get past any challenge you might face. Hello there. In these videos, you've been introduced to spreadsheets, SQL, and so many other tools. We've also talked about choosing the right tool before you start a project. But sometimes you find yourself stuck on a problem during your data analysis. That might mean it's time to reconsider which tool you're using for the job. For example, if you're working with a simple spreadsheet, maybe 5 to 10 rows and a few columns, then pivot tables are a great way to visualize that data. But if that spreadsheet is more than 1 million rows, it'll start to crash, making a pivot table hard to complete. When you find yourself working with a huge spreadsheet that keeps crashing, you might switch to SQL to pull the data you need from different locations in a database instead of from a single spreadsheet. You might remember that SQL can handle trillions of rows of data and is now a standard language for working with database programs. SQL is great for querying, updating, and optimizing data. But trying to analyze your data with only SQL can get complicated. As you continue to progress as a data analyst, you might find yourself spending a lot of time building long, nested queries and then debugging them. It might be time to consider another tool, R. R is a new tool that you'll work with later on, but for now, I'll tell you a little bit about it so that you can start getting excited. R is another programming language, but it's not a database language like SQL. It's a programming language frequently used for statistical analysis, visualization, and other data analysis. R is a little different from other tools we've been working with, but it's a great complement for the tools you're already using. With R, you'll be able to analyze and visualize data in all kinds of new ways. We'll talk about R more later on, but I hope this sneak peek gives you an exciting first look. Having a variety of tools in your toolkit is important as a data analyst, but just as important is knowing when to use them. If you find yourself stuck on a problem, it can be a good idea to take a step back and reconsider how you're approaching a task. Do you have too much data for a single spreadsheet? Switch to SQL. Are you spending more time debugging queries than actually analyzing data? Maybe you should consider R. You also know how to find answers online now, so if you ever run into a problem and need to try a different tool, a quick search can be really helpful. There might be resources online, or someone else may have had the same problem and posted about it. This is great if you start feeling stuck on a problem, and you might even find a new way to use a tool you're already familiar with. And that brings us to the end of this module. Great job. We've covered a lot of information. We learned about converting and formatting data, how to combine multiple pieces of data, and how to search for help when you need support during your analysis. Coming up next, you'll take on the weekly challenge. As always, feel free to go back over anything we've learned from these past videos. Then I'll see you for the next video. Good luck. Welcome back. In the next few videos, we'll explore something called data aggregation. Aggregation means collecting or gathering many separate pieces into a whole. For example, the Milky Way galaxy is an aggregation of stars, dust, and gases. So data aggregation is the process of gathering data from multiple sources in order to combine it into a single summarized collection. In data analytics, a summarized collection, or summary, describes identifying the data you need and gathering it all together in one place. For example, let's say you have a cabinet full of different puzzles. One day, a shelf breaks and all the boxes topple over, scattering the puzzle pieces everywhere. To get each puzzle organized again, you need to identify the pieces that correspond to each particular puzzle, gather them together, and put them back into their correct boxes. Only then can you work with these pieces and create a complete picture. So in data, the puzzle pieces represent the data that lives in different separate data sets. Getting them organized is the aggregation process. Then the piles of pieces that complete a single puzzle become your summary. And finally, putting those pieces back together is like analyzing them to gain important insights. Data aggregation helps data analysts identify trends, make comparisons, and gain insights that wouldn't be possible if each of the data elements were analyzed on its own. For instance, data on high school graduations for individual students can be aggregated into a single graduation rate for an entire class. Data can also be aggregated over a given time period to provide statistics such as averages, minimums, maximums, and sums. For example, that same yearly graduation rate data can be aggregated once again into a summary that shows us graduation rates for districts, states, and countries. Here's another example. Let's say you had data on real estate sales in a particular neighborhood for each of the past 10 years. If you aggregated all of that data, you'd be able to discover the average price of a home in that area and how values have increased or decreased over time. Functions are a big help in making data aggregation possible. You'll learn how to use some of the most common ones to create your summaries soon. In addition, we'll talk about aggregating data using something called a subquery. You've seen SQL in action, and you understand that a query is a request for information from a database. So a subquery, also called an inner or nested query, is a query within another query. After the next several videos, you'll know how to aggregate data and understand the tools you'll be using along the way. Let's get started. Hi again. In this video, we'll prep our data for VLOOKUP, a data aggregation tool. As you learned before, data aggregation is the process of gathering data from multiple sources in order to combine it into a single summarized collection. Data aggregation can give you all kinds of information about the data you are looking at. For example, in marketing, you can aggregate data from an ad campaign to see how it performed over time and for particular customers. Travel companies use data aggregation to figure out how much their competitors charge for a certain flight, hotel room, or rental car type. Then they can make sure they price their own products as competitively as possible. One thing these businesses all have in common is that they can use VLOOKUP to help them achieve these goals. As a reminder, VLOOKUP stands for vertical lookup. Basically, it's a function that searches for a certain value in a column to return a corresponding piece of information. Earlier, we used VLOOKUP to take the value in one cell and search for a match in another. We were able to match a product code made up of numbers and letters that lived in one spreadsheet to the actual name of the product that lived in another. But before any of that can happen, we need to make sure our data is properly prepared. As you've heard many times, clean data is much more likely to give you accurate results. So let's start with the first common data cleaning task, different data types. For example, a data set might have dates formatted as numbers, or numbers represented as text strings instead of numeric values. When data is not in a consistent format, or a format that the spreadsheet application recognizes, VLOOKUP won't know what to do with that data, and it'll return an error. Earlier you learned how to convert numbers to dates using the format tool. So now, let's focus on converting text to numeric values. To do this, you could use the format menu to select a type of number. But you could also use the value function. Value is a function that converts a text string that represents a number to a numerical value. Here's an example. In this spreadsheet, the numbers in column A are currently text strings. We can confirm this by running a simple sum function. The syntax is equal to sum, open parentheses, and then the items you want to add together. Here it's A2 to A4. The colon says we're including everything between these two references. Now you can add a close parentheses and press enter, or you can click and drag on the cells you want inside the parentheses to save a little bit of time. The result is 0. That's because the function doesn't work on text strings. But if we apply the value function, it automatically converts that text to a numeric value. To do that, we'll type equals value, then an open parentheses. Inside, we reference the cell whose value we want to convert, in this case, A2. So now, if we close the parentheses and press enter, you'll notice that the 1, 2, 3 is numeric. If we drag it down the column, the 4, 5, 6, and 7, 8, 9 also become numeric. Now we can test it by running another sum function. We'll type equals sum and an open parentheses. Then B2, colon, and B4. So B2, B3, and B4 are included in the sum. Close the parentheses and press enter. Now it shows that the total is 1,368. Okay, the next common error comes from having extra spaces in your spreadsheet. As you've learned, when data is copied from one source to another, sometimes a few leading or trailing spaces tag along. These can cause problems when using VLOOKUP, so we want to make sure to use trim during the data cleaning process. Trim automatically deletes any extra spaces added to the cell. Another typical mistake in VLOOKUP, which you can easily catch during data cleaning, are duplicates. If there are duplicate rows in the search, it will return only the first match it finds. As you learned before, Remove Duplicates is a tool that automatically searches for and eliminates duplicate entries from a spreadsheet. Using Remove Duplicates, as you saw in a video a little while ago, is a great way to get rid of duplicates and help make sure you find the right record during the lookup. It's always good to remember that clean data is the foundation that everything else is built on, and VLOOKUP can be a very useful data cleaning tool. In the next video, we'll keep exploring more ways you can use VLOOKUP. See you there. When people start out in data analytics, they often think that those of us who've been in the field for a while know everything. But trust me, we're all still figuring things out. And a lot of the time, that means troubleshooting. Troubleshooting has to do with asking the right questions, and that's what we'll focus on in this video. We'll learn how you can use troubleshooting to solve all kinds of problems. To do this, we'll need to talk about some of the limitations of VLOOKUP and then practice fixing some of the most common problems that data analysts face. Some of the troubleshooting questions I like to ask myself: how should I prioritize these issues? Trying to solve lots of problems all at once can feel overwhelming. I find it helps when you take things one at a time. Next, I ask, in a single sentence, what's the issue I'm facing? This helps to clarify what's really going on so I don't get bogged down with extra details. After all, if you don't have a clear objective before looking at the data, you can find just about anything. It's always best to start with your own clear understanding of the situation. Then let the data tell you if you're on the right track or not. The next question I ask myself is, what resources can help me solve the problem? The internet is one of the best resources out there. If you have a question, chances are thousands of others run into exactly the same thing. So a quick search can be really helpful. And it's good to remember that people are resources too. Don't be afraid to ask questions. Not only is it a great way to learn, it can also help you build strong relationships with your colleagues. And a final important question I think about: how can I stop this problem from happening in the future? If a new procedure or guideline can stop the same issue from popping up again, that's a great time saver. All right, let's start by noting that VLOOKUP only returns the first match it finds, even if there are lots of possible matches. To understand this, imagine your dataset is a phone book. According to research, some of the most popular names are James Smith and Maria Garcia. This means if you need information about the 100th Maria Garcia listed, VLOOKUP won't work. It'll only give you results for the very first Maria it finds. Something else to keep in mind is that VLOOKUP can only return a value from the data to the right. It can't look left. Good news, there's a simple solution. Data analysts usually get around the problem by copying and pasting a column to the left of the data they want to look at. This way, the lookup value is in the leftmost column and the data they want is to the right of it. Here's another problem I see a lot. Let's say the first few rows of a VLOOKUP have returned the correct result, but when you drag the function down the column, problems start popping up. This is probably because the table array part of the function hasn't been locked or made absolute. An absolute reference is a reference that is locked so that rows and columns won't change when copied. You can fix this issue by wrapping the table array in $signs. As you learned a while back, the $sign controls how the reference will be updated. They make sure that the corresponding part of the reference doesn't change. Something else that can throw off your VLOOKUP results are version control issues. In other words, a function worked perfectly at first, but then something in the spreadsheet it was referencing changed. For example, maybe a user inserted a column. So now the columns in your function no longer direct VLOOKUP to the right place. When something like this happens, it'll return an incorrect value. There are a few actions data analysts can take to ensure this doesn't happen. First, lock the spreadsheet. This stops other people from making changes. To do this in Sheets, select Data, then Protected Sheets and Ranges. In other spreadsheet applications, there are other tools that do the same thing. Next, choose what you want to protect. In this case, we want to protect the entire sheet. Then you can set permissions to either show a warning or restrict who can edit. Choose only you, then Done. But keep in mind, there will be times when other people need to work in the spreadsheet, so locking them out might make you pretty unpopular with your coworkers. When that's the case, you can use match, which is a function used to locate the position of a specific lookup value and can help you with version control. We won't get into that right now, but just know that it's an option in case you ever need it. The final problem we'll talk about has to do with exact and approximate matching. When using VLOOKUP, you're likely to get different results depending on whether you enter the word true or false within your function. True tells VLOOKUP to look for approximate matches, and false tells VLOOKUP to look for exact matches. So if a function looks like this, it's telling VLOOKUP to find the closest match to the text or number we're looking for. It's important to note that VLOOKUP starts at the top of a specified range and searches downward vertically in each cell to find the right value. It stops searching when it finds any value that's greater than or equal to the lookup value. That's why data analysts typically use false, like this. That way, VLOOKUP only returns the exact match to what you've entered in the lookup value. VLOOKUP is one of the most popular lookup and reference functions in spreadsheets. It's also one of the trickiest. Coming up, you'll learn about more of these common challenges. Everything you learn will help you run into fewer problems when you start using VLOOKUP as a future data analyst. Hey, welcome back. So far, we've checked out a few different tools you can use to aggregate data within spreadsheets. In this video, we'll cover how to use join in SQL to aggregate data in databases. First, I'll tell you a little bit about what a join actually is, and then we'll explore some of the most common joins in action. Let's get started. Join is a SQL clause that's used to combine rows from two or more tables based on a related column. Basically, you can think of join as the SQL version of VLOOKUP, which we just covered. There's 4 common joins data analysts use: inner, left, right, and outer. Here's a handy visualization of what each join actually does. We'll use these to help us understand these functions. Joins help you combine matching or related columns from different tables. When we learned about relational databases, we referred to these values as primary and foreign keys. Primary keys reference columns in which each value is unique to that table. But that table can have multiple foreign keys, which are primary keys in other tables. For example, in a table about employees, the employee ID is the primary key and the office ID is a foreign key. Joins use these keys to identify relationships and corresponding values. An inner join is a function that returns records with matching values in both tables. If we think about our tables as the circles of this Venn diagram, then an inner join would return the records that exist where the tables are overlapping. For the records to appear in the results table, there has to be key values in both tables. The records will only merge if there's matches in both tables. When you input join into SQL, it usually defaults to inner join, so a lot of analysts will use join as shorthand instead of typing the whole query. A left join is a function that will return all the records from the left table and only the matching records from the right table. Here's how you can figure out which table is left or right. In English and SQL, we read from left to right, so the table mentioned first is left and the table mentioned second is right. You can also think of left as the table name to the left of the join statement and right as the table name to the right of the join statement. In this diagram, you'll notice that the entire left table is colored in, and the overlap with the right table, which shows us that the left table and the records it shares with the right table are being selected. Each row in the left table appears in the results, even if there's matches in the right table. Right join does the opposite. It will return all records from the right table and only the matching records from the left. You can get the same results if you flip the order of the tables and use a left join. For example, select from table A, left join table B is the same as select from table B, right join table A. Finally, there's outer join. Outer join combines right and left join to return all matching records in both tables. This means it'll return all records in both tables. If there's records in one table without a match, it'll create a record with null values for the other table. Using joins can make working with multiple data sources a lot easier, and it can make relationships between tables more clear. But unfortunately, they don't work in SQL. Let's find out why. Here's an example. Let's say you're working with employee data across multiple departments. We have an employees table and a departments table, which both have some columns like department ID. We can use different join clauses to help us pull different data from our tables and aggregate it. Maybe we want to get a list of employees with their department name, excluding any employee without a department ID. Because the department ID record is used in both tables, we can use an inner join to return a list with only those employees. As a quick reminder, analysts will sometimes just input join for an inner join, but for this example, we'll write it out. So, to build this query, we'll start with select and as to tell SQL how we want the columns titled. Then we'll use from to tell it where we're getting this data, in this case, the employees table. And then we'll input inner join in the other table we're using, which is departments. We can specify which column in each table will contain the matching join key by writing on employees.department_ID equals departments.departments_ID. Now let's run it. And there. Now we've got a list of employee names and department IDs for the employees that have those IDs. But we could use left or right join to return a list of all employee names and their departments when available. Let's try both really quickly. So this will start similar to the last query. We'll put in select as and from again. But this time, we'll say left join and use on like we did with the last query. When we execute the query, we get back this new list with the employee names and departments, but you'll notice there's null values. These are places where the right table, which is departments in this case, didn't have corresponding values. Let's try right join just to test it out. This query will be almost the same. Only difference is that we'll use the right join clause to return all of the rows from the right table, whether they have matching values in the table to the left of the join statement or not. In this case, the right table is departments. Now, let's try out one last join, outer. Outer join will fetch all of the employee names and departments. Again, this query will start a lot like the other ones we've done. We'll use select, as, and from to choose what data we want and how. We'll grab this from the employees table. Input full outer join with the departments table to get all of the records from both. We'll also use on again here. Now we can run this. And we'll get all of the employee names and departments from these tables. There will be nulls in the department.name column and the employee.name column and role columns because we've joined columns that don't have matching values. And there. Now you know how joins work. Joins are super useful when you need to work with data from multiple related tables. They give you a lot of flexibility with how you combine and view that data. And if you ever have trouble remembering what inner, right, left, or outer join do, just think back to our Venn diagram. We'll keep learning about aggregating data in SQL next time. See you soon. Hi, it's great to have you back. By now, we've discovered that spreadsheets and SQL have a lot of tools in common. Earlier in this program, we learned about count in spreadsheets. Now it's time to look at similar tools in SQL, count and count distinct. In this video, we'll talk about when you'd use these queries and check out an example. Let's get started. Count can be used to count the total number of numerical values within a specific range in spreadsheets. Count in SQL does the same thing. Count is a query that returns the number of rows in a specified range. But count distinct is a little different. Count distinct is a query that only returns the distinct values in that range. Basically, this means count distinct doesn't count repeating values. As a data analyst, you'll use count and count distinct anytime you want to answer questions about how many. like how many customers did this, or how many transactions were there this month, or how many dates are in this data set. And you'll use them throughout the data analysis process at different stages. For example, you might need them while you're cleaning data to check how many rows are left in your data set. Or you might use count and count distinct during the actual analysis to answer a how many question. You'll run into these kinds of questions a lot, so count and count distinct are really useful to know. But let's check out an example to see count and count distinct in action. For this example, we're working with a company that manufactures socks. We have two tables, warehouse and orders. Let's take a quick look at these tables before we start querying. First, we'll check out the warehouse table. You can see the columns here: warehouse ID, warehouse alias, the maximum capacity, the total number of employees, and the state the warehouse is located in. We'll pull up the top 100 rows of the orders table next. We can use limit here to limit the number of rows returned. This is useful if you're working with large data sets, especially if you just want to explore a small sample of that data set. From this query, we're actually going to start with a from statement so that we can alias our tables. Aliasing is when you temporarily name a table or column in your query to make it easier to read and write. Because these names are temporary, they only last for the given query. We can use our from statement to write in what our table's aliases are going to be to save us some time in other parts of the query. So we'll start with from and use aliasing to name the warehouse orders table just orders. Let's say we need both the warehouse details and the order details because we want to report on the distribution of orders by state. So we're going to join these two tables together since we want data from both of them, and alias our warehouse table in the process. In this case, we're using join as shorthand for inner join because we want corresponding data from both tables. And now that we have the aliases in place, let's build out the select statement that comes before from. Let's run that. And there. Now we have data from both tables joined together, and we know how to create these handy aliases. Now we want to count how many states are in our order data. To do that, we'll use count and count distinct now. We can try a simple count query first. We'll join the orders and warehouse tables in our from statement. And in this case, we'll start with select and count the number of states. Let's run this query and see what we get. Wait, that's not quite right. This query returned over 9,000 states because we counted every single row that included a state. But we actually want to count the distinct states. Let's try this again with count distinct. This query is going to look similar to the last one, but we'll use distinct to cut out the repeated instances we got the last time. We'll use the query we just built, but replace count with count distinct in our select statement. Let's try this query. That's more like it. According to these results, we have 3 distinct states in our orders data. Let's check out what happens when we group by the state column in the warehouse table, which we'll call warehouse.state. We'll use join and group by in our from statement. So let's start there again. And then group by warehouse state. Now, let's build out our select statement on top of that. We're still going to use count distinct. And let's run it. Now we have 3 rows, one of each state represented in the orders data. And our count distinct on the number of orders sums up the count we ran earlier, 9,999. You'll find yourself using count and count distinct during every stage of the data analysis process. So understanding what these queries are and how they are different is key. Great job, and I'll see you again soon. Hey, it's great to have you back. In this video, I'll introduce you to another kind of SQL query, subqueries. A subquery is a SQL query that is nested inside a larger query. Have you ever seen one of those nesting doll toys? They're also known as matryoshku, Russian nesting dolls. Subqueries are a lot like nesting dolls. No, really. Your larger query could have a subquery in it, and then that subquery could have a subquery, and then that subquery could have another subquery. But when you stack them all together, they make one query. With subqueries, you can combine different pieces of logic together. Because the logic of your outer query relies on the inner query, you can get more done with a single query. This means all of the logic is in one place, which makes it more efficient and easier to read. The statement containing the subquery can also be called the outer query or the outer select. This makes the subquery the inner query or inner select. The inner query executes first so that the results can be passed onto the outer query to use. Subqueries can get a little confusing because there's so many layers. But if you keep in mind that the innermost query executes first, it'll be easier to order your subqueries when you want them to execute. Subqueries can also be nested inside all sorts of other queries. Usually, you'll find subqueries nested in from or where clauses. Let's try out some common subqueries. We'll start with a subquery and a select statement using the bike sharing data from an earlier example. For the first statement, let's say we want to compare the number of bikes available at a station to the average number of bikes available. We're going to use this query to pull the average number of bikes available. Then we're going to incorporate it as a subquery. Now, let's build our outer select query. We want to select the station ID and the number of bikes available. Then we'll put the select query that's pulling the average number of bikes inside that outer query by using parentheses. We'll also build from into the subquery before closing it with another parentheses and completing the outer query. The end of the outer join query has as to show what we want to call this column and a final from statement to indicate which table we're referring to. Now let's run it. And there, we've got a table with both the number of bikes available and the average number of bikes available at different stations. It's really common to see subqueries nested in from and where statements, so let's try those next. We could use a from statement to calculate the number of rides that have started at each station over time. We'll start with our outer query and input select station ID, name, and number of rides. We'll use as to tell it how we want the table labeled, and from to tell it where we're pulling data from. But before we finish that query, we'll add a subquery. We'll put our parentheses here and then select the start station ID. Then we can tell it to count the number of rides from the trip data and group it by the start station ID. After that, we'll close the subquery with a parentheses so that we can continue building the outer query. We'll use as again, and then use inner join and on to join it with the station ID data. And finally, we'll tell it to put it in descending order. Let's see what happens when we run that. We now have the number of rides started at each station. Okay, one last example. Let's use a where statement. The bike sharing company has two kinds of users, subscribers and one-time customers. Let's say we wanted a list of stations subscribers used. As always, we start with the outer query. Select the station ID and name from the public data set we're using. And this time, we'll use a where statement. We'll also use in so that we can specify multiple values in this where statement. Then we'll put our subquery in the parentheses. We'll add select, from, and where again. but this time we'll tell it that we only want data on specific customers. It's good to note that you can use comparison operators in subqueries, even multiple row operators like in, any, or all. In this case, we'll use equals to indicate that we only want the subscriber user data. Now, let's run the query. And we've got the station ID and names for stations that fit our criteria. So that's subqueries in action. Subqueries can be challenging. There's a lot of layers to think through, and you might find yourself running into errors when you practice. That's totally okay. Having to go through that challenge means you're growing. If everything was easy, we wouldn't find new ways to grow. For me, it's all about how much work and how much time I need to put in to do it. So give yourself time to practice this new concept. Coming up, you'll get a chance to use subqueries to aggregate data, or you can move on to the weekly challenge. You'll take everything you've learned, like using VLOOKUP, different joins, and subqueries, and apply it to this upcoming assessment. We've been doing a lot of complex work, so if you want to take a moment to review these videos before moving on, feel free. And once you finish the challenge, I'll see you again for our next big learning adventure. See you soon.
Hi, I'm Justin. I work here at Google in the Google Cloud space. I lead a small team of data analysts who answer business problems for our executive team. The first thing I would tell you about my journey to analytics was it was not direct. I came to Google 3 years ago and have been doing data analytics, and I've really been enjoying that role. And it's kind of tied together this through line of excitement about data and answering questions that have an impact. Your career path's not always straightforward. Maybe data analytics won't be my final destination, but what I would say is just keep changing little by little. Figure out what's exciting about your role right now. In my case, it was I loved avoiding politics and coalition building and really just bringing better facts and better insights to really motivate decisions. So kind of figure out what you like about your current role, your current job, and then figure out what different role could you take that would build on that, but maybe get you more of what you like. Be curious. The number one skill is really just asking why, and then going and trying to answer that question. And you'll lead you down, along whether it's Wikipedia to understand this model that someone using and saying, why did they use that model? You go and look up that model and sort of follow that thread. Or, there's so many great resources for different languages. If you want to understand SQL, there's so many great tools, but I guess the number one thing is just sort of follow your curiosity. So when I'm reviewing resumes, the first thing obviously I'm looking for is those core skills, the ability to analyze data, demonstrated experience with some of the tooling we use. But I'm also looking for a real passion in answering questions. So examples where someone's really dug in and tried to understand the why, and they just kept asking, why is this happening? Why is this happening? And really dig in.
Hey there. So we've got some experience nesting subqueries into our SQL statements to perform more complicated queries. Now it's time to talk about how to aggregate data with subqueries. Coming up, we'll learn about some new subquery statements and use them to aggregate data. The query we're going to build in this video is pretty advanced. It's going to be a little complicated, but I know you've got what it takes. Let's get started. We've used functions like where to filter our data before, but the where function can't be used with aggregate functions. For example, you can use where on a statement and follow it with group by. But when you want to use group by first and then use where on that output, you'll need a different function. This is where having comes in. Having basically allows you to add a filter to your query instead of the underlying table when you're working with aggregate functions. That way, it only returns records that meet your specific conditions. Similarly, case returns records with your conditions by allowing you to include if/then statements in your query. So let's try to aggregate our data with subqueries and test out these new functions. Let's say we're working with a company that makes socks that we talked about earlier. We've been asked to calculate what percentage of the orders are fulfilled by each warehouse. Basically, we're interested in knowing which warehouses are delivering the most orders. We've seen these tables before, but as a quick refresher, here's the orders table. You can see the columns here: order ID, customer ID, warehouse ID, order date, and ship date. And if we pull up the warehouse table, we can check out its columns. We have the warehouse ID, warehouse alias, the maximum capacity, the total number of employees, and the state where the warehouse is located. Before we start building the rest of our query, we'll want to alias our table names. As a reminder, aliasing is when you temporarily name a table or column in your query to make it easier to read and write. This example query is a little bit more complicated than the ones we've seen before, so aliasing will help save us some time. We'll start by aliasing the warehouse table in our from statement. The from statement in this query is near the end, but we'll build this first so that we can use the alias everywhere else. We'll simplify it to just warehouse for the rest of this query. We know that we're going to join these tables together, so let's add that while we're working on this part of the query anyway. We're using a left join here because we want all the information from our warehouse data, even if it doesn't show up in the orders table. Then we'll alias the orders table as part of this statement. Now both of our tables have temporary names we can use, and we've already finished a join statement. But before we can build the beginning of this query, let's go ahead and add our group by statement after this join. We'll group these by the warehouse ID and name. And now we'll go back to the beginning of the query. We'll select the warehouse ID. Then we'll use concat to combine the strings with the warehouse's state and alias as the warehouse name. Then we'll use count to get the number of orders per warehouse. Next, we'll build in a subquery to pull the total number of orders placed across all warehouses. We'll input select again and then write the subquery in parentheses. We'll put an asterisk after count to indicate that we want to include everything from the orders table. And finally, we'll close out the subquery and use as to name this column total orders. Now that our subquery logic is complete, we can use a case statement to create categories for our warehouses based on how many orders they will fulfill. We'll represent these as percentages. You should notice count in the statement a few times. We'll start by saying when the number of orders from our order table is less than or equal to 0.2. Then the table will say fulfilled 0 to 20% of orders. And then we'll use when again to indicate that when the number of orders is greater than 0.2, and less than or equal to 0.6, it'll say fulfilled 21% to 60% of orders. After that, we can use else to have everything that doesn't meet the criteria of our case statement say fulfilled more than 60% of orders. Then we'll use end as to name this column fulfillment summary. That brings us back to the portion of the query we've already written, but we're going to add a having statement at the very end of this query. Our warehouse table has warehouses that are currently being built, and we want to filter those out since they aren't fulfilling orders yet. We can use having to only include warehouses that have at least one order. Now, before we execute this query, let's take a moment to look at the whole thing. We have an outer select, a count subquery, a case statement, a join, and having all wrapped into one query. We've built a really complex query, so let's run it to see the new table. And there, Now we can easily identify what % of our company's total orders are being fulfilled by each warehouse. These warehouses met our criteria, and we can see here in the fulfillment summary column the percentage categories we outlined in our case statement. Obviously, since we included a having statement to specify only warehouses with at least one order, there aren't any warehouses currently under construction in this table. That really complicated query we wrote created this specific table of data we can use to easily compare how these warehouses are performing. There you go. That's a quick taste of what it's like to work with subqueries in data aggregation. Clauses like having and case paired with subqueries will help you build more and more complex queries, which lets you do more and more complex things in SQL. Hi, good to have you back. Coming up, we're going to be reviewing some familiar concepts and then using those concepts to explore new ones. As a data analyst, you'll use key tools and processes over and over, but you'll also learn new things as you grow in your job. It could be anything from building a new kind of analysis to a time-saving shortcut. When I first got to Google, I relied on just a couple of programs and tools to access data and do my analysis. But I soon realized that I wasn't working as efficiently as I wanted to. Once I got comfortable pulling data and analyzing it using SQL, it allowed me to be a lot more efficient than before. And the better I got at SQL and pulling the data from data tables, the faster I completed my analysis. I was hooked. Over the next few videos, I'll show you some ways to be as efficient as possible while completing calculations during your analysis. We'll start by revisiting spreadsheets where we'll look at formulas for basic calculations. Then we'll move into conditional formulas that use the if function to check whether a condition is met through a calculation. After that, we'll explore the multifunctional SumProduct function. Try saying that 5 times quickly. SumProduct adds and multiplies all in one step, so it's very useful. Next, we'll take another look at pivot tables. If you've skipped around and it's your first time learning about them, you'll get to know all about them. Pivot tables have tons of uses, including organizing your calculations. We'll then pivot to SQL, pun intended. We'll show how queries and calculations go hand in hand in SQL. We'll also look at temporary tables in SQL, which are helpful for temporarily storing your data during analysis. We'll be covering lots of new concepts in these videos, so feel free to hit the pause button at any time to think through the problem or steps to try it on your own. And you can always review the videos as much as you need to. So to recap, we'll have a little bit of a review and then cover some all new concepts, all about calculations. Are you ready? Good. Me too. Hey there. You probably do a lot of calculations in your daily life. Maybe it's figuring out how to tip someone or balancing your budget. You might do some of these calculations in your head or with paper and pencil or the calculator on your phone. You might even have shortcuts you use to make the calculations easier. You'll perform a lot of these calculations as a data analyst too, but they'll involve more numbers and a wider range of calculations. That's where you will put your data analyst tools to work. We'll show you how you can use formulas in a spreadsheet to complete some of the more basic calculations. Formulas are one of the many shortcuts that data analysts use. But rest assured, even though they're shortcuts, they still calculate with complete accuracy. We've covered a lot of these calculations earlier in the program, but if you skip that part and want a refresher, we'll review them here. These calculations will also be more advanced than the ones we've covered so far, but they will also be closer to what you might use on the job. We'll be using Google Sheets in this video, but you can also use Excel. The steps might look a little different in Excel, but the outcomes will be the same. Okay, let's try out some calculations with sales data from a discount store chain. We'll look at data from one of the stores in the chain. Our objective: use the existing sales data to find any trends. This is a great way to see a lot of the ways formulas can be useful in your analysis. We'll start by finding annual sales over the years 2011 to 2020. The data is already organized in columns by month and in rows by year, but we don't have the total sales for each year yet. We can use a sum function to help us figure that out. We'll add the sales for 2011 first. We'll add a heading for the annual sales column. Then we can type our sum function in a formula. All formulas begin with an equal sign, so we'll type that first, followed by sum and then an open parentheses. After the open parentheses, we need to tell the formula which cells are being added. In this case, we need data from the whole row, which begins in cell B2. B2 is the cell reference we'll use. Instead of typing each cell one by one, we can put them in the formula quickly by selecting cell B2 and dragging the fill handle across the row to the last cell with sales data, M2. The fill handle is the tiny box in the corner of each cell. You can use it for lots of things, like selecting multiple cells for a formula or continuing a pattern across several cells. The fill handle definitely qualifies as a shortcut. All right, now we'll complete the formula by closing the parentheses and pressing Enter. And just like that, we've calculated the total sales for 2011. Here's another shortcut we worked on in an earlier video. We can use the formula we created to calculate the total sales for the other years in the data set. All we have to do is drag the fill handle down the other cells in the annual sales column, and we'll have total sales for the rest of the years in the data set. Let's say we also need to find the growth in annual sales from year to year. This would be a good time to think through the problem before we try to solve it. Do we have the data we need to solve this? Not yet. Thinking backwards like this helps us plan out the steps to move forward. The first step we'll need to do is calculate the total sales by year. Then we'll measure the rate of change between years. We'll start by labeling a new column. In this case, we won't need to use a function or parentheses. Since we're only using data from 2 cells, we can just use the name of those cells. We'll type an equal sign and then click in cell N3, which automatically populates that cell in the formula. Next, we'll add a minus sign to the formula because we're subtracting to find the difference between 2 consecutive years. Clicking in cell N2 gives us the total from 2011, which we can then subtract from the total from 2012. Then we hit Enter and get our sales growth from 2011 to 2012. We're definitely getting some useful data here, so let's keep going. We can also use our sales growth to find the growth rate between the 2 years. We'll show this as a percentage, so we'll head our column with the percent sign and growth. To do this, we'll divide the total in cell O2 by the annual sales from 2011 in cell N2. A slash is a symbol that a formula recognizes as division, so we'll place that between the 2 cell references. And presto, there's the growth rate. Growth rates are usually shown as percentages, which can be easier than a decimal to read and understand. So let's change this number to a percentage. Time for another shortcut. All we have to do is click the percent style button and our growth rate will become a percentage. We can select the cells for both the total growth and the growth rate to populate the rest of the 2 columns. We have some negative numbers, but that just means that there was negative growth from one year to the next. Okay, we've got just a few more things to calculate for our stakeholders. Next up is finding the average sales. We want to compare sales between months to learn if there's a trend, so we'll add this in a row instead of a column. This will line up our averages under each month. To find our averages, we'll calculate the total and then divide that total by the number of values add it to get it. We can do this by using the average function. Between our parentheses, we'll select the cells that contain the sales data for January, B2 through B11. We'll duplicate that formula across the row through December to look for trends. Right away, we know that summer months and December have the highest average sales. Since our stakeholders will want to understand our findings quickly and easily, we'll add a little visualization to the data with conditional formatting. Conditional formatting is a spreadsheet tool that changes how cells appear when values meet specific conditions. So let's apply conditional formatting to the cells with the average sales by month. We'll use a color scale to show the range of averages with the lowest monthly average remaining as white, and we'll apply shades of green to the rest of the values. The brighter the green, the higher the average. Now, when we share our analysis with our stakeholders, they'll be able to tell right away which months have the highest average sales. Okay, just a couple more steps to complete our analysis. Now we need to find the minimum and maximum for average monthly sales. With a data set this small, it might be easy to find the minimum and maximum values without a formula, but it's still good practice to use one. Not to mention, using a formula helps prevent human error. We'll again rely on formulas with functions to do these calculations. We'll start with the lowest monthly average. Our function here is min, followed by the cells with the average month, B12 through M12. After we press enter, the lowest monthly average is calculated. We can repeat the same steps to find the highest monthly average. In this formula, we'll use the same data, but we'll replace min with max for maximum. So for this store location, sales are strongest in December and weakest in January. We could share these findings with stakeholders if they've met our objectives. If they haven't, we might need to continue with our analysis. Either way, I hope you've learned how spreadsheet formulas can be valuable tools when doing calculations. Coming up, we'll check out more formulas. See you soon. Welcome back. One of the first calculations most kids learn how to do is counting. Soon after, they learn adding, and that doesn't go away. No matter what age we are, we're always counting or adding something, whether it's change at the grocery store or measurements in a recipe. Data analysts do a lot of counting and adding too. And with the amount of data you'll come across as a data analyst, you'll be grateful to have functions that can do the counting and adding for you. So let's learn how these functions, COUNTIF and SUMIF, can help you do calculations for your analysis more easily and accurately. We'll start with the COUNTIF function. You might remember COUNTIF from some of the earlier videos about data cleaning. COUNTIF returns the number of cells that match a specified value. Earlier, we showed how COUNTIF can be used to find and count errors in a data set. Here, we'll only be counting. Just a reminder though, while we won't be actively searching for errors in this video, you'll still want to watch out for any data that doesn't look right when doing your own analysis. As a data analyst, you'll look for and fix errors every step of the way. For this example, we'll look at a sample of data from an online kitchen supplies retailer. Our stakeholders have asked us to answer a few questions about the data to understand more about customer transactions, including the revenue they're bringing in. We've added the questions we need to answer to the spreadsheet. We'll set up a simple summary table, which is a table used to summarize statistical information about data. We'll use the questions to create the attributes for our table columns: count, revenue total, and average revenue per transaction. Each of our questions ask about transactions with one item or transactions with more than one item, so those will be the observations for our rows. We'll make quantity the heading for our observations. We'll also add borders to make the summary table nice and clear. The first question asks, how many transactions include exactly one item? To answer this, we'll add a formula using the COUNTIF function in cell G11. We'll begin with an equal sign, COUNTIF, and an open parentheses. Column B has data about quantity, so we'll select cells B3 through B50 followed by a comma. Next, we need to tell the formula the value that we're looking for in the cells we've selected. We want to tell the data to count the number of transactions if they equal 1. In this case, between quotation marks, we'll type an equal sign and the number 1 because that's the exact value we need to count. When we add a close parentheses and press enter, we get the total count for transactions with only one item, which is 25. We can follow the same steps to count values greater than 1. But this time, because we only want values greater than 1, we'll type a greater than sign in our formula instead of an equal sign. Getting this information helps us compare the data about quantity. Okay, now we need to find out how much total revenue each transaction type brought in. Since the data isn't organized by quantity, we'll use the SUMIF function to help us add the revenue for transactions with one item and with one more item separately. SUMIF is a function that adds numeric data based on one condition. Building a formula with SUMIF is a bit different than one with COUNTIF. They both start the same way with an equal sign and the function, but a SUMIF formula contains the range of cells to be evaluated by your criteria and the criteria. In other words, SUMIF has a list of cells to check based on the criteria you set in the formula. Then the range where we want to add the numbers is placed in the formula if that range is different from the range being evaluated. There's commas between each of these parts. Adding a space after each comma is optional. So let's try this. In cell H11, we'll type our formula. The range to be evaluated is in column B, so we'll select those cells. The condition we want the data to meet is for the values in the column to be equal to 1, so we'll type a comma and then inside quotes an equal sign and the number 1. Then we'll select the range to be added based on whether the data from our first range is equal to 1. This range is in column C, which lists the revenue for each transaction. So every amount of revenue earned from a transaction with only one item will be added together. And there's our total. Since this is revenue, we'll change the format of the number to currency so it shows up as dollars and cents. So the transactions with exactly one item earned $1,555 in revenue. Let's see how much the transactions with more than one item earned. Okay, let's check out the results. Just like with our COUNTIF examples, the second SUMIF formula will be the same as the first except for the condition, which will make greater than 1. When we run the formula, we discover that the revenue total is much higher, $4,735. This makes sense since the revenue is coming from transactions with more than one item. Good news. To complete our objective, we'll do 2 more quick calculations. First, we'll find the average revenue per transaction by dividing each total by its count. This will show our stakeholders how much of a difference there is in revenue per transaction between one item and multiple item transactions. This information could be useful for lots of reasons. For example, figuring out whether to add a discount on purchases with more than one item to encourage customers to buy more. We'll put these calculations in the last column of our summary table. You might remember that we use a slash in a formula as the operator for division calculations. The average revenue for transactions with one item is $62.20. And the average revenue for transactions with more than one item is $205.87. And that's it for our analysis. Our summary table now gives stakeholders and team members a snapshot of the analysis that's easy to understand. Our COUNTIF and SUMIF functions played a big role here. Using these functions to complete calculations, especially in large data sets, can help speed up your analysis. They can also make counting and adding a little more interesting. Nothing wrong with that. And coming up, we'll explore more functions to make your calculations run smoothly. Bye for now. Hi again. Data analysts love discovering new ways to work on their analysis, especially when those new ways simplify their work. I know I'm a big fan of learning new tricks to complete tricky tasks. Instead of trying to find a new way to do something every time I do an analysis, I try to learn from other people by asking questions and getting help when I need it. The people I work with like to use the phrase, stealing with pride. All this means is that you should feel no shame for using a process in your analysis that you learned from someone or somewhere else. Fellow team members, message board posts, online searches, I've used all of these resources for ideas, with pride. Of course, I always cite my sources when I do. That's a super important step to remember. The SumProduct function is also one of those tricks that analysts come across either on their own or from another source. You can also think of it as a shortcut for doing more complex calculations. We'll show you how SumProduct works and when you might use it to make your work life simpler. SumProduct is a function that multiplies arrays and returns the sum of those products. And here's what the SumProduct formula looks like. Equal sign, the SumProduct, followed by an open parentheses and arrays being multiplied and then added together. Each array is separated by a comma. An array is kind of like a range in a spreadsheet, but keep in mind, an array is a collection of values in cells, not the cells themselves. So when added to a formula, the SumProduct function multiplies each of the values in 2 or more arrays together. For example, each value in the array of cells B3 through B7 can be multiplied by its corresponding value in the array of cells C3 through C7. So B3 times C3, B4 times C4, and so on. It'll then return the sum of all of those multiplications. Let's check out an example using data from a kitchen supplies company. You might remember this example from our COUNTIF and SUMIF video. We've been given some data about a product order, including the quantity of each product that was sold in the order and the unit price, which tells how much one of each product cost. Our job is to use the data in these 2 columns to find out the total revenue for this order. And that's where SumProduct comes in. To find the total revenue, we need to do both addition and multiplication calculations. So first off, we need to find the revenue that each item brought in separately. If we did this without SumProduct, we'd have to multiply each quantity by its unit price, 50 times $1.25, 25 times $5, and so on. Then we'd have to add all of those revenue amounts together to get the total revenue. Fortunately, the SumProduct function does all of that for us. Let's add the label total revenue in cell G5 and then click G6 to input our formula. We'll then start our formula with an equal sign and the function, followed by an open parentheses. It's good to remind ourselves that the arrays we add to our formula should always be inside the parentheses. Next, we'll select cells B3 through B7 for the first array, followed by a comma. The comma acts as a separator between the two arrays in the formula. Then we'll select cells C3 through C7 for the second array, followed by a close parentheses to complete our formula. We don't need to include the brackets in our actual formula. We included them in the syntax example to clearly define each array for you. Then we press Enter to get our total revenue. Since we're dealing with revenue, we'll format the number as currency. So we've learned the total revenue is $655, but that's not the actual profit from the sales of these kitchen supplies because we haven't included the profit margin in our calculations. The profit margin is a percentage that indicates how many cents of profit have been generated for each dollar of sale. So in our data set, product number 789 has a profit margin of 20%, meaning each product sold earns a total profit of 20 cents for every dollar. And just like the calculation for revenue, we can save time finding profit margin by using the sum product function. There's only one difference between the formula for profit margin and revenue in this spreadsheet, but it's an important difference. To start, in cell G7, we type the same first part of the formula. Then we include the two arrays in the same way as well. But instead of ending our formula, we add another comma, followed by another array. This time, we'll select the cells with the profit margin, D3 through D7. We'll finish our formula and our calculation is complete. The sum product function saved us from having to multiply each individual revenue amount by each profit margin percentage, then add each profit margin amount together. Using sum product for calculations is a time saver and helps you avoid making mistakes. Definitely a trick worth remembering. And there's more worth remembering about calculations coming up next. Hey there! By now we've learned a lot about functions and formulas. They are very helpful tools for your toolbox and great for finding shortcuts to complete calculations. But there's another tool out there that does some of the same things in a spreadsheet, the pivot table. As a quick reminder, pivot tables let you view data in multiple ways to find insights and trends. We've talked before about how pivot tables help with cleaning and organizing your data, including sorting and grouping data. But pivot tables can also help with calculations. For example, they're great for quickly calculating sums and averages. Let's revisit our movie data set to show you how pivot tables and calculations work hand in hand. Earlier, we summarized and organized this data in pivot tables. We'll do that here too, but in this case, the organization is a bonus to using pivot tables for calculations. You can do these steps in Excel as well, though some of the steps might look different. In this example, your manager asked you to find some trends to help them think through new movie ideas using revenue calculations. This spreadsheet has data about movies from several years ago, so it probably wouldn't be as useful right now. Still, the steps we take to analyze the data absolutely apply then and now. So let's get into it. First, we need to find out how much revenue was generated each year. A pivot table is a good way to organize this, so we'll build a pivot table to show this. In our pivot table, we can also find the average revenue per movie. We can then check our findings for some possible trends. We'll start by finding the revenue generated each year. This gives us the release date for each movie in column B and the box office revenue in column N. Instead of organizing the table by year and building a formula to calculate the revenue per year, we'll create a pivot table. We'll add the pivot table in a new sheet, keeping the data range from cell A1 to cell N509. Adding a new sheet is especially helpful when working in a large data set like this. It helps keep our calculations together in one place and separate from the rest of the data. We'll rename this new sheet Revenue to call out where our calculations are, both for ourselves and for anyone else on our team who might need our analysis. Now we can build our pivot table starting with the rows. We'll sort the rows by release date to find the revenue for each year. You might notice this creates a row for every date on which one or more movies in this dataset was released. Since we only need the years, we'll right-click in one of the cells in the release date column to create a pivot date group, and we'll group by year. Now we have one row for each year in which these movies were released. Next, we want to work with values. We'll add the box office revenue data here. This populates the column next to the release dates with the total box office revenue in each year. These calculations are automatic because the pivot table is already set to summarize the data using the sum function. So no need to change this setting. There's other functions in the Summarize By menu though, like min for the minimum amount of revenue for each year and count for the number of movies that generated revenue in each year. Okay, let's check out what we've got here. This data shows that 2014 had the highest box office revenue while 2016 had the lowest. This might be useful information, but finding the average revenue per movie would most likely be more useful since there was a number of different movies released each year. So we'll add another column for the average revenue earned by each year's movies. We can do this in the same pivot table. We'll add another value and change the function that we use to summarize from sum to average. The average function gives us the average revenue per year for the movies in the data set. We can see that the average revenue in 2015 was much lower than in other years. Since this data stands out so much, let's keep exploring to find out why. Taking your analysis to the next level like this is a sign of a great analyst. When you're in your job, you want to answer the questions that your managers and stakeholders ask, but you also want to answer the ones that come up while you're doing your analysis. So let's try to figure this out. First, we'll note how many movies from each year were included in the dataset. We'll add a new value and use the count function this time. This shows us that there's more movies in the dataset from 2015 than from any other year. But 2015 still has the second lowest total box office revenue. This could mean a few things. It's likely that a lot of the movies from 2015 just didn't earn much revenue compared to the other years, which would bring down the overall average revenue even if the total revenue remained on par with the other years. We'll explore just this one possibility here, but you can always go further when you analyze data in your own job. It'll depend on your objectives and the questions you need to answer. For now, let's copy and paste our pivot table so we can test our hypothesis. We'll rename the columns in our copy table to differentiate them from our original table. We'll name them based on the data we'll be looking at, which I'll explain in a moment. Another great pivot table feature that'll help us here is the filter option. Earlier you learned how this lets us filter data so we can look at only the values we need. So we'll select a cell in our copied pivot table and add a filter to the box office revenue. The filter will then be applied to the entire table. When we open the status menu, we can choose to filter the data to show specific values. But in our case, we want to filter by condition so we can figure out how many movies in each year earned less than $10 million of revenue. This is why we renamed our columns with a less than sign and an abbreviation for $10 million. The condition we'll use in our filter is less than, and our value will be $10 million. We'll type our number in a dollar and cents format so the condition matches the data in our pivot table. This might not be necessary, but it prevents potential errors from happening. Now we know that 20 movies released in 2015 made less than $10 million. This seems like a high number compared to the other years, but keep in mind there were more movies from our dataset released in 2015 than the other years. It's still hard to tell how much of an impact these lower earning movies had on the average revenue. So let's run a quick formula to find the percentage of movies for each year that earned less than $10 million. This will make it easier to compare them from year to year. We'll create a customized column called a calculated field using our values menu. A calculated field is a new field within a pivot table that carries out certain calculations based on the values of other fields. You can do this in Excel too, using field settings and the create formula. To get our average, we'll divide the count from our movies under $10 million by the count for all movies in our original pivot table. After count and in open parentheses, between single quotes, we'll type a less than sign and then the rest of our column name in a closed parentheses. Then we'll type a slash as our division operator and we'll repeat the previous steps from our box office revenue count. Then we'll select Custom from our Summarize By menu since we're not using the sum function. That didn't work. We have an error message in the calculated field. It might be because we're using values from two different pivot tables. Let's first check that a calculated field will work in our copied pivot table. We'll change our formula to prove that calculated fields work and to verify that the values in our average column are accurate. For our new formula, we'll use the sum function and divide the sum of the box office revenue data from our original table by the count of the same data. Since we applied our filter for this pivot table earlier, the formula will only return the average revenue of movies under 10 million. Okay, that worked. So we know that it's not a problem with the calculated field. And as an added bonus, we were able to check the accuracy of some data. Always a good thing. But we still need to find the percentage of movies for each year that earned less than $10 million. So instead of a calculated field, we'll add a formula in a new column. Then we can use the values from both of the pivot tables we'll need for this calculation. We'll add a heading for our table in cell G10. We'll name it % of total movies. Then we'll add our formula to the next cell in the column. We'll divide the number of movies in the copy table by the number of movies in the original table. Next, we'll use the fill handle in the cell with our formula and drag it to apply the formula to the rest of the years. And to cap it off, we'll format these numbers as percentages. Now our analysis shows that 16% of the movies released in 2015 earned less than $10 million of revenue. The other years are all close to 10%. This is one possible explanation for why the average revenue is comparatively low in 2015. In real life, we'd most likely need to take our analysis even further and explore the data even more depending on our objectives. But for this video, our objectives are complete. You've learned how you can use pivot tables to perform data calculations. It'll take practice, but pivot tables are worth it because they do more than calculate. They organize and filter data too. Pivot tables are also used to form the framework for lots of data visualizations, like graphs and other charts. You'll learn more about data visualizations soon. For now, though, take a second to breathe. We've covered a lot of complex ideas in the last few videos. Functions, formulas, and pivot tables are all great tools to use in your analysis, and with practice and experience, it'll feel like you've used them forever. Just take your time getting to know how they work. Use these videos and other resources, like the readings we've included, to explore them further. In the meantime, we'll discover how the spreadsheet calculations you've been learning about connect to calculations using SQL. Stay tuned. By now, you probably know that there's more than one way to do the daily task of a data analyst. Calculations are no exception. As we've shown in earlier videos, you can complete the same calculations in lots of different ways in spreadsheets. You can also complete them using SQL. In this video, we'll give you an overview of how SQL calculations compare to spreadsheet calculations. Let's look at the arithmetic operators that are used in both spreadsheets and SQL. An operator is a symbol that names the type of operation or calculation to be performed in a formula. As you learned earlier, the four basic arithmetic operators in spreadsheet formulas are the plus sign for addition, the minus or hyphen for subtraction, the asterisk for multiplication, and the / for division. These same operators calculate data in the same way when writing queries in SQL. The operators are embedded in the queries when pulling data from a database. Just like spreadsheet formulas, there's a few different ways to perform calculations using queries. Let's look at the syntax for one possible query. The syntax of a query is its structure. It should include all the specific details of the data you want to pull into a new table where those details should be placed. So if you want to add values from two columns of a table, you start with the select command, followed by the name of your first column, then the name of your second column. Then you'd add the names of both columns with a plus sign between them. After that, you type as, followed by the name you'd like to give the column with the added totals. Finally, you then complete your query by typing from and then the name of the table that you're pulling the data from. Running this query would get you a table showing the two columns whose values are being added together, plus a new column showing the sums of those values. The operator in this query is a plus sign since values are being added. If you needed to subtract, multiply, or divide, you'd follow the same steps using the appropriate operators. If you need to use more than one arithmetic operator in a calculation, you'd use parentheses to control the order of the calculations. So if we included column C in our query, we could place parentheses around column A plus column B. We'd then add an asterisk if we're multiplying, followed by column C. This query would return in a new column the sum of the values in column A and B multiplied by the values in column C. All right, now let's say you only wanted the remainder from a division calculation. Well, you need a different operator for this, the modulo operator. The modulo operator is represented by the % symbol. This is an operator that returns the remainder when one number is divided by another. In a spreadsheet, you could complete the same calculation using the mod function. This brings us to another similarity between calculations in spreadsheets and SQL. A lot of times, you can use functions instead of operators to complete calculations. For example, the sum function can complete addition problems in spreadsheets and SQL. The average function in a spreadsheet is the same as the AVG function in SQL. They both return the average value of a set of numbers. In SQL, these functions are considered aggregate functions because they perform a calculation on one or more values and return a single value. You'll learn more about how they're used with the group by command in a query soon. So those are the basics of SQL calculations. Knowing how to write a query for a calculation is a good first step. Stay with us and you'll learn more about calculations in SQL. Bye for now. Hi again. Earlier we showed you how to complete calculations in SQL. While there's a few different ways, embedding them in queries is a very useful one. When you include a calculation in a query with other commands, you can do more work faster. Here's a basic query syntax that we talked about. We start with select and then the names of the columns we want to use in our calculations. Then we add in calculation details, including an operator like a / for division. Next, we type as, followed by the new column's name to label the column with the calculated values. Finally, we end our query with the from command and the name of the table that we're pulling data from. Now let's take it to the next level with some embedded calculations that use a syntax like this one. Even better, we'll do this with some data about avocados. Sorry to those of you who aren't avocado lovers like me. Okay, let's get started. Feel free to continue watching as we show you the steps using BigQuery. If you're joining us, open up your tool of choice for using SQL. Be sure to look through the instructions in the reading right before this video to help you get started. Okay, data's already loaded, so we can jump right in. Our goal is to find out the total number of bags of avocados sold on each date at each location using this data. There's already a column that shows us the total, but we want to make sure we understand how that total is calculated. We want to make sure that the total column is just small, large, and extra large bags added together. So we'll add the values in those three columns together in our query and then compare them to the total bags column in the dataset. We'll start with the select command, which we'll use to pull certain columns from the table. We are selecting several columns, so we'll press enter after select and after the comma after each column name. Next, we'll type those column names. Date, region, small underscore bags, large underscore bags, extra large underscore bags, and total underscore bags. Underscores are the lines used to underline words and connect text characters. Using spaces can confuse certain servers and applications, so using underscores instead helps avoid potential issues while keeping the names readable. Now we'll add the calculation to the query using the names of the three columns with plus signs between them. Small bags plus large bags, plus extra large bags. Since we want this calculation in a new column, we'll use the as command to name the column total underscore bags underscore calc. We've added the word calc so we can compare the columns to each other after we calculate our results. Now, we'll finish our query with from and the name of the dataset and subset we're pulling from, avocado underscore data dot avocado underscore prices. Okay, let's run the query. In the total bags calc column, the data shows the sum of each date for the number of small, large, and extra large bags of avocados that were sold at each location. If we quickly compare the two columns showing the total number of bags, we learn that the values are the same. This lets us know that the data we want to use is the right data. Now that we have verified the total number of bags, we can use those values in another query. We need to find what percent of the total number of bags were small bags. Finding this out might help stakeholders make decisions on how to package avocados or which size bag to run a sale on. Our job is to get that information to the stakeholders, so we'll set up a new query. We'll select the date, region, total bags, and small bag columns for this query. Next, we'll set up a new column starting with our calculation. To find the percentage of small bags, we need to first divide the number of small bags by the number of total bags using a slash as the operator. We'll put this part of the calculation in parentheses to let the server know that this calculation should be performed first. Then we'll multiply this total by 100 using an asterisk as our operator. Multiplying by 100 gives us a value that's a percentage instead of a decimal. Percentages usually make it easier for people to understand quickly when you share results with them. We'll use the as command to name this new column small bags percent. Then we'll add from and the name of the set we're pulling from. And we'll run our query. Oops, we got an error in our results. It says that we can't divide by 0. Since we're finding percentages, dividing by 0 won't work. This means that somewhere in the data set, there's a total bags equal to 0. We'll have to fix this in our query. We can fix this using the where command. Where lets us add a condition to our calculation. So after we type where, we'll type total underscore bags followed by a less than sign and then a greater than sign. These symbols tell the server that the values we're calculating should not be equal to the value we specify. In this case, that value's 0, so we'll add a 0 to our query. Now, when we run the query, you'll notice our new column shows the percent of small bags in the total bags count. We'd get the same results if we used an exclamation mark followed by an equal sign in place of the less than and greater than signs. Note that this is one way for doing it, but there are functions such as safe divide that also allow you to avoid this error. Those are just a couple of examples to get you started, but with SQL, you can complete just about any calculation you want during your analysis. And embedding the calculations in your queries will help you keep your analysis organized while getting your results. The calculation methods we showed you here are just the beginning, so look for more coming up. See you soon! Hey, good to see you. As a data analyst, you'll find that your calculations come in all shapes and sizes. Earlier, we showed you how to do some of the more basic calculations in SQL. While basic calculations are great, sometimes you'll need to group data before completing calculations. The group by and order by commands help you do this. These commands are usually paired with aggregate functions like sum or count. We'll show you how you can use these commands and functions to calculate and summarize data from groups of rows in a table. Let's explore the group by command first. Group by is a command that groups rows that have the same values from a table into summary rows. The group by command is used with select statements. In a basic select from or select from where query, group by comes at the end of the query. All right, let's try using group by. We'll work with a database with data from a bike sharing system. We want to find out how many rides people took on these bikes per year. This data has several columns, but for this task, we only need the start time column. Since this data set isn't organized by date and the start time column isn't organized by year, we'll need to include steps in our code to organize it. We also want a total number of rides each year, so we'll need to include a calculation in our query for this. And depending on the questions we've been tasked with answering, this might be the first step of many in our analysis. We'll start our query with the select command. We'll then add extract to our query. The extract command lets us pull one part of a given date to use. We'll extract the year from the start time column. To do this, we'll add an open parentheses followed by year, which lets the server know the part of the date we need. Then we'll add the from command and start time, so we can get the year from all of the start times in that column. We'll close the parentheses and then use as and the word year to name the column we're creating. On the next line of the query, we'll use the aggregate function count followed by an asterisk in parentheses. This will count the bike rides in the start time column. Using the asterisk, make sure that all the start times are counted in the data. Then we'll name our column number of rides with underscores between each word instead of spaces. We'll add from in the database we're pulling on the next line. In this case, that's BigQuery-public-data.new_york.citybike_trip. And here's our group by command. We'll use this to group the data by year. So we'll type group by followed by year. We can further organize our results by using the order by command. Adding this after group by orders the results. We'll add year to order the data by year. It's good to note that by default, order by sorts data in ascending order. Now we can run our query to get the results. The years are ordered starting with 2013 and ending with 2016. If we want to change this to descending order, we can add the keyword DESC to the end of the query and run it again. But whichever order you use, the group by and order by commands are great for helping us complete and organize a calculation for our analysis. This is one way to include calculations when aggregating data. And it's just one of many ways that SQL helps keep your analysis running smoothly and moving forward. There's still more to come on calculations in SQL. Coming up, we'll learn more about data validation. See you soon. Hi again. Earlier we covered data validation, a spreadsheet function that adds drop-down lists to cells. Using data validation lets you control what can and can't be entered into your worksheet. One of its uses is protecting structured data and formulas in your spreadsheets. But as useful as it is, the data validation function is just one part of a larger data validation process. This process involves checking and rechecking the quality of your data so that it is complete, accurate, secure, and consistent. While the data validation process is a form of data cleaning, you should use it throughout your analysis. If this all sounds familiar to you, that's good. Ensuring you have good data is super important. And in my opinion, it's kind of fun because you can pair your knowledge of the business with your technical skills. This will help you understand your data, check that it's clean, and make sure you're aligning with your business objectives. In other words, it's what you do to make sure your data makes sense. Keep in mind, you'll build your business knowledge with time and experience. And here's a pro tip. Asking as many questions as possible whenever you need to will make this much easier. Okay, let's say we're analyzing some data for a furniture retailer. We want to check that the values in the purchase price column are always equal to the number of items sold times the product price. So we'll add a formula in a new column to recalculate the purchase prices using a multiplication formula. Now, comparing the totals, there's at least one value that doesn't match the value in the purchase price column. We need to find an answer to help us move forward with our analysis. By doing some research and asking questions, we find that there's a discount of 30% when customers buy 5 or more certain items. If we hadn't run this check, we could have missed this completely. You've learned that as an analyst, calculations are a big part of your job. So it's important that whenever you do calculations, you always check to make sure you've done them in the right way. Sometimes you'll run data validation checks that are common sense checks. For example, let's say you're working on an analysis to figure out the effectiveness of in-store promotions for a business that's only open on weekdays. You check to make sure that there's no sales data for Saturday and Sundays. If your data does show sales on weekends, it might not be a problem with the data itself. It might not even be a problem at all. There might be a good reason, like maybe your business hosts special events on Saturdays and Sundays. Then you would have sales for those weekends. You still might want to leave out the weekend sales in your analysis if your objective is only to look at the weekdays. But doing this data validation might save you from miscalculations and other errors in your analysis. You should always do data validation no matter what analysis tool you're using. In an earlier video, we used SQL to analyze some data about avocados. One of the queries was a check to make sure the data showing the total number of bags was the sum of small, large, and extra large bags. By running this query, we were able to determine that the total number column was accurate. We compared our two columns briefly in that video, but to be absolutely sure that there's no issues with the data values in those columns, we could have also run another query. In this query, we would select all using the asterisk and from the avocado prices dataset. In our where clause, we'd also type out where our calculated total does not equal the total bags column. If no values are returned, we can be sure that the values in the total bags column are accurate. And that led us to continue our analysis. But when we tried to find what percent of the total number of bags was small, we ran into a small problem. We received an error message about dividing by 0. We fixed that error by adjusting our query. If we had linked that query to a presentation that went to our stakeholders, they'd show us the divide by 0 error instead of the figures we wanted. By building in these types of checks as part of your data validation process, you can avoid errors in your analysis and complete your business objectives to make everyone happy. And trust me, it's a great feeling when you do. And another great feeling is knowing that you've made it through another video and learned something new. And we have more where that came from coming soon. See ya! Hello again. Now if you're like me, you always have sticky notes available nearby to write a reminder or figure out a quick math problem. Sticky notes are useful and important, but they're also disposable since you usually only need them for a short time before you recycle them. Data analysts have their own version of sticky notes when they're working in SQL. They're called temporary tables, and we're here to find out what they're all about. A temporary table is a database table that is created and exists temporarily on a database server. Temp tables, as we call them, store subsets of data from standard data tables for a certain period of time. Then, they're automatically deleted when you end your SQL database session. Since temp tables aren't stored permanently, they're useful when you only need a table for a short time to complete analysis tasks like calculations. For example, you might have a lot of tables you're performing calculations on at the same time. If you have a query that needs to join 7 or 8 of them, you could join the 2 or 3 tables having the fewest number of rows and store their output in a temp table. You could then join this temp table to one of the other bigger tables. Another example is when you have lots of different databases you're running queries on. You can run these initial queries in each separate database and then use a temp table to collect the results of all of these queries. The final report query would then run on the temporary table. You might not be able to make use of this reporting structure without temporary tables. They're also useful if you've got a large number of records in a table and you need to work with a small subset of those records repeatedly to complete some calculations or other analysis. So instead of filtering the data over and over to return the subset, you can filter the data once and store it in a temporary table. Then you can run your queries using the temporary table you've created. Imagine that you've been asked to analyze data about the bike sharing system we looked at earlier. You only need to analyze the data for bike trips that were over 60 minutes or longer, but you have several questions to answer about the specific data. Using a temporary table will let you run several queries about this data without having to keep filtering it. There's different ways to create temporary tables in SQL, depending on the relational database management system you're using. We'll explore some of these options soon. For this scenario, we'll use BigQuery. We'll apply a with clause to our query. The with clause is a type of temporary table that you can query from multiple times. The with clause approximates a temporary table. Basically, this means it creates something that does the same thing as a temporary table. Even if it doesn't add a table to the database you're working in for others to see, you can still see your results, and anyone who needs to review your work can see the code that led to your results. Let's get this query started. We'll start this query with the with command. We'll then name our temp table trips _ over _ 1 _ HR. Then we'll type the as command in an open parentheses. On a new line, we'll use the select from where structure for our subquery. We'll type select followed by an asterisk. You might remember the asterisk means you're selecting all the columns in the table. Now we'll type the from command and name the database set we're pulling from. BigQuery-public-data.new _york.citybike_trips. Next, we'll add a where clause with the condition that the length of the bike trips we need in our temp table are greater than or equal to 60 minutes. In the query, it goes like this: trip duration space greater than sign equal sign space 60. Finally, we'll add a close parentheses on a new line to end our subquery. And that sets up our temporary table. Now we can run queries that'll only return results for trips that lasted 60 minutes or longer. Let's try one. Since we're working in our version of a temp table, we don't need to open a new query. Instead, we'll label our queries before we add our code to describe what we're doing. For this query, we'll type 2 hashtags. This tells the server that this is a description and not part of the code. Next, we'll add the query description. Count how many trips are 60 plus minutes long. And then we'll add our query. Select, then on a new line, count with an asterisk in parentheses, and as followed by CNT to name the column with our count. Next, we'll add from and the name we're using for our version of a temporary table, trips over 1 hour. When we run our query, the results show the total number of bike trips from the dataset that lasted 60 minutes or longer. We can keep running queries on this temp table over and over as long as we're looking to analyze bike trips that were 60 minutes and over. And if you need to end your session and start a new runtime later, most servers store the code used in temp tables. You'll just need to recreate the table by running the code. When you use temporary tables, you make your own work more efficient. Naming and using temp tables can help you deal with a lot of data in a more streamlined way, so you don't get lost repeating query after query with the same code that you could just include in a temp table. And here's another bonus to using temp tables. They can help your fellow team members too. With temp tables, your code is usually less complicated and easier to read and understand, which your team will appreciate. Once you start to explore temporary tables on your own, you might not be able to stop. Don't say I didn't warn you. Coming up, we'll explore even more things you can do with temp tables. See you soon. Hello there. Earlier, we introduced you to temporary tables. They're a great resource to use during your analysis because they help you keep your SQL code organized and efficient. You learned how to use a with clause to create a type of temporary table, and now we'll get into some other ways you can create temp tables, along with the pros and cons they present. And that's one of the great things about data analytics. There's almost always more than one way to get your analysis done. The select into statement is a good example of how to get a temp table done. This statement copies data from one table into a new table, but it doesn't add the new table to the database. It's useful if you want to make a copy of a table with a specific condition, like a query with a where clause. So far, we've been using BigQuery to show you how SQL works, but BigQuery doesn't currently recognize the select into command. Instead, here's an example of how a select into statement might look in another RDBMS. In this statement, a new table named Africa Sales is created using the data from the global sales database about the African region. Using select into is a good practice when you want to keep the database uncluttered and you don't need other people using the table. Now, if lots of people will be using the same table, then the create table statement might be the better option. This statement does add the table into the database. So if everyone needs access to the Africa sales table, your query would start with create table followed by the same select from where query as in the select into statement. In most relational database management systems, or RDBMSs, you can add metadata to describe the data that's contained in the table you've created. This can help make the table easier to understand for anyone using it. The create table statement is also useful for tables that are more complex. For example, if the code's difficult to replicate, then making a temp table in this way means it'll be saved for you to access later. The way you create a temporary table using the with clause or a select into or create table statement is usually up to you and your needs. The more you work in SQL, the more you might have preferences as well, especially since there's more than one way to create temporary tables. You may also find that you're working in an RDBMS that uses a different syntax. For example, you might need to use a create temp table statement instead of create table. Here's some good news. The syntax that you need for each unique RDBMS is usually pretty easy to find with a quick online search. But no matter how or where you create temporary tables, there isn't much downside to them. It's good to note, though, that sometimes building a temp table can interrupt your workflow. Again, that'll depend on your objectives and your preferences. You can repeat your code over and over instead of making a temp table, but that usually leaves your queries less readable and more vulnerable to typos. As you continue exploring the world of data analytics, you'll find that temporary tables are just one of the many resources you'll be able to use. And the more you use them, the easier it'll be to navigate that world. You completed another course. Congrats. We've still got some more to learn, but you can always go back and review what you've covered already. Coming up, you'll meet my colleague Kevin. Kevin can't wait to show you everything the next part of the program has to offer. And now that you're familiar with lots of different ways to analyze data, you'll be ready to share your analysis results through visualizations and reports. Up next, we'll focus on helping you develop your data visualization skills with tools like Tableau that'll help you get your visualizations looking great. You'll also learn how sharing your data is really about telling the story of your data and how it answers the questions that prompted your analysis. Finally, you'll learn what it takes to make an effective presentation and how to manage and respond to the questions. Thanks so much for joining me in exploring the world of data analytics. You've made it this far, so be proud, and keep it up as you move to the next course.
Hey there. It's great to see how far you've come in this Google Data Analytics Certificate. So first off, I want to say congrats on your achievement. And second, welcome to your next course. It's all about the art of data storytelling through visualization. As a data analyst, you can do all the necessary work of planning, collecting, cleaning, and analysis. But you also need to show stakeholders what your data means in a compelling way using visuals. We're here to show you how that's done. And with my experience as Director of Analytics at Google, I hope I'll be a pretty good guide. My name's Kevin, and I'll be your instructor for this course. This part of your training is particularly meaningful to me because I love data storytelling. I can't think of anything in today's business world that's more vibrant, more exciting, and more rewarding. With the amount of data we have around us, data analytics plays a key role in pretty much every part of business. In my opinion, there isn't a skill that's more important to you as an analyst than being able to effectively communicate the stories you uncover to stakeholders. Stakeholders usually lack the time, access to data, or expertise needed to find those stories by themselves. That's why we'll focus on visualizing data to help you better share data stories, which means we're now at the share phase of the data analysis process. We'll start with the basic concepts of visualization and why visualizing your analysis is such an important part of data analytics. From there, we'll discuss how to plan for and start building effective visualizations that are inclusive, accessible, and consider the audience first. Afterwards, we'll explore one possible tool you can use for data visualization, Tableau. Tableau helps us create visualizations from our analysis so that we can share our findings more effectively. We'll show you how data visualizations, including visual dashboards, can help bring your data to life. We'll also explore how you can use visualizations in your presentations and slideshows to continue telling a story with data. We'll discuss the art and science behind effective presentations. Finally, you'll learn how to anticipate and answer questions from stakeholders and respond to their feedback. Throughout the course, I'll guide you through what I think is the most exciting part of the data analysis process. By the end, you'll have everything you need to plan, create, and present effective and compelling data visualizations. Now that we've gotten to know each other a little, it's time to get down to business. Coming up, we'll talk a bit about the history of data visualization and why visualizations matter so much today. We'll also discuss the methods for using imagery effectively and what you can do to make the most out of your visuals. See you there. Data analytics is the collection and analysis and then use of data to tell stories using charts and visualizations so that businesses can make better decisions. So I've always loved numbers and have always enjoyed math and calculus and those sorts of things. So data came really easy to me. I was working at a consultancy before and using lots of numbers, and I enjoyed it for sure, but it wasn't until I worked at an advertising agency where I saw the creative expression of numbers and how data could drive that creativity that it really all fell into place for me. And I realized that doing analytics in a marketing and an advertising setting was exactly what I wanted to do. And I found that I just really enjoyed when we put those two things together. I think the visuals that come out of data analysis and data analytics are really beautiful. But what is even more interesting for me are the stories behind them. If you look at a big block of text or a big block of numbers, those stories are in there, but they really have to be found. And so it takes certain skill to pull those things out. And I find that skill, that analysis, really exciting and interesting. But it ultimately then ends in a beautiful visualization, which I find very gratifying. You know, there are great data visualization thinkers, and you see these visuals all over the place. You can find inspiration from looking at news outlets today and seeing the visuals that they present and how they tell stories that way. Visualizations have become so important that you can find them everywhere, and you can take great inspiration from that. But I also take inspiration from unlikely sources like photography and art and others, and seeing how composition is created, how color is used. I think that's really important, and I try hard to bring those sorts of elements and those sorts of influences into the visualizations I create. So I know this course is pretty intense. We are throwing a lot at you. Your brain is probably overloaded. You're probably fried. Just stick with it. It is all going to start to piece together and make sense. The biggest thing that I think you can think of is just how important these skills really are. This is the new way of doing business, involving data, using the analytics tools and techniques that we're talking about to make decisions. So there's a great big reward waiting for you at the end of this course. I'm Kevin. I am Director of Analytics here at Google. Welcome back, future data analyst. As a budding analyst, you'll be exposed to a lot of data. People learn and absorb data in so many different ways, and one of the most effective ways that this can happen is through visualization. Data visualization is the graphic representation and presentation of data. In reality, it's just putting information into an image to make it easier for other people to understand. If you've ever looked at any kind of map, whether it's paper or online, then you know exactly how helpful visuals can be. Data visualizations are definitely having a moment right now. Online, we are surrounded by images that show information in all kinds of ways. But the history of data visualization goes back way further than the web. Visualizing data began long ago with maps, which are the visual representation of geographic data. This map of the known world is from 1502. Map makers continued to improve their visualizations as new lands were charted. New data was collected about those locations, and new methods for visualizing the data were created. Scientists and mathematicians began to truly embrace the idea of arranging data visually in the 1700s and 1800s. This bar graph is from 1821, and it doesn't look too different from bar graphs that we see today. But since the beginning of the digital age of data analytics in the 1990s, the scope and reach of visualizations have grown along with the data they graphically represent. As we keep learning how to more efficiently communicate with visuals, the quality of our insights continue to grow too. Today, we can quantify human behavior through data, and we've learned to use computers to collect, analyze, and visualize that data. As an analyst in today's world, you'll probably split your time with data visuals in two ways: looking at visuals in order to understand and draw conclusions about data, or creating visuals from raw data to tell a story. Either way, it's always good to keep in mind that data visualizations will be your key to success. This is especially true once you reach the point where you're ready to present the results of your data analysis to an audience. Getting people to understand your vision and thought process can feel challenging, but a well-made data visualization has the power to change people's minds. Plus, it can help someone who doesn't have the same technical background or experience as you form their own opinions. So here's a quick rule for creating a visualization. Your audience should know exactly what they're looking at within the first 5 seconds of seeing it. Basically, this means the visual should be clear and easy to follow. In the 5 seconds after that, your audience should understand the conclusion your visualization is making, even if they aren't totally familiar with the research you've been doing. They might not agree with your conclusion, and that's okay. You can always use their feedback to adjust your visualization and go back to the data to do further analysis. So now let's talk about what we have to do to create a visualization that's understandable, effective, and most importantly, convincing. Let's start from the beginning. Data visualizations are a helpful tool for fitting a lot of information into a small space. To do this, you first need to structure and organize your thoughts. Think about your objectives and the conclusions you've reached after sorting through data. Then think about the patterns you've noticed in the data, the things that surprised you, and of course, how all of this fits together into your analysis. Identifying the key elements of your findings helps set the stage for how you should organize your presentation. Check out this data visualization made by David McCandless, a well-known data journalist. This graphic includes 4 key elements: the information or data, the story, the goal, and the visual form. It's arranged in a 4-part Venn diagram, which tells us that all 4 elements are needed for a successful visualization. So far, you've learned a lot about the data used in visualizations. That's important because it's a key building block for your visualization. The story or concept adds meaning to the data and makes it interesting. We'll talk more about the importance of data storytelling later, but for now, just remember that the story and the data combined provide an outline of what you're trying to show. The goal or function makes the data both useful and usable, and the visual form creates both beauty and structure. With just 2 elements, you can create a rough sketch of a visual. This could work if you're at an early stage, but won't give you a complete visualization because you'd be missing other key elements. Even using 3 elements gets you closer, but you're not quite finished. For example, if you combined information, goal, and visual form without any story, your visual will probably look fine, but it won't be interesting. On their own, each element has value, but visualizations only become truly powerful and effective when you combine all 4 elements in a way that makes sense. And when you think about all these elements together, you can create something meaningful for your audience. At Google, I make sure to develop visualizations to tell stories about data that include all 4 of these elements. And I can tell you that each element is a key to a visualization success. That's why it's so important for you, as the analyst, to pay close attention to each element as we move forward. Other people might not know or understand the exact steps you took to come to the conclusions you've made, but that shouldn't stop them from understanding your reasoning. Basically, an effective data visualization should lead viewers to reach the same conclusion you did, but much more quickly. Because of the age we live in, we're constantly being shown different ways to view and absorb information. This means that you've already seen lots of visuals you can reference as you design your own visualizations. You have the power to tell convincing stories that can change opinions and shift mindsets. That's pretty cool. But you also have the responsibility to pay attention to the perspectives of others as you create these stories. So it's important to always keep that in mind. Coming up, we'll start drawing connections between data and images to create a strong foundation for your visual masterpieces. I can't wait to get started. Hello again. Earlier we talked about why data visualizations are so important to both analysts and stakeholders. Now we'll discuss the connections you can make between data and images in your visualizations. Visual communication of data is important to those using the data to help make decisions. To better understand the connection between data and images, let's talk about some examples of data visualizations and how they can communicate data effectively. You've maybe come across lots of these in your daily life, and we'll explore them a little bit more here. A good place to start is a bar graph. Bar graphs use size contrast to compare 2 or more values. The horizontal line of a bar graph, usually placed at the bottom, is called the x-axis. In bar graphs with vertical bars, the x-axis is used to represent categories, time periods, or other variables. The vertical line of a bar graph, usually placed to the left, is called the y-axis. The y-axis usually has a scale of values for the variables. In this example, the time of day is compared to someone's level of motivation throughout the whole work day. Bar graphs are a great way to clarify trends. Here, it's clear this person's motivation is low at the beginning of the day and gets higher and higher by the end of the workday. This type of visualization makes it very easy to identify patterns. Another example is a line graph. Line graphs are a type of visualization that can help your audience understand shifts or changes in your data. They're usually used to track changes through a period of time, but they can be paired with other factors too. In this line graph, we're using 2 lines to compare the popularity of cats and dogs over a period of time. With 2 different line colors, we can immediately tell that dogs are more popular than cats. We'll talk more about using colors and patterns to make visualizations more accessible to audiences later too. Even as the line moves up and down, there's a general trend upwards, and the line for dogs always stays higher than the line for cats. Now let's check out another visualization you'll probably recognize. Say hello to the pie chart. Pie charts show how much each part of something makes up the whole. This pie chart shows us all the activities that make up someone's day. Half of it's spent working, which is shown by the amount of space that the blue section takes up. From a quick scan, you can easily tell which activities make up a good chunk of the day in this pie chart and which ones take up less time. Earlier, we learned how maps help organize data geographically. The great thing about maps is they can hold a lot of location-based information, and they're easy for your audience to interpret. This example shows survey data about people's happiness in Europe. The border lines are well defined, and the colors added make it even easier to tell the countries apart. Understanding the data represented here, which we'll come back to again later, can happen pretty quickly. So data visualization is an excellent tool for making the connection between an image and the information it represents. But it can sometimes be misleading. One way visualizations can be manipulated is with scaling and proportions. Think of a pie chart. Pie charts show proportions and percentages between categories. Each part of the circle or pie should reflect its percentage to the whole, which is equal to 100%. So if you want to visualize your sales analysis to show the percentage of your company's sales that come from online transactions, you could use a pie chart. The size of each slice would be the percentage of total sales that it represents. So if your online sales accounted for 60%, the slice would be 60% of the whole pie. Now here's a misleading pie chart. It's supposed to show opinions about pizza toppings, but each slice or segment represents more than one option, and they all add up to well over 100%. There's lots of ingredients listed below the image that are not even included in the visual data, and all of the segments are the same size, even though they're supposed to be showing different values. If a visualization looks confusing, then it probably is confusing. Okay, let's explore another example where the size of the graphic components comes into play, this time with a bar chart. In a truncated bar chart like this one, the values on the y-axis don't start at 0. The data points start at 9,100 and are at intervals of 100. This makes it seem like the data, let's say it's for novel clicks per day on different website links, is fairly wide-ranging. In this view, website E seems to clearly receive way more clicks than website D, which receives more clicks than website C, and so on. While the graph is clear and the elements are easy to understand, the way the data is presented is misleading. Let's try to fix this by changing the graph's y-axis so that it starts at 0 instead. Now, the difference between the website clicks per day don't look nearly as drastic. By making the y-axis start at 0, we're changing the visual proportions to be more accurate and more honest. Some platforms always start their y-axis at 0, but other programs like spreadsheets might not fix the y-axis. So it's important to keep this in mind when creating visualizations. By following the conventions of data analysis, you'll be able to avoid misleading visualizations. You always want your visualizations to be clear and easy to understand, but never at the expense of communicating ideas that are true to the data. So, we've talked about some effective data-driven visualizations like bar graphs, line graphs, and pie charts, and when to use them. On top of that, we've discussed some things to avoid in your visualizations to keep them from being misleading. Coming up, we'll check out how to make those visualizations reach your target audience. See you then. Hey there. You're back and ready to learn how to create powerful data visualizations. Coming up, we'll explore how to take our findings and turn them into compelling visuals. Earlier, we discussed the relationship between data and images. Now we'll build on that to explore what visualizations can reveal to your audience and how to make your graphics as effective as possible. One of your biggest considerations when creating a data visualization is where you'd like your audience to focus. Showing too much can be distracting and leave your audience confused. In some cases, restricting data can be a good thing. On the other hand, showing too little can make your visualization unclear and less meaningful. As a general rule, as long as it's not misleading, you should visually represent only the data that your audience needs in order to understand your findings. Okay. Now let's talk about what you can show with visualizations. Change over time is a big one. If your analysis involves how the data has changed over a certain period, could be days, weeks, months, or years, you can set your visualization to show only the time period relevant to your objective. This visualization shows the search interest in news story topics like environment and science and social issues. The viz is set up to show how the search interest changes day to day. The bubbles represent the most popular topic on each day in a given part of the U.S. As news stories come up, the data changes to reflect the topic of those stories. If we wanted the data for weekly or monthly news cycles, we'd change the interactive feature to show changes by week or month. Another situation is when you need to show how your data is distributed. A histogram resembles a bar graph, but it's a chart that shows how often data values fall into certain ranges. This histogram shows a lot of data and how it's distributed on a narrow range from -1 to +1. Each bin or bucket, as the bar is called, contains a certain number of values that fall into one small part of the range. If you don't need to show that much data, other histograms would be more effective, like this one, about the length of dinosaurs. Here, the bins or buckets of data values are segmented, so you can show each value that falls into each part of the range. If your data needs to be ranked, like when ordering the number of responses to survey questions, you should first think about what you want to highlight in your visualization. Bar charts with horizontal bars effectively show data that's ranked, with bars arranged in ascending or descending order. A bar chart should always be ranked by value, unless there's a natural order to the data, like age or time, for example. This simple bar chart shows metals like gold and platinum ranked by density. An audience would be able to clearly see the ranking and quickly determine which metals had the highest density, even if this data viz included a lot more metals. Correlation charts can show relationships among data, but they should be used with caution because they might lead viewers to think that the data shows causation. Causation, or a cause-effect relationship, occurs when an action directly leads to an outcome. Correlation and causation are often mixed up because humans like to find patterns even when they don't exist. So if two variables look like they're associated in some way, we might assume that one's dependent on the other. That implies causation, even if the variables are completely independent. And if we put that data into a visualization, then it would be misleading. But correlation charts that do show causation can be effective. For example, this correlation chart has one line of data showing the average traffic for Google searches on Tuesdays in Brazil. The other lines for a specific date of search traffic, June 15th. So the data is automatically correlated because both lines are representing the same basic information. But the chart also shows one big difference. When a football match, or soccer match for Americans, began on June 15th, the search traffic showed a significant drop. This implies causation. Football is a very popular and important sport for Brazilians, and the data in this chart verifies that. We've now talked about time series charts, histograms, ranked bar charts, and correlation charts. Each of these charts can visualize a different type of analysis. Your business objective and audience will help figure out which of these common visualizations to choose. Or you may want to check out some other kinds of visualizations out there. There's also a glossary of visualizations that you'll be able to reference later. So that wraps up our lesson on creating visualizations. Coming up next, we'll add some more layers to your planning and execution of visuals. So hang on tight. Hey, great to see you again. So far, we've shown that there's lots of choices you'll make as a data analyst when creating visualizations. Each of your choices should help make sure that your visuals are meaningful and effective. Another choice you'll need to make is whether you want your visualizations to be static or dynamic. Static visualizations do not change over time unless they're edited. They can be useful when you want to control your data and your data story. Any visualization printed on paper is automatically static. Charts and graphs created in spreadsheets are often static too. For example, the owner of this spreadsheet might have to change the data in order for the visualization to update. Now, dynamic visualizations are interactive or change over time. The interactive nature of these graphics means that users have some control over what they see. This can be helpful if stakeholders want to adjust what they're able to view. Let's check out a visualization about happiness that we've created in Tableau. Tableau is a business intelligence and analytics platform that helps people see, understand, and make decisions with data. Visualizations in Tableau are automatically interactive. We'll go into the dashboard to see how the happiness score has changed from 2015 to 2017. We can check this out in our 12th slide, Yearly Happiness Changes. On the left are the country-level changes in happiness score. The countries are sorted by largest increase to largest decrease. On the right, there's a map with overall happiness scores. The color scale moves from blue for the countries with the highest happiness score to red for those with the lowest. If you look below the map, you'll notice a year-to-view slider where people can choose which year's happiness scores to display on the map. It's currently set for 2016, but if someone wants to know the scores for 2015 or 2017, they can adjust the slider. They could then make note of how the color coding and score labels change from year to year. Other dynamic visualizations upload new data automatically. These bar graphs continually update data by the minute and second. Other data visuals can do the same by day, week, or month. So if you need to, you can show trends in real time. Having an interactive visualization can be useful for both you and the audience you share it with. But it's good to remember that the more power you give the user, the less control you have over the story you want the data to tell. It's something to keep in mind as you learn how to create your own visualizations. You'll want to find the right balance between interactivity and control. Something else to consider is the choice between using a static or dynamic visualization. This will usually depend on the data you're visualizing, the audience you're presenting to, and how you're giving your presentation. Now that we've made some decisions about what kind of data viz we want to create, we can start thinking about the design, which is exactly where we're going to start talking about next time. See you there.
Hello, and welcome back. You probably didn't think you'd be learning about art in a data analytics course, but that's exactly what we're going to do. Both data analysts and artists use elements of art in their work. We'll introduce those elements to you here, and we'll show you how to apply them to visualizations later. The elements we'll check out are line, shape, color, space, and movement. Now, these aren't the only elements to consider, but these particular ones can add value to your data viz by making them more visually effective and compelling. Lines in visualizations can be curved or straight, thick or thin, vertical, horizontal, or diagonal. They can add visual form to your data and help build the structure for your visualization. These charts show some of the variety that lines can bring to your data viz. The combo chart shows two different types of lines, both providing a graphic for the data. The line chart does the same, but uses curved lines instead. Shapes are also known for their variety. Shapes and visualizations should always be two-dimensional. This is because three-dimensional objects in a visualization can complicate the visual and confuse the audience. Shapes are also a great way to add eye-catching contrast, especially size contrast, to your data story. This circle, used for a pie chart, lets someone quickly understand the data in a familiar format. Shapes with symmetry are usually more familiar to people, so there's less work for the audience to do when viewing symmetrical data viz. But the asymmetrical shapes in this map are still instantly recognizable as countries. It's good to note that the data you're sharing with your audience will usually inform the types of shapes you want to use in your data viz. Next, we have colors. And colors are, well, colors. Of course, in the eyes of artists and analysts, colors can be much more complex. Colors can be described by their hue, intensity, and value. The hue of a color is basically its name: red, green, blue, and so on. Intensity is how bright or dull a color is. And finally, there's value. The value is how light or dark the colors are in a visualization. In more scientific terms, value indicates how much light is being reflected. Dark values with some black added are called shades of color, like these shades of green. Light values with white added are called tints, like these tints of blue. In this map, there are shades and tints of gray. The value of these colors help us understand the population data in the map, and varying the color's value can be a very effective way to draw our audience's attention to specific areas.
Space is the area between, around, and in the objects. There should always be space in data visualizations, just not too much or too little. For example, the space between the bars of a bar graph, like this one, should be smaller than the width of the bars themselves. This will draw the viewer's attention to the bar and the data it represents instead of the empty space. Finally, there's movement. Movement is used to create a sense of flow or action in a visualization. One of my favorite examples is the data viz, The Wealth and Health of Nations. This viz showcases a correlation between the financial health and physical health of nations. It traces these elements over time so you can see how the two correlated effects play out. The movement pulls in data from the 1800s all the way up until recently. The interactivity allows for a greater volume of data to be displayed and will reveal multiple stories from the same data visualization. Remember, this is something that should be used sparingly. There's a fine line between attracting attention and distracting the audience. A static image lets you control all elements of the story you want to tell. When you start incorporating movement and interactivity, the story is controlled by whoever is controlling the interactivity, whether that's you or possibly your audience if you've turned control over to them. We'll discuss this delicate balance later on in the course. When you bring many of these art elements together in a visualization like this one about sea levels, it can be beautiful and provoking. It proves that there's a place for creative expression in data analytics. Coming up, we'll continue exploring ways to add meaningful creative expression to your data viz. Bye for now. Welcome back. Let's jump in. Hopefully by now we've developed a clear picture of data viz. We've explored everything from design principles to the types of charts you can use in your visualizations. Choosing the right visualization for your data findings can often come down to one question. Which one will make it easiest for the user to understand the point you're trying to make? No matter how complex your analysis is, your audience will only care about what's in front of them and how easy they can understand it. As you complete your analyses, you'll have to decide which visualizations serve your needs and your audience's needs for each task. For example, if you want to show a comparison of the different age groups of visitors to a website, a line graph with a line for each age group plus 1 for total users would work. But let's say you want to highlight the differences among the age groups to compare them more directly. For that, you might use a positive-negative bar chart like this. We've touched on this before, but let's make some more connections between the data you'll have after analysis and the visualizations you'll want to use for different cases. We'll start with some charts. You've worked with some of these before, and we'll cover more about charts with more examples later. You'll also discover that the best charts to suit your purposes might depend on the needs of your industry and company and the stakeholders who will be in your audience. For comparing data over time, we showed you how line graphs can be effective. Like in this one, bar graphs and stacked bar graphs, along with area charts, can also be good ways to visualize how data changes over time. By the way, there's a lot of charts out there. We'll give you as much information as possible about as many as we can, but doing your own research or practicing using them in visualizations will also be helpful. Okay, when you're comparing distinct objects, like in our example about mobile versus computer usage, ordered bar and grouped bar graphs and ordered column charts are useful. Then there's charts that show parts of a whole. This is known as data composition, and it's achieved by combining the individual parts of a visualization and displaying them together as a whole. Stacked bars, donuts, stacked areas, pie charts, and tree maps can do all this. Now, to show relationships in your data, you might want to use scatter plot and bubble charts, column line charts, and heat maps. Let's revisit the happiness data viz to show you an example of this. Each of these scatter plots show the relationship between a country's happiness score and one of the factors that contributes to that score. So the health versus happiness scatter plot shows a strong relationship between the life expectancy of people living in a country and how happy those people are. Basically, as life expectancy increases, so does their happiness score. Speaking of happiness, a successful data visualization results in a happy audience. So it's important to understand how your audience is viewing your data visualizations, since they should always be top of mind. And it all starts in the brain. When processing information, our brains try to find patterns and rely on visual context. As data analysts, we can use our understanding of the human visual system to produce better visuals. When we create visualizations, we can do so in a way that helps the audience process the information and helps them remember what they're seeing. Visual journalist Donna Wong proposes that effective visuals, like the data viz we've been discussing here, have three essential elements. The first is clear meaning. Good visualizations clearly communicate their intended insight. The second is a sophisticated use of contrast, which helps separate the most important data from the rest using visual context that our brains naturally look for. The third essential element for effective visuals is refined execution. Visuals with refined execution include deep attention to detail, using visual elements like lines, shapes, colors, value, space, and movement. In other words, the elements of art that we talked about earlier. The first rule in most businesses is to satisfy the customer. It's no different with data analytics. While your customers will probably be managers and other stakeholders, you should always think of them first when creating data visualizations. Think about the 5-second rule we called out earlier. If you make your data viz easy to look at and understand quickly, then you'll have done your job. And then you'll be satisfied, just like your customers. Coming up, we'll talk about design thinking and data visualizations. See you soon. Hey, welcome back. We've covered a lot of ground in our exploration of data visualizations. We've talked a lot about how your audience should be the focus when you are making decisions about charts, colors, space, labels, and everything else that goes into a data viz. Now let's talk about design thinking. Design thinking is a process used to solve complex problems in a user-centric way. When you bring design thinking into your work, you're trying to identify alternative strategies for your visualizations that might not be clear right away. You have to challenge your own thinking and explore different ways of approaching the problems and finding solutions. Airbnb is one example of a company that used a design thinking approach to help their business grow. When the company, a vacation rental online marketplace, wasn't generating as much revenue as they wanted, they decided to start experimenting. Even though the data they collected and analyzed was valuable, they needed to look at their product through the eyes of the customer. They realized the photos of the places that customers were seeing just weren't very good. So they decided to help their customers replace the not-so-great photos with more professional-looking ones. So they hired a photographer and went door to door to take professional photos of their New York City listings. In a week, the listings with these photos saw 2 to 3 times more bookings, and their revenue nearly doubled, thanks to their new design thinking, user-based mindset. If design thinking can work for companies like Airbnb, it can help data analysts too. And data visualization is the perfect stage of your analysis to apply a user-based mindset. If you use design thinking when planning and creating your data viz, you'll be making decisions based on the needs of the people who will be viewing them. This way, your audience will be engaged and enlightened by how you visualize your findings. While the design thinking process comes in lots of different forms, they all have stages or phases. We'll talk about 5 phases that you can use when creating data visualizations: empathize, define, ideate, prototype, and test. In the spirit of design thinking, these phases don't have to follow a set order. Instead, think of them as an overview of actions that can help you produce a user-centered design in your visualizations. In the empathize phase, you think about the emotions and needs of the target audience of your data viz, whether it's stakeholders, team members, or the general public. Here, you should avoid areas where people might face obstacles interacting with your visualizations. For example, Let's say you've been working on an analysis for a pharmaceutical company about how patients have been responding to a new treatment. You're getting ready to visualize the data, so you should think about the audience, which will include stakeholders like pharmacists, doctors, and other medical professionals. Maybe you're thinking of using a color scheme that you like, but you realize that these colors might be a challenge to some people. The colors might be too bright or dramatic, which might not be right for the seriousness of the data. Or the colors might not have enough contrast for people who have color vision deficiencies. By adjusting the colors, you'll be empathizing with the needs of your audience. If there's someone on your team who is vision impaired, you'll want to find a way to explain the data verbally as well. The define phase helps you define your audience's needs, their problems, and your insights. This goes hand in hand with the empathize phase, as you'll use what you learned in that phase to help you spell out exactly what your audience needs from your visualization. You could use this phase to think about which data to show in your visualization. Maybe this data viz will also be presented to patients who are part of your company's study. While you'll need to meet your objectives, there might be data that could make these people uncomfortable. You can think of ways to position that data to make it more digestible. Or, if you're presenting to different audiences, you can adjust your visualizations to meet each group's needs by seeking input from members of the group or colleagues who've worked with that group before. In the ideate phase, you start to generate your data viz ideas. You'll use all of your findings from the empathize and define phases to brainstorm potential data viz solutions. This might involve creating drafts of your visualization with different color combinations, or maybe experimenting with different shapes. Creating as many examples as possible will help you refine your ideas. The key here is to always remember your audience when coming up with ideas and strategies. You want to think about how you can position your visualizations to meet the needs and expectations of your audience. The final two phases are prototype and test. Here you'll start putting your charts, dashboards, or other visualizations together. If you've kept your audience in mind through all the phases to this point, then your data viz will be informative and approachable. You might want to create lots of visualizations to choose which one best meets your objective. You can test your visualizations by showing them to team members before presenting them to stakeholders. If you've created more than one for the same data or for different audiences, like the medical professionals and the patients from our earlier example, you can share all of your options. As always, listen to any feedback you get. Critiques, both your own and others, are key to the design thinking process. They help you keep your focus on the audience by integrating new ideas in your final product. The phrase thinking outside the box is used a lot, but it definitely applies here. The box, in this case, is your own usual way of approaching data and its visualization. If you embrace design thinking, you'll be able to create super effective data viz for any audience. Up next, we'll cover more things you need to consider within your data viz. See you there. Hey, great to have you back. Let's dive back in. Over 1 billion people in the world have a disability. That's more than the populations of the United States, Canada, France, Italy, Japan, Mexico, and Brazil combined. Before you design a data viz, it's important to keep that fact in mind. Not everyone has the same abilities, and people take in information in lots of different ways. You might have a viewer who's deaf or hard of hearing and relies on captions, or someone who's colorblind might look to specific labeling for more description. We've covered a lot of ways to make a data visualization beautiful and informative, and now it's time to take that knowledge and make it accessible to everyone, including those with disabilities. Accessibility can be defined a number of different ways. Right from the start, there's a few ways you can incorporate accessibility in your data visualization. You just have to think a little differently. It helps to label data directly instead of relying exclusively on legends, which require color interpretation and more effort by the viewer to understand. This can also just make it a faster read for those with or without disabilities. Check out this data viz. The colors make it challenging to read and the legend is confusing. Now if we just remove the legend and add in data labels, bam! you've got a clearer presentation. Another way to make your visualizations more accessible is to provide text alternatives so that it can be changed into other forms people need, such as large print, braille, or speech. Alternative text provides a textual alternative to non-text content. It allows the content and function of the image to be accessible to those with visual or certain cognitive disabilities. Here's an example that shows additional text describing the chart. And speaking of text, you can make data from charts and diagrams available in a text-based format through an export to Sheets or Excel. You can also make it easier for people to see and hear content by separating foreground from background. Using bright colors that contrast against the background can help those with poor visibility, whether permanently or temporarily, clearly see the information conveyed. Another option is to avoid relying solely on color to convey information and instead distinguish with different textures and shapes. Another general rule is to avoid overcomplicating data visualizations. Overly complicated data visualizations turn off most audiences because they can't figure out where and what to focus on. That's why breaking down data into simple visualizations is key. A common mistake is including too much information in a single piece or including long chunks of text or too much information in graphs and charts. This can defeat the whole purpose of your visualization, making it impossible to understand at first glance. Ultimately, designing with an accessibility mindset means thinking about your audience ahead of time, focusing on simple, easy to understand visuals, and, most importantly, creating alternative ways for your audience to access and interact with your data. And when you pay attention to these details, we can find solutions that make data visualizations more effective for everyone. So now you've completed your first close-up exploration of data visualization. You've discovered the importance of creating data viz that cater to your audience while keeping focus on the objective. You learned different ways to brainstorm and plan your visualizations and how to choose the best charts to meet that objective. And you also learned how to incorporate elements of science, art, and even philosophy into your visualizations. Coming up, we'll check out how to take all of these learnings and apply them in Tableau. You'll get to see how this data visualization tool makes your data viz work more efficient and effective. See you soon.
I'm Andrew, and I'm a data and insights manager on the ads research and insights team. What does that actually mean? I help my company, Google, make better decisions through data, and I also work with our data to tell stories for marketers. Basically data storytelling at scale. Accessibility should be built into everything we do. Accessibility is really about making sure that you are creating data visualization, graphs, charts, tables that anyone can interact with, whether they have a long-term or even just a temporary form of impairment. It could be auditory, it could be visual, it could be sensory in some way. Typically the ones we talk about in data visualization have to deal with color and contrast, or maybe they can't see. So there's a number of things you can do in your visualizations as you're getting ready to show people and bringing it out into the world to make it easier for them to understand your graph, to understand the points you're trying to make, and just to make your stuff more inclusive. You're going to create this stuff, and you're not going to be the one presenting it anymore. It's going to show up in a place where you won't be the one being able to navigate the data for people and frame it for people. And that's a good thing. But as it moves further away from you, you also won't be there standing by it, being able to explain it to people and be like, hey, here's the point. Or hey, maybe you can't read or see this, or maybe these colors are confusing. Let me make sure that you got the point clearly. It's just a way of making sure that everyone in the room is able to experience the thing you work so hard on and able to take away the point in a clear way that they too can basically take action on the data that you spent all this time working with and making presentable for folks. So all these things, they're great for accessibility and they're more inclusive, but they're also just making you a better data analyst and a better storyteller because they force you to become more empathetic of your audience and who's receiving your data. You're making this to move the hearts and minds of other people to convince someone else that this data is meaningful to them and they should take an action on it. or they should know this and they should use this for their organization or for their lives or for whatever the thing may be. And so by focusing on accessibility, by focusing on the audience, by making it more inclusive, you're making your data clearer and more impactful for everyone.
Hello again. We've already discussed how helpful data visualizations can be when we want to fit a lot of knowledge into a small space. Now it's time to explore a powerful tool that can help you create these visualizations and bring your data to life. It's called Tableau, a visual analytics platform that makes it a lot easier to explore and manage data. You might remember hearing a bit about Tableau in some of our earlier discussions, but you're about to discover even more. Plus, when you get comfortable with Tableau, you'll find it even easier to use similar tools, giving you another skill that'll help you stand out in the job hunt. Coming up, we'll cover some of the features that make Tableau effective for visualizations and why it's used across industries. After that, the fun really starts. We'll jump right in and explore the Tableau interface, identifying and applying the various tools it has to offer. I'll show you how to add data sources, control visual elements, and work with a variety of features that'll make your visualization really powerful. Like any software platform, there's some best practices to keep in mind, so I'll show you some examples of the good and the bad when it comes to visualizations. We'll also get creative, using color vision deficiency palettes to make our visualizations more accessible, and we'll show you how multiple data sources can be combined to tell a more comprehensive story. By the time we wrap up here, you'll be able to publish your own visualizations on Tableau. I am so excited to lead you on this Tableau tour. It's another useful tool that you'll be able to turn to as a future data analyst so that you can visualize and publish data you care about. After all, data has a story, and this is your chance to share it with others. All right, let's discover what it's all about. Welcome back. Mastering online tools like Tableau will make it easier for your audience to understand difficult concepts or identify new patterns in your data. Need to help a news outlet showcase changing real estate prices in regional markets? Check. Want to help a nonprofit use their data in better ways to streamline operations? Check. Need to explore what video game sales look like over the past few decades? Double check. Many different kinds of companies are using Tableau right now to do all of these things and more. This means there's a good chance you'll end up using it at some point in your career. But I'm getting ahead of myself. First, let's talk about what Tableau actually is. You might remember learning that Tableau is a business intelligence and analytics platform that you can use online to help people see, understand, and make decisions with data. But it's not all business all the time. Take this data viz, for example, created by Tableau enthusiast Eve Thomas to record Bigfoot sightings across the US. It's available on Tableau Public, which we'll be using together in our activities in this course. Tableau can help you make and easily share interactive dashboards, maps, and graphs with your data. Without any coding, you can connect to data in lots of formats like Excel, CSV, and Google Sheets. You might also find yourself working with a company that uses another option like Looker or Google Data Studio, for example. Like Tableau, Looker and Google Data Studio help you take raw data and bring it to life visually. But each does this in different ways. For example, while Tableau is offered in a variety of formats like browser and desktop, Looker and Google Data Studio are completely browser-based. But here's the great news. Once you learn the fundamentals of Tableau, you'll find they easily transfer to other visualization tools. Ready to get started using it? Then without further ado, meet Tableau, up next. Hello and welcome to the intersection of analytics and art, the place where data analysts like me go to unleash the true potential of data with meaningful visuals, and the place where future data analysts like you can also go to learn how to do this. Welcome to Tableau, one of the many visualization platforms that helps you do more with your data. When you turn data into a visualization, you get to watch it transform before your eyes into a meaningful story that people can connect to and care about. Visualizations in Tableau are dynamic, not static. As a quick refresher, dynamic visualizations are interactive or change with time. The interactive nature of these graphics means your audience has some control over what they see, and you have incredible flexibility with how you create them. So let's create our own visualization using a preloaded table on Tableau Public. It's important to note that there's different ways to create visualizations in Tableau. Tableau has a few different offerings, but for this course, we're using Tableau Public in browser, which is free. One cool thing about Tableau Public is the public gallery with data viz examples from across the web. For now, you'll be working with one of these examples from the gallery. You'll be copying over data workbooks to your own profile to start creating and publishing visualizations. To get started, sign into your Tableau Public account. You can check out an earlier reading for more details. Then, to access the workbook, open the Google Career Certificates page on Tableau Public by clicking the link included in this video and the reading from earlier. This opens a new tab that is still linked to your account. Here's what the page should look like. There are a few workbooks loaded up with different data sets that you can save to your own profile. These are a great starting point for creating your own visualizations. There will also be a resource following this video that goes through how to download Tableau and load your own data. But for now, let's use this gallery as a starting point. Now, click to view the workbook titled Just the Data, World Happiness. This brings up the data table we use to help create the World Happiness data viz that's in the gallery. Next, go to the menu in the upper right corner and click Make a Copy. At this point, Tableau will save a copy of this workbook to your own profile so you can create your own visualizations. Now that you're working in your own copy, create a new worksheet so you can build a data viz from scratch. You'll click on Worksheet in the top menu and then New Worksheet. To start building your data viz, add country as a detail in the Marks shelf. You can do this by dragging the country table over to the detail icon. This sets up your viz as a world map to represent the data in the table. Next, add the happiness score to the color on the Marks shelf. This applies a color scheme to the viz, in this case, shades of blue. This range of colors doesn't offer a lot of contrast, especially for people with color vision deficiencies. So to adjust the colors, click the Color menu and click Edit Colors. Then change the color scheme to green-blue diverging, and check the box for Stepped Colors, which shows a clearer difference between the highest and lowest happiness score. Darker blue means a higher happiness score, whereas darker green relates to a lower happiness score. You can see this broken down in the scale. So with just a couple of steps, we have an interesting visualization that shows happiness data in a way that's easy to digest. The countries and colors on the map are readable and offer some great insights. But let's keep going so we can explore more Tableau features to refine your data viz. Because there are 3 years of data in the table we're using, you can filter the data to only include 2016. Using multiple years can also be useful depending on your objective. Regardless, you have lots of options for filtering. So we'll add year to the filter shelf. Then we'll choose to filter by year. And we'll select 2016. Let's focus our visualization on one region, the European region. To do this, move your cursor to find the View toolbar. Use the tools in this toolbar to pan to and zoom in on the European region. This takes some time and practice. Once you have a pretty good view of Europe and its surrounding areas, use the Shape tools in the same toolbar to select as much of Europe as you can. Since we're practicing, make your best guess if you're not sure which countries to include. If you were working on a visualization that you were going to share with others, you'd want to double check that it was accurate. Hover your cursor over one of the countries and it shows you data about that specific country, as well as all the countries you've selected in the region. Then use the lasso selection tool to select just a few countries like this. Keep only. This applies another filter, this time to the country you're including in your viz. You'll notice that the color scheme of these countries is updated. This reflects that the range of colors is now only being applied to these countries. Countries in this region might have been in the same part of the range when compared to the rest of the world, but now they're in different parts because the data being measured is specific to this region. To make your viz even better, add the happiness score as a label in the map. You can now see a happiness score for each country on the map. This adds an extra layer of detail to the viz to help make a connection to the actual data. There's an option to change the data type of the happiness scores from decimals to whole numbers. But when you do this, you lose the contrast that the values with the decimals offers. So change it back to show the happiness score as a decimal. Now, to make it even more interactive, let's add a filter with a slider. This will allow your audience to filter by happiness score so they can focus on fewer countries. But first, let's bring in more of the map we started with. To do this, hover on the map and select the zoom home icon in the toolbar to reveal more countries on the map. Next, we're going to add happiness score to the filter shelf. We'll select all values and click Next. Then, for the range of values, we'll click OK to accept the default settings. In the filter shelf, click the drop-down to open the menu for the happiness score and select Show Filter. If we select the drop-down for the menu again, we can confirm that Show Filter has a check mark next to it. You can toggle the check mark to display or not display the filter. When Show Filter is marked, a slider is displayed to the right of the map. Now, try filtering to show a happiness score of 6.0 or below. And there you have it, our first visualization based on data we brought in from an external source. Pretty powerful, right? We'll save our viz so we can admire it anytime we want to, and maybe even practice using the Tableau tools with it. It's always important to save your work, but make sure not to include any personal information in your file name. All of the data visualizations created in Tableau Public are visible to, well, the public. You can also keep your visualizations hidden. You'll see the eye with a slash through it on your viz, and the viz will remain hidden. It's up to you, but lots of data vids created by users like you are viewable. In fact, you can easily check them out by searching on Tableau Public. Then you can search for any kind of data viz, including world happiness visualizations. You'll come across all types of data viz, many with advanced settings. Some of the examples you'll find in the gallery are stronger than others. Coming up, we'll talk about effective data visualizations and some ways you can make your data viz work even stronger. See you soon. Hi, and welcome back. In this video, we're going to use Tableau to create a data viz, a great way to share insights with others. To begin, you'll need to download the dataset we'll use for this activity. Click the link to create a copy of the dataset and download it. If you don't have a Google account, download the dataset directly from the attachment. As we go through the steps, you can put this video on one side of the screen and follow along in another window. You might notice your screen is slightly different from what you see here. Tableau might have updated its interface, but the steps should be pretty much the same. First, log in to Tableau Public. If you haven't created an account, go back to the reading about logging into Tableau Public. Okay, now go to the circle and select My Profile. From there, choose Create a Viz. This will open the Tableau Public interface. From the Connect to Data window, go to the Files tab and upload the CO2 dataset we downloaded earlier. Or you can navigate to the Data tab of the Tableau Public interface. Under the drop-down, click New Data Source. Then open the CO2 dataset. After the data uploads, the screen will show the data source interface. Underneath Connections, double-click on the sheet CO2 Data Cleaned to load that data into the main part of the screen. You can also drag and drop the sheet into the area where it says Drag Tables Here. Click Update Now to preview the data you opened in the bottom portion of the screen. Each row corresponds to a single data point, and each column represents a different feature. Tableau interprets the type of data in each column. Each icon represents a different type of data. For example, a number sign represents numerical data, while an ABC represents string data. A globe represents geographic data, and so on. Tableau has interpreted the first two columns as geographic data, the third column as string data, and the last three columns as numeric data. All right, let's make a data viz that demonstrates the amount of CO2 emissions that come from each country. To do this, choose the Sheet 1 tab. On the far left of the screen is a banner with column names above a gray line. In Tableau, these are called the dimensions of the data. Below this line are the different measures that you can track for these dimensions. To create a chart that displays the CO2 emissions per country, we're going to start by double-clicking the country name dimension. The main display will show a map of the countries on the planet with dots indicating which countries are represented in the data. The dots are all the same size because, with no measure selected, Tableau defaults to scale each country equally. If you want to scale by CO2 emissions, we'll need to include a specific measure. Double-click or drag and drop onto the sheet the measure CO2 kilotons. This will change the size of the dots to be proportional to the amount of CO2 emitted. Tableau has a wide selection of options for depicting the measures for a given dimension. Most of these options are contained in the middle column between the main display and the columns with dimensions and measures. Now, let's customize the look of our chart to better communicate trends in the data. If we drag and drop a measure on one of the marks, such as color, size, and label, we can change that aspect of the measure's visualization on the chart. For instance, say we want to change the color of the CO2 measure. We would drag the measure CO2 kilotons to the box with the color label. Then we can select this box to pull up a list of color options. Feel free to pause this video and play around with the different options. Get creative. And if you ever want to reverse a change that you make to a Tableau sheet, just use the back arrow. There it is. We just created our first chart using Tableau. But what if we wanted to change the dimensions or measures? Instead of visualizing the CO2 per country, maybe we want to chart the CO2 per capita per region. To do this, we could double-click on the dimension region and then do the same for the measure CO2 per capita. This builds a new chart. We can edit the title by hovering the cursor over the title box and clicking on the arrow to bring up a drop-down menu. Then we'll choose Edit Title. Let's give it the name Global CO2 Emissions. Or if we wanted to delete a chart, we could select the Clear Sheet button in the toolbar. This will wipe out the chart and bring us back to an empty sheet. Don't worry if you do this by accident or change your mind. The back button introduced earlier will bring the chart back. To delete a sheet entirely, right-click on the Sheets tab and select Delete. We won't be able to delete a sheet if it's the only sheet in our file. But be careful. Unlike clearing a sheet, deleting a sheet altogether cannot be undone. Make sure to save your progress by hovering over the File tab and selecting Publish As. Congratulations! Now you're ready to start visualizing your data. This is far from the end of the story, though. Soon you will explore even more advanced tools in Tableau. Hey there! In this video, we'll take a closer look at effective and ineffective data visualizations using Tableau. That's right. Even though this platform can help you create some really beautiful visuals, all those features and functions can lead to something that's just not very useful too. You might remember the 5-second rule we spoke about earlier. A sign of a good data visualization is that once you show it to an audience, they should understand what you're trying to convey within 5 seconds. This means it's clear, effective, and most importantly, convincing. If you keep that rule of thumb in mind before you begin any Tableau viz, you'll be on the right path to creating good visuals. Let's take a look at an example of a good use of a diverging color palette. A diverging color palette displays two ranges of values using color intensity to show the magnitude of the number, and the actual color to show which range the number is from. It's a good way to show the difference between numbers. Here, green is associated with higher numbers and red with lower numbers. You may come across tables like this as it relates to business metrics and KPIs. The colors you choose should fit within the scope of the audience's expectations. While this might not always be true globally, a lot of people associate green with positive and red with negative. This makes things nice and clear. Here's an ineffective data viz example. There's a lot about this viz that isn't working well, but these colors are hard to read. This graph uses green and orange, and the data points are really close together. These colors don't clearly show the difference between low and high data points. Data visualization allows us to share meaningful stories about data, but we can't do it if it's too hard for the audience to understand the data viz we're sharing. Using color pairings that don't fit your audience's expectations could add another layer of unnecessary complexity. Brace yourself, because there's another way to make an ineffective data visualization even worse. If you add a few too many labels, you end up with a data visualization that's really hard to take in. Doing this makes the visualization too busy, it takes up too much space, and it prevents the labels from being clearly shown. All of this is made worse by using different fonts across the labels. What we have here is good data turned bad because of the visuals. Having an interactive visualization can be useful for both your audience and for you as the analyst. But just like anything else, the more power you have, the more responsibility you have. Lose sight on the qualities of a good viz, and you could lose control over the story you want the data to tell. Now that you've learned how to use visual enhancements to your advantage, next up, we'll check out ways you can get even more creative with them. Stay tuned. Hey, good to see you again. One of my favorite aspects of data visualizations is how creative it lets me be. You might remember me saying earlier that data viz is the intersection of art and analytics, and it really is. I'm here to help you find your inner kid with a crayon. From turning messy charts into effective ones, to making your visuals more accessible to people who have color vision deficiencies, it's time to explore how your creativity can help you get the most out of your data. Jump right in by signing into your Tableau account. We'll return to our World Happiness data in the Google Career Certificates page. Click the link included in this video to open the gallery. Now, click to view the workbook titled Just the Data, World Happiness. We used this same workbook in the earlier video about getting started with Tableau. Let's click up here to get started. Let's say we want to use this data in this table to figure out what the biggest contributors to a country's happiness score are. We'll start by digging into the relationship between happiness scores and the other country measures to see what we can find. To start, create a new worksheet to build your own data viz from scratch. You'll click on Worksheet and then New Worksheet. Since our data has 3 years of values, let's filter to 2016. To do this, add year to the filter shelf and choose 2016. Add happiness score to the rows shelf. Then add economy GDP per capita to the columns shelf. Next, drag and drop country to the detail section. This creates a separate circle or data point for each country. You might notice that where the economy score is higher, the happiness score is also higher. To make this trend easier to see, let's add a trend line. Now, duplicate this sheet so that all of your formatting stays the same. In the duplicate sheet, replace economy, GDP per capita, with another measure such as family. Drag the family table into the column shelf to replace economy. We'll rename our original tab Economy. And this new tab Family, so that we can easily recognize what they show and find them when we need to. Try doing this for more of the measures. Now let's show what multiple visualizations on a single dashboard look like, so you can more easily see the relationship between them. Drag your visualizations, which are now listed in the left tables column, one at a time to populate the dashboard. They can be arranged in different ways. Take note of which trend lines have the steepest incline. Those are the ones with the strongest relationship to happiness score. Each chart should have an easily understood purpose that's immediately clear to your audience. And that's just what this does. You can also add a companion table, which shows the same data in a different way in case people in your audience prefer tables. In my experience, some stakeholders prefer to see their data in spreadsheets. We've been spending a lot of time using one data source, but you'll likely end up juggling more than one data set at a time as an analyst. Coming up, you'll have the option to learn more about combining multiple data sources in Tableau. Bye for now. Hi, and welcome back. In this video, we're going to use Tableau to link multiple data sets. This lets analysts compare all data sets in the same visualization, visualize comparisons and combinations of data, and share more complex projects. You can put this video on one side of the screen and follow along in another window. You might notice your screen is slightly different from the video. That's okay. Tableau updates its interface from time to time, but the general steps will stay the same. And feel free to pause this video as you work in your own Tableau workspace before continuing to the next step. To begin, we're going to need to download the 4 data sets we'll use for this activity. Click the link to create a copy of the data sets and download them. If you don't have a Google account, download the data sets directly from the attachments. Now imagine this scenario. You're working as a data analyst for a policy research institute. For your current project, you need to create a visualization that shows the CO2 emissions per capita for each country from 2000 to 2011. You'll also provide information about each country's population, GDP, and energy use. All right, let's get started. First, log into Tableau Public. If you haven't created an account, refer to the earlier reading, Logging into Tableau Public. Go to the circle, then choose My Profile. From there, select Create a Viz. This will open the Tableau Public interface. The Connect to Data window will pop up. From here, you can go to the Files tab and upload the CO2 dataset. Now, go to the Data Source tab, then the Connections column. From here, choose the plus icon to add another dataset. First, add energy. Then, add GDP total and total population. Now we'll have 4 datasets loaded into Tableau. You can proceed to linking them with joins. Tableau has already added energy into the multiple connections area. We can remove it by dragging it back to the connections column. Now let's create joins. As a reminder, inner and outer joins are types of relationships that can be used to combine data based on common columns of information. To set up our first join, we'll select CO2 under Connections. Beneath that, in the Sheets section, click and drag CO2 data cleaned to the Multiple Connections section. Then, double-click the box created by the dataset. This opens the physical table and lets us create joins. To set the first join, select the energy dataset under Connections and drag the energy sheet beneath it to the right side of the CO2 data cleaned box. A pop-up window for a join will appear. It will automatically populate with year from CO2 data cleaned and year 1 from energy. If not, Put year on the left side of the chart and year 1 on the right side. Then choose Add from Join Clause under Year. Select Country Name from the drop-down on the left side and Country on the right side. After that, use the X to close the drop-down menu. We need to fix something in our data set. Year and year 1 have a number sign above them. We can click those number signs and select Date instead to change the data type for each column. Now, join the other data sets. Choose GDP total under Connections. Then, under Sheets, drag the GDP total sheet into the white space underneath the energy box. The pop-up window should already be populated with year 1 under Data Source and year GDP total under GDP total. Before adding any additional joins, the data type for year GDP total needs to be changed. We'll make its data type Date just like we did with the other year columns. Now, continue setting the join. Choose the Venn diagram between energy and GDP total, then add new join clause under year 1. A drop-down menu will appear. Under CO2 data cleaned, select country name. Then the empty field under GDP total across from country name. Set the right side of the join to country 1. Then close the join pop-up. We'll repeat this process for total population, the last data set we downloaded. When we drag the sheet to create the join, the window should already be populated with year under data source and year total population under total population. Change year total population to the date data type to match the other year columns. Then select the Venn diagram to edit the join and click Add New Join Clause under Year. Under CO2 Data Cleaned, choose Country Name. Then, on the right side of the row, Country Total Population. Close the pop-up. If you haven't yet, be sure to update your data by clicking on the Update Now button. Nice! You've joined 4 different sources of data. Check out your new data set. While your dataset CO2 went from 1960 to 2011, your other datasets went from 2000 to 2015. The intersection, the years they have in common, only includes 2000 to 2011. This is the time span that we need. However, there are some changes we still need to make. Some of the data types need to be converted. Similar to when you change your year columns to date types, you'll need to change the energy use and current GDP columns. Above the energy use column is an ABC icon. This means it's a string type. Select it to open a drop-down and change it to number decimal. Current GDP is also a string type, but needs to be a whole number instead. Choose the ABC icon to change it to number whole. All right. Now we get to make our visualization. To begin, choose the Sheet 1 tab. You'll notice a column on the left side of the screen. Under CO2 Data Cleaned, drag Country Name to the Detail square. Drag CO2 per capita to the Color square. Then choose the square and edit colors. Select the palette drop-down and change it from Automatic to Red-Green Diverging. Check the boxes for stepped color and reversed. Because green is generally viewed as a good thing when it comes to CO2 emissions, you want the colors to move toward red as emissions worsen. Click the Show Advanced drop-down, then the Start and End boxes. Put 0 into the Start column and 62 at the End column. Then close the window. Drag Year from under CO2 Data Cleaned into the Filters area. Choose Years, Next, All, and then OK. In the Filters box, right-click on Year, Year. Select Show Filter. The filter will appear on the right side of the screen. On the far right side of the screen, choose the arrow to the right of year. Select single value. Now, the areas will be colored only for the values of each year. Select any year between 2000 and 2011 to view that year's CO2 emissions. Make sure to save your progress by clicking the Publish As icon or hovering over the File tab and selecting Save. If you are asked to create an extract, return to the Data Source tab and click Create Extract. Then click Save again. Congratulations! You've linked your data and made a comprehensive data viz in Tableau. The more visualizations you make, the more you'll be able to share complex analyses and insights. Storytelling is the oldest form of teaching. Humans have been sharing knowledge through stories for tens of thousands of years, back when TVs and computer screens were the walls in a cave. In fact, scientists have confirmed that cave paintings were created by early humans who used their art to convey the stories of their imaginations. Today, storytelling is still the most natural form of education. That's because stories make learning easier by helping us process and remember information. Everyone tells stories, even if we're just sharing how our day went with a friend. Many experts believe that human brains automatically organize events with a beginning, a middle, and an end. Thinking about things in this way, like stories, helps us make sense of the past, the present, and the future. On top of that, stories also help us relate to other people and create important human connections. It's no wonder that people are so captivated by stories. Over the course of history, many important inventions have changed how stories are told. For example, the invention of the printing press led to newspapers, magazines, and books. The invention of motion picture camera made movies possible. And soon we had TV, videos, on-demand, and streaming services that let us enjoy all kinds of stories anywhere, anytime. The invention of data visualization tools changed the way people tell stories once again. As you've learned, data visualization is the representation and presentation of data to help with understanding. Coming up, you'll discover how to use data visualization to transform data into a meaningful story that people connect to and care about. You'll also start working with dashboards and dashboard filters. A dashboard is a tool that organizes information, typically from multiple data sets, into one central location for tracking, analysis, and simple visualization through charts, graphs, and maps. And just like filters in spreadsheets and queries, a dashboard filter is a tool for showing only the data that meets a specific criteria while hiding the rest. Soon, you'll know how to use these tools to tell stories that motivate and persuade people to take action based on the data you present. Finally, you'll understand the key attributes of data-driven stories and effective ways to communicate them in all sorts of business situations. Ready to become an expert storyteller? Then let's turn to the next chapter of your data analytics story. Stephen Few, an innovator, author, teacher, and data visualization expert, once said, "Numbers have an important story to tell. They rely on you to give them a clear and convincing voice." Facts and figures are very important in the business world, but they rarely make a lasting impression. To create strong communications that make people think and convince them to take action, you need data storytelling. Data storytelling is communicating the meaning of a data set with visuals and a narrative that are customized for each particular audience. A narrative is another word for a story. In this video, you'll learn about data storytelling steps. These are engage your audience, create compelling visuals, and tell the story in an interesting way. Here's an example from the music streaming industry. Some companies send their customers a year-in-review email. It highlights the songs the users have listened to most and sometimes congratulates them for being a top fan of a particular artist. This is a much more exciting way to share data than just a printout of the customer's activity. It also reminds the listener about how much time they spend enjoying the service, a great way to build customer loyalty. Here's another example. Some ride-sharing companies are using data storytelling to show their customers how many miles they've traveled and how that equals spending less money on gas, reducing carbon emissions, and saving time they might otherwise have spent fighting traffic. It makes it really easy for the rider to clearly see the value of the service in this simple and fun visual. Data stories like these keep the customer engaged and make them feel like their choices matter because the companies have taken the time to create something just for them. And importantly, the stories are interesting. Knowing how to reach people in this way is an essential part of data storytelling. Images can draw us in at a subconscious level. This is the concept of engaging people through data visualizations. So far, you've been learning about the importance of focusing on your audience. Coming up, you'll keep building on that knowledge. You'll discover that there are 3 data storytelling steps, and the first is knowing how to engage your audience. Engagement is capturing and holding someone's interest and attention. When your audience is engaged, you're much more likely to connect with them and convince them to see the same story you see. Every data story should start with audience engagement. All successful storytellers consider who's listening first. For instance, when a kindergarten teacher is choosing books for their class, they'll pick ones that are appropriate for 5-year-olds. If they were to choose high school level novels, the complex subject matter would probably confuse the kids and they'd get bored and tune out. The second step is to create compelling visuals. In other words, you want to show the story of your data, not just tell it. Visuals should take your audience on a journey of how the data changed over time or highlight the meaning behind the numbers. Here's an example. Let's say a cosmetic company keeps track of stores that buy its product and how much they buy. You could communicate the data to others in a spreadsheet like this, or you could create a colorful visual, such as this pie chart, which makes it easy to see which stores are most and least profitable as business partners. That's a much clearer and more visually interesting approach. Now, the third and final step is to tell the story in an interesting narrative. A narrative has a beginning, a middle, and an end. It should connect the data you've collected to the project objective and clearly explain important insights from your analysis. To do this, it's important that your data storytelling is organized and concise. Soon you'll learn how to do that using slides for a discussion during a meeting and a formal presentation. We'll discuss how the content, visuals, and tone of your message changes depending on the way you're communicating it. And speaking of business communications, one of the many ways that companies use visualization to tell data stories is with word clouds. Word clouds are a pretty simple visualization of data. These words are presented in different sizes based on how often they appear in your data set. It's a great way to get someone's attention and to unlock stories from big blocks of text where each word alone could never be seen. Word clouds can be used in all sorts of ways. On social media, they can show you which topics show up in posts most often, or you can use them in blogs to highlight the ideas that interest readers the most. This word cloud was created using text from the syllabus of this course. It tells a pretty engaging story, where data, analytics, analysis, SQL, and spreadsheets are, unsurprisingly, some of the lead characters. All right, let's continue turning the pages of your data analytics story. There's lots of action and adventure to come. Welcome back. When you want to communicate something to others, a great story can help you reach people's hearts and minds and make them more open to what you have to say. In other words, stories make people care. As you learned before, the first of the 3 data storytelling steps teach us that, for a story to be successful, you need to focus on who's listening. Data analysts do this by making sure that they're engaging their audience. That's what we'll explore together now. First, you need to know your audience. Think back to the example of telling someone a joke they've heard many times before and expecting them to laugh at the punchline. Not likely. To get the response you're seeking, you've got to understand your audience's point of view. That means thinking about how your data project might affect them. It helps to ask yourself a few questions. What role does this audience play? What is their stake in the project? And what do they hope to get from the data insights I deliver? Let's say you're analyzing readership data from customers to help a magazine publisher decide if they should switch from quarterly to monthly issues. If your stakeholder audience includes people from the printing company, they're going to care because the change means they have to order paper and ink more frequently. They also might need to assign more staff members to the project. Or, if your stakeholders include the magazine authors and editors, you'll want to keep in mind that your recommendations might change the way they work. For instance, they might need to write and edit stories at a faster pace than they're used to. Once you've considered the answers to those questions, it's time to choose your primary message. Every single part of your story flows from this one key point, so it's got to be clear and direct. With that in mind, let's think about the key message for the data project about our pretend magazine. Maybe the readership data from customers shows that print magazine subscriptions have been going down recently. You discover in survey data that this is mainly because readers feel the information is outdated. So, this finding suggests that readers would probably appreciate a publication cycle that gets the information into their hands more often. But that's not all. Your reader survey data also shows that readers prefer shorter articles with quick takeaways. The data is generating a lot of possible decision points. The volume and variety of information in front of you may feel challenging. So to get the key message, you'll need to take a few steps back and pinpoint only the most useful pieces. Not every piece of data is relevant to the questions you're trying to answer. A big part of being a data analyst is knowing how to eliminate the less important details. One way to do this is with something called spotlighting. Spotlighting is scanning through the data to quickly identify the most important insights. There are many ways to spotlight, but lots of data analysts like to use sticky notes on a whiteboard, kind of like how archaeologists make sense of the artifacts they discover in a dig. To do this, you write each insight from your analysis on a piece of paper, spread them out, and display them on a whiteboard. Then you examine it. It's important not to get bogged down in every tiny detail. Instead, look for broad, universal ideas and messages. Try to find ideas or concepts that keep popping up again and again, or numbers and words that are repeated often. Maybe you're finding things that look like they're connecting or forming patterns. Highlight these items or group them together on your whiteboard. Next, explore your discoveries. Find the meaning behind the numbers. The idea is to identify which insights are most likely to help solve your business problem or give you the answers you've been seeking. This is how spotlighting can lead you to your key message. Remember to keep your key message clear and concise, as an overly long message, like this one shown on screen, has less chance of conveying the most important conclusion. Here's a clear, concise message that's likely to engage your audience because it's short and to the point. Of course, no matter how much time and effort you put into studying your audience, you can't predict exactly how they'll react to your recommendations. But if you follow the steps we're discussing, you'll be much more likely to have good results. In an upcoming video, you'll learn how to deal with situations that don't go quite according to plan. And that's okay. It happens to all of us.
My name is Carolyn, and I'm a measurement lead at Google. And that means that I measure a client's advertising investment and figure out ways that it can perform better for them in the future. Over the course of my career, I've worked in 4 very different fields, but the thing that links all of them together is my ability to understand data, to get the information that I need out of it, and to convey it in a simple and compelling way. A really early example of this is from a man named John Snow. He was a doctor in London in the 1850s, and he was living during a cholera outbreak. And the theory at the time was cholera was spread through the air or, ill humors. People didn't really know what was causing it, but he thought that it was caused by drinking really contaminated and gross water from the Thames. So he went out and interviewed people who were sick and asked them where they got their water. And he found out through mapping the data that they got it all at the same pump. So he went to the authorities and asked them to dismantle the pump, and they took the handle off, and the outbreak ended. This started a really robust field of epidemiology, but it also is a great example of data journalism. Most recently, before Google, my job was as a data journalist, and that was to use data to tell stories. I worked at the Chicago Tribune for 3 years. I worked a lot around the election season and Olympics, big graphic moments where there's a lot of interesting data and a need to understand it. The field of data journalism has changed a lot over time, but not as much as you might think. We have a lot more access to data and data that we've never really tracked before, but it's still the job of the data journalist to really understand what that data means. As we have more and more data, it's not really helpful to a reader to just say, here's a link to a database. You still have to uncover the meaning beneath it and really understand what's the insight within the data. The tools that a journalist would use to understand something, which is consulting an expert, really diving into a story, are very similar to the tools I need at Google to really understand a media investment and make a really clear recommendation of what someone should do in the future. My advice is to understand the tools that are available to you and know how they work, but never to let those tools overwhelm your story. So I never want to look at a piece and know, oh, this was created using Data Studio or using Microsoft Excel. I want to know what the data says and what a data journalist's point of view is behind that story. Don't let the way you create something influence what it's actually saying. People just want to know what you've distilled and what new information you've found in all the hard work you've done. I love the field of data journalism because it's just how my brain works. I'm always the type of person who will doodle in the margins or make a quick chart to really understand the data beneath it. And that forces me to find a point of view and to share that with other people. I love that through data, I can communicate with a large audience and really help them understand the world around them.
Have you ever been driving a car when one of the warning lights on the dashboard suddenly comes on? Maybe the gas gauge starts blinking because you're getting low on fuel. It's handy when you have that alert right in front of you, clearly showing you that you need to pay attention to your gas level. Can you imagine if cars didn't have dashboards? We'd never know if we were about to run out of gas. We'd have no idea if our tire pressure was low or if it was time for an oil change. Without dashboards, if our cars started acting differently, we'd have to pull out the user manual, sift through all that information inside, and try to figure out the problem ourselves. Car dashboards make it easy for drivers to understand and respond to any issues with their vehicles because they're constantly tracking and analyzing the car's status. But, as you've been learning, dashboards aren't just for cars. Companies also use them to share information, get people engaged with business plans and goals, and uncover potential problems. And just like a car's dashboard, data analytics dashboards take tons of information and bring it to life in a clear, visually interesting way. This is extremely important when telling a story with data, which is why it's a big part of number 2 in our 3 data storytelling steps. You've learned that a dashboard is a tool that organizes information from multiple data sets into one central location for tracking, analysis, and simple visualization through tables, charts, and graphs. Dashboards do this by constantly monitoring live, incoming data. As we've been discussing, you can make dashboards that are specifically designed to speak to your stakeholders. You can think about who will be looking at the data and what they need from it, and how often they'll use it. Then you can make a dashboard with the perfect information just for them. This is helpful because people can get confused and distracted when they're presented with too much data. A dashboard keeps things neat and tidy and easy to understand. When designing a dashboard, it's best to start simple with just the most important data points. And if later on you discover something's missing, you can always go back and tweak your dashboard or create a new one. An important part of dashboard design is the placement or layout of your charts, graphs, and other visuals. These elements need to be cohesive, which means they're balanced and make good use of the space on the dashboard. After you decide what information should be on your dashboard, you might need to resize and reorganize it so it works better for your users. One option in Tableau is choosing between a vertical or horizontal layout. A vertical layout adjusts the height. A horizontal layout resizes the width of the views and objects it contains. Also, as you can see here, evenly distributing the items within your layout helps create a clear and organized data visual. You can select either tiled or floating layouts. Tiled items are part of a single layer grid that automatically resizes based on the overall dashboard size. Floating items can be layered over other objects. In this example, the map and scatter plots are tiled. They don't overlap. This really helps make clear what the data is all about, which is valuable because the majority of people in the world are visual learners. They process information based on what they see. That's why sharing your dashboards with stakeholders is such a valuable practice. Now, there's something important to keep in mind about that. Sharing dashboards with others likely means that you'll lose control of the narrative. In other words, you won't be there to tell the story of your data and share your key messages. Dashboards put storytelling power in the hands of the viewer. That means they'll craft their own narrative and draw their own conclusions. But don't let that scare you away from being collaborative and open. Just understand the risks that come with sharing your dashboards. After all, sharing information and resources means that you'll have more people working on the solution to a big problem or coming up with that next big idea. This leads to more connections, which can result in really exciting new practices and innovations. So far, we've focused a lot on understanding our audience. Whether you're trying to engage people with data storytelling or creating dashboards designed for a certain person or group, understanding your audience is key. As you've learned, you can make dashboards that are tailored to meet different stakeholder requirements. To do this, it's important to think about who will be looking at the data and what they need from it. In this video, we'll continue exploring how to create compelling visuals to tell an interesting and persuasive data story. One great tool for doing this is a filter. You've learned about filters in spreadsheets and queries, but as a refresher, filtering means showing only the data that meets a specific criteria while hiding the rest. Filtering works the same way with dashboards. You can apply different filters for different users based on their needs. Tableau lets you limit the data you see based on the criteria you specify. Maybe you want to filter data in a data set to show only the last 6 months. Or maybe you want to see information from one particular customer. You can even limit the number of rows or columns in a view. To explore these options, let's return to our world happiness example. Say your stakeholders were interested in only a few of the topics that affect overall happiness. Filtering for just gross domestic product, family, generosity, freedom, trust, and health, and then creating individual scatter plots for each would make this possible. You can also use filters to highlight or hide individual data points. For instance, if you have a scatter plot with outliers, you may want to explore what your plot would look like without them. However, note that this is just an example to show you how filters work. It's not okay to drop a data point just because it's an outlier. Outliers can be important observations, sometimes even the most interesting ones. So be sure to put on your data detective hat and investigate that outlier before deciding to remove it from your dashboard. Here's how to do it. To filter data points from the view, we can choose a single data point or click and drag in the view to select several points. Let's choose just one. Then, on the tooltip that appears, we'll select Exclude to hide it. Or we could have chosen to do it the other way by keeping only selected data points. Here's another example. If your data is in a table, you can filter entire rows or columns from your view. To do this, we'll select the rows we want in the view. Then, on the tooltip that appears, we'll choose to keep only those countries. Again, we could have also selected the data points we wanted to exclude and picked that option instead. Or if you like, we can even pre-filter a Tableau dashboard. This means that your stakeholders don't have to filter the data themselves. Basically, by doing the filtering for them, you can save them time and effort and direct them to the important data you want them to focus on. Personally, I think the best thing about filters is they let you zero in on what's important. Sometimes I'm working with a huge data set and I want to concentrate only on a specific area, so I'll add a filter to limit the data displayed on my dashboard. This cuts the clutter and gives me a simple, clear visual. I use filters a lot when working with data about advertising campaign performance. Filters help me isolate specific tactics, such as search or YouTube ads, to see which ones are working best and which ones could be improved. By limiting and customizing the information I'm looking at, it's much easier for me to see the story behind the numbers. And as I'm sure you've noticed, I love a good data story. As a data analyst, you'll often be relying on spreadsheets to create quick visualizations of your data to tell your story. Let's practice building a chart in a spreadsheet. To follow along, use the spreadsheet link in the previous reading, also included in the video. We'll be using Google Sheets, so this might look a little different in other spreadsheet platforms like Excel. We'll begin by filtering just the data on how many customers purchased Basic, Plus, or Premium software packages. To start, select the column for the software package and insert a chart. The spreadsheet suggests what it thinks is the best type of chart for our data. But we can choose any type of chart you'd like. Spreadsheet charts also let you assign different styles, axis titles, a legend, and many other options. Feel free to explore the different functionality later on. We'll also cover this more in a reading. There's lots of different options to choose from. Let's say we also have data on which countries our customers are from and their overall satisfaction score for the software they purchased. First, highlight columns A and B. Then, click on Insert and then Chart again. Under Chart Type, you'll want to select the first Map option. Voila! Now we have a map that summarizes the customer survey scores by country. We can also customize this chart by clicking Customize in the top right corner. Let's say we wanted to change our colors from red and green to a gradient so it's more accessible. We can do that by clicking Geo and then change the min color to the lightest shade of blue, the mid color to the middle shade of blue, and the max color to the darkest shade of blue to show the spectrum of scores from low to high. Now we have a map chart that shows where respondents are most satisfied with their software in dark blue and least satisfied with their software in light blue. And this will be easier for anyone in our audience with color vision deficiencies to understand. Tableau and spreadsheets are common tools for creating data visualizations. By using their built-in functionalities, like filters and charts, you can zero in on what information is most important and create compelling visuals for your audience. And now that we've explored some ways to create visuals, it's time to start preparing our data narrative. Coming up, we're going to talk more about telling stories with data and organizing presentations. I'll see you soon. Businesses everywhere know the power of using data to solve problems and achieve goals. But all the data in the world won't get you anywhere if your stakeholders can't understand it, or if they can't stay focused on what you're telling them. So you want to create presentations that are logically organized, interesting, and communicate your key messages clearly. An effective presentation supports your narrative by making it more interesting than words alone. It starts with how you want to organize your data insights. The narrative you share with your stakeholders needs characters, a setting, a plot, a big reveal, and an aha moment, just like any other story. The characters are the people affected by your story. This could be your stakeholders, customers, clients, and others. When adding information about your characters to your story, you have a great opportunity to include a personal account and bring more human context to the facts that the data has revealed. Think about why they care. Next up is the setting, which describes what's going on, how often it's happening, what tasks are involved, and other background information about the data project that describes the current situation. The plot, sometimes called the conflict, is what creates tension in the current situation. This could be a challenge from a competitor, an inefficient process that needs to be fixed, or a new opportunity that the company just can't pass up. This complication of the current situation should reveal the problem your analysis is solving and compel the characters to act. The big reveal, or resolution, is how the data has shown that you can solve the problem the characters are facing by becoming more competitive, improving a process, inventing a new system, or whatever the ultimate goal of your data project may be. Finally, your aha moment is when you share your recommendations and explain why you think they'll help your company be successful. When I'm working on a presentation, this is where I like to start too. Using these basic elements to outline your presentation can be a great place to start, and they can help you organize your findings into a clear story. And once you've decided on these 5 key parts of your story, it's time to think about how to pair your narrative with interesting visuals. Because, as you're learning, an interesting and persuasive data story needs interesting and persuasive visuals. Coming up, you'll learn even more about how to be an expert data storyteller. Welcome back. Now that you know how to prepare the key parts of your data story, the character, setting, plot, big reveal, and the aha moment, it's time to think about the visuals and how your slideshow should look. It's always good to remember that your presentation reflects on you. If it's messy, disorganized, or full of images that don't support your story, your audience could easily lose confidence in your results and recommendations. On the other hand, if your slideshow looks professional and appealing, you've got a better chance to capture your audience's attention and keep them focused on your main points. Themes are a great tool for this. They control the color, font types and sizes, formatting, and positioning of text and visuals. Some themes are fun or creative, while others have a more professional look. By choosing a theme that matches the tone and information you're communicating, your presentation will have a consistent look and support the argument you are trying to make. Next comes the title. It's good to include a title and subtitle that describe what you're about to present. You should include the date of your presentation too, especially if you're including data that's likely to change over time. Specifying a date, such as a date created or date last updated, gives anyone viewing your presentation important context. A good slideshow guides the audience through your main communication points, but it doesn't repeat every word you say or give a lot of written information. Part of your job is to choose what information to include. This might be a description of what's being shown in a visual, the first step in a process, a set of directions, or an important message that you want to be sure your audience understands and remembers. Also, be sure to adjust the font size so your audience can easily read what you've written. A good rule is to keep text to less than 5 lines and 25 words per slide. Basically, you want your audience focused on what you're saying, not busy reading the slides. Also, choose your words carefully. It's always smart to avoid slang terms, abbreviations that people might not know, and words or phrases that are specific to one particular region. Now let's discuss visuals. Visuals help the audience quickly understand the content of each slide. They can help you make a point in a way that words might not be able to alone. Great visuals don't leave room for interpretation because the meaning is instantly understood. When you include visuals on a slide, try not to share too many details all at once. Choose just the data points that support your points, especially your key message. I like to ask myself, what's the single most important thing I want my audience to learn from my analysis? That helps me decide which visuals will be most likely to get the point across. If you have several important things you need to include, don't cram them all on one slide. Instead, create a new visual for each point. Then, add an arrow, a call-out, or another clearly labeled element to direct your audience's attention toward what you want them to look at. And finally, when you get to your big reveal and aha moment, your visuals must communicate these messages with clarity and excitement. These are the most powerful discoveries from your analysis. Make it feel that way. Before you go, there's one last thing I'd like to share. It's a quick tip for knowing when to copy and paste, link, or embed a visual into a slideshow. This can be challenging for new data analysts, but there are some simple points to keep in mind. When you copy and paste a visual into your presentation, you can edit it directly within your slideshow. If your visual or its data points exist in other places, such as a Tableau dashboard, any changes you make will not affect them there. Now, this also means your visuals won't be updated if the original dataset changes. This means your visual might not be reflecting the latest information. But if you link your visual within your presentation, the visual lives within its original file, and the slideshow connects to it with the visual's URL. Because the two files are now linked, when you make changes to the original file, say a spreadsheet, the changes will automatically appear in your presentation. This can be useful if the data is likely to change over time. Your slideshow will always be up to date. Finally, an embedded object also lives in the original source file, but the difference is that it doesn't get automatically updated if the source file changes. The embedded copy is completely independent. Similarly, you can make changes to it in your presentation without affecting the visual or data points from the original source file. So the main difference between pasted, linked, and embedded objects has to do with where you store them and how you update them after you place them in your slideshow. Now that you're beginning to understand how to make great slideshows, take a few minutes to practice what you've learned. Create a new slideshow and select an appropriate theme. Add your text, visuals, and an exciting reveal at the end. Try pasting, linking, and embedding visuals from different sources to see how they behave differently. You can design a presentation about any data set that interests you. It doesn't need to be long or have a ton of information. Just take the first steps and have fun telling your own data story.
Hi, my name is Sandhas and I am an analytical lead at Google. My role is turning data into powerful stories that influences business decisions. I have an untraditional background where I have a 6-year gap between my high school and my college career. So for me, when I was trying to start all over again, so I started at a community college. That was my first exposure to online learning. And it was perfect because I was managing kids at home. So at Google, we talk a lot about imposter syndrome, and I personally relate to it quite a bit. Being the first female in my family to graduate university and also being an immigrant, a lot of the times I'm surrounded by people who do not look like me. For example, there was one time where I was presenting to senior leaders in my org, and I was so nervous presenting to them. I was like, I'm going to totally blow this up, and they're going to figure out that I'm just totally a fraud and fake. One of the things that I changed is that even though I was the only female in my team, I started networking. I started expanding my network. And I met a lot of women who are from the country where I am from. And they were also immigrant. They also struggled with English. And they also looked like me, and they were doing very well in their career. They were being successful. So when I looked at them, I was like, okay, if they can do it, then so can I. So that was, for me, was a big confidence boost to kind of get over that imposter syndrome feeling. But I struggle from it day to day. I'm struggling with it right now, standing in front of you. Do I even deserve to be talking about my journey and my skills? So it's completely normal. There are a few things that I like to do. One is that I like to give myself a pep talk. Pep talk definitely works. Just saying you're totally worth it. You deserve it. It does wonders for me personally. The second thing I like to do is I like to keep a log of my success and failures. So when I am at a down point, when I'm feeling down or feeling like I do not belong here, I look at all the things that I have achieved from that log, and that kind of helps me. That's a good reminder of the hard work that I've put in to kind of get here. So I did not get here because of luck. I got here because I worked hard and I earned it. My family is actually really, really proud of me. After seeing me go to school and graduate with 2 kids, my younger brother, he actually went to school with 2 kids as well, and he graduated, he finished his master's program. And my sister-in-law, who also had 2 kids and she was managing it, and after seeing me that I could do it, they had somebody to look up to. And so my sister-in-law went back to school and she finished her degree as well. So I think just being the first in my family was really hard because I didn't have anybody to look up to. But now I am that person that people in my family can look up to, specifically girls, and they can pursue whatever they put their minds to.
Welcome back. Now that we're in the share phase of the data analysis process, it's time to show other people what we've found. You've already learned about creating data visualizations and how to use data-driven storytelling. Now it's time to talk about actually presenting the data. Maybe the idea of presenting your findings to stakeholders makes you nervous, or maybe you're getting excited just thinking about it. Either way, these upcoming videos will get you ready to present like a pro. Coming up, we'll learn about the art and science of presentations, some best practices you can use for future presentations, and how to bring multiple data sources together to tell the whole story. As a data analyst, it's important to find answers and make new discoveries during your data analysis. But it's just as important to share those findings with other people. So if you're ready, let's get started. Hi again. Earlier in this program, you learned how to keep your audience in mind when communicating your data findings. By making sure that you're thinking about who your audience is and what they need to know, you'll be able to tell your story more effectively. In this video, we'll learn how to use a strategic framework to help your audience understand the most important takeaways from your presentation. To make your data findings accessible to your audience, you'll need a framework to guide your presentation. This helps to create logical connections that tie back to the business tasks and metrics. As a quick reminder, the business task is the question or problem your data analysis answers. The framework you choose gives your audience context to better understand your data. On top of that, it helps keep you focused on the most important information during your presentation. The framework for your presentation starts with your understanding of the business task. Raw data doesn't mean much to most people, but if you present your data in the context of the business task, your audience will have a much easier time connecting with it. This makes your presentation more informative and helps you empower your audience and knowledge. That's why understanding the business task early on is key. Here's an example. Let's say we're working with a grocery store chain. They've asked us to identify trends in online searches for avocados to help them make seasonal stocking decisions. During our presentation, we want to make sure that we continue focusing on this task and framing our information with it. Let's check out this example slide presentation. We can begin our presentation by framing it with the business task. Here, in this second slide, I've added goals for the discussion. It starts with share an overview of historical online avocado searches. Under that, a more detailed explanation. We'll cover how avocado searches have grown year over year and what that means for your business. Then, we'll examine seasonal trends in online avocado searches using historical data. This is important because understanding seasonal trends can help forecast stocking needs and inform planning. And finally, discuss any potential areas for further exploration. This is where we'll address next steps in the presentation. This clearly outlines the presentation so our audience knows what to expect. It also lets them know how the information we share is going to be connected to the business task. You might remember we talked about telling a story with data before. You can think of this like outlining the narrative. We can do the same thing with our data viz examples. If we're showing this visual graph of annual searches for avocados, we might want to frame it by saying, this graph shows the months with the most online searches for avocados last year. So we can expect that this interest in avocados will fall on the same months this year. That can even be used in our speaker notes for this slide. This is a great place to add important points you want to remember during the presentation ahead of time. These notes aren't visible to your audience in presentation mode, so they're great reminders you can refer to as you present. Plus, you can even share your presentation with speaker notes ahead of time to make the content more accessible for your audience. Using this data, the grocery store can anticipate demand and make a plan to stock enough avocados to match their customers' interests. That's just one way we can use the business task to frame our data and make it easier to understand. You also want to make sure you're outlining and connecting with your business metrics. By showcasing what business metrics you use, you can help your audience understand the impact your findings will have. Think about the metrics we use for our avocado presentation. We track the number of online searches for avocados from different months over several years to anticipate trends in demand. By explaining this in our presentation, it's easy for our audience to understand how we used our data. These data points alone, the dates or number of searches, aren't useful for our audience. But when we explain how they are combined as metrics, the data we're sharing makes so much more sense. Here's another potential data viz that we want to use. We can frame it for our audience by including some of our metrics. There's an explanation of what time period this data covers. Our data shows Google search queries from 2004 to 2018. Where we gathered this data from, search queries are limited to the United States only, and a quick explanation of how the trends are being measured. Google Trends scores are normalized at 100. So now that our audience understands the metrics we use to organize this data, they'll be able to understand the graph more clearly. Using a strategic framework to guide your presentation can help your audience understand your findings, which is what the sharing phase of the data analysis process is all about. Coming up, we'll learn even more about how to weave data into your presentations. Hey, great to have you back. So we know how to use our business tasks and metrics to frame our data findings during a presentation. Now let's talk about how you'll work data into your presentations to help your audience better understand and interpret your findings. First, it's helpful for your audience to understand what data was available during data collection. You can also tell them if any new relevant data has come up or if you discovered that you need different data. For our analysis, we use data about online searches for avocados over several years. The data we collected includes all searches with the word avocado, so it includes a lot of different kinds of searches. This helps our audience understand what data they're actually looking at and what questions they can expect it to answer. With the data we collected on searches containing the word avocado, we can answer questions about the general interest in avocados. But if we wanted to know more about something specific, like guacamole, we'd probably need to collect different data to better understand that part of our search data. Next, you'll want to establish the initial hypothesis. Your initial hypothesis is the theory you're trying to prove or disprove with data. In this example, our business task was to compile average monthly prices. Our hypothesis is that this will show clear trends that can help the grocery store chain plan for avocado demand in the coming year. You want to establish your hypothesis early in the presentation. That way, when you present your data, your audience has the right context to put it in. Next, you'll want to explain the solution to your business task using examples and visualizations. A good example is the graph we used last time that clearly visualized the search trend score for the word avocado from year to year. Raw data can take time to sink in, but a good example or visualization can make it much easier for your audience to understand you during a presentation. Keep in mind, presenting your visualizations effectively is just as important as the content, if not more. And that's where the McCandless method we learned about earlier can help. So let's talk through the steps of this method and then apply them to our own data visualizations. The McCandless method moves from the general to the specific, like it's building a pyramid. You start with the most basic information, introduce the graphic you're presenting by name. This directs your audience's attention. Let's open the slide deck we were working on earlier. We've got the framework we explored last time in our 2 data viz examples. According to the McCandless method, we want to introduce our graphic by name. The name of this graph, Yearly Avocado Search Trends, is clearly written here. When we present it, we'll be sure to share that title with our audience so they know where to focus and what the graphic is all about. Next, you'll want to answer the obvious questions your audience might have before they're asked. Start with the high-level information and work your way into the lowest level of detail that's useful to your audience. This way, your audience won't get distracted trying to understand something that could have easily been answered when the graphic was introduced. We added in the information about when, where, and how this data was gathered to frame this data viz. But it also answers the first question many stakeholders will ask. Where's this data from, and what does it cover? So going back to the second graph in our presentation, let's think about some obvious questions our audience might have when they see this graph at first. This data viz is really interesting, but can be hard to understand at a glance. So our audience might have questions about how to read it. Knowing that, we can add an explanation to our speaker notes to answer these questions as soon as this graph's introduced. This shows time running in a circle with winter months on top and summer on bottom. The farther elements are away from the center, the more queries happen around that time for avocado. Now some of the answers to these questions are built into our presentation. Once you've answered any potential questions your audience might have, you'll want to state the insight your data viz provides. It's important to get everyone on the same page before you move into the supporting details. We can write in some key takeaways to this slide to help our audience understand the most important insights from the graphic. Here, we let the audience know that this data shows us a consistent seasonal trends year over year. We can also see that there's low online interest in avocados from October through December. This is an important insight that we definitely want to share. Even though avocados are a seasonal summer fruit, searches peak in January and February. For a lot of people in the United States, watching the Super Bowl and eating chips with guacamole is popular this time of year. Now, our audience knows what takeaways we want them to have before moving on. The fourth step in the McCandless method is calling out data to support that insight. This is your chance to really wow your audience, so give as many examples as you can. With our avocado graphs, it might be worth pointing to specific examples. In our monthly trends graph, we can point to specific weeks recorded here. During the week of November 25th, 2018, the search score was around 49, but the week of February 4th, the search score was 90. This shows the rise and fall of online search interest with the help of some of the very cool data in our graphs. Finally, it's time to tell your audience why it matters. This is the so what moment. Why is this insight interesting or important to them? This is a good time to present the possible business impact of the solution and clear action stakeholders can take. You might remember that we outlined this in our framework at the beginning of our presentation. So let's explain what this data helps our grocery store stakeholder do. First, they can account for lower interest in avocados between the months of October and December. They can also prepare for the Super Bowl surge in avocado interest in late January, early February. And they'll be able to consider how to optimize stocking practices during summer and spring. There's a little more detail under each of these points, but this is a basic breakdown of the impact. And that's how we use the McCandless method to introduce data visualizations during our presentations. I have one more piece of advice. Take a second to self-check and ask yourself, does this data point or chart support the point I want people to walk away with? It's a good reminder to think about your audience every time you add data to a presentation. So now you know how to present data using a framework and weave data into your presentation for your audience. And you got to learn the McCandless method for data presentation. Coming up, we'll learn some best practices for actually creating presentations. See you soon.
My name is Brittany, and I'm an analytical lead at Google. One of the tips that I have is to try to keep things kindergarten simple. And what that means is keep the concepts that you're presenting as simple and as straightforward as possible. Whenever you enter a room, there are going to be people within that room of varying interest levels, varying knowledge levels. They have different levels of subject matter expertise. Nobody wants to present to a room whose eyes are glazing over. My pet peeve about seeing certain presentations with data is that they often will include what I like to call eyesore charts. And what an eyesore chart is, it has way too much data, it has way too many colors, it just looks busy, and you just really can't figure out what the presenter is actually trying to say. Another tip that I have is to make your presentation fun. So nobody wants to be in a room where you are talking for a full hour and the only voice that you're hearing is your own. One of the things that I try to do to break it up is I try to think of little fun games or quizzes, or I'll play a video or ask questions to the audience just to make sure that they're fully engaged and that they are talking back to me. Another tip that I try to incorporate into my presentations is storytelling. Everybody loves a good story, and when you do it right, you are able to connect and make your audience engage in a way that they probably wouldn't if you weren't telling that story. The last tip that I have is make sure that you have an ally in the room. Oftentimes, before I'm giving a really big data presentation, I will find one or two people that I know are going to be in the room and present my content to them ahead of time. And what that does is it allows me to not only get feedback, but it also allows me to make sure that someone else is nodding their head and aligned to the numbers that I'm about to present. And I can't even tell you how many times that I've been in presentations where those allies have really come to my rescue when the room asks a lot of questions or are potentially trying to poke holes in the analysis. Those allies are there to speak up, and they really are going to have your back and lend credibility to what it is that you're presenting. The most challenging part of my job would be the fact that I am there to convince people to do something that they might not be fully confident that they should be doing. And a lot of times it takes multiple conversations, multiple rounds of convincing for someone to actually come around to what I was trying to articulate or get them to do. When you have spent maybe 6 months or a year building an analysis and building a story and building a narrative for someone to apply to their strategies, and they actually come around and they actually do it, that makes the challenges worth it.
So we're going to dive into specific examples that we have. So we've built what we call a messy example of a data presentation, and we'll walk through each slide and the presentation as a whole to understand why it doesn't actually work well for explaining a specific analysis. We have a title slide, the relationship between health and happiness around the world. Now, right off the bat, there is a very generic picture about the world. It is a very lengthy title, and we know what we're going to be talking about, but there's nothing here that's really compelling about the presentation. So the first slide, when we are looking at a data presentation, we have immediately put a lot of data in front of them and a lot of text in front of them. So right now, they don't know what they're looking at. There was no statement of purpose. We don't have an introduction slide. They don't know who I am. They don't know why they're there. So what are we talking about? Why are we talking about it? What should they walk away with? There's none of that, and we've just immediately gone into the specific data visuals that we are showing them. Now, an important aspect of every slide is also to have a title. Now, title, subtitle, these things help people understand exactly what this slide is going to be discussing so that they know what they're trying to understand as you are talking. So immediately getting here, the audience is going to be lost. They're going to be trying to read the slide. They're going to be trying to decipher what the visuals mean. It's important for you to make sure there's not too much going on. Now, if we move on to the next slide, what we're looking at here is the visuals better. It's easier to understand. There's not more than one of them. We have a map. We have visual colors to represent the numeric values within them. But again, there's nothing for them to really understand. Now, this is where you can explain within the speaker notes, but you also have, again, a lot of words, no title. What is it that they are really trying to get from this slide? Part of a good presentation as well is the theme that you have, or a consistent theme. So you've now switched sides of the specific visual. You have the text on the other side. Doesn't mean you can't do it, but what you're really trying to do throughout a presentation is build some familiarity, especially with data analytics. You're building familiarity with the visuals that you're showing them, the data. By the end of the presentation, they should understand the data or the concept as much as you do. And finally, we have the conclusion slide. This one does have a title, has laughter is the best medicine. We understand, again, what it is that we're looking at, but there was no logical flow on how to get here. Was this overall presentation compelling? We put 2 slides on there. We had too much text. We didn't really explain anything about it. And again, there's awkward placement on where all of these things are within the slide itself. When you're thinking about building a presentation, you should think about it from the audience's point of view. The only thought that's going through their head is, where should my focus be? As I'm trying to listen, as I'm trying to comprehend, where should I be looking? If you have slides like we just showed you, they don't know where they should be looking, or they're going to spend their time reading and trying to comprehend while you're also talking. So it's very important that you are directing their gaze and directing the audience so that they know exactly what they should be listening to, what they should be trying to understand, and you are guiding them through to the overall conclusion. So to sum up in terms of what is wrong with this overall presentation, and not just what you're going to be talking about or what you are trying to conclude, but just the overall placement of the data visuals and the visuals that you chose. So the main thing is there was no story, no logical flow. You started with a bunch of scatter plots and a lot of text, and you moved on to the heat map of the happiness scores. But without somebody presenting something, without any idea of or concept behind what they are trying to conclude, you didn't have titles. There was too much text. It was very difficult to understand, and it was uneven and inconsistent. So even if you had a really good explanation on each slide, you might have lost the audience, because what they were trying to do, what they were trying to understand, is what was the slide trying to tell them. And finally, the most important part of any data analytics presentation is the recommendation or conclusion slide. You had that, but there was no title. They didn't know that this was the end of the presentation, that this is where they should be trying to put all the pieces together. Coming up, we're going to discuss how we can improve this presentation, as well as dive into what the presentation will actually look like when we're trying to explain how health and happiness are correlated. So now that you know what not to do, I'm going to walk you through how I would tackle a presentation. So to start, you can see the title slide is a lot simpler. We have a title, we have who is presenting, and we have when it occurred. Now, I do want to talk a little bit about the date at the bottom, which is an important factor that you shouldn't forget to include. You may come back to this presentation a few months later, even a year later, or this may be disseminated across your company. It's important to know that when this analysis took place and why and what were the circumstances of it. And a big part of that is what were the circumstances of the company at the time that this was actually presented. So the next slide is giving an idea of what you're going to be presenting to everyone and when. So you start with your purpose statement, right? You're going to be discussing what are we talking about. The next aspect is where you actually tell your story. And that's an important concept, is this overall presentation is a story with data. And finally, you have your conclusion slide. You're going to be very clear that this is the conclusion. This is where you're going to add recommendations if this is in a business context. And then you'll have your appendix where you can have an additional information on data visuals as well as overall context for the presentation that may not work within the overall flow itself. So our transition slide, what are we talking about? So this is where you let the audience know what we're talking about. What are we trying to tell them? What are all the slides that are following this going to be driving towards? So when we look at this slide, I'm trying to identify if there are geographic, demographic, and or economic factors that contribute to a happier life. That is the purpose of the overall presentation. So everybody now in the room knows this, and that is what they're going to be thinking about as you present all of the data to them. Next section on our table of contents, present the data. It is important to mention these will probably have different titles as you build them out, but this is the topic that we're moving into. So you'll recognize this visual from the messy slide, but it has a different color context. That's not as important, but what is important is when you get here, you have a title on the slide, you have a visual, but there's no text. And this is an important aspect to it, is what we're trying to do is walk and introduce the audience to the overall data that you're going to be using. Now, this is the first slide that has any form of content on it, so it's important that you introduce them to the underlying data. And seeing as the data is all about geographic, demographic, and economic data points per each country, it's important that the visual represents that. If I were to be the presenter on a slide like this, I would start by getting to this slide and explaining the process and data that we're looking at. So we analyzed a data set consisting of data collected from residents of European countries between 2015 and 2017. The data contained demographic and economic data for individuals within each country, including population, GDP, or gross domestic product, and a happiness score per person. So I've now introduced them to the data set. There's still no text, so they know that they should be looking at the visual and listening to me. Now the next aspect, which can be overutilized, but I've also seen underutilized, is using animations in your presentation. Animations can be used as a way to direct your audience's attention as you speak. A way to say, look over here at this area of the slide as I'm talking. It also allows them not to get too bogged down or distracted as you're introducing new concepts to them. Because remember, as you're introducing data, the technical components may be new to a lot of people. And finally, another way to do this is through annotations on top of visuals that can be used as another form of directing their gaze and their overall attention. So putting these together, we can have something like an annotation appear as you're discussing it. So if we were trying to explain what the visual is showing, we have an annotation that pops up that says happiness score and points to the score within the specific country. And we can explain exactly what the visual is showing. So in this way, we could say something like, we began by creating a heat map of the happiness score for each country, where the number within each country represents the overall score, and the colors represent how high or how low the score is on a scale. So the darker blue the country is, the higher the numeric happiness score for that country. The deeper red that the country is, the lower the happiness score and overall numeric value. So what we've done before any text has appeared on the screen is explain the visual, explain the overall data that they're going to be looking at throughout the presentation so that they now can understand when we dive into this specific analysis. So it's important that you only use text on the screen in a short and concise manner to highlight the main points that you're discussing. So after I introduce the visual, I can now dive into the analysis. So we have our first bullet point. Happiness levels vary widely by country. So with this, as it appears, my speaker notes can be something along the lines of, however, as high and low scores are spread sporadically throughout the map, there is little correlation that we find between geographical location and happiness. Finally, we concluded that the geographical location alone was not a strong indicator of happiness. So as you can see, as I'm discussing and as I'm explaining what we were looking at within the data, the overall text on the screen only populated as I began to discuss it. So the audience knew exactly where to look and exactly what to be listening to when I'm talking. A very important aspect of the flow of the overall presentation is the transition from one slide to the next. So as I'm discussing this, you can use a bullet point, you can use your speaker notes. Either way, there should be some transition from one slide to the next so that the audience knows that this part is over and they know what's coming next. So for this slide, I used my speaker notes. So I'm going to explain the transition. Something like, our next step was to identify the demographic and economic differences between the higher and lower countries to isolate the correlated features between them. So we get to the next slide. Very common theme. It may be a different visual, but the overall title and where the text is going to show up is going to be in the same place. So we familiarize them with the overall theme of the presentation within 3 slides. Now, the title immediately tells what we're going to be discussing. The previous one was geographic. This one is all based on population. As we move through this slide, and as you saw in the messy example, we use a lot of scatter plots. And scatter plots may not always be the best option because they are rather difficult for people to follow within presentations. But if you explain it to them once so that they understand, you can use them throughout the presentation because you've familiarized them with it. So, because it's the first time it popped up, it's important that you explain the visual in depth and all the features of it that you will be talking about later throughout the presentation. We use animations again. We talk about what are the axes on the scatter plot. We created a scatter plot in which we plotted countries based on their happiness score and the population to see if there was a correlation between the two. The higher up something is on the scatter plot, the happier the country is. The further to the right that the country is plotted, the larger the population. And the line that goes between the two is testing for correlation, or if these two different points are related to one another. So these annotations and these animations are there to clarify what the chart is plotting. Now, the overall purpose is that we are attempting to identify if there is a relationship between the population size of the country and the overall happiness score. So now that you have explained what this visual is, you can now dive into the results of it. Now, this slide itself has one bullet point. It is the results of the overall analysis that you can find just based on the data visual. We found that there was little to no correlation between happiness and population based on the analysis that we ran. So all discussion and in-depth explanation of the visual is kept in the speaking notes besides the overall annotations. And again, the transition is very important to the next slide. So you can say something like, so next we dove into the specific demographics of each country to see if we can identify the features that separate or correlate with the overall happiness of the country. Again, same thing. We have the title. We know what we're going to be talking about now. This is now the health of each country and how it correlates with happiness. We have a scatter plot again, except the good news is you've already introduced what the scatter plot is and what you are comparing on there. So now the audience has been familiarized with the data set. You don't have to go through and explain exactly what the visual is representing. You can dive into the overall differences or analysis that you're going to be presenting on this slide. You can have something explaining that we found a positive correlation between happiness and health, or overall life expectancy of the country. Now, we found this because the correlation coefficient between the two different factors, being happiness and health, was 0.50. Now, you just introduced a new concept. This is where you have to now explain the new concept because otherwise you may lose people in the room. This is a technical component to your overall analysis, and it is an important component, so it is critical that you do explain what it is, but in a simplified way so that everybody understands. So you can say something along the lines of, a correlation coefficient is a measure of strength and direction of the linear relationship between two variables. So in other words, the closer to 1 that the number is, the more positively correlated they are, meaning when one of the variables goes up, so does the other one. The closer to -1 that the number is, the more negatively correlated they are, meaning as one of the variables, such as happiness, goes up, that the other variable, like health, would go down. And the closer to zero it is, it means they are not correlated at all, which is what we saw between population and happiness, and means that they have no relationship together. So we've now explained exactly what it is that we used as an analysis on this specific slide. And it's important, again, that we discuss the transition to the next. So we did find that there was a positive correlation between happiness and health, but the question remains, are happy people healthy, or are healthy people happy? We know that they are related, but we don't know what causes the other. And finally, what contributes to a longer life expectancy? If we know that longer life expectancy is related to happiness, what is it that helps create longer life expectancy within a country? Now, these are the two questions that we need to answer before the end of the presentation, moving on from here. So again, we are creating a logical flow as we move through this presentation. Now we are looking at a new concept, wealth, within each country. Now that you are using, such as the scatter plot, are familiar with the audience, it's okay now that you add in additional ones. So you can say something along the lines of, we then analyzed how GDP, or the overall economic status of the country, relates to the overall health of the country. Because if we know that GDP is related to health, and we know that health is related to happiness, then we can infer additional information through that. So we found that there is a strong correlation between gross domestic product and the overall health of a specific country, with a 0.7 correlation coefficient, so higher than the overall correlation coefficient for health and happiness. Next, we found an even stronger correlation between GDP and happiness. So whereas we first looked at health and happiness and then GDP and health, we're now looking at GDP and happiness and found that it has the highest correlation coefficient between all three of those comparisons. So we have a conclusion within just this slide, which is we found that richer countries have a higher average happiness level. This is a good transition to the overall conclusion of now your entire presentation. So again, you're directing your audience through just presenting the text that you want them to look at. Your first conclusion from your overall presentation: wealthier countries and ones that have sustained economic growth tend to have a higher average happiness level. Your second conclusion: healthier countries also tend to have a happier population. However, healthier countries also tend to be wealthy. And finally, this is where you take it home. So our evidence suggests that wealth, health, and happiness all go together. It's important to also discuss any caveats or future analysis that needs to be ran to answer the questions that may come up based on this analysis. So we have said that the evidence suggests that wealth, health, and happiness all go together, but that does not mean that one causes the other. So there needs to be future analysis to understand any causal effects between them. And then you have your final slide, and this is where questions would come in. So it's important to remember that data storytelling is an art. What we've given you is some high-level overview and examples of what not to do and an improved version, but don't be afraid to put yourself in there. The overall presentation style is going to come from your personality and skill set within data analytics. You can use the tools that we use to help you build the layout of your presentation, but it's up to you to really put a lot of yourself into it and a lot of your own skills to help people understand the overall analytics that you've run.
Hey there. So far, we've learned about using a framework to guide your audience through your presentation and how to weave data in. Now I want to talk about why these presentation skills are so important and give you some simple tips you can use during your own presentations. As a data analyst, you have two key responsibilities: analyze data and present your findings effectively. Analyzing data seems pretty obvious. It's in the title Data Analyst, after all. But data analysis is all about turning raw information into knowledge. If you can't actually communicate what you've learned during your analysis, then that knowledge can't help anyone. There's plenty of ways data analysts communicate: emails, memos, dashboards, and of course, presentations. Effective presentations start with the things we've already talked about, like creating effective visualizations and organizing your slides. But how you deliver those things can make a big difference in how well your audience understands them. And you want to make sure they leave your presentation empowered by the knowledge and ready to make decisions based on your analysis. That's why strong presentation skills are so important as a data analyst. And if the idea of giving a presentation makes you nervous, don't worry. A lot of people feel that way. But here's a secret: it gets easier the more you practice. Now let's look at some tips and tricks you can use when giving your presentations. We'll go over some more advanced ones later, but let's start with the basics for now. It's natural to feel your adrenaline levels rise before giving a presentation. That's just because you're excited to be there. To help keep that excitement in check, try taking deep, controlled breaths to calm your body down. As a bonus, this will also help you channel all that excitement into a presentation style that shows your passion for the work you've done. You might remember we talked earlier about using the McCandless method to present data visualizations. Well, it's also a good rule of thumb for presentations in general. Start with the broader ideas, the obvious questions your audience might have, and what they need to understand to put your findings in context. Then you can get more specific about your analysis and the insights you've uncovered. Let's go back to our avocado example and imagine how we'd start that presentation. After we introduce ourselves and the title of our presentation, we have a slide with our goals for the discussion. We start with the most general goals and then get more specific. We might say, our goal for today is to first provide you all with the state of the world on online avocado searches. Then we'll examine the opportunities and risks of seasonal trends in online avocado searches. We'll move into actionable next steps that can help you start taking advantage of these opportunities, as well as help to mitigate the risks. And finally, we'd love to make the third part a discussion with you about what you think of these next steps. What you'll want to notice here is how our presentation focuses on the general interest in avocados online before getting into specifics about what that means for our stakeholders. We also learned about the 5-second rule. As a quick refresher, whenever you introduce a data visualization, you should use the 5-second rule and ask 2 questions. First, wait 5 seconds after showing a data visualization to let your audience process it. Then, ask if they understand it. If not, take time to explain it. Then, give your audience another 5 seconds to let that sink in before telling them the conclusion you want them to understand. Try not to rush through data visualizations. This will be the first time some of the people in your audience are encountering your data, and it's worth making time in your presentations for them. Here's our first data viz in the avocado presentation. When we get to this slide, we want to introduce our yearly avocado search trends graph and explain the basic background we've included here. After we wait 5 seconds, we can ask, are there any questions about this graph? Let's say one of our stakeholders asks, could you explain Google search trends? Great! After explaining that, we wait another 5 seconds. Then we can tell them our conclusion. Searches for avocados have been increasing every year. You'll learn more about these concepts later on, but these are some great tips for starting out. Finally, when it comes to presenting data, preparation is key. For some people, that means doing dress rehearsals. For others, it means writing out a script and repeating it in their head. Others find visualizing themselves giving the presentation helps. Try to find a method that works for you. The most important thing to remember is that the more prepared you are, the better you'll perform when the lights are on and it's your turn to present. Coming up, we'll cover more best practices for presentations and also look at some examples. Looking forward to it. Hey, good to see you again. By now, you've learned some ways to organize and incorporate data into your presentations. You've also covered why effective presentation skills are so important as a data analyst. Now you're ready to start presenting like a pro. Coming up, I'll share some pro tips and best practices with you. Let's get started. We've talked about how important your audience is throughout this program, and it's especially important for presentations. It's also important to remember that not everyone can experience your presentations the same way. Sharing your presentation via email and putting some forethought into how accessible your data viz is before your presentation can help ensure your work is accessible and understandable. But during the actual presentation, it can be tempting to focus on what's most interesting and exciting to us and not on what the audience actually needs to hear. And sometimes, even the best audiences can lose focus and get distracted. But here's a few things you can do during your final presentation to help you stay focused on your audience and keep them engaged. First, try to keep in mind that your audience won't always get the steps you took to reach a conclusion. Your work makes sense to you because you did it. This is called the curse of knowledge. Basically, it means that because you know something, it can be hard to imagine your audience not knowing it. It's important to remember that your audience doesn't have the same context you do, so focus on what information they need to reach the same conclusion you did. Earlier, we covered some useful things you can add to your presentations to help with this. First, answer basic questions about where the data came from and what it covers. How was it collected? Does it focus on a specific time or place? You can also include your guiding hypothesis and the goals that drove your analysis. Adding any assumptions or methods you use to reach your conclusions can also be useful. For example, in our avocado presentation, we grouped months by season and looked at overall trends. And finally, explain your conclusion and how you reached it. Your audience also has a lot on their mind already. They might be thinking about their own work projects or what they want to have for lunch. They aren't trying to be rude, and it doesn't mean they aren't interested. They're just busy people with a lot going on. So, try to keep your presentation focused and to the point to keep their minds from wandering. Try not to tell stories that take your audience down an unrelated line of thinking. And try not to go into too much detail about things that don't concern your audience. You might have found a really exciting new SQL database, but unless your presentation is about databases, you can probably leave that out. Your audience can also be easily distracted by information in your presentation. For example, the more you include in a chart, the more your audience will need to explore it. So try to avoid including information in your presentations that you don't think will be productive to discussions with your audience. Sharing the right amount of content to keep your audience focused and ready to take action. It's also good to note that how you present information is just as important as what you present. And I have some best practices for delivering presentations. First, pay attention to how you speak. Keep your sentences short. Don't use long words where short words will work. Build in intentional pauses to give your audience time to think about what you've just said. Try to keep the pitch of your sentences level so that your statements aren't confused for questions. Also, try to be mindful of any nervous habits you have. Maybe you talk faster, tap your toes, or touch your hair when you're nervous. That's totally normal. Everyone does. But these habits can be distracting for your audience. When you're presenting, try to stay still and move with purpose. Practice good posture and make positive eye contact with the people in your audience. Finally, remember that you can practice and improve these skills with every presentation. Accept and seek out feedback from people you trust. Feedback is a gift and an opportunity to grow. And with that, you've completed another module. The presentation skills you've learned here, like using frameworks, weaving data into your presentation, and best practices you can apply during your actual presentations, are going to help you communicate your findings with audiences effectively. Hello. So let's talk about how you can be sure you're prepared for a Q&A. For starters, knowing the questions ahead of time can make a big difference. You don't have to be a mind reader, but there's a few things you can do to prepare that'll help. For this example, we'll go back to the presentation we created about health and happiness around the world. We put together these slides, cleaned them up a bit, and now we're getting ready for the actual presentation. Let's go over some ways we can anticipate possible questions before our Q&A to give us more time to think about the answers. Understanding your stakeholders' expectations will help you predict the questions they might ask. As we previously discussed, it's important to set stakeholder expectations early in the project. Keep their expectations in mind while you're planning presentations and Q&A sessions. Make sure you have a clear understanding of the objective and what the stakeholders wanted when they asked you to take on this project. For this project, our stakeholders were interested in what factors contributed to a happier life around the world. Our objective was to identify if there were geographic, demographic, and/or economic factors that contributed to a happier life. Knowing that, we can start thinking about the potential questions about that objective they might have. At the end of the day, if you misunderstood your stakeholders' expectations or the project objectives, you won't be able to correctly anticipate their questions. So think about these things early and often when planning for a Q&A. Once you feel confident that you fully understand your stakeholders' expectations and the project goals, you can start identifying possible questions. A great way to identify audience questions is to do a test run of your presentation. I like to call this the colleague test. Show your presentation or your data viz to a colleague who has no previous knowledge of your work and see what questions they ask you. They might have the same questions your real audience does. We talked about feedback as a gift, so don't be afraid to seek it out and ask colleagues for their opinions. Let's say we ran through our presentation with a colleague, we showed them our data visualizations, then asked them what questions they had. They tell us they weren't sure how we were measuring health and happiness with our data in this slide. That's a great question, and we can absolutely work that information into our presentation. Sometimes the questions asked during our colleague test help us revise our presentation. Other times, they help us anticipate questions that might come up during the presentation, even if we didn't originally want to build that information into the presentation itself. So it helps to be prepared to go into detail about your process, but only if someone asks. Either way, their feedback can help take your presentation to the next level. Next, it's helpful to start with zero assumptions. Don't assume that your audience is already familiar with jargon, acronyms, past events, or other necessary background information. Try to explain these things in the presentation and be ready to explain them further if asked. When we showed our presentation to our colleague, we accidentally assumed that they already knew how health and happiness were measured and left that out of our original presentation. Now, let's look at our second data viz. This graph is showing the relationship between health, wealth, and happiness, but includes GDP to measure the economy. We don't want to assume that our audience knows what that means. So during the presentation, we'll want to include a definition of GDP. In our speaker notes, we've added gross domestic product, total monetary or market value of all the finished goods and services produced within a country's borders in a specific period of time. We'll fully explain what GDP means as soon as this graphic comes up. That way, no one in our audience is confused by that acronym. It helps to work with your team to anticipate questions and draft responses. Together, you'll be able to include their perspectives and coordinate answers so that everyone on your team is prepared and ready to share their unique insights with stakeholders. The team working on the World Happiness Project with you probably have a lot of great insights about the data, like how it was gathered or what it might be missing. Touch base with them so you don't miss out on their perspective. Finally, be prepared to consider and describe to your stakeholders any limitations in your data. You can do this by critically analyzing the patterns you discovered in your data for integrity. For example, could the correlations found be explained as coincidence? On top of that, use your understanding of the strengths and weaknesses of the tools you use in your analysis to pinpoint any limitations they may have introduced. While you probably don't have the power to predict the future, you can come pretty close to predicting stakeholder and audience questions by doing a few key things. Remember to focus on stakeholder expectations and project goals. Identify possible questions with your teams, review your presentation with zero assumptions, and consider the limitations of your data. Sometimes, though, your audience might raise objections to the data before and after your presentation. Coming up, we'll talk about the kind of objections they might have and how you can respond. See you next time. Welcome back. In this video, we'll talk about how you can handle objections about the data you're presenting. Stakeholders might raise objections during or after your presentation. Usually these objections are about the data, your analysis, or your findings. We'll start by discussing what questions these objections are asking, and then talk about how to respond. Objections about the data could mean a few different things. Sometimes stakeholders might be asking where you got the data and what systems it came from. Or they might want to know what transformations happened to it before you worked with it, or how fresh and accurate your data is. You can include all this information in the beginning of your presentation to set up the data context. You can add a more detailed breakdown in your appendix in case there are more questions. When we are talking about cleaning data, you learn keeping a detailed log of data transformations is useful. That log can help you answer the questions we're talking about here. And if you keep it in your presentation's appendix, it'll be easy to reference if any of your stakeholders want more detail during a Q&A. Now, your audience might also have questions or objections about your analysis. They might want to know if your analysis is reproducible. So it helps to keep a change log documenting the steps you took. This way, someone else could follow along and reproduce your process. You can even create a slide in the appendix section of your presentation explaining these steps if you think it'll be necessary. And it can be useful to keep a clean version of your script if you're working with a programming language like SQL or R, which we'll learn all about later. Also, be prepared to answer questions like, who did you get feedback from during this process? This is especially important when your analysis reveals insights that are the opposite of your audience's gut feelings about the data. Making sure to include lots of perspectives throughout your analysis process will help you back up your findings during your presentation. Finally, you might be faced with objections to the findings themselves. A lot of the time, these will be questions like, do these findings exist in previous time periods? Or, did you control for the differences in your data? Your audience wants to be sure that your final results accounted for any possible inconsistencies, and that they're accurate and useful. Now that you know some of the possible kinds of objections your audience might raise, let's talk about how you can think about responding. First, it can be useful to communicate any assumptions about the data, your analysis, or your findings that might help answer their questions. For example, did your team clean and format your data before analysis? Telling your audience that can clear up any doubts they might have. Second, explain why your analysis might be different than expected. Walk your audience through the variables that change the outcomes to help them understand how you got there. And third, some objections have merit, especially if they bring up something you hadn't thought of before. If that's true, you can acknowledge that those objections are valid and take steps to investigate further. Following up with more details afterwards is great too. And now you know some of the basic objections you might run into. Understanding that your audience might have questions about your data, your analysis, or your findings can help you prepare responses ahead of time. And walking your audience through any assumptions about the data or unexpected results are great approaches to responding. Coming up, we'll go over even more best practices for responding to questions during a Q&A. Bye for now. Hello again. Earlier, we talked about some ways that you can respond to objections during or after your presentations. In this video, I want to share some more Q&A best practices. Let's go back to our World Happiness presentation example. Imagine we've finished preparing for a Q&A, and it's time to actually answer some of our audience's questions. Let's go over some ways that we can be sure that we're answering questions effectively. We'll start with a really simple one. Listen to the whole question. I know this sounds like a given, but it can be really tempting to start thinking about your answer before the person you're talking to has even finished asking their question. On slide 11 of our presentation, we outline our conclusions. After explaining these conclusions, one of our stakeholders asks, "How was happiness measured for this project?" It's important to listen to the whole question and wait to respond until they're done talking. Take a moment to repeat the question. Repeating the question is helpful for a few different reasons. For one, it helps you make sure that you're understanding the question. Second, it gives the person asking it a chance to correct you if you're not. Anyone who couldn't hear the question will still know what's being asked. Plus, it gives you a moment to get your thoughts together. After listening to the question and repeating it to make sure you understand, you can explain that participants in different countries were given a survey that asked them to rate their happiness. And just like that, your audience has a better understanding of the project because you took the time to listen carefully. Okay, so now that they know about the survey, they're interested in knowing more. At this point, we can go into more detail about that data. We have a slide built in here called the appendix. This is a great place to keep extra information that might not be necessary for our presentation, but could be useful for answering questions afterwards. This is also a great place for us to have more detailed information about the survey data so we can reference it more easily. As always, make sure you understand the context questions are being asked in. Think about who is your audience and what kinds of concerns or backgrounds they might have. Remember the project goals and your stakeholders' interests in them. And try to keep your answers relevant to that specific context, just like you made sure your presentation itself was relevant to your stakeholders. We have this slide with data about life expectancy as a metric for health. If you're presenting to a group of stakeholders who are in the healthcare industry, they're probably going to be more interested in the medical data and the relationship between overall health and happiness. Knowing this, you can tailor your answers to focus on their interests so that the presentation's relevant and useful to them. When answering, try to involve the whole audience. You aren't just having a one-on-one conversation with the person that's asked the question. You're presenting to a group of people who might also have the same question or need to know what that answer is. It's important to not accidentally exclude other audience members. You can also include other voices. If there's someone in your audience or team that might have insight, ask them for their thoughts. Keep your responses short and to the point. Start with a headline response that gives your stakeholders the basic answer. Then, if they have more questions, you can go into more detail. This can be difficult as a data analyst. You have all the background information and want to share your hard work, but you don't want to lose your audience with a long and potentially confusing answer. Stay focused on the question itself. This is why listening to the whole question is so important. It keeps the focus on that specific question. Answer the question as directly as possible using the fewest words you can. From there, you can expand on your answer or add color, context, and detail as needed. Like when one of our stakeholders asked how the data measuring happiness was gathered. We started by telling them that a survey was used to measure an individual's happiness, and only when they were interested in hearing more about the survey did we go into more detail. So to recap, when you're answering questions during a presentation Q&A, remember to listen to the whole question, repeat the question if necessary, understand the context, involve your whole audience, and keep your responses short. And remember, you don't have to answer every question on the spot. If it's a tough question that'll require additional analysis or research, it's fine to let your audience know that you'll get back to them. Just remember to follow up in a timely manner. These tips will make it easier to answer questions and make you seem prepared and professional. Now that your presentation ready, it's time to wrap up. We covered a lot about how to consider questions before a Q&A, how to handle different kinds of objections, and some best practices you can use in your next presentation. That's it for now. See you in the next video.
Throughout my journey, and something that you'll probably move through as you become further and further along in your career in data analytics is it's not the data itself that is really important to the company. It's the understanding of the data and the impact that it can take. But a lot of business leaders don't have the technical expertise to understand the data in its raw form. So you as the analyst are the translator. So the most important part of the data is you, is the translator of the data for the business leaders. And I found throughout my career that presenting data is probably the most important aspect of being a data analyst, because it doesn't matter how compelling the analysis is or how accurate it is. If people don't understand it, then it doesn't offer value to the business, and it doesn't offer value to anyone. I've devoted a lot of my time, and a big part of my current job is really to help business leaders understand their data and taking something that's very technical and simplifying it so that people understand what it means and how they can use it to impact the business. And it's an art form, it's a skill to really be able to take something that's highly technical and simplify it down so that everybody in the room understands what it's saying and how to use it. So a lot of times when I'm looking at somebody's presentation or building one myself, a really important aspect to a presentation is to define your purpose. Define exactly what it is that you are going to be talking about and why it's important. Why is everybody in the room there, and what are they going to take away from this presentation? The next aspect to a really good presentation is to keep it concise. You don't want things to be too wordy, you don't want a lot of text on the screen, and you don't want it to be too long. It's not that everybody is too busy to be in the room, but you really want to make sure that you're making your point without losing everybody's focus. The next one is have some logical flow to your presentation. You don't want everybody's focus bouncing around from different ideas as you're trying to make your point. You want a very concise and logical flow so that they know what's coming next and what you're talking about currently. The next aspect to think about is making the presentation visually compelling. You want somebody to know what they're looking at and understand it. So the visuals that you choose, the theme that you have for the overall presentation should be appealing, and it should draw people in so that they know exactly what they're getting out of the presentation. And all of these things roll up to the one main concept that you should be thinking about when building a presentation, which is how easy is it to understand? You are trying to make something that is very technical, data analysis, and simplify it down so that it doesn't matter what the technical background or even business background of the person, but they understand what it is that you are trying to explain to them.
Now that you've finished the course challenge, you're officially ready to move on to the next course. Nice. Coming up, Carrie will show you how to use something new, R. R is a programming language that you can use to collect, analyze, and visualize data in new and complex ways. This is different from the skills we've learned so far. Just one of the reasons why it's so exciting. You'll also learn more about what programming languages are and how to use R to work with data. Before you move on, though, I'd like to thank you for joining me in this course and taking on this learning opportunity. Learning should be a lifelong pursuit, and the work you put into learning opportunities like this class will make you better at anything you choose to do. You have come a long way from the first videos in this program. Take a moment to celebrate your progress and everything you've learned. After that, head on to the next course. Carrie is waiting to help you get started.
Hey there, Data Pro. You've come a long way since the beginning of your learning journey. Congratulations on your accomplishment. Just think of all the skills you've learned along the way. You now know how to use structured thinking to define a problem and ask the right questions, work with spreadsheets, databases, and tools like SQL to organize and transform data, clean your data to make sure it has integrity before you analyze it, create impactful visuals to illustrate key points, and craft a compelling story to communicate insights to stakeholders. That's an impressive list of skills, but we're not done yet. Your skill set's about to get even bigger. In this course, you'll learn about a new concept called programming and how you can use the R programming language to analyze your data. By now, you know that the data analysis process includes 6 phases. ask, prepare, process, analyze, share, and act. Now we'll learn all about the R programming language and how it can help you in each phase of the process. When you're done, you'll be presented with an optional case study. The case study will give you the chance to solve a data analysis problem using all the skills you've learned in this program. You'll find out more about this project later on. Okay, let's talk about computer programming. Computer programming refers to giving instructions to a computer to perform an action or set of actions. You can use different programming languages to write these instructions. You might choose a specific language based on the project you want to pursue or the problem you want to solve. The R programming language is super useful for organizing, cleaning, and analyzing data. If this is your first experience with computer programming, welcome! When I first started learning about data analysis, I didn't have a background in programming either. In fact, before I fell in love with data, I was trained as an opera singer. I also have a lot of friends that came into this field from the arts and learned about programming later in their career. R is a great place to start. Learning R for the first time can be challenging and even more empowering. A lot of the skills you've learned in this program will help you learn basic programming concepts. Take it one step at a time and go at your own pace. And just like in previous videos, you'll start with the basics and move forward from there. You've tackled tough challenges before, and you always come out on top. You've got this. Let me introduce myself. My name's Carrie. I work as a research manager at Google. I lead a team that researches the best way to improve the performance of people in organizations. In other words, I help people work better and work smarter, and help organizations function in a healthy and productive way. I first learned R as a junior data analyst, while I was working on a multi-year project about virtual work. We were looking at data on people's virtual work experiences and trying to understand how working remotely impacts performance. It was a complex project with a lot of data to sift through. I kept encountering problems and searching for better and faster ways to do things. This is when I became aware of the power of R. Whenever I got stuck, I'd learn a little more about R and discover a solution to my problem. I soon realized that R could help me do almost anything involving data, even better and faster than I thought possible. Fortunately, there are tons of great online resources for R and a super supportive online community. If I had a question, I'd go online and find the answer. As the project progressed, I was able to learn more and more and become a much more effective data analyst. My teammates even started coming to me for advice about R. Realizing that I could continue to learn my skills at any stage in my career was an empowering experience. Learning R unlocked my ability to perform data analysis at the highest level. In your future career as a data analyst, you'll have the opportunity to continually learn and grow. To me, that might be one of the coolest aspects of the job, and learning R is one of the most rewarding parts of that growth process. I'm still learning new ways to use R all the time. Plus, you can apply these skills to other programming languages, like Python, Julia, or JavaScript. There's no limit to how far you can go with programming. It even goes beyond data analysis. After I learned R, I found myself thinking about all kinds of projects I could use programming for, both at work and for fun. It opens up a whole new world of possibilities. Now, let's talk about what you're about to learn. We'll start off with an introduction to programming languages. Then, we'll take a closer look at R itself and explore its main features and functions. We'll also cover some basic programming concepts and learn how to use them effectively in R. Next, we'll learn how to work with data in R. You'll discover how R can supercharge your data analysis skills and let you clean, transform, visualize, and report data in new and more powerful ways. Learning R will help you take your data analysis to the next level. It'll also look great on your resume. R is widely recognized as a key credential in entry-level job positions. Knowing how to use R will give you a big boost in your job hunt and will help you stand out as a new analyst. Coming up, we'll talk more about programming languages in general and how they can help you analyze your data. After that, we'll jump right into R. Before you know it, you'll be using R to power your data analysis. Hi, great to see you again. When I first learned R, it was the visuals that really got me hooked. I still think it's so cool that you can write a little bit of code, press a button, and presto, out pops an awesome data visualization. Before we get into all of the details, I thought it would be fun to give you a quick sneak peek and show you what R can do. What follows will be a preview of what you're going to learn. By the end of this course, you'll not only understand all this code, you'll be able to write and execute it as well. For now, just sit back, relax, and enjoy the show. Let's start by loading a library and getting a dataset to work with. We can use the Palmer penguins dataset, which contains size measurements for 3 penguin species that live on the Palmer archipelago in Antarctica. This includes data on stuff like body mass, flipper length, and bill length. The dataset has 344 rows of information sorted into 8 columns. The Palmer penguins data is popular with analysts and is great for fun exploration, visualization, and teaching concepts. We'll see more of this dataset later on in the course. Let's say we want to visualize the relationship between body mass and flipper length. You may guess the larger the penguin, the longer the flipper. We can find out for sure by creating a plot. Let's make a scatter plot. A scatter plot uses points to display the relationship between 2 variables. So the 2 variables we're going to compare are body mass and flipper length. No need to memorize all these details right now. You'll have time to learn more about them later on. Let's check out the parts of this code and how they fit together. The first function starts the plot. If we run the code at this point, all we get is a blank plot. If we add some more code, R will put labels on each axis of our plot and add lines for data. Body mass is on the y-axis, and flipper length is on the x-axis. But the data points are not yet visible. To get the complete plot, we can add some more code that tells R how to represent our data. For example, we could use points, bars, or lines. We'll use points to create a scatter plot. We can go further. For example, we can change how the plot looks. Let's change the color of all of the points to purple. You can hit the up arrow to pull up the last piece of code you ran, so we'll do that now. And then we'll add in color equals purple inside geom point. Now we can hit enter to run this. We can also add new information to the plot and use color to highlight it. Let's tell R to assign a different color to each species of penguin. This way, we can link data points to each group of penguins. Gentoos are the largest. The legend just to the right of the plot shows us that the blue points refer to the gentoos. R automatically creates a legend for the plot to help us understand the color coding. R does everything you tell it to do, and even does stuff you don't ask for. It's just that helpful. We can also use shape to highlight the different penguin species. Or we can use both color and shape. In addition to highlighting our data, we can also reorganize it. We can break our data down into smaller groups or subsets and create a plot for each subset. Let's say we want to focus on the data for each species. Facet functions let us create a separate plot for each species. Check this out. Facets are so great. We can even put text on our plot to point to specific data or communicate a message. Let's give our plot a title to clearly indicate its purpose. Finally, we can save our plot so we can access or share it later on. Now, if we click on the Files tab, we'll find our file in the list. Let's open it up. Well, that's the end of the show. I hope you enjoyed it as much as I did. We were able to take a big data set and quickly visualize some significant patterns. These are some of the basic functions in R. In other words, this is just the beginning. It's exciting to think of all the ways R can help you realize the full power of data analysis. As you move forward, you'll learn more about each of the functions we use to create our plots. By the end of this course, you'll be the one writing and executing all of this code. Coming up, we'll learn more about computer programming and how it can help you analyze your data. See you soon. The advice I would give to someone just learning R is that mistakes are part of the process. Errors and error messages are part of the process. When I think about the people who are even better than I am in R, I think I've come to realize they're not necessarily smarter than I am, but they may be a little bit more persistent and delving a little bit deeper. And certainly compared to when I started, I think initially I'd see an error message and think, I did it wrong. Like, uh-oh, game over. And now it's like, oh, that's just part of the game. When I started to get a little bit of exposure to what R looked like, I was like, oh, that seems too sophisticated. It seems like it probably is really, really hard. But the people who used it that I had met were always really enthusiastic about it, and they felt like it had so many advantages over other software that you can use for running analyses. There were a lot of times before I used R where I might use spreadsheets or some other tool, and I would kind of be trying to hack at what really needed to happen. Sometimes I was using multiple tools because an individual tool couldn't really do all of what I wanted it to do, but it's sort of like I knew in my mind, and yet it wasn't totally fluid, the execution of it. The more exposure I've gotten to R, the more I realize a lot of what I would try to do that way, I can just do within one program, and it can all sort of interlock really fluidly. At first, I was really unconfident. I had a couple of scripts where I had some friends who were better at R, people I worked with who would sit down and sort of like help me go through and understand the code. And so it felt like really silly to ask them the kind of like simple question of like, okay, but why is a bracket here? Or why would we do this? But they were fortunately really patient people. And then at some point, our entire department said, actually, really everybody needs to be using this because we need everyone on the same platform. We need consistency in our analyses. We need to be able to code review each other's analyses as well. And so we all took an online course together, and that actually helped me feel really a lot more confident because it was walking through each step of what you needed to know, got an opportunity to practice, and then it felt like, okay, even if there's things I don't know, I've made it through introduction. Like I've made it through this next module. So I guess I do know something. And then once I started to apply it in my work, there would still be points where I was like, wait, I don't know how to solve this problem. And then I would talk to a friend, Google something. And generally it was like, I knew a lot more than I thought that I did. And from that, I suddenly unlocked my ability to produce a whole lot of analyses quickly with the big data set, and also produce a whole lot of data visualizations really quickly using ggplot2.
Hi, my name's Carrie, and I'm a research manager within people operations at Google. Hi, great to have you back. Earlier, you learned that programming means giving instructions to a computer to perform an action or set of actions. And even if this is your first time programming, you already have plenty of experience telling a computer what to do. For example, you've probably used a spreadsheet function to sort your data or perform calculations. Or you might have used SQL to tell a computer how to pull data from a database or join two different data tables. Programming goes even further. It gives you the highest level of control over your data. SQL can communicate with databases, but a general purpose programming language lets you create your own applications and build your own functions from scratch. To program, you first need to know a programming language. In this video, we'll learn about the basics of programming languages and how they can help you work with your data. Programming languages are the words and symbols we use to write instructions for computers to follow. You can think of a programming language as a bridge that connects humans and computers and allows them to communicate. Programming languages have their own set of rules for how these words and symbols should be used, called syntax. Syntax shows you how to arrange the words and symbols you enter so they make sense to a computer. Coding is writing instructions to the computer in the syntax of a specific programming language. Just like the variety of human languages around the world, there's lots of different programming languages available to communicate with computers. There's a language for almost anything you want to do, from designing websites, to developing video games, to working with data. For example, Python is a general-purpose language that can be used for all sorts of things, from working with artificial intelligence to creating virtual reality experiences. JavaScript works well for developing online apps and is an essential part of web browsers. Some other popular programming languages for data analysis include SAS, Scala, and Julia. Personally speaking, R is my favorite language for data analysis. But you might want to explore other languages as well. While programming languages can look different on the surface, they all share similar structures and coding concepts. Once you learn your first language, you'll find it easier to learn others. Coming up, we'll explore R's many capabilities. Before that, let's talk about some benefits of using any programming language to work with your data. I'll highlight 3. Programming helps you clarify the steps of your analysis, saves time, and lets you easily reproduce and share your work. Let's start with clarity. Programming languages have specific rules and guidelines for giving instructions to the computer. When you're telling a computer what to do, your instructions have to be very clear. There can't be any inconsistency in the way you write code. If there is, the code won't work. Translating your thoughts into code forces you to figure out exactly how to write each step of your analysis and how all the steps fit together. It gives your analysis a level of precision that makes it really powerful. Using a programming language for data analysis also saves you lots of time. For example, take the process of cleaning and transforming your data. With one line of code, you can create a separate data set without any missing values. With another line, you can apply multiple filters on your data. This lets you spend less time preparing your data and more time on the analysis itself. Finally, programming languages make it easy to reproduce your analysis. Data analysis is most useful when you can reproduce your work and share it with other people. They can double-check it and help you solve problems. Code automatically stores all of the steps of your analysis. So you can reproduce and share your work at any time in the future, weeks, months, or even years later. Here's an example. Let's say you're working on a project. You've collected and cleaned your data and started your analysis. But the results don't add up. You suspect a mistake was made in the process. You'd like to discuss the issue with a teammate and get their feedback. If you used a spreadsheet, you both might have to redo the entire analysis to discover the error. There's no easy way to record and reproduce your steps in a spreadsheet. But if you use a programming language, all your work can be reproduced and shared in a moment. From loading the data to creating visualizations to reporting the results. Plus, you can easily update your analysis and fix any errors simply by changing the code. I hope that gives you a better understanding of what programming languages are all about. Next up, we'll check out R in more detail. See you soon! Hello again! Now that we've talked about programming languages in general, let's get to know R. So, what is R? R is a programming language frequently used for statistical analysis, visualization, and other data analysis. Later on, you'll take a tour of R Studio, which is a popular software environment for the R language. In this video, we'll discuss R's main features and functions and its advantages for data analysis. R is super cool. I'm excited for you to learn about it. R is based on another programming language named S. In the 1970s, John Chambers created S for internal use at Bell Labs, a famous scientific research facility. In the 1990s, Ross Ihaka and Robert Gentleman developed R at the University of Auckland, New Zealand. The title R refers to the first names of its two authors and plays on a single letter title of its predecessor, S. Since then, R has become a preferred programming language of scientists, statisticians, and data analysts around the world. There's lots of reasons why people who work with data love R. I want to share 4 with you. R is accessible, data-centric, open source, and has an active community of users. First, R is an accessible language for beginners. Lots of people without a traditional programming language learn R. I should know I'm one of them. R really appeals to anyone who wants to solve problems that involve data. And that's one of the things that's so great about R. It's all about data. R is what's known as a data-centric programming language. It's specifically designed to make data analysis easier, more efficient, and more powerful. Another awesome thing about R is that it's open source. Open source means that the code's freely available and may be modified and shared by the people who use it. Let's pause for a moment and unpack how amazing this is. First, anyone can use R for free. Second, anyone can modify the code, fix bugs, and improve it. In fact, over the years, lots of excellent programmers have made improvements and fixes to the R code. For example, anyone who knows the R language can create what's called an add-on package. We'll talk more about R packages later. For now, just know that literally thousands of R packages exist, and they were all built by people who wanted to solve specific problems. A lot of these packages are super useful for data analysts. As an R user, you now enjoy the benefit of this shared knowledge. And let me just add, the R community is the best. This vibrant, diverse, and accessible community is so supportive of new learners. You can go online anytime to find answers to all your R questions. Check out websites like R for Data Science Online Learning Community and R Studio Community. On top of that, R users are all over Twitter and other social media. You'll discover tons of resources for professional networking, mentoring, and learning. Now that we know more about the general benefits of R, let's talk about some specific situations when you might use it for data analysis. Here's 3 scenarios: reproducing your analysis, processing lots of data, and creating data visualizations. First, R can save and reproduce every step of your analysis. Earlier, we discussed how data analysis is most useful when you can easily reproduce your work and share it with others. In R, reproducing your analysis is as easy as pressing a button on your keyboard. Your code stores it forever, and you can share it with anyone at any time. Processing lots of data is also something R does really well, just like SQL. As you learned earlier, spreadsheets organize projects in sheets or tabs. If you've ever had to deal with spreadsheet files that have tons of sheets or lots of data in each sheet, you know that things can start to move very slowly. Working with too much data in a spreadsheet can even cause crashes. R can handle large amounts of data much more quickly and efficiently. Finally, R can create powerful visuals and has state-of-the-art graphic capabilities. As you've seen in this program, tools like spreadsheets and Tableau offer lots of options for visualizing your data. R's on another level. With only a small bit of code, you can create histograms, scatter plots, line plots, and so much more. And that's just the beginning. If you work with more advanced packages, you can make some seriously impressive data visualizations. Learning R is a huge benefit to anyone interested in becoming a data analyst. As I mentioned earlier, knowledge of R will help you stand out as a job candidate. And as you keep moving forward, R will help you find solutions for more complex data problems. You can keep learning about R throughout your career as a data analyst. The sky's the limit when it comes to developing your data analysis skills. That's all for now. Coming up, we'll check out the RStudio environment together. Before you use RStudio, you need to download and install the basic R interface. You'll learn how to do that in an upcoming reading. Most analysts who work with the R language use the RStudio environment to interact with R, and not the basic interface. That's why we're focusing on RStudio in this program. Following this video, you'll find resources for downloading R and RStudio if you're interested in learning more. Bye for now. Hey there! It's time to take our tour of RStudio. The examples we look at are from RStudio Cloud, but RStudio works in a similar way across all platforms. Feel free to use the platform that works best for you. Later on, if you want to learn more, you'll find resources on how to download and install RStudio on your own device. RStudio is an IDE, or Integrated Development Environment. This means that RStudio brings together all the tools you might want to use in a single place. The R console, which we explored earlier, is one part of this environment. RStudio also includes an editor for writing code and tools for managing your data and creating visuals. RStudio is built specifically for use with R. It'll help maximize your productivity as a data analyst. Data analysis is like driving a car. You can think of R and RStudio as different parts of this car. R is like the car engine. RStudio is kind of like the accelerator, the steering wheel, and dashboard all in one. It lets you tell the engine what to do and helps you get to where you want to go. Just as a speedometer and navigation system make driving much easier, RStudio's environment makes using R much easier. In an earlier reading, you learned how to access RStudio. So let's log into RStudio now and explore. The RStudio environment has 4 main windows called panes. Each pane helps you perform different functions. The first time you open RStudio, you'll see 3 panes. A 4th pane is hidden by default, but it's easy to open. Just click on File in the menu. Then select New File and R Script. RStudio has lots of keyboard shortcuts. To learn more, check out Keyboard Shortcuts Help. You can make the panes smaller or larger by clicking on the Minimize or Maximize buttons at the upper right of each pane. You can also click and drag the borders of the panes to adjust their size. Click on the Panes button for more feature options. Now that we've got all 4 panes open, let's explore each of them. We'll start on the lower left and move clockwise from there. You might recognize the R console from an earlier reading. As a quick refresher, the console is the place where you give commands to R. For example, we can tell R to show us a summary of the penguins data that we used in an earlier video to create visuals. You'll need to install and load the Palmer Penguins dataset if you haven't done so already. Above the console, in the upper left, is the source editor pane. You'll use the source editor when working with R scripts. There are two main ways of writing code in RStudio, using the console or using the source editor. You can type commands directly into the console, but they'll be forgotten when you close your current session. As we've discussed, it's important to be able to reproduce and share all the steps of your analysis. If you save your script in the editor, you can access your work again at any time and show others how you did it. The source editor and the console also work together in RStudio. When you execute code in the editor, the code automatically appears in the console. If you're working on a long analysis, this makes it easy to execute the entire code all at once or run specific sections of it as you go along. Let's run some code in the editor and check it out. Pro tip, always keep in mind that R is case sensitive. Here, we use a capital V for the view function. Next, let's go to the environment pane in the upper right. Here you'll find all the data you currently have loaded and can easily organize and save it. For example, if you import data from a spreadsheet, it'll be visible in the environment pane. You can view each object in the environment pane by clicking on it. You can also toggle between a list view and a grid view. To the right of the Environment tab, you'll find the History tab. All your previous commands are saved here, and they're easy to search and re-execute. You'll find the most recent line of code at the bottom of the list. You can copy any line to the command console by double-clicking it. In the lower right, you'll see a pane that has tabs for files, plots, packages, and help. The Files tab gives you access to your file directory and shows the contents of the current working folder. You can easily find and manage all your files and create new project folders. Next is the Plots tab. If we create a plot, the result appears here. For example, we can create a scatter plot with the penguins dataset we used earlier. You'll learn more about creating plots in RStudio later on. Earlier, we talked about R packages, which are custom solutions to data problems developed by R users. RStudio gives you access to a library of R packages, known as the tidyverse. You can upgrade, install, and manage your library in the Packages pane. Packages loaded in your current session have a check mark. Later on, we'll explore the tidyverse in more detail. Finally, click on the Help tab. Here you can find helpful resources for R and RStudio. There are tons of resources out there to help answer all your questions. Be sure to take advantage of them. That's our tour of RStudio. We're just scratching the surface of what RStudio can do. Soon, you'll get to explore RStudio in more detail. Speaking as a data professional, I love working in RStudio. It makes my work so much easier, faster, and better. Congratulations on finishing another step in your data analyst learning journey. Coming up, we'll learn some basic programming concepts. Then we'll start working with R. For those of you who are new to programming, you're about to write your first lines of code. See you then. Hi, and welcome back. We've given you a big picture overview of R and RStudio. Now we'll turn our focus to the actual programming and coding you'll do using RStudio. I went pretty far in my career not knowing programming before it became clear I needed to learn it. Getting to know R was such a valuable learning experience. It took some time, and I reached out to more experienced R users with lots of questions. And eventually, it all came together for me. Being open to learning new skills is such an important part of your career. And now, I'm able to help you learn some new skills too. I'll start by sharing the fundamentals of programming using R in RStudio. Earlier, we explained how R is like the engine of a car, and RStudio is like the accelerator, steering wheel, and dashboard all in one. Getting to know fundamentals will help you keep your R car running smoothly. These fundamentals are both alike and different from the other analysis platforms you've come to know well, spreadsheets and SQL. Then we'll move into coding in RStudio. We'll discuss the syntax for performing calculations and the standards and naming conventions for all code. We'll also explore the R tool known as a pipe, which you'll use to make a sequence of code easier to work with and read. Then we'll check out R packages. While these packages won't be delivered to your door, they are delivered by the R community. These packages contain reusable functions and more, and are usually built by users for users like yourself. We'll get to know a collection of packages called the tidyverse. You'll learn how to install the tidyverse so you can start using it in RStudio. We'll also work with some of the more popular tidyverse packages, like ggplot2 for visualization. You'll be able to carry over what you've learned about RStudio to the next part of the program, where you'll start working with data. As we explained earlier, for this program, we'll use the in-browser version of RStudio, RStudio Cloud. But RStudio is also available to be downloaded. So let's get going. See you soon. Hey there. Anytime you're learning a new skill, from cooking to driving to dancing, you should always start with the fundamentals. Programming with R is no different. To build this foundation, you'll get familiar with the basic concepts of R, including functions, comments, variables, data types, vectors, and pipes. Some of these terms might sound familiar. For example, we've come across functions in spreadsheets and SQL. As a quick refresher, functions are a body of reusable code used to perform specific tasks in R. Functions begin with function names like print or paste, and are usually followed by one or more arguments in parentheses. An argument is information that a function in R needs in order to run. Here's a simple function in action. Feel free to join in and try it yourself in RStudio using your cloud account. Check out the reading for more details on how to get started. You can pause the video anytime you need to. We'll open RStudio Cloud to get started. We'll start our function in the console with the function name print. This function name will return whatever we include in the values in parentheses. We'll type an open parenthesis followed by a quotation mark. Both the close parenthesis and end quote automatically pop up because RStudio recognizes this syntax. Now we just have to add the text string. We'll type coding in R. Then we'll press enter. Success! The code returns the words coding in R. If you want to find out more about the print function, or any function, all you have to do is type a question mark, the function name, and a set of parentheses. This returns a page in the help window, which helps you learn more about the functions you're working with. Keep in mind that functions are case sensitive, so typing print with a capital P brings back an error message. Functions are great, but it can be pretty time-consuming to type out lots of values. To save time, we can use variables to represent the values. This lets us call out the values anytime we need to with just the variable. Earlier, we learned about variables in SQL. A variable is a representation of a value in R that can be stored for use later during programming. Variables can also be called objects. As a data analyst, you'll find variables are very useful when programming. For example, if you want to filter a dataset, just assign a variable to the function you use to filter the data. That way, all you have to do is use that variable to filter the data later. When naming a variable in R, you can use a short phrase. A variable name should start with a letter and can also contain numbers and underscores. So the variable 5penguin wouldn't work well because it starts with a number. Also, just like functions, variable names are case sensitive. Using all lowercase letters is good practice whenever possible. Now, before we get to coding a variable, let's add a comment. Comments are helpful when you want to describe or explain what's going on in your code. Use them as much as possible so that you and everyone can understand the reasoning behind it. Comments should be used to make an R script more readable. A comment shouldn't be treated as code, so we'll put a hashtag in front of it. Then we'll add our comment, "Here's an example of a variable." Now let's go ahead with our example. It makes sense to use a variable name to connect to what the variable is representing. So we'll type the variable name first_variable. Then, after the variable name, we'll type a less than sign followed by a dash. This is the assignment operator. It assigns the value to the variable. It looks like an arrow, which makes sense since it's pointing from the value to the variable. There are other assignment operators that work too, but it's always good to stick with just one type in your code. Next, we'll add the value that our variable will represent. We'll use the text, "This is my variable." If we type the variable and hit run, it'll return the value that the variable represents. This is a very basic way of using a variable. You'll learn more ways of using variables in your code soon. For now, let's assign a variable to a different data type, numeric. We'll name this second variable and type our assignment operator. We'll give it the numeric value 12.5. The environment pane in the upper right part of our workspace now shows both of our variables and their values. There are other data types in R, like logical, date, and date time. R has a few options for dealing with these data types. We'll explore them later. With functions, comments, variables, and data types, you've got a good foundation for working with R. We'll revisit these throughout this program and show you how they're used in different ways during analysis. Let's finish up with two more fundamental concepts, vectors and pipes. Simply put, a vector is a group of data elements of the same type stored in a sequence in R. You can make a vector using the combine function. In R, this function is just the letter C followed by the values you want in your vector inside parentheses. All right, let's create a vector. Imagine this vector is for measurement data that we need to analyze. We'll start our code with the variable VEC_1 to assign to the vector. Then we'll type C and the open parenthesis. Then we'll type our list of numbers separated by commas. We'll then close our parentheses and press enter. This time, when we type our variable and press enter, it returns our vector. We can use this vector anywhere in our analysis with only its variable name, vec_1. The values in the vector will automatically be applied to our analysis. That brings us to the last of our fundamentals, pipes. A pipe is a tool in R for expressing a sequence of multiple operations. A pipe is represented by a percentage sign, followed by a greater than sign and another percentage sign. It's used to apply the output of one function into another function. Pipes can make your code easier to read and understand. For example, this pipe filters and sorts the data. Later, we'll learn how each part of the pipe works. So there they are, the Super 6 fundamentals: functions, comments, variables, data types, vectors, and pipes. They all work together as a foundation for using R. It's a lot to take in, so feel free to watch any of these videos again if you need a refresher. When you're ready, there's so much more to know about R and RStudio. So let's get to it. Hi again. We've shown you how your work as a data analyst can be done in different ways using different tools. That's true in this program, and it'll be just as true when you start your job. Operations and calculations are two concepts we've checked out before. Coming up, we'll go back to them and learn how to use operators in R for a range of tasks, including calculations. An operator is one of the key components of a calculation. When we first talked about operators, we defined them as a symbol that names the type of operation or calculation to be performed in a formula. The same is true when we use operators in R code. So let's check out some of these operators in R. Imagine we've got our hands on some e-commerce sales data that we need to analyze. We'll learn how to use operators to complete calculations on the sales data, and for some other tasks too. Throughout our analysis, we'll use variables that R will store so that we can reference them whenever we need to. We'll use assignment operators, which we worked with earlier, to do this. Assignment operators are used to assign values to variables and vectors. So if we've got a bunch of sales figures that we want to include in a vector, we can use an assignment operator to assign them to a variable. Here's an example. Now, whenever we want to use these sales figures, we just type the variable we assigned. Next, let's check out arithmetic operators. These operators are used to complete math calculations, and they might seem familiar. Plus signs do addition on variables, and minus signs do subtraction. We use an asterisk to perform multiplication, and a slash performs division. There's other arithmetic operators too, but these are enough to get you started. Let's try a calculation for our sales data in RStudio. Feel free to follow along on your own as we go through these steps. We'll complete our work in a script to make sure our calculations are saved. As an analyst developing code in R, you'll spend most of your time in scripts. When you save a script, you'll have a complete record of your work. You'll use the console mostly to show the results of your programming. Also, even though we're not doing a deep analysis here, it's still a good idea to save our work for easy access later if we need it. First, let's add a comment. After the hashtag, we'll type R first calculations. We'll start by assigning sales figures from the first 2 quarters of the year to variables. Before we complete our first calculation, we'll assign it to a new variable, midyear_sales. Then we'll add our quarterly figures using the plus sign as our addition operator. Let's run it and get the total of our sales data. When we run code in a script, the return shows up in the console. This total's now assigned to the midyear_sales variable. We can check this by typing in midyear_sales into the console and hitting enter. You may notice that calculations in R work in a similar way to calculations in spreadsheets and SQL. It's helpful to make connections across the tools that you're working with. Let's do one more calculation using our total sales from the first 2 quarters represented by midyear underscore sales. We'll multiply it by 2 to get a general idea of total sales for the year. We'll use an asterisk as our arithmetic operator. You'll find there's other ways to perform these types of calculations, but these are great examples of how the operators work, both for calculations and other operations. For now, let's save our script so that we can use these same variables again if we need to do more work in our sales data. Just like in other formats, we simply click Save As and then type a file name. An R file extension is automatically applied to our file name. We'll close our script. When we're ready for more sales data analysis, we can open it again using the File menu. There are other categories of operators that you'll learn about later, but knowing how assignment and arithmetic operators help you program calculations is a good place to start. We're definitely moving forward in R and RStudio. Let's keep it rolling by learning more about pipes, another great tool in R. See you soon! Hello there! I have to say, getting a package delivered to you is one of life's simple pleasures. Doesn't matter if it's a surprise package or something you ordered yourself, it's exciting to open your package to discover what's inside. No wonder those unboxing videos on YouTube are so popular. Well, R has a different kind of package that R users can open. These packages are units of reproducible R code, and they make it easier to keep track of code. They're created by members of the R community to keep track of the R functions that they write and reuse. These community members might then make the packages available to other users. It's one of the great things about being part of this community. Packages in R include reusable R functions and documentation about the functions, including how to use them. They also contain sample datasets and tests for checking your code to make sure it does what you want it to do. By default, R includes a set of packages called Base R that are available to use in RStudio when you start your first programming session. There's also recommended packages that are loaded but not installed. Before using functions from one of these packages, you'd have to load it with a library command, like library boot, for example. Let's find out which packages we already have in RStudio. We'll work in our console instead of a script for now, because we're practicing and don't need to save this code for later. To check out our packages, we'll just run the command installed.packages. And there's our list. Let's focus on the package and priority columns. The package column gives the name of the package, like cluster or graphics. The priority column tells us what's needed to use functions from the package. If you come across the word base in the priority column, then the package is already installed and loaded. You can use all of the functions of that package as soon as you open RStudio. If you find the word recommended, then the package is installed but not loaded. You'll also notice a list of packages in the bottom right part of our workspace. This list includes a brief description of each package. To load class and other uninstalled packages, we'll need to use the library function, followed by the name of the package. And now, the class package has a check next to it, so it's been successfully loaded for use. If you want to learn even more about your loaded packages, you can click on their names in the Packages tab. This opens the Help tab and shows topics related to the package you selected. You can also use the Help function in your programming to call up the Help tab. While the pre-installed packages give you tons of useful functions, there's even more packages that'll further expand your programming abilities. You can find thousands of R packages just by doing an online search. One of the most commonly used sources of packages is CRAN. CRAN stands for Comprehensive R Archive Network. It's an online archive with R packages, source code, manuals, and documentation. When you start working with R, you'll be able to do your own searches to find packages in CRAN or elsewhere. It's almost always easier to just search with your favorite search engine, though. So, packages are a pretty big part of using R. They give you most of what you need to complete your programming throughout the data analysis process. Who knows? You might even turn your own code into packages for others to use. Up next, we'll keep unpacking R packages. See you soon. Welcome back! As we discussed earlier, packages are a big part of what makes R so great. Packages offer a helpful combination of code, reusable R functions, descriptive documentation, tests for checking operability, and sample datasets. And for lots of data analysts, at the top of the list of useful packages is Tidyverse. Tidyverse is actually a collection of packages in R with a common design philosophy for data manipulation, exploration, and visualization. Using Tidyverse can help you work your way through pretty much the entire data analysis process. The packages in Tidyverse work together naturally. I started learning about Tidyverse when I was working on a survey project. It felt like I was stepping into a more advanced zone of R. I understood the basics, but now I was finding out how the Tidyverse improves on the basics. That's when I got even more excited about working in R. I realized that the more I put into learning about the Tidyverse, the more I'd get out of it. On top of that, the community support for Tidyverse is strong too. It's one of the reasons why Tidyverse is considered a key part of programming for most R users. The principles associated with Tidyverse, which you'll learn both here and at your job, have been widely adopted by the R community. You'll find lots of tutorials and examples related to the Tidyverse online that show you these principles and how they're applied to data analytics. Okay, let's install the Tidyverse. You can follow along on your own using your RStudio Cloud account. Check out the reading for more details. Earlier, you learned how to find base R packages using the function installed packages. To install packages like the Tidyverse that aren't in base R, we'll use the install packages function. As we discussed earlier, this function calls the Tidyverse and other packages from CRAN. Let's talk about why CRAN was created. Since packages not in base R are mostly made by R users, people need a reliable way to check and validate submitted code. CRAN makes sure any R content open to the public meets the required quality standards. So, if it's sourced through CRAN, you can feel good that the package is authentic and valid. Another major source of packages and other R content is GitHub. Now, we'll get back to installing the Tidyverse. We'll first type install.packages. Then, between the parentheses, we'll type Tidyverse in quotes. The quotes aren't always necessary, but best practice is to use quotes to make sure that we're accurate. We'll press Enter and wait for RStudio to install Tidyverse. When we click on our Packages tab, we come across a lot of new packages on the list. That's Tidyverse. You might have noticed that none of the packages are checked off. We need to load them first before we can use them. But that's a mighty long list, so let's just load the package named Tidyverse for now using the library function. The return shows that not only was Tidyverse loaded, but 8 other packages were too. It also shows a list of conflicts. Conflicts happen when packages have functions with the same names as other functions. Basically, the last package loaded is the one whose functions will be used, so we'll stick with the Tidyverse functions. But it's important to note that these messages only appear once. So as you get more used to R, you'll be able to figure out if you want to use certain functions over others. The loaded packages are ggplot2, tibble, tidyr, readr, per, dplyr, stringr, and forcats. These packages are the core of the tidyverse because you'll use them in almost every analysis. All of them work together to make your data analysis smooth and efficient. With these packages, Tidyverse helps you do everything from importing and transforming data to exploring and visualizing it. We'll check out this core of packages soon, and we'll use them even more as we continue working in RStudio. If you're working on your own in R, you can check out some of the other packages too. The packages available in Tidyverse change a lot, but you can always check for updates by running tidyverse_update open parentheses and close parentheses in your console. You can then update the packages in a couple of ways. If you use the update packages function, it'll update all of your packages. That might take a while. So if you just want to update one package, you can use the install packages function again with the package name as your argument in parentheses. You should update packages regularly to make sure you've got the latest version in your code. Conflict notifications are just one type of message that can show up in the console. You might find warnings and error messages as well. A quick search using the Help tab will usually tell you what the message means and what, if anything, you'll need to do to address it. Coming up, we'll keep moving through the Tidyverse. You'll find out more about why Tidyverse is such an integral part of R. See ya! Great, you're back! Have you ever taken a tour of a famous landmark or an unfamiliar city? It can be pretty exciting. You get to learn all about the features of the landmark or city. Eventually, you get to know them pretty well, and you can share what you learned with others. Well, we're here to take a different kind of tour, a tour of the Tidyverse. For this tour, we won't be traveling anywhere special, but we will help you learn about the exciting Tidyverse features. And once you know them a little better, you can most definitely share what you learned with others. For this tour, we'll focus on the core packages of Tidyverse we discussed earlier: ggplot2, tidyr, readr, dplyr, tibble, per, stringr, and forcats. We also learned how to install and load them in RStudio. Once they're loaded, you won't need to do anything else with their actual packages. They'll do their thing as you program. So what is their thing? Well, it depends. But there's 4 packages that are an essential part of the workflow for data analysts: ggplot2, dplyr, tidyr, and readr. You'll most likely use these more often than the others. ggplot2 is used for data visualization, specifically plots. With ggplot2, you can create a variety of data viz by applying different visual properties to the data variables. Here's an example of ggplot2 in action. You'll have your own chance to use ggplot2 later. tidyr is a package used for data cleaning to make tidy data. We covered tidy or clean data earlier, but as a quick reminder, it's data where every part of a data table or data frame is the right type in the right place. tidyr works with wide and long data to make sure this happens. Next, we have readr, which is used for importing data. The most common function from readr is read_CSV. This will import a CSV file into R. A CSV file contains data separated by commas in a table format. To accurately read a dataset with readr, you combine the function with a column specification. The column specification describes how each column should be converted to the most appropriate data type. It's good to keep in mind this isn't usually necessary because readr will figure it out for you automatically. We'll come across readr functions as we continue to explore R. Now, on to dplyr. dplyr offers a consistent set of functions that help you complete some common data manipulation tasks. For example, the select function picks variables based on their names, and the filter function finds cases where certain conditions are true. And yes, dplyr is another package we'll get to later. There's plenty to look forward to. So that's the Fab Four of the tidyverse. They'll all make your programming in R more straightforward and efficient. The other 4 packages are definitely useful too, but you might not use them as often. Tibble works with data frames. Purr works with functions and vectors, helping make your code easier to write and more expressive. String R includes functions that make it easier to work with strings. Forcats provides tools that solve common problems with factors. As a quick reminder, factors store categorical data in R, where the data values are limited and usually based on a finite group like country or year. Using the tidyverse and its packages will help you fine-tune your analysis. And besides tidyverse, you also learned the fundamentals of R, from variables to vectors and more. You explored the different operators in R and saw how they can help you complete calculations. You had the chance to check out pipes and how they can make your programming more efficient. And you unpacked packages to find out how they're a big part of what you can do in R. We've covered a lot of ground in just a few videos, so this might be a good time for you to do a little review. You can rewatch videos and revisit any other resources that can help you get an even better grasp of all the terms, concepts, and processes that are part of R. Looking ahead, you'll start working with data in R, including a more thorough exploration of how tidyverse impacts your process. You'll see Tibble, readr, and other tidyverse packages in action. And you'll find out how to clean and organize your data in R. All this and more coming up. I'll see you soon. Hi again. Earlier, we introduced something called pipes. A pipe is a tool in R that helps make your code more efficient and easier to read and understand. In this video, we'll explore pipes in more detail. As a quick reminder, a pipe is a tool in R for expressing a sequence of multiple operations. In other words, it takes the output of one statement and makes it the input of the next statement. So instead of typing out functions contained inside other functions, you can use the pipe operator to do the same work. In programming, we describe this as nested. Nested describes code that performs a particular function and is contained within code that performs a broader function. You can think of a pipe as a way to code the phrase "and then." Say you've got sales data and you need to find the mean or average. You can create a pipe by calling up the data and then grouping the data and then summarizing the group data using a mean function. Let's check out an example. First, we'll open RStudio. Then we'll start a new script so we can save our work. We'll save it as tooth growth exploration. We'll use the tooth growth dataset, which is already installed in R. This dataset contains data about the effect of vitamin C on the growth of teeth in guinea pigs. It's a well-known dataset that'll help us learn about how pipes work. To load any dataset already installed, we use the data function. We then add the name of the dataset, tooth growth. Now that the data is loaded, we can check it out with the view function. Notice how view begins with the capital V. It's a good reminder that functions and variables are case-sensitive in R. In a script, we use the Run button to run our code. The return usually shows up in the console, but with view, a new tab appears in the script showing the contents of the dataset. Now, let's say we need to filter and sort this data to organize it for analysis. Without pipes, we could do this either by nesting commands or by creating a sequence of data frames. We'll chat more about data frames soon. Let's start by filtering the dataset. Note that we'll want to first install and load the correct filter function, which comes as part of a package. Installing a package may take a few moments. This function comes as part of the dplyr package. We'll assign a name to the new dataset and then apply the filter function. This filters the data so that we only see rows where the dose of vitamin C is exactly 0.5. This includes both types of vitamin C used in the study, orange juice, or OJ in our dataset, and ascorbic acid, or VC. Next, we'll sort it with the arrange function. We'll include the name of the filtered dataset, followed by the column name we want to sort by. In this case, len, which stands for length of tooth. When we run this, the return appears in the console. The data is arranged in ascending order by len. The return only shows rows where the dose amount is 0.5. So the data's been filtered and sorted based on our code. Let's try another way to get the same return. We'll use a nested function, which is a function that is completely contained within another function. Here's the nested function for filtering and sorting this dataset. Notice that the filter function from our previous code is the nested function. With nested functions, we read from the inside out. The code filters the data first, then it arranges or sorts it. Now, let's run this. We tweaked the code, but we get the same result. Now, we'll use a pipe. As a quick reminder, the operator used to call out a pipe is a percentage sign, followed by a greater than sign and another percentage sign. You can also use keyboard shortcuts to insert pipe operators. Control-Shift-M for PCs and Chromebooks, and Command-Shift-M for Macs. We'll start this pipe by assigning it to a variable. Then, we'll type the name of the dataset we're pulling data from, tooth growth. We'll use our keyboard shortcut to add the pipe operator after that. Now, we can press Enter to go to the next line. RStudio automatically indents the next line, recognizing that it's part of the pipe. Next, we'll filter the data. We don't have to call out the dataset inside parentheses like we did in earlier examples, because we started our pipe with it. The pipe automatically applies the dataset to each step. All right. Let's finish up our pipe on a new line with the arrange function and sort the data. Since this is our last line of code, we don't need a pipe operator. Finally, click Run. Our pipe is set up to call the dataset, and then filter the dataset, and then sort the dataset. All three methods work, but you can see how pipes help make your programming more efficient and less cluttered. This means fewer chances for mistakes and better readability for anyone looking at your code. And because of the structure of a pipe, we can easily add to or change the code without having to start over. And presto, we get the same return as our other methods. So let's do that. Building on our example, let's say we also wanted to compute the average tooth length, or len, for each of the 2 supplements used in the study, orange juice, or OJ, and ascorbic acid, or VC. We'll replace the arrange function with the group by function. This will group our results by the 2 supplements, so we type sup in the parentheses and add a pipe. We're adding a pipe this time because we have another line of code to add. So we group by and then we summarize. Our argument, which comes after the function summarize, looks pretty complex, but it basically tells R what to do with missing values and to make sure the data is grouped the right way when we add the summarize function. Now we'll run our new pipe and get the average length of tooth when the dose is equal to 0.5 for each of our supplements. Nice! Now, there's a couple of things to remember when using pipes. First, it's important to add the pipe operator at the end of each line of the piped operation, except the last one. Another group rule of thumb is to check your code after you've programmed your pipe. Remember, RStudio automatically indents lines of code that are part of a pipe. If a line in your code isn't indented, it probably hasn't been added to the pipe. That could lead to an error statement. Then, you can revisit the piped operation to check for parts of your code to fix. With the other methods we showed you, it'd be more of a challenge to find the messy parts. Another reason to use pipes when you can. Pipes, or piping, and the functions that are part of the piping process are building blocks for putting together analyses in R. In upcoming videos, you'll learn how you can use these building blocks to clean, transform, and analyze your data. For now, feel free to take your time reviewing and maybe even practicing with the functions, operations, and other elements in R and RStudio that we've already covered.
Hi, I'm Connor, and I'm a marketing analytics manager at Google Cloud. I was running into barriers of not being able to do certain analysis because it was too time-consuming with my limited technical knowledge. So I started to teach myself things like SQL to help me access data through the current company's database that I had so that I could manipulate that data to better understand it. I can tell you at first it is an incredibly frustrating thing to move through because it takes a lot of time and effort to do something that seems very simple or something that would be very easy to do in spreadsheets, but may be very difficult to do at first as you're learning how to code. But also one of the most fulfilling things that I've ever done, because once you're able to understand something, it opens up an entire new realm. Learning coding was revolutionary for my job. I remember when I first started as an analyst, all of the data that I used was in spreadsheets, and I had to run analysis and create formulas to manipulate the data, understand the data, and even analyze the data. Now, when we started to get more and more data, the formulas that I would run would take hours. And I remember at one point I spent a few hours creating a formula and then executed it, and it took over 10 hours to run. So I left my computer open and let it run throughout the night, woke up, and it was still running. Fast forward a year later, after I had learned SQL and Python, I was able to run the same type of analysis in milliseconds. So really understanding what it is that you are trying to do, coding helps you manipulate and analyze data at a rate that previously or without a coding knowledge would be very difficult to do. One important aspect of any type of script or when you are coding is to structure it for overall readability. More often than not, you're going to be working on a team. Now, it's important that when you're writing a script, that you understand how it works, but also that somebody else who you work with can also come and understand what it is that you are trying to do within that script. Now, it's very important that it not only works and is efficient, but that it is also not too verbose, meaning that it is not overly complex. So an important aspect of readability is if you are looking through your code and you realize that I've written the same thing multiple times, or I'm using the same logic or algorithm multiple times, that is a point in time where you can really consolidate your code and make it a lot more concise, which vastly helps with readability, vastly helps anybody who comes and is trying to read your code. And that includes you 2 weeks from now. Because I can promise you, when you start coding, you will realize that what makes sense to you right now may not make sense to you 3 weeks from now. An important aspect for readability and overall understanding of your code is using comments. Comments are a way to write something out in a standardized language like English and a way that somebody can understand it, but the computer doesn't pick up as actual code. So for explaining every line that you write or explaining an entire section of your code in a comment allows somebody to walk themselves through your code and read exactly what it is that you are trying to accomplish with the code that you've written. Now, without comments, you are leaving it up to the person to really follow your code and understand it themselves, which may not be an easy task for somebody because they may have a different way of coding the same thing that you are doing. Documenting your work is an important aspect. Documentation will explain in depth exactly what your code is doing, why it was built, what is the purpose for it, and any limitations. The last one is a rather difficult concept to understand as you are first diving into learning a coding language, and that is building it for scalability as well as making it dynamic. Now, when I say building something for scalability, what I mean is if you are building a specific script of code to solve a task that you're running now, what you want to be sure of and answer is, will this code or could this code be used in the future for something else? Now, if it is, it's important that you make your code available to be scalable. That means that it is efficiently run so that if the size of the data that it is running any manipulations on increases, it doesn't bog down your code too much, and that it can handle large data loads as well as small. Another aspect to that is making your code dynamic. So what that means is not hard coding any values within your code that don't change when they need to. So these are just a few of the best practices, and as you continue down your path as a data analyst, you'll pick up many, many more. There's always more to learn, there's always more to understand, but this should help you in beginning down your path to understanding coding.
Hey, it's great to have you back. Now that we've been introduced to R and programmed with it, let's learn about even more ways you can use R during our analysis process. We'll start by learning more about data frames and how to use them, and then explore how to work with our data in different ways using tidyverse packages. After that, we'll cover how to check for bias in R. R's community has really helped me grow as a data analyst, especially when it comes to processes like data cleaning. R helps me clean more efficiently, and I can turn to a community of folks to learn how they have cleaned similar data. Sharing knowledge of R and being able to code review has improved my work a ton. I'm so excited to show you new ways to work with R and get more out of your data. Earlier I mentioned that learning R was going to be fun. Here's where we get to take what we've learned so far and put it into action. When you're ready, you can get started in the next video. See you soon! Hey, welcome back. Before we can start cleaning and organizing our data, or even check it for bias, we need to get our data into a usable format. This is where data frames come in. You might remember we talked a little bit about data frames before. In this video, we'll learn more about what data frames are and how you can use them. Let's get started. First, let's talk about what a data frame is. A data frame is a collection of columns. It's a lot like a spreadsheet or a SQL table. Here's an example of a data frame in R. It's a lot like other tables we've worked with throughout this program. There's column names and rows and cells with data. The columns contain one variable, and the rows have a set of values that match each column. We use data frames for a lot of the same reasons as tables too. They help summarize data and put it into a format that's easy to read and use. There's some things to know about data frames before working with them. We'll learn more about data frames throughout this program, but this is a great starting point. First, columns should be named. Using empty column names can create problems with your results later on. Let's think back to our example. Each of the columns are named based on the variable they represent. There's caret, cut, color, clarity, depth. All of these columns represent data about the diamonds. Next, it's important to know that the data stored in your data frame can be many different types, like numeric, factor, or character. Often, data frames contain dates, timestamps, and logical vectors. Finally, each column should contain the same number of data items, even if some of those data items are missing. Data frames are foundational. Now, let's talk about tables. In the tidyverse, tables are like streamlined data frames. They make working with data easier, but they're a little different from standard data frames. First, tables never change the data types of the inputs. They won't change your strings to factors or anything else. You can make more changes to base data frames, but tables are easier to use. This saves time because you won't have to do as much cleaning or changing data types in tables. Tables also never change the names of your variables, and they never create row names. Finally, tables make printing in R easier. They won't accidentally overload your console because they're automatically set to pull up only the first 10 rows and as many columns as fit on screen. Super useful when you're working with large sets of data. Data frames and tables are the building blocks for analysis in R, so having set standards for how they're built and dealt with is pretty important. If we all have the same understanding of what a data frame is, we can communicate more effectively. It's like we're all speaking the same language. It's also just a lot more practical. We need to be able to do things like define columns and review code easily in R. These characteristics make it easier to share your data and reproduce your analysis. Consistent data structures like data frames make it easier to operate on an entire data set. Tidy data refers to the principles that make data structures meaningful and easy to understand. It's a way of standardizing the organization of data within R. These standards are pretty straightforward. Variables are organized into columns, observations are organized into rows, and each value must have its own cell. Now that you know a little more about data frames, let's start using them. Coming up, I'll teach you how to create data frames, add data to them, and expand them. Bye for now. Hey there! Earlier, we learned about data frames and their key characteristics. Now, we'll actually start working with them. As a data analyst, a lot of your work will depend on data frames. If you don't create a data frame, your ability to work with your data will be limited. Think about spreadsheets. That basic structure of columns and rows carries over to R. Data frames are basically the data analyst's default way to interact with data. That's why knowing how to create and work with data frames is so important. So let's check out an example. Here we'll use R's built-in data frames. One of the great things about R and R packages is that there's a lot of interesting, easy-to-access data sets built in. These data sets let you practice some of the tools we've been learning. Let's open RStudio and get started. We'll use a preloaded dataset with information about diamonds. This dataset's part of the ggplot2 package in the tidyverse, so make sure you first load ggplot2. We'll learn how to load our own datasets later too, But diamonds is a good data set to practice with. We can load this data now by using data open and close parentheses. You might notice that when we start to type diamonds, RStudio gives us the option to select it from its drop-down menu. That's because this data set already exists in our library. Okay, now let's add this data frame to our data viewer. There's 10 columns and 100 rows in this data frame, but we might not want to see all of it. We can use the head function to give us just the first 6 rows. This is a nice preview of the entire data set. Accidentally printing the full data frame to the console can be annoying and can take a long time to compute. You can avoid printing the full data frame by using functions like head to get a quick preview. We can also get the structure of the data frame using functions like structure and call names. These are just 2 functions you can use to check out your data. We'll explore other functions like glimpse later on. For example, we could use the structure function to highlight the structure of this data frame. This gives us some high-level info, like the column names and the type of data contained in those columns. But if we just want to know the column names, we can use call names instead. Here we have caret, cut, color, clarity, depth, all of the columns included in this dataset. We can also use the mutate function to make changes to our data frame. The mutate function is part of the dplyr package, which is in the tidyverse. So you'll need to load the tidyverse library before you test out mutate. Let's add a new column first. All we have to do is input mutate and then tell R we want to add a new column to the diamonds data frame. We'll first call mutate, followed by the name of the data frame we want to change. Then we'll add a column and the name of the new column we want to create. Then we want to calculate this new column. In this case, to make it easier to read the caret column, we'll multiply it by 100 to create a new column, caret_2. And when we run this, presto! Our data frame has a new column. You won't lose any columns when you create the new one. The rest of the data frame will still be the same. Data frames are usually the starting point for analyzing data in R, so it's important to understand the characteristics of data frames and how to create them. Great job, and I'll see you next time. Hi again. Now that we've got a little more experience with data frames, we can start doing some interesting things like clean, standardize, manipulate, and visualize data. We'll go through some common tasks that you'll perform as a data analyst, but we're just scratching the surface of what you might want to do in R. We'll start with the basics and learn how to clean up our columns. There will be a reading with a handy list you can refer to afterwards too. Let's install the Here, Skimmer, and Janitor packages now. We'll go ahead and open our console. First, we'll add the Here package. This package makes referencing files easier. To install it, we'll just write install.packages, and then, in the parentheses, we'll put Here. And RStudio will install it. After we install it, we'll also need to load it using library. Next, we'll install SkimR and Janitor. As a quick reminder, these packages simplify data cleaning tasks. They're both really useful and do slightly different things. The SkimR package makes summarizing data really easy and lets you skim through it more quickly. We'll install it now. The Janitor package has functions for cleaning data. after it's done installing, we'll still need to load it. Finally, we want to make sure the dplyr package is loaded since we're going to be using some of its features. There. Now we've got all the packages we need for basic data cleaning. Now, let's load some data in. Later, when you're practicing with your own data, you can use read to grab a file. For example, if you had a CSV you wanted to load, you could write read_CSV and input the file name in the parentheses. This is where the here package comes in handy. So be sure to install and load the here package before trying to save CSV files. For now, we'll load a really fun package to practice with, the Palmer Penguin package. This is a dataset we've used before, but just as a quick reminder, the Palmer Penguin data has lots of information about 3 penguin species in the Palmer archipelago, including size measurements, clutch sizes, and blood isotope ratios. And who doesn't love penguins? First, we'll install the package. So we'll type install.packages and input Palmer Penguins. And then remember to load it by using the library function. And now that we've got this data loaded into our library, we can try some cleaning functions on our columns. There's a few different functions that we can use to get summaries of our data frame: skim without charts, glimpse, head, and select. The skim without charts function gives us a pretty comprehensive summary of a dataset. Let's try it out. When we run this, we get a lot of info back. First, it gives us a summary with the name of the dataset and the number of rows and columns. It also gives us the column types and a summary of the different data types contained in the data frame. Or we could use glimpse to get a really quick idea of what's in this dataset. When we run this command, it'll show us a summary of the data. There's 344 rows and 8 columns. We have species, island, measurements for bills, which are basically beaks and flippers, the penguin's body mass in grams, the sex, and finally, the year the data was recorded. We can also use head to get a preview of the column names and the first few rows of this dataset. Having the column names summarized like this will make it easier to clean them up. We can use select to specify certain columns, or to exclude columns we don't need right now. Let's say we only need to check the species column. We can input penguins, then a pipe to indicate we'll add another command, and rselect. We'll jump back into an R script because it will be easier to see. Now we have just the species column, or maybe we want everything except the species column. We'll put -species instead of species. And now we have every column but species. The select statement is useful for pulling just a subset of variables from a large data set. This lets you focus on specific groups of variables. There's a lot of other select functions that build on this that we'll cover later on. Now that we know our column names, we've got a better idea of what we might want to change. The rename function makes it easy to change column names. Starting with the penguins data, we'll type rename and change the name of our island column to island_new. Now, looking at our column names, we can see the column name has changed. Or, let's say we want to change our columns so that they're spelled and formatted correctly. In spreadsheet programs, as long as our column names are meaningful, they're fine. But since we have to type the column names over and over in R, we need them to be consistent. Similar to the rename function, the rename with function can change column names to be more consistent. For example, maybe we want all of our column names to be in uppercase. We can use the rename with function to do that. This will automatically make our column names uppercase. But since variable names are usually lowercase, we'll use the to lower option to change it back. The clean names function in the janitor package will automatically make sure that the column names are unique and consistent. Let's try the clean names function on our penguins data. This ensures that there's only characters, numbers, and underscores in the names. And now you know some functions for cleaning columns in your datasets. Try practicing them on your own with the Palmer Penguins data. And once you're comfortable with these functions, we'll learn even more about data cleaning in R. See you soon! Hey, great to have you back. We've learned how to create data frames and perform some basic cleaning functions. Now it's time to start getting organized in R. Coming up, I'll teach you some functions that'll help you organize and filter your data. These functions look a little different in R than in the other tools we've used so far. But the reason we use them is still the same. If we don't organize our data, we can't turn information into knowledge. Organizing our data and comparing different metrics from that data helps us find new insights. In other words, it makes our data useful. To help us do this, we'll use the arrange, group by, and filter functions. Let's start by sorting our data. We'll keep working with the Palmer Penguins data from earlier. In case you don't remember, refer to the link below. We'll also need to load the right packages. All the packages we'll need are part of the core tidyverse. So let's load the core tidyverse now. We can use the arrange function to choose which variable we want to sort by. For example, let's say we want to sort our penguin data by bill length. We'll type in arrange and our column name. And when we execute this command, it'll return a tibble with data sorted by bill lengths. It's currently in ascending order. If we want to sort it in descending order, we just add a minus sign before the column name. And now, the longest penguin bill is first. Now, it's important to remember this data is just in our console. To save this as a data frame, we'll start by naming it. Then we'll input the function we used to arrange the previous version of the penguins data. When we execute this, it'll save a new data frame, and we can use view penguins2 to add it to our data. This lets you save cleaned data without losing information from the original dataset. You can also sort by data using the group by function. Group by is usually combined with other functions. For example, we might want to group by a certain column and then perform an operation on those groups. With our penguin data, we can group by island and then use the summarize function to get the mean bill length. We checked out the summarize function when we introduced piping. Basically, the summarize function lets us get high-level information about our penguin data. So let's build our group by statement first. We're not interested in NA values, so we can leave those out using the drop_NA argument. This addresses any missing values in our dataset. It's important to be careful when using drop_NA. It's useful doing a group-level summary statistic like this, but it'll remove rows from the data. Now, let's use summarize. We'll title the summary column mean bill length millimeters. And then we'll build the mean statement. And when we run this, we get a data frame with the 3 islands and the mean bill length of the penguins living there. We can get other summaries too. For example, if we want to know the maximum bill length, we can write a similar function and replace mean with max. And now we know that the penguin with the longest bill lived on Besco Island. Both group by and summarize can perform multiple tasks. For example, we could group by island and species, and then summarize to calculate both the mean and max. To do that, we can write a similar command. We'll put species and island in our group by and drop any missing values. And then we can add a summarize statement with a max and mean calculation. And when we run this, we have both groupings and the max and mean. Thanks to piping, we can combine all of these cleaning and transforming tasks into one code chunk. Finally, we can filter results using the filter function. Let's say we only want data on Adelie penguins. We'll start with the data set we're using, and then add the filter. You might notice that we're using two equal signs here. That's on purpose. The double equal sign means exactly equal to in R. And now we have a data frame that only contains data on Adelie penguins. This lets us narrow down our analysis if we need to. Being able to clean and organize data is a key step in the data analysis process. And knowing the right tool for the job is an important skill for a data analyst. R makes wrangling data easier and gives you a lot of functionality across the different stages of the data analysis process. Now that we've cleaned our data, we can get ready to transform it. Coming up, we'll learn how to use the separate, unite, and mutate functions, and how to use them to transform our data in R. See you next time! Welcome back! So far, we've started cleaning and now working with data in R. Now, let's talk about how to transform data. Sometimes you need to be able to break up a variable across multiple columns, or combine existing columns, or even add new values to your data frame. Coming up, we'll use the separate, unite, and mutate functions to transform our data in R. Luckily, the packages already downloaded into our library have some tools we can use to do just that. Let's open RStudio Cloud and check them out. To start, we'll create a data frame from scratch. For this example, we'll create a standard data frame so that we can test out other functions. But you could also make a tribble here, since we're manually inputting the data. You'll learn more about tribbles in a reading. For our dataset, we're going to copy and paste some data to create our own data frame. If you want to use the same data to follow along, check out the earlier reading. Our data contains employee information, including names and job titles. You can just copy it in. We can then name the data frame employee, indicate the column names as ID, name, and job title, and print the whole data frame. Right now, the first and last names are combined into one column. We can use the separate function to split these into separate columns. We'll start with separate, and then the data frame we want to work with, and the column we'd like to separate. Then we'll add what we'd like to split the name column into. We'll just name these new columns first name and last name. And finally, we'll tell R to separate the name column at the first blank space. When we run this, it'll build us new columns for the first and last names. The separate function has a partner, unite. The unite function allows us to merge columns together. Basically, it does the opposite of separate. Let's say we're working with the version of this data frame with two name columns, and we want to combine them. We'll copy in this data as well. Our unite statement's a lot like our separate. We'll start with unite and indicate the data frame we're referring to. Then we'll name the column we're combining first name and last name in, and then we'll say which columns we're combining. No quotation marks needed here. And finally, we can include a space that separates them. And when we run that, those two columns are combined. In addition to separating and merging columns, we can also create new variables in our data frame using the mutate function. We worked with mutate a little bit before to clean and organize our data, but mutate can also be used to add columns with calculations. Let's go back to our Penguin dataset. Right now, the body mass column's measured in grams. Maybe we want to add a column with kilograms. To do that, we'll use mutate to perform the conversion and add a new column. And it'll return a tibble with our new column. You can make calculations on multiple new variables by adding a comma. Let's add a column converting the flipper length too. Now we've learned how to transform existing data in our tables and how to create new variables. Separate, unite, and mutate are some basic functions that we'll keep building on. And you might discover new ways to use them while you're practicing too. Coming up, we'll talk more about summarizing data frames and how to address bias. I'll see you soon. Great to have you back. Earlier, we talked about summarizing data in R, and we even used the summarize function to calculate the mean for one of our Penguin data variables. Now, we'll work with a very famous data example, Anscombe's quartet. Anscombe's quartet has 4 data sets that have nearly identical summary statistics, but those summary statistics might be misleading. Data visualizations, especially for data sets like these, are so important. They help us discover things in our data that would otherwise remain hidden. Plus, you'll discover some of the ways R can create awesome visualizations. Let's install the packages. This may take a few minutes to load. Okay, let's load the Anscombe's quartet data now. When we view this data, we notice that there's 4 sets of X and Y axes in the data frame. That's the quartet. Data can be summarized by different statistical measures. We'll get a summary of each set with the mean, standard deviation, and correlation for each of these data sets. We'll start by indicating that we want to group our data by set. Then we'll input our summarize function. When we run this, we'll get a summary of these statistical measures. In our summary tibble, we can check the mean. The mean for X in each dataset is 9. and the mean for y is 7.5. The standard deviation can help us understand the spread of values in a dataset and show us how far each value is from the mean. The standard deviation for x and y in every set in the quartet is the same, 3.32 and 2.03. Finally, we've got our correlation, which shows us how strong the relationship between two variables is. Here, it looks like the correlation between x and y in all four sets is around 0.816. So, based on the summaries we created with our statistical measures, these datasets are identical. But sometimes, just looking at the summarized data can be misleading. Let's put together some simple graphs to help us visualize this data and check if the datasets are actually identical. You'll learn more about plotting data in R later, but for now, we'll just get a quick idea of how this data appears. Check it out! These four datasets appear quite different when we visualize them. If we'd just gone with the statistical summaries, we never would have known that this data is actually really different. I want to show you one more really cool thing, the Datasaurus package. The Datasaurus creates plots with the Anscombe data in different shapes. But let's run it to see that for ourselves. First, you'll start off with installing and loading the package. Then we'll create a chart. It's okay if these commands seem complicated. You'll be creating your own plots soon. This is just a sneak peek at how R can help you create data visualizations. When we run this, it shows us several different plots. There's the famous dinosaur, a bullseye, a star. R is a pretty powerful visualization tool. You could use the relationships between data points to create many other shapes. As you can see, you can do a lot of things with R. Data visualizations like the ones we just explored help you discover so much more about the data you're working with. It's important to explore your data in multiple ways to learn a little more about its story. Next, we'll learn how to use R functions to check for bias. Hey, welcome back. By now, you've already learned the importance of fair, unbiased data in data analysis. In R, we can actually quantify bias by comparing the actual outcome of our data with the predicted outcome. There's a pretty complicated statistical explanation behind this, but with the bias function in R, we don't have to perform this calculation by hand. Basically, the bias function finds the average amount that the actual outcome is greater than the predicted outcome. It's included in the sim design package, so it's helpful to install that and practice on your own. If the model is unbiased, the outcome should be pretty close to 0. A high result means that your data might be biased, a good thing to know before you analyze it. Let's say we're working with a local weather channel to determine if their weather predictions are biased. First, we need to install and load a package called SimDesign. We'll use the bias function to compare forecasted temperatures with actual temperatures. For this example, we'll just take a small sample of our weather data and input them here. We'll label this the actual temp. Then we'll put in the predictions. and then the bias function. When we run this, we find out that the result is 0.71. That's pretty close to 0. But the predictions seem biased towards lower temperatures, which means they aren't as accurate as they could be. And now that the local weather channel knows about this, they can find the problem in their system that's causing biased predictions. This doesn't mean that their predictions will be perfect all the time, but they'll be more accurate overall. Let's try another example. In this scenario, we're working for a game store. The store has been keeping a record of how many copies of new games they sell on release day. They want to compare those numbers to their actual sales so that they can find out if they are ordering new stock according to their actual needs. Just like the previous example, we will start by inputting our sales data. We'll label that actual_sales and add the data points. Next, we'll input the amount of stock they ordered as predicted_sales and input those data points. And now we have our data ready to go. As you learned in the first example, the bias function compares the actual outcome and the predicted outcome of the data to determine the average amount the actual outcome is greater than the predicted outcome. An unbiased model should be close to 0. Let's run the bias function on our sales data now. Like before, we'll just type bias to start the function and then actual_sales and predicted_sales in the parentheses. When we press enter, wow, the result is -35. That's pretty far from 0. The predicted outcome is larger than the actual outcome, which means they may be ordering too much stock for release days. Now that they've used the bias function to compare these data points, they can reevaluate their stocking practices to avoid buying more stock than they need at once. And that's it for now. We've covered a lot together. We learned how to create data frames. We tried out some basic data cleaning functions. We got a little preview of how data viz in R can help us better understand our data. And finally, we learned how to use the bias function. I've still got a lot more I want to tell you about R. And if the data visualizations we created in this module were exciting for you, I've got great news. Coming up, we'll learn all about data viz in R. But first, you've got a weekly challenge to tackle. I know you're going to do great, and if you want to review any of the material we've covered in these videos, feel free. This might be the first time you've encountered R, so it's a great opportunity to practice something new. Your code might throw up some errors at first. That's just part of writing code. Learning from our mistakes is how we grow. I'll see you afterwards for our next adventure in R. Hi there, great to see you again. I've really enjoyed introducing you to R. By now, you know your way around R and RStudio, and you're familiar with some basic programming concepts. You've also learned how to clean and organize data in R. You've taken on the challenge of learning programming and developed new skills for data analysis. Great job! Now, you'll learn how to use code to visualize your data. Data visualization is one of the most important parts of data analysis. Powerful visuals show stakeholders what your data means in a clear and compelling way, and highlighting key insights. Visuals help bring the story of your data to life, and make that story easier to understand. You might remember the sneak peek I gave you of R's data visualization powers. I created those visuals with ggplot2, one of the core packages of the tidyverse. ggplot2 is R's most popular visualization package, and for good reason. It's a powerful and user-friendly data viz tool. Up next, you'll learn how to write and execute all the code we previewed earlier. You'll learn how to use ggplot2 to create a variety of plots, organize and represent different variables in your dataset, and customize the look and feel of your visuals. Working with ggplot2 can help you get the most out of your data. Your new data viz skills will also make it easier to learn other parts of R. Going forward, you'll be better able to visualize the results of any change you make to your data. Plus, you get an immediate result for all your hard work, which is one of my favorite parts of creating plots in ggplot2. Just enter some code, run it, and out comes a cool-looking visual that helps you and others understand your data. Visualization is a key part of a data analyst's workflow, and R lets you move back and forth between analysis and visualization quickly and easily. I'm looking forward to showing you what ggplot2 can do. See you soon! Hi again! In this video, we'll focus on ggplot2. We'll learn about its main features and functions, and how it can help you visualize your data. First, let's talk about some different visualization packages you can use with R. Base R has its own package, and there are other useful packages you can add. They'll help you do almost anything you want with your data, from making simple pie charts to creating more complex visuals like interactive graphs and maps. General-purpose packages like Plotly let you do a wide range of visualization functions. Others, like RGL, focus on specific solutions like 3D visuals. Some of the most popular include ggplot2, Plotly, Lattice, RGL, Digraphs, Leaflet, HighCharter, Patchwork, ggAnimate, and ggRidges. Personally, ggplot2 is my favorite for data analysis. It's both powerful and flexible. With a little bit of code, you can create all kinds of different plots. You can use ggplot2 on its own, or extend its powers with other packages. Plus, it's the most popular visualization package in R. A lot of data analysts prefer to use ggplot2, which is why we're using ggplot2 here. ggplot2 was originally created by the statistician and developer Hadley Wickham in 2005. Wickham's inspiration for creating ggplot2 came from the 1999 book The Grammar of Graphics, a scholarly study of data visualization by computer scientist Leland Wilkinson. The first two letters of ggplot2 actually stand for Grammar of Graphics. And in the same way the grammar of a human language gives us rules to build any kind of sentence, the grammar of graphics gives us rules to build any kind of visual. So ggplot2 has some basic building blocks that you can use to create plots. In other words, when you learn the basic steps for creating a plot in ggplot2, you can reuse these steps to create lots of different kinds of plots. Plus, you can add or remove layers of detail to your plot without changing its basic structure or the underlying data. This makes ggplot2 really powerful. In the next video, we'll go over these steps one by one. ggplot2 has lots of other benefits too. You can create all different types of plots, including scatter plots, bar charts, line diagrams, and tons more. You can change the colors, layout, and dimensions of your plots, and add text elements, like titles, captions, and labels. With just a little bit of code, you can create high-quality visuals. Plus, ggplot2 lets you combine data manipulation and visualization using the pipe operator. ggplot2 also has tons of functions that cover all your data viz needs. To give you an idea, check out the ggplot2 cheat sheet, which is a popular reference guide. You can find out more about the cheat sheet in an upcoming reading. It's not important to learn all these functions right away, or even know what they are. Over time, as you get into more advanced data analysis, you can learn about new functions as you need them. Just know that if you need to find a function for something, ggplot2 probably has it. And like we discussed, even the basic functions of ggplot2 let you do so much. We'll focus on some core concepts in ggplot2: aesthetics, geomes, facets, labels, and annotations. These might be new concepts to you, and that's okay. We'll learn about them together, and soon we'll explore each in detail. For now, let's get a quick preview. In ggplot2, an aesthetic is a visual property of an object in your plot. For example, in a scatter plot, aesthetics include things like the size, shape, or color of your data points. Think of an aesthetic as a connection or mapping between a visual feature in your plot and a variable in your data. We'll talk more about mapping later on. A geome refers to the geometric object used to represent your data. For example, you can use points to create a scatter plot, bars to create a bar chart, or lines to create a line diagram. You can choose a geome to fit the type of data you have. Points show the relationship between two quantitative variables. Bars show one quantitative variable varies across different categories. Up next, we'll talk about the facet function. Facets let you display smaller groups or subsets of your data. With facets, you can create separate plots for all the variables in your dataset. Finally, the label and annotate functions let you customize your plot. You can add text like titles, subtitles, and captions to communicate the purpose of your plot or highlight important data. That's all for now. Coming up, we'll use code to create our own first plot in ggplot2. Welcome back! In this video, we'll use the Palmer penguins data to learn how to create a plot in ggplot2. Earlier, I used this data to give you a preview of what ggplot2 can do. You might remember that the penguins dataset contains size measurements for 3 penguin species that live in the Palmer archipelago in Antarctica. The dataset includes variables such as body mass, flipper length, and bill length. Now, we'll learn how to use code to create those visuals. We'll go through the process of creating a plot step by step. We'll also go over some general tips on how to write code in ggplot2 and check out some useful help resources. First, let's log into RStudio Cloud. As we go along, I encourage you to join in and try out all the code in RStudio. Feel free to pause the video anytime you need to. We're assuming you already have the tidyverse packages installed. If you don't, refer to an earlier video or run install.packages tidyverse. Let's start by loading the ggplot2 package and the penguins dataset. Let's check out the plot that shows the relationship between body mass and flipper length in the 3 penguin species. The plot shows a positive relationship between the 2 variables. In other words, the larger the penguin, the longer the flipper. Now, let's check out the code. The code uses functions from ggplot2 to plot the relationship between body mass and flipper length. As a quick refresher, in R, a function's a name followed by a set of parentheses. Lots of functions require special information to do their jobs. You write this information, called the function's argument, inside the parentheses. The 3 functions in the code are the ggplot function, the geomePoint function, and the AES function. Every ggplot2 plot starts with the ggplot function. The argument of the ggplot function tells R what data to use for your plot. So, the first thing to do is choose a data frame to work with. You can set up the code like this. inside the parentheses of the function, write the word data, then an equal sign, then penguins. This code initializes or starts the plot. If we stop right now and run the code, the result will be an empty plot. Let's try it. This is just the first step in creating a plot. The next thing you might notice about this code is the plus sign at the end of the first line. You use the plus sign to add layers to your plot. In ggplot2, plots are built through combinations of layers. First, we start with our data. Then, we add a layer to our plot by choosing a geom to represent our data. The function geom_point tells R to use points to represent our data. Keep in mind that the plus sign must be placed at the end of each line to add a layer. Adding a geom function is the second step in creating a plot. As a reminder, a geom is a geometric object used to represent your data. Geoms include points, bars, lines, and more. In our code, the function geom_point tells R to use points and create a scatter plot. We'll learn more about geoms later on. Next, we need to choose specific variables from our dataset and tell R how we want these variables to look in our plot. In ggplot2, the way a variable looks is called its aesthetic. As a quick reminder, an aesthetic is a visual property of an object in your plot, like its position, color, shape, or size. The mapping equals AES part of the code tells R what aesthetics to use for the plot. You use the AES function to define the mapping between your data and your plot. Mapping means matching up a specific variable in your dataset with a specific aesthetic. For example, you can map a variable to the x-axis of your plot, or you can map a variable to the y-axis of your plot. In a scatter plot, you can also map a variable to the color, size, and shape of your data points. We'll learn more about aesthetics soon. Mapping aesthetics to variables is the third step in creating a plot. In our code, we map the variable flipper length to the x-axis and the variable body mass to the y-axis. Inside the parentheses of the AES function, we write the name of the aesthetic, then the equal sign, then the name of the variable. We write the code, and R takes care of the rest. Using the penguins data, R creates a scatter plot, puts the variable body mass on the y-axis, and the variable flipper length on the x-axis. Our code follows the common sequence for creating plots in ggplot2. Earlier, we talked about the grammar of graphics, a set of steps for making all kinds of different plots. You can also think of this sequence as the basic grammar for making plots in ggplot2. To create a plot, follow these 3 steps. Start with the ggplot function and choose a dataset to work with. Add a geom_function to display your data. Map the variables you want to plot in the arguments of the AES function. We can also turn our code into a reusable template for creating plots in ggplot2. To make a plot, replace the bracketed sections in the code with a dataset, a geom_function, or a group of aesthetic mappings. We can make all kinds of different plots using this template. For example, instead of plotting the relationship between body mass and flipper length, we could use 2 different variables in the penguins dataset. Let's try bill length and bill depth. We can put bill length on the x-axis and bill depth on the y-axis. Let's run the code and check out this new scatter plot. As you learn to write code in R, or any other programming language, you'll come across problems. It happens to everyone. I've been working in R for years, and I still write code that has errors. A lot of times, these will be minor errors with easy fixes. It helps if you pay attention to the details. For example, R's case sensitive. If you accidentally capitalize the first letter in a certain function, it might affect your code. Also, make sure every opening parenthesis in your function matches with a closing parenthesis. Notice how this code won't run correctly, but this code does. One common problem when working with ggplot2 is remembering to put the plus sign in the right place when adding a layer to your plot. Always put the plus sign at the end of a line of code. It's easy to forget, and put it at the beginning of the line. Or you might accidentally use a pipe instead of a plus sign. We all make mistakes. That's part of the learning process. The good news is we have plenty of tries to get it right. There's also plenty of resources to help you out. To learn more about any R function, just run the code $function_name. For example, if you want to learn more about the geom_point function, type in $geom_point. As a new learner, you might not understand all the concepts in the help page. At the bottom of the page, you can find specific examples of code that may show you how to solve your problem. If you still can't find what you're looking for, feel free to reach out to the R community online. As we mentioned earlier, there are tons of great online resources for R. Chances are, someone else has had the same problem. That's it for now. Up next, we'll learn more about aesthetics. See you soon.
Hello, my name is Joseph. I'm a people analyst at Google. As a people analyst, my job is to work with executives and HR business partners to use data to make informed people decisions. So my journey into people analytics is a very unique one. Coming from an inner city school in New York and going to school in Syracuse, which is a private school, the transition was very different in terms of the rigor academically and also the social level that I was competing with. And just being completely honest, I did feel like I didn't belong there. I felt imposter syndrome each and every day. And my first semester, I was struggling with my academics because of the lack of strong foundation that I had every time I finished my classes. I was seeking for tutoring opportunities. So I was working 3 times or 4 times more than my peers. But in the long run, I actually came to a point where I was doing much better than my peers. And I was the one actually, teaching them, also tutoring them on your homeworks. When I was going to college my freshman year, I wanted to major in computer engineering. But unfortunately, coming from a family of immigrants who did not know what computer engineering was, or even saw someone in our community who has, really succeeded in that, they really discouraged me from pursuing this path, again, because they didn't want to take the risk. Unfortunately, I switched my major from computer engineering into undecided. Fortunately for me, 2 years later, I found another Black friend of mine who was also an immigrant, African, who was majoring in information technology. And just by me learning from his experience and the classes he was taking, it really got me really interested in the field. I took 1 introductory classes and I really succeeded in that. Prior to Google, I used to work at a company called Accenture, where I was a consultant doing customer analytics. So towards the end of my second year at the company, I went to a job fair where Google was recruiting there. So I spoke to the recruiter and she mentioned to me about this new practice called people analytics, which is very similar to what I was doing at Accenture. I just went back home, did my research, and from there, I was really interested in the space that I wanted to definitely develop my career in. So since I started Google, I just will also honestly say that it was very challenging in terms of the rigor and the difficulties of the work that we were doing. So the first thing that I did was I seek for mentors I knew was interested in my career development and also an advocate for myself. So by talking to them and just learning a few lessons from them as to ways to better maneuver through this space, I first gained a lot of courage and also was motivated to even learn beyond the work environment. Second thing is that I want to make sure that I'm constantly learning and also leveraging my peers as a resource. So whenever I do get analysis that I need a second opinion on, I turn to my teammates who will just make sure they give me the encouragement I need or a second opinion for me to better enhance my analysis. And I believe the third thing that I always do is that I seek for stretch opportunities, right? So for example, I know that there's a space that I'm lacking in that I need to develop. I make sure that I ask my manager that, hey, I know that I struggle in this space. How can I actually grow in this area by giving me more work that will allow me to develop that skill set in? So I would say that's a mix of acknowledging that you see a gap in your personal development and also working towards improving that by leveraging the resources around you and just working towards that goal to improve yourself each and every single day and also every year as well.
Hello again. In this video, you'll learn how to change the aesthetics of your visuals, which can help you present your data in a more compelling way. With aesthetics, you can highlight key points in your data and communicate more clearly and effectively with your stakeholders. Earlier, we learned that an aesthetic is a visual property of an object in your plot. For example, in a scatter plot, aesthetics include the size, shape, or color of your data points. You can display a point in different ways by changing its aesthetics or the way it looks. You can make a point small, triangular, or blue, or a combination of these. Let's go back to our penguins dataset and review the code for our plot that shows the relationship between body mass and flipper length. As a quick refresher, the mapping equals AES part of the code tells R what aesthetics to use for the plot. You use the AES function to define the mapping between your data and your plot. Mapping means matching up a specific variable in your dataset with a specific aesthetic. For example, you can map a variable to the x-axis of your plot, or you can map a variable to the y-axis of your plot. To map an aesthetic to a variable, set the name of the aesthetic equal to the name of the variable inside the parentheses of the AES function. Our code tells R to map flipper length to the x-axis and body mass to the y-axis. Let's log into RStudio Cloud and run the code. As a quick reminder, let's start by loading the ggplot2 package and the penguins dataset. R will automatically place the appropriate label on each axis of our scatter plot. After you map a variable to an aesthetic, R takes care of the rest. You can also map data to other aesthetics, like color, size, and shape. Right now, our plot's in black and white. It clearly shows the positive relationship between the two variables. As the values on the x-axis increase, the values on the y-axis increase. But it's also got some limitations. For example, we can't tell which data points refer to each of the 3 penguin species. To solve this problem, we can map a new variable to a new aesthetic. Let's add a third variable to our scatter plot by mapping it to a new aesthetic. We'll map the variable species to the aesthetic color by adding some code inside the parentheses of the AES function. We'll add a comma after the body mass variable and type color =, species. Our code tells R to assign a different color to each species of penguin. Let's check it out. The gentoos are the largest of the 3 penguin species. The legend just to the right of the plot shows us that the blue points refer to the gentoo penguins. Not only does R automatically apply different colors to each data point, it also gives a legend to show us the color coding. That's what I love about R. Give it just a little bit of code and it'll go the extra mile to help you out. We can also use shape to highlight the different penguin species. Let's map the variable species to the aesthetic shape. To do this, we can change the code from color equals species to shape equals species. Instead of colored points, R assigns different shapes to each species. Now, the legend shows us a circle for the Adelie species, a triangle for the chin straps, and a square for the gentoos. You might notice that our plot's in black and white again because we removed the code for color. Let's put some color back into our plot. If we want, we can map more than one aesthetic to the same variable. Let's map both color and shape to species. We'll add the code color equals species while keeping the code shape equals species. Now, our plot shows a different color and a different shape for each species. We can keep going. Let's add size as well and map 3 aesthetics to species. If we add size equals species, each colored shape will also be a different size. Using more than one aesthetic can also be a way to make your visuals more accessible, because it gives your viewers more than one way to make sense of your data. We can also map species to the alpha aesthetic, which controls the transparency of the points. Our first plot showed the relationship between body mass and flipper length in black and white. Then, we mapped the variable species to the aesthetic color to show the difference between each of the 3 penguin species. If we want to keep our graph in black and white, we can map the alpha aesthetic to species. This will make some points more transparent or see-through than others. This gives us another way to represent each penguin species. Let's try it. Alpha is a good option when you've got a dense plot with lots of data points. You can also set the aesthetic apart from a specific variable. Let's say we want to change the color of all the points to purple. Here, we don't want to map color to a specific variable, like species. We just want every point in our scatter plot to be purple. So we need to set our new piece of code outside of the AES function and use quotation marks for our color value. This is because all the code inside of the AES function tells R how to map aesthetics to variables. For example, mapping the aesthetic color to the variable species. If we want to change the appearance of our overall plot without regard to specific variables, we write code outside of the AES function. Let's write the code and run it. That's all for now. We just learned about the most common aesthetics for points: X, Y, color, shape, size, and alpha. We also discovered how aesthetics can change the look of our plot and highlight important data. We've covered a lot so far and learned a bunch of new concepts. It takes time to process new information and learn new skills. So feel free to watch any of these videos again if you need a refresher or want to practice in RStudio. Coming up, we'll learn more about geomes. See you then! Great to see you again. In this video, we'll learn how to use different geome functions to create different types of plots, such as scatter plots and bar charts. There are lots of different geomes available. You can choose a specific geome based on how you want to represent your data and your goals for communicating it. This lets you tell the story of your data in different ways and communicate effectively to different audiences. Let's start with 2 visualizations. Both visuals contain the same X variable and the same Y variable. Both use the same data, but each plot uses a different visual object to represent the data. One uses points, the other uses a smooth line. In other words, they use different geomes. In ggplot2, a geome is the geometrical object used to represent your data. Geomes include points, bars, lines, and more. The geom_point function uses points to create scatterplots. The geom_bar function uses bars to create bar charts, and so on. To change the geom in our plot, we need to change the geom function in our code. For example, take the plot that shows the relationship between body mass and flipper length. The code uses geom_point to create a scatter plot. Let's log into RStudio Cloud and watch what happens when we change geoms. First, let's load the ggplot2 package and the penguins dataset. Now, we can put geom_smooth in place of geom_point. We still have the same data, but now the data's got a different visual appearance. Instead of points, there's a smooth line that fits the data. The geom_smooth functions useful for showing general trends in our data. The line clearly shows the positive relationship between body mass and flipper length. The larger the penguin, the longer the flipper. We can even use two geoms in the same plot. Let's say we want to show the relationship between the trend line and the data points more clearly. We can combine the code for geom_point and the code for geom_smooth by adding a plus symbol after geom_smooth. Let's write the code and run it. Let's say we want to plot a separate line for each species of penguin. We can add the line type aesthetic to our code and map it to the variable species. Geom_smooth will draw a different line with a different line type for each species of penguin. The legend shows how each line type matches with each species. The plot clearly shows the trend for each species. Finally, let's check out the geom_jitter function. The geom_jitter function creates a scatter plot and then adds a small amount of random noise to each point in the plot. Jittering helps us deal with overplotting, which happens when the data points in a plot overlap with each other. Jittering makes the points easier to find. I'll show you what I mean. Let's replace geom_point with geom_jitter. Now that we've seen what ggplot2 can do with scatter plots, let's explore bar charts. We'll use the diamonds dataset that you're already familiar with. This includes data like the quality, clarity, and cut for over 50,000 diamonds. This dataset comes with the ggplot2 package, so it's already loaded. To make a bar chart, we use the geom_bar function. Let's write some code that plots a bar chart of the variable cut in the diamonds dataset. Cut refers to a diamond's proportions, symmetry, and polish. Notice that we didn't supply a variable for the y-axis. When you use geom_bar, R automatically counts how many times each x value appears in the data, and then shows the counts on the y-axis. The default for geom_bar is to count rows, but that's only one of the many different applications for bar charts. For example, the x-axis of our plot shows 5 categories of cut quality: fair, good, very good, premium, and ideal. The y-axis shows the number of diamonds in each category. Over 20,000 diamonds have a value of ideal, which is the most common type of cut. Geom_bar uses several aesthetics that you're already familiar with, such as color, size, and alpha. Let's add the color aesthetic to our plot and map it to the variable cut. We write the code the same way as we did with scatter plots and add color equals cut after x equals cut. Don't forget to put a comma after x equals cut to add a new aesthetic. The color aesthetic adds color to the outline of each bar. R also supplies a legend to show the color coding. Let's say we want to highlight the difference between cuts even more clearly to make our plot easier to understand. We can use the fill aesthetic to add color to the inside of each bar. In our code, we put fill equals cut in place of color equals cut. R automatically chooses the colors and supplies a legend. That looks great. I really enjoy using the fill aesthetic. If we map fill to a new variable, geom_bar will display what's called a stacked bar chart. Let's map fill to clarity instead of cut. Our plot now shows 40 different combinations of cut and clarity. Each combination has its own colored rectangle. The rectangles that have the same cut value are stacked on top of each other in each bar. The plot organizes the complex data. Now we know the difference in volume between cuts, and we can figure out the difference in clarity within each cut. This is just the beginning of what you can do with geoms. ggplot2 has over 30 geom functions that you can use to make plots, and extension packages give you even more. The ggplot2 cheat sheet is a great resource for learning more about geoms. As you move forward and do more advanced data analysis, you'll find plenty of new geoms to work with. Until then, the geoms we just reviewed will keep you busy and let you do a lot with your data. Coming up, we'll learn how to use the facet functions to display our data in different ways. Bye for now. Welcome back. In this video, we'll learn how to use the ggplot2 facet functions to display our data in new ways. Facet functions let you display smaller groups or subsets of your data. A facet's a side or section of an object, like the sides of a gemstone. Facets show different sides of your data by placing each subset on its own plot. Faceting can help you discover new patterns in your data and focus on relationships between different variables. For example, let's say you're looking at sales data for a clothing company. You might want to break down your data by category to show specific trends. Children's clothing versus adult clothing, or spring fashions versus fall fashions. Or if you are running an employee engagement survey, you might want to break down your data by tenure and compare senior employees to new employees. ggplot2 has two functions for faceting, facet_wrap and facet_grid. Let's explore them both. We'll start with facet_wrap. To facet your plot by a single variable, use facet_wrap. Let's say we wanted to focus on the data for each species of penguin. Take our plot that shows the relationship between body mass and flipper length in each penguin species. The facet_wrap function lets us create a separate plot for each species. To add a new layer to our plot, we'll add a plus symbol to our code. Then, inside the parentheses of the facet_wrap function, type a tilde symbol followed by the name of the variable. Let's log into RStudio Cloud and check it out. As a reminder, we'll start by loading the ggplot2 package and the penguins dataset. You can find the tilde symbol in the upper left corner of your keyboard, just below the escape key. There, the separate plots show the relationship between body mass and flipper length within each species of penguin. Pretty cool, right? Facets help us focus on important parts of our data that we might not notice in a single plot. If your visual is too busy, for example, if it's got too many variables or levels within variables, faceting can be a good option. Let's try faceting the diamonds dataset. Earlier, we made a bar chart that showed the number of diamonds for each category of cut: fair, good, very good, premium, and ideal. We can use facet_wrap on the cut variable to create a separate plot for each category of cut. Let's check it out. To facet your plot with two variables, use the facet_grid function. Facet_grid will split the plot into facets vertically by the values of the first variable and horizontally by the values of the second variable. For example, we can take our penguins plot and use facet_grid with the two variables sex and species. In the parentheses following the facet_grid function, we write sex, then the tilde symbol, then species. Let's run the code. There are 9 separate plots, each based on a combination of the 3 species of penguin and 3 categories of sex. Facet_grid lets you quickly reorganize and display complex data, and makes it easier to spot relationships between different groups. If we want, we can focus our plot on only one of the 2 variables. For example, we can tell R to remove sex from the vertical dimension of the plot and just show species. Let's check it out. You can easily spot differences in the relationship between flipper length and body mass between the 3 species. In the same way, we can focus our plot on sex instead of species. Facets let you reorganize your data to show specific relationships between variables and reveal important patterns and trends in subsets of your data. That's all for now. Next up, we'll learn how to customize our plots using labels and annotations. Until next time. Hi, great to have you back. Coming up, we'll learn how to customize the look and feel of our plots using the label and annotate functions. In everyday language, to annotate means to add notes to a document or diagram to explain or comment upon it. In ggplot2, adding annotations to your plot can help explain the plot's purpose or highlight important data. When you present your data visuals to stakeholders, you may not have much time to meet with them. Labels and annotations will point their attention to key things and help them quickly understand your plot. Let's start with the label function. It's super useful for adding informative labels to a plot, such as titles, subtitles, and captions. For example, we can add a title to our plot that shows the relationship between body mass and flipper length for the 3 penguin species. A title will clearly indicate the purpose of the plot. Let's go over the code. First, we add a plus sign to add a new layer to our plot. Next, in the parentheses following the label function, we write the word title, then an equal sign, then the specific text we want in our title. Let's log into RStudio Cloud and check it out. First, let's load the ggplot2 package and the penguins dataset. Remember, put the plus sign at the end of a line of code. It's easy to forget. R automatically displays the title at the top of the plot. We can also add a subtitle to our plot to highlight important information about our data. To do this, we enter the code for a subtitle in the same way as a title. Remember to add a comma after the title argument before you enter your subtitle. R automatically displays the subtitle just below the title. We can add a caption to our plot in the same way. Captions let us show the source of our data. The Palmer penguins data was collected from 2007 to 2009 by Dr. Kristen Gorman, a member of the Palmer Station Long-Term Ecological Research Program. Let's cite Dr. Gorman in our caption. R automatically displays the caption at the bottom right of our plot. Titles, subtitles, and captions are labels that we put outside of the grid of our plot to indicate important information. If we want to put text inside the grid to call out specific data points, we can use the annotate function. For example, let's say we want to highlight the data from the Gen 2 penguins. We can use the annotate function to add some text next to the data points that refer to the Gen 2s. This text will clearly communicate what the plot shows and reinforce an important part of our data. Okay, let's check out the code. In the parentheses of the annotate function, we've got information on the type of label, the specific location of the label, and the context of the label. In this case, we want to write a text label. We also want to place it near the Gen 2 data points. Let's put it at the following coordinates. X-axis equals 220 millimeters, and y-axis equals 3,500 grams. Finally, let's write our text. The Gen 2s are the largest. Let's run it. Check it out! R automatically places the text label on the correct coordinates in our plot. We can customize our annotation even more. Let's say we want to change the color of our text. Well, we can add color equals followed by the name of the color. Let's try purple. We can also change the font style and size of our text. Use font face and size to write the code. Let's bold our text and make it a little larger. We can even change the angle of our text. For example, we can tilt our text at a 25-degree angle to line it up with our data points. Let's try it. That looks great. By this point, our code is getting pretty long. If you want to use less code, you can store your plot as a variable in R. As a quick reminder, to create a variable in R, you type the variable name, then a less than sign, followed by a dash. Let's try it with the variable name p. Now, instead of writing all the code again, we can just call p and add an annotation to it, like this. You get the same result. Some people like to see every step of their code listed out in front of them. So there are advantages to doing it the longer way. It's really up to you. I just want you to know that you've got options. Hopefully this gives you an idea of some of the ways you can customize your plots. Labels and annotations can be really helpful when it comes to highlighting important parts of your data and communicating key points. That's all for now. Coming up, you'll learn some useful ways to save your plots in ggplot2. See you next time. Hi, and welcome back. In this video, we'll learn how to save our plots. Saving your work so that you can access it later is so important. It lets you continue to work on it yourself or share it with others. Being able to reproduce and share your work is a key part of your future analyst role because it lets you collaborate with teammates. they can double-check your work and offer feedback to help you improve it. So let's save our plots. To do this, you'll use the Export option in the Plots tab of RStudio, or the ggSave function provided by the ggplot2 package. First, we'll save our plots using the Export option. Then we'll use the ggSave function. Let's log into RStudio Cloud. We'll load the ggplot2 package and the Penguins dataset. To start, let's write some code and create the plot that shows the relationship between body mass and flipper length in 3 penguin species. Let's use the Export option in the Plots tab to save our plot. We can save it as an image file or a PDF file. Let's try saving it as an image. There are 6 different options for image format, including PNG and JPEG. Let's try PNG. Next, we name our file and click Save. Now, if we click on the Files tab, we'll find our file in the list. Let's open it up. Looks great! That covers the Export option for saving a plot. Now, let's check out the ggSave function. ggSave's a useful function for saving a plot. It defaults to saving the last plot that you displayed and uses the size of the current graphics device. Let's try saving our plot as a PNG file using ggSave. ggSave will automatically save the plot that shows the relationship between body mass and flipper length because this is the last plot that we displayed. We have to give the file a name and say what kind of file we want to save it as. Let's write the code. Within the parentheses of the function, we start off with a quotation mark, followed by the name of the file. Let's name it 3 penguin species. We put a period after the file name, then the type of file we want, then a closing quotation mark. Let's run it. Now, if we click on the Files tab, we'll find our new file in the list. Let's open it up. Again, looks great. That covers the basics of saving plots. After all your hard work creating plots in ggplot2, you definitely want to remember to save them so you can access and share them later on. And that's the end of our work on data visualization. You're off to a great start visualizing data with ggplot2. Plus, the concepts we've covered are a great base for learning even more about data viz in R as you move forward. We started off by learning the basic steps for creating plots in ggplot2. From there, we learned how aesthetics can change the look of our plots and highlight important parts of our data. We used different geomes to create different types of plots, like scatter plots and bar charts, and used facet functions to show subsets of our data. Then we customized our plots with labels and annotations. Finally, we learned how to save all our hard work so we can access and share it later on. That's a lot of ground we covered. Feel free to review the videos anytime you want and move at your own pace. It takes lots of time and practice to become familiar with new concepts and to develop new skills. No one gets everything right the first time around, but the more you practice, the more you'll start to feel at home in ggplot2. If it doesn't always feel easy, that's okay. That just means your mind is expanding and your skill set's getting bigger. Trust me, it's worth it. Learning ggplot2's a game changer for anyone interested in visualizing data. I hope you enjoyed it as much as I did. I love creating visuals in ggplot2. Coming up, you'll learn how to document and report your data using R. Until next time. Hi, and welcome back. We've covered a lot in our time working in R. We've learned the ins and outs of R and RStudio, including how to analyze and visualize your data. Now, you'll learn how to document and report your work using R Markdown. R Markdown is a file format for making dynamic documents with R. You can use an R Markdown file as a code notebook to save, organize, and document your analysis using code chunks, comments, and other features. When you finish your data cleaning and exploration, you can create a report in R Markdown to summarize your findings for stakeholders. The core of the work we do in my department involves analytics. When my team started getting bigger, we noticed we didn't have a shared language for data analysis. So, there was an effort for everyone to learn R so we could collaborate more easily. Now, everyone speaks the same programming language. We can review each other's code, which has led to more consistency and collaboration, and better analysis. R Markdown reports are great for sharing knowledge. These reports let anyone, from a small group of online users to a large company, share and reproduce analysis. In this course, we'll start with an overview of R Markdown, and then we'll learn how to install R Markdown in RStudio. After that, we'll check out how to create an R Markdown document. We'll also explore the structure and components of the document, so you'll have an idea of how to use them to record and report your analysis. Next, we'll show you how to insert and edit pieces of code called chunks into your document. And finally, we'll check out the process of exporting your documentation. It's always good to have a report of the analysis you've done, both for yourself and your stakeholders. After that, we'll wrap up our time with R. Of course, your time with R can keep going, and you can keep practicing. I hope you'll put R to good use in your future job as a data analyst too. It's a huge advantage in your career. Speaking of your career, when you've completed everything in the R program, you'll have the chance to add to or start building your portfolio by completing a case study. This is a great way to showcase all the skills you've learned so far and stand out to future employers. We'll talk more about this project later. In the meantime, let's get back into the R groove. See you soon! Hi again. As a data analyst, you'll need to refer to your analysis at a moment's notice. You might need to share it with your fellow team members, or a stakeholder might ask about one of your conclusions. Documenting your work makes it easy to quickly share your analysis with anyone. And that's where R Markdown comes in. Earlier, we learned that R Markdown is a file format for making dynamic documents with R. R Markdown lets you create a record of your analysis and conclusions in a document. It ties together your code and your report so you can share every step of your analysis. And the best part is, you don't even have to leave RStudio to do this. This document will help stakeholders and team members understand what you did in your analysis to reach your conclusions. Their feedback will also help you improve your analysis. R Markdown documents are written in Markdown. Markdown is a syntax for formatting plain text files. Using Markdown makes it easier to write and format text in your document. Markdown is also easy to read and to learn. For example, if you want to italicize a word or phrase in Markdown, just add a single underscore or asterisk right before and after the word. When you create a report of the document, the Markdown formatting's no longer visible, just the word or phrase in italics. We'll show you more formatting options soon, but they're all similar to this example. Basically, they're simple enough to let you focus on descriptions and explanations of your analysis without having to think too much about how to format them. Besides text, R Markdown also includes an interactive option called an R Notebook that lets users run your code and show the graphs and charts that visualize the code. Any R Markdown document can be used as a notebook. This creates a clear overall picture of your analysis and conclusions. R Markdown lets you convert your files into lots of different formats too. You can create HTML, PDF, and Word documents, or you can convert to a slide presentation or dashboard. Having these options makes it easy to share the same analysis in a variety of ways, depending on your audience. The Markdown language was originally designed for HTML output. HTML is the set of markup symbols and codes used to create a web page. R Markdown has the most available features for this format, but you can get good results in any of the formats. While R Markdown is a great way to record and share your analysis, there are other options too. Notebooks like Jupyter, Kaggle, and Google Colab do a lot of the same things as an R Markdown notebook, including the interactive elements. You'll read more about these options in a little bit. Coming up, we'll create an R Markdown document. You'll get to see this effective analysis tool in action. See you soon! Welcome back. Exploring the different tools available for analysis is one of the more fun parts of being a data analyst. By now, you've had the chance to try out tools like spreadsheets, BigQuery or other SQL tools, and Tableau. Now, we'll check out a tool you can use in RStudio, R Markdown. As a reminder, R Markdown is a great tool for documenting your analysis at any stage, but especially when you've completed a project. Let's open up RStudio and get started with R Markdown. Feel free to follow along with the video and try it out on your own later. Or go ahead and join us now in your own RStudio account. We'll first install the R Markdown package by using our install packages function and R Markdown in parentheses. As a reminder, installing packages can take some time. Bright red text may show up in your console as it installs. That's all perfectly normal. Okay, let's open up a new R Markdown, or RMD, file using the File menu. If you're working along with us and you're prompted to do install packages that you'll need to open your file, go ahead and click Yes. Right away, you might notice some of the outputs available in R Markdown. For now, we'll use the default HTML and document options. The other output options will also be available later. We'll add a file name and author and then open our file. Next, we'll save it so we can use it later. So now we have an RMD file filled with metadata at the top and chunks of code in the gray sections. There's text in between for explaining the code and adding comments on your analysis and conclusions. This R Markdown documents in its original format. It's definitely useful and can be edited and added to, but if we want to produce a report containing all text, code, and results, we need to click the Knit button. Now we've got the report. It's an HTML file that you can share with others. Let's compare the original .rmd file with the HTML report. You can tell that the text has been transformed into a more viewer-friendly format. Also, the code chunks have all been run, and we now have their output, both the columns of data and the plot from an analysis on the CARS dataset. The report's clear and formatted in a way that's easy to follow and understand. We could share it with stakeholders, even if they've got no experience in R. R Markdown files are definitely an effective way to complete the data analysis process. You can start your analysis in R and create a report complete with code and visualizations all in the same workspace. Coming up, we'll show you more examples of how to use R Markdown to make your documentation even more effective. Bye for now. Hello there. Earlier, we showed you how to get started using R Markdown. We created a Markdown document called an RMD file, which is super useful for making and saving a final report that summarizes your data exploration and analysis findings. In this video, we'll check out the structure of the text in an RMD file and how you can format it to better organize and emphasize your findings. Let's go into RStudio and open the file we saved earlier called R Markdown Intro. If you're working along with us and don't have a file saved, you can open up a new R Markdown or RMD file using the File menu. If you're prompted to install packages, go ahead and click Yes. Click OK to open with the default options and then save your file. Now, let's dig deeper into this file. We'll start at the top. This is the YAML header section. YAML is a language for data that translates it so it's readable. Fun fact, YAML originally stood for Yet Another Markup Language. This section is called out using 3 dashes on the first and last lines. This syntax automatically creates the YAML header section when it's used in an RMD file. In an RMD file, this section's basically for metadata, or the data about the data in the rest of the file. The title, author, date, and file type of an output are automatically included when you create a new file. There's lots of different functions and formatting options in this section. For now, just make sure you have at least the 4 details we've got in our file now. You can use the template that appears when you open the file and just edit over it, or you can start from scratch using the 3 dashes to create the YAML section and the rest of the contents in the file. We'll cover these steps over the next few videos and in the other program resources. Next, let's check out the text in the white areas of our file. Think of the text as a way to comment on and explain your code and analysis and any visualizations you're including. You can format the text to include links, ordered lists, equations, and more. The text is formatted using Markdown, the syntax we introduced earlier. We've included a reading that shows you all of the ways to format text, as well as lots of other great Markdown tips and tricks. You'll also learn some more formatting examples in the next video. For now, let's try some examples that are in this file. On line 12, there's 2 hashtags and a space before the words R Markdown. Hashtags are used for headers. The more hashtags, the smaller the header. The space is important as well. Otherwise, RStudio won't recognize that this is a header. Let's knit our file again. There's the R Markdown header in the HTML file. If we add 2 more hashtags in the .rmd file and click knit once again, the output changes. The header's now smaller. We'll change it back because the original format made sense. Since this header is introducing information about R Markdown, that comes in the next 2 paragraphs, we want to emphasize it. In the first paragraph of this section, there's a brief summary of Markdown. There's a link in the text, and it's formatted using angle brackets. Using these brackets results in a clickable link in the output. That's a handy feature if you want to refer to any helpful links or include them as sources for your analysis. In the next paragraph, knit is set off with 2 asterisks on either side of the word. This bolds the word. Using 1 asterisk on either side would instead italicize the word. Let's scroll down to the last paragraph. Here we've got some inline code, which can be inserted directly into the text of a .rmd file. The code appears in a gray box, like the code chunks we'll talk about soon. Using inline code like this lets you refer to the code directly as you explain it. Let's knit our file one more time. All the formatting works together to make a well-designed, readable file that's easy to share with stakeholders and team members. That's it for now, but there's lots more to learn about creating your own reports. Stay tuned.
I'm Meg, and I'm a product lead at Google. As a product lead, I work with designers and web developers to build features that our users will love. Specifically, I work for Kaggle, which is an online data science community for people who are learning data science and machine learning. So we get to build exciting features that help people learn from data and advance in their careers. I work with designers and researchers to do studies to understand what our users want and what they need in the product. And I work with engineers to figure out exactly how to write out those requirements for the features that we decide to build. Learning any programming language is really empowering because your only limits are your creativity and your curiosity. It's really the curiosity that I have about the world that led me to research and data analysis, especially with R. I just felt it was really freeing to be able to ask a question about the world and know how I could work with data to get an answer to that question. The second thing that I think is really exciting and empowering about knowing a programming language is the transferable skills that it gives you. And then the last thing I think is really exciting is really the community and ecosystem that comes along with it. R is really no exception when it comes to that. In fact, I think R's community is really outstanding. And to have the community and that public ecosystem of resources right at your fingertips is really going to supercharge what you can do with data as a data analyst. And I think that's super exciting. It's completely normal to feel intimidated or confused or kind of stuck as you're first learning R. There are things that are kind of quirky about the language, and it's not your fault. You just kind of have to get past those things, and I can promise that things will make a lot more sense, especially once you're able to start using the tidyverse. I would say, stick with it. And the other, kind of piece of advice I'd have is try to connect with the R community as early as possible in your R learning journey. The thing that's just fantastic about R is the fact that its community is really vibrant, it's really welcoming, and you're going to find things like people who are expert practitioners in R who are, sharing their kind of their mistakes, and they're willing to share their kind of learning journey as well. And I think it'll really help you see that, you're not alone. I definitely had these moments where I was pretty frustrated when I was first learning R. When it really clicked for me was when I had the opportunity to use R to answer my own personal research questions. That is when you feel like you have a personal vested interest in the outcome of your analysis. That feeling of reward and satisfaction when you push through is, something that can help really build that momentum to keep learning.
Great to see you again. As we've explored R Markdown, we've learned how the interactive elements work. When you change something in your RMD file, RStudio automatically applies it to your report. In this video, we'll show you a few more formatting options for making your report more complete and dynamic. Let's go back once again to our .rmd file called R Markdown Intro. We'll make some edits, add some elements, and then convert it to an HTML document. We'll start by adding bullets. Just like in a standard document, bullets can help you organize your content. In our file, we'll turn the list of the documents that R Markdown can author into bullet points. We use asterisks in the .rmd file to create the bullets in the output document. We'll revise this section so that the bullet points are set up in the right way. Now let's check out a different way to include a link in the file. When you're writing a report, you might want to link to the company website or to pages you used for research. Right now, in the first paragraph, we have the website URL inside of angle brackets. To embed the link in text instead, let's change the formatting. We'll start by changing the text to better fit the embedded link. Then we'll add square brackets and the word we want to embed the link in. And we'll change the angle brackets around the URL to parentheses. Both types of links work great, but some URLs are long and might clutter your report. In those cases, embedding links saves space and can look cleaner. Let's say you want to embed an image too. Images are good for showing your workflow or displaying visualizations you want to reference in your report. Or maybe you just want to add a GIF or another fun image. That's great. Just make sure your stakeholders will appreciate it. Let's go ahead and have some fun with this example. We'll embed an image with the plot example. Then we'll add an exclamation point and a caption for the image in square brackets. Next, we'll copy the URL for our image and paste it inside parentheses. Now let's check out our finished product. We'll view it in our browser. That way, when we click the embedded link, it opens up in a new tab in the same browser. Here's our bullet points and our image and caption. And here's our embedded link, which we can click to open the website. And there's lots more ways to format an RMD file to get it ready to turn into a complete, organized, and effective report. While reports are a key part of presenting your analysis to stakeholders, they can be just as important for your own learning. You can use .rmd documents to keep track of your learning by including notes and linking to online resources. You can embed useful images and add bullet points too. Speaking of learning, let's find out more about code chunks and RMD files in the next video. See ya! Hi again. We've learned a lot about R Markdown, or RMD files, and how they can be formatted and converted into reports for stakeholders. We've also explored the YAML header and the comments, descriptions, and explanations for the analysis shown in the report. Now comes the heart of an RMD file, the code. Code added to an RMD file is usually called a code chunk. We've shown you these code chunks in some of the RStudio sessions we've been running, and you may have noticed code chunks if you've been practicing along with us. Now we'll show you what they're all about. Earlier, we worked with the Palmer Penguins dataset. We ran some code to analyze the data and create visualizations. After this step, we'd probably want to set up a practice report with notes about our analysis. We'll do that here and incorporate some code and visuals. Let's start by opening up RStudio and then the script with our programming, the ggplot_hook file. We could share this file directly with others, but it's not very effective. It's hard to read and doesn't always include any takeaways. So we'll create a new .rmd file instead. We'll add a title and author. Now we have two tabs in our script pane. We can toggle between them just like with browser tabs. We'll save our new .rmd file. This file's in the template format, so we'll delete everything except the header section and start our own. We already set up the header section, so we don't need to make any changes there. Instead of deleting, we could make edits section by section, adding our own comments and code along the way. But deleting the file contents gives us a blank space to work in and helps us avoid potential errors from mixing our own comments and code with the pre-existing ones in the template. Before we add any code, we want to describe its purpose. The first code chunk will set up our R environment by loading our packages using the library function. So on a new line, we'll type 2 hashtags to format a header for this section, followed by the header text, setting up my environment. Then we'll add a note about the code. We've added apostrophes before and after tidyverse and Palmer penguins because they're the names of the packages, which makes them part of the actual code. And now we'll add our code. RStudio has a handy code menu that we can use to insert a code chunk. There's also a button in our script pane that lets us add code chunks. This creates a gray section in our file and chunk delimiters. A delimiter is a character that indicates the beginning or end of a data item. You could also type these delimiters directly in the file. 3 backticks, followed by an R in braces to begin the code chunk, and 3 backticks to end it. Or you could use the keyboard shortcuts Control plus Alt plus I on a PC or Chromebook, and Command plus Option plus I on a Mac. Since we're in RStudio, the code menu works just fine. Inside the first brace, we'll label our code chunk. After the R, we'll add a space and then type loading packages. This adds another layer to our organization. We can now easily find this code chunk and its label using the contents menu at the bottom of our script pane. Next, between our delimiters, we'll add our first code chunk, which we use to load our 2 packages. Even if they're already loaded, loading them again makes sure that our packages will be updated to the latest version. We can type starting on the line after the first delimiter. But since we also have our programming file available, we'll copy and paste from there. Now we can run our code right in the file to check it for errors. And there's the code output. We can also change our code chunk options. There's options for changing the output and for turning off warnings and messages. These are useful for when you're ready to create a final report for stakeholders. You'll have control over what you'll show them in the report. For example, if you get warnings with your output that don't impact your findings, you can turn off the warnings for stakeholders. So the code chunks are the key to making this report a good learning tool and eventually a document worth presenting to stakeholders. When you have code embedded in a file and can show its output, you can provide evidence for your findings and share your sources. And if you need more evidence for how R Markdown can help you document your analysis, we've got it coming next. See you then. Hi again. One of the most powerful things about an R Markdown file is that you can convert it to different output types to create shareable reports. We've been focusing on HTML documents, but there are other options we can explore. Let's start by opening our earlier report. We created this report as a learning document to help you think through your code and analysis. For this video, imagine it's a report you need to share with stakeholders. The file is currently in the .rmd format, but as we've shown, it can be converted using the knit button. The knit drop-down menu includes three main options: HTML, PDF, and a Word document. You can use knit to convert your file to any of these types whenever you want, but it's good practice to wait to convert to a PDF or Word doc. Instead, stick with HTML while you're working. HTML doesn't have page breaks, so you can focus on generating content for your report and not its appearance. The knit button isn't the only option for converting your file. The YAML can be edited to change your metadata or incorporate more details. For example, we'll change our output in this file to PDF. When we click the knit button to render the file and run the code, the output's in a PDF format. So you know how changing the metadata can have an effect on the whole report. And if you need to create a certain type of document over and over, or if you want to customize the appearance of your final report, you can create a template. If it's a monthly or annual report that you're creating for stakeholders, you can just run one line of code to update your data, and your report's ready. We won't cover creating a template here, but it's something you might want to learn more about on your own as you get more experience in R. We've now explored a big part of R Markdown and R documentation. We've explained what R Markdown is and how to use it in RStudio to create .rmd files. We've checked out the structure of these files and how you can format them to make reports. We've shown you what code chunks are and how to include them in your documentation. And we've shown you how to take all of that analysis, plus your explanation of that analysis, and transform it from a .rmd file into a report that you can use as a learning document or share with stakeholders. It's a great way to wrap up the data analytics process in R and RStudio. And it's nearly time for you to wrap things up in this program. But if you want to review any concepts or practice some more in RStudio, feel free to rewatch the videos anytime for some extra help. See you soon!